I think you could heat it up with some UV light. I do agree. I think certain shit will heat it up, but just my torch won't. That'd be a good test to see what method, try it with the torch.
But your torch produces UV.
What I have to do is
produces infrared.
What I have to do is focus that beam on the container that it's in, and it'll slowly heat up and boil the water. But if you just focus it on the water, you ain't getting nothing, man. That which would
you're probably just reflecting.
That's weird, ain't it?
Reflecting most of the heat, Brian, as opposed to absorbing.
Yeah,
it's probably just reflecting.
Yeah, that's a good. I'll consider that explanation. If it's like reflecting the heat, or deflecting and reflecting, maybe one or the other, combination of both. But yeah, it's not accepting it. It's counterintuitive. Let me say this. When you see it, it's counterintuitive as fuck.
Hey?
Say that again?
Unlike other things, water's wet. So you can't sort of put the fire in it. Whereas, like the metal objects, you can really get the fire, and the fire touches everything. So with water, you've got no choice but to try and put a container around it and heat that container. So there's also that as well.
So you think if I dug a hole, okay, or if I maybe even concrete or something, or just I don't want a bunch of water. I just want it to where the flame is far enough away from the edge, where the flame still overwhelms the amount of water. So if I'm going to do this test, I'm going to maybe dig a hole and line it, maybe concrete or something. And I mean, I got a million bags of this shit, but just right here in front of me. Let me see. Just sitting right here, I fucking got bags of concrete and shit. But I was just thinking of lining it and making it maybe, I don't know, a foot and a half, about 18 inches each way, so the flame I just have right in the middle, and I just have it about, let's say the flame coming out is probably about a foot long. Well, we'll call it 10 inches long. So I'll make the water about that deep, maybe a foot deep, and I'll get the torch down right on it. So off what I just described, let's say we have about 3 gallons of water, maybe 5. We'll call it 5 gallons of water, kind of sitting in the ground, and underneath the ground, there's concrete or whatever, but you're not seeing it because it's in the ground. Okay, so basically it just looks like a puddle of water in the ground. I keep the torch away from the dirt and the concrete. I focus it right on the middle of a 5-gallon bucket. You could even picture that in your head, a 5-gallon bucket. But I keep the water. I keep the torch away from the bucket. Focus blasting in right on the middle of this water. How long do you think it would take to boil? A 2,000-degree torch.
Well, it literally depends how much of that 2,000-degree torch is being transferred into the water. That's how much. I mean, yeah. Like a bomb calorimeter. Like when they use those things to see how many calories are in food, they're literally seeing how much it takes to raise a certain amount of water by 1 degree.
Right, so they're using electricity for that, right?
No, they're burning food in those things. But my point being is, there's a known amount of energy it takes, obviously, to raise water by 1 degree. And if it takes forever, like you're saying, to get this water to come up in temperature, it obviously is just a fact that you're not transferring that energy. It's a poor method to shoot a flame at the surface of water, obviously, to heat it up.
Right. But do you think it would boil, though, eventually?
And look, it all depends if that surface area can dissipate the heat at a faster rate that the rest of it, it can be transferred. How deep is this? Is a 5-gallon bucket? I don't think it would, no.
A 5-gallon bucket.
If it was shallower and wider, potentially.
Okay, let's call
Don't
it
know.
let's say a 3 gallon bucket, like one of them sawed off 5 gallon buckets. So it's the same diameter as a 5 gallon bucket, but it's just like just barely over half the height of it. So it's a 3 gallon bucket, a little snub nose 5 gallon bucket.
I don't know. Look, typically you want to put the heat source underneath. Like every device that you know of to heat water, the heat source is put underneath because heat
Right,
rises. And that's the
right.
only
But
real
I'm
efficient way to
specifically,
transfer energy through water.
yeah,
So
I
to
know
do it
that.
from the
I'm
top, it
asking you.
won't.
I'm just trying to see the way. I mean, it's not a right or wrong answer. I mean, I've got my opinion. I've got what I've tried, but I haven't really went into depth with it. I'm just wondering what you're thinking. Like, would it eventually boil with what I just
Not
described?
from the
What do you
top.
think? What do you
No,
think? Yeah, I don't either.
not from the top. No.
I don't either. I wonder if every liquid's like that. Like, if I put cooking oil in there, you think it would behave the same? I've never tried it. It's a fair question, huh?
No, it is because it's a very different liquid. Yeah.
Could be
It
the
acts
same. I mean,
differently.
it could be similar. You know, like it is
No,
definitely
because
different
you'd burn
liquid.
it. You'd be burning it with that torch. It just wouldn't, it's hard to compare the two, to be honest.
Yeah, yeah, yeah. Let me think of a different liquid, like something non-flammable that's not water, because and take out the magic out of the water, and maybe it's just the fact that liquid itself is. But it like to me in my mind, it's the water's like got some special properties. But maybe if I use like let's see, what are the liquids like a non-flammable pure liquid that doesn't have water? Hmm.
Yeah, look, at the end of the day, I think you'd still have the same issue because the heat source is being applied from the top. It's poorly distributed through whatever it is. Yeah, I don't think
Yeah.
you're ever. I mean, give it millions of years, maybe fucking, and no other, nothing else at play.
I mean,
Potentially, I can't
I've
write
seen them
that
put.
out.
I've seen them put fucking. Now that I think about it, I've seen them take a water balloon and put a piece of tape on it, and take a torch and fucking torch that piece of tape, and the water balloon don't bust. Now that I think about it, um, it just I'm not even sure they use tape, but I remember it had something to do with a torch and a water balloon, and every fiber in your bone is thinking you're going to see a disaster about to happen, and it melt through it immediately, and it
Mm.
didn't. Doesn't it? It's weird. I wish I
Yeah, that
remembered
makes
exactly how
sense.
it set up was.
Counterintuitive, but it does make sense. Yeah.
Now, I wonder if there was like alcohol in that balloon, or oil, olive oil, or just curious.
No, it's just that the balloon, the rubber needed to get to a certain temperature to melt, but it couldn't do that because it had liquid on the other side sucking up the heat. So it just couldn't get to the temperature.
And if I remember right, it was just a little small torch, but it's still, I mean, a torch nonetheless. Um, I got like every size torch just about, man. Got the copper melting kind with the butane, the small propane kind, the little micro torch, the big ass fucking 20-gallon propane tank wand torch. I just accumulated a few of them, just different size shit, melting different shit. But I was trying to think of how to get zinc. I went through all the stuff I had and could scrap and find, and you get better at identifying zinc and recognizing it from aluminum. But I didn't have enough to do what I'm doing. I'm like working on batteries with zinc and copper and shit, and I'm like, where can I get zinc, man? And I had an old penny jar, and I realized that I did this one thing. I replicated something an experiment a dude did. He just scratched a little hole in the freaking on the penny to get the little tiny copper shell off, and then you put it in and hydrochloric acid or muriatic acid, the shit we clean driveways and shit off with. And it'll give you zinc chloride, or you could use sulfuric acid if you have that. You just put it in there and it'll bubble away and leave you with zinc sulfate, and what you have is a little bit of copper, and that's every penny after 1983 in America. They quit putting copper to realize that, dude, I got a whole bunch of zinc. So I just took about, I don't know, I mean, I looked online first, and I think it was for like 5 pounds of elemental zinc or whatever. It was crazy, ridiculous, man. Like $100-something or something for, I forgot exactly how much, but whatever it was like, no way, dude. I'm not spending that much money on fucking zinc. I'm gonna find it and melt it down, you know. But so I realized, dude, the pennies, man, the fucking pennies. I took like just a little pile, like about eighth of a pickle jar. You know, not that much, but short enough. Torched them, and it just leaves the little thin paper thin copper shell behind. But when you put it in the acid, it literally leaves it still looks like a penny, and it's virtually weightless. That's how much copper it is. It's just a paper thin shell, thinner than paper even. But from looking at it, it looks like an actual penny. You go to grab it, and it freaking crumbles like ash. Not quite like ash, but damn near. But the zinc, when you melt it, dude, I just put it on a little plate of steel at an angle and torched it, and sure enough, man, all the zinc came down. Clean zinc, man, freaking shiny ass.
Awesome.
Yep, for just a few dollars. Instead of spending fucking hundreds of dollars where they try and sell you. It's crazy some of the prices they try and get for some of these things. And people pay it.
Yeah, well, I was thinking, mate, I'd probably pay the $100 and just get it and save the hassle of doing what you did. But, you know, you're obviously the type to go and do what you did, so you'll save the money. Good on you.
It might have been more than that, man. Or either less zinc. I forgot. It was ridiculous. The prices were ridiculous. That's just the one thing I remember. If it would have been reasonable, whatever the price was for the amount, if it was reasonable, I would have just paid it, you know, instead of going through the trouble. But it was ridiculous. I forgot the price. And I didn't want to sound like I was lying and just throw some crazy number out there, so I just used an even number. But it was not fair. Like, I don't know who would be who would need zinc bad enough to spend that kind of money, but whatever. You see what I'm saying? Zinc is energy dense, man. As far as for batteries go, I get some halocurrent off the zinc and copper. It depends on how strong you want to make the electrolyte. Like, you can get it but it reacts even when you're not using it. If you make a real strong one, it'll be reacting even when you're not using it. But you'll get a lot of, like, you can get a couple amps off a little ass fucking battery, copper and zinc. But whether you're using it or not, it's gonna react and disintegrate to get one that strong. But that's how these zinc carbon batteries work. They pretty much work until the zinc disintegrates. There's just a tiny little shell of zinc, and when it gets thin enough, corroded away enough, it stops giving you the power you need. You know, it starts dropping under like a volt or something, like 0.8, 0.9 volt. You know, but as long as that zinc, if you make it, you know, if you just use manganese dioxide or whatever, carbon, probably graphite, anything like that, and you just use a weak solution of potassium hydroxide, it won't generate on its own, you know. Won't give you as much power, but it'll still give you quite a bit, and it'll last until the zinc disintegrates. It'll keep going if you have the right amounts of shit. So I was thinking about, but it's not really rechargeable. So I was trying to find a way to make it rechargeable, you know.
Hey, Brian.
Yeah, there's always pros and cons.
Brian, I typed into YouTube water versus torch just to see what came up, and the first thing that came up, I put it in the live stream. If you want to share it, you might want to watch it. It's pretty good. It's
Yeah, that's Brown's gas.
is that it with the water and torch?
Yeah, that's Brown's gas. Yeah, fucking been around
Yeah.
for a very long time. Somewhat suppressed,
Cool.
but
It's a water torch, and it was crazy because he's burning stuff, and it makes things burn so quickly with the water, and then it turns right back into water.
yeah. And you can touch
there you
the
go.
end of the torch nozzle, and it's not hot.
Yeah, it's not
which is
hot.
another phenomenon about it.
Right.
That's cool, man. I gotta see that, man. I even made one to separate the hydrogen and oxygen and shit, but it didn't really seem like that. I don't think I did it right. I mean, even though I had catching all the bubbles and shit coming off the anode and the cathode separately, it somehow seemed to mix together. Like I don't like atomically, I don't fucking know, but they didn't seem like very different gases, man. It just kind of seemed like the same shit. Maybe I need to my setup needs to be a little bit better, but then I realized I don't need to separate it for what I was trying to do. It's just kind of a waste of time and effort to try and separate this shit when by itself together, it's buoyant as hell. It floats like a son of a bitch, you know. It's light and it's flammable as shit. But it's a different kind of flammable. It's instantaneous, but it's like an implosion. Like them put the bubbles on their hand from them setups. That shit's legit. It like implodes, man. So you could put a bunch of them bubbles of that gas on your hand and light it, and it'll make a loud ass sound, dude. And you'll like your ears will be ringing, and your hand will be fine. Nothing wrong with it at all. You barely even felt it. Scary,
Whoa.
but not dangerous. Weird.
You ever make a 2-liter bottle bomb? Little crystal Drano, some aluminum foil, some water, shake it up. I think it's Ajax you use.
I've done the brake fluid and chlorine one, definitely.
With the 2-liter bottle.
Oh yeah, run back.
Yeah, the thing gets huge. Cops will be called.
And don't get any brake fluid on anything that you like that might have some paint on it, because it'll be fucked.
Oh, bamboo
If you
dick
want
tip.
to get, yeah, hey, if you want to get rid of your neighbour's dog, just put some brake fluid on a nice piece of ribeye steak and chuck it over the fence.
What's up, Carlos?
Hey, man.
Hey, I missed invites from you for something. I don't know where it was, but I've noticed I missed some invites from you.
Haven't been here for a while.
Well, invite me again while I'm here so it doesn't expire wherever it was you want.
If I can remember. What's going on? We're discussing alternative energy and batteries, or what?
Sounds like it. I want to figure out what Ewar was talking about with the gold and the mercury to collect the etheric energy or whatever.
Is that like on his latest?
No, that was a little while back. You know, he
Yeah.
thought that the steeples were somehow transferring the energy down into this gold mercury setup of some sort, maybe. He's speculating, obviously. But it seemed like there was some kind of device in those little octagonal open window steeple areas that are all over the place. Maybe where generating power or you know, working like a etheric energy collection type device. I also want to know what that golden snitch type looking thing is that the Christ figure's carrying as he rides on the shoulder of Offerus. They've got that little ball, that little gold ball. There's lots of depictions of that. What was that? You know what I'm talking about?
Yeah. So I was just daydreaming. I was thinking of while you were talking, I was soaking it up, but I was also thinking of what I was watching earlier on
What
with
was that?
oh, what's his name?
Something about bamboo dicks?
Bamboo Dick. I should change my handle.
Where'd that come from?
Uh,
Oh, go ahead.
I think it might have been Kosho looked it up because we were saying that Richard Pierce was first to fly before the Wright brothers, and he found out that Richard Pierce's nickname was Bamboo Dick.
Oh,
Yeah, so I claimed it. Yeah,
who's
just
Richard Pierce?
just to remind him. Yeah.
I don't know who that is.
He's the guy that flew the first powered flight before the Wright brothers.
Ah, okay.
Yeah.
Oh, first as far as I mean, was that the fake first? Was that the fake first or the fake first? Who knows how long they've had it, right?
Oh fuck! There's so much fake shit in this world today. It's hard to tell. Yeah.
Yeah,
Who knows?
the fake fakes cover up the fake.
Yeah, there's layer upon layer of fake, eh?
Yep. You put
Yeah.
out like Jesse Smollett. That's a perfect fake. You know who Jesse Smollett is?
No. How small is that?
I think it's small. I don't know if it's a Smollett or it's Jesse Smollett or Smollett. Anyway, he's this actor guy that did like this thing about being attacked by white supremacists or something. He's a black actor, but the whole thing about it is that you know, he was supposedly caught faking it, right? Right. So it's all a made up story. So if the news reports on a story as if it's real, and then they find out it's fake, they're sure to tell you is the lesson you learn, right? So it's like a fake story to make all the other ones that are fake look real.
Wow.
Just to make
Yeah,
it seem like they're doing their job, you know, catching the fakes.
there's like a hidden agenda in a storyline. You have to look really deep to find out actually what's going on, eh?
Mm-hmm.
It's a giant
A lot of
rabbit hole.
subterfuge.
Yeah, interwoven. Yeah, it's so deep. Like if you look at the basic channel of RV Russian vids or whatever it is, like he just really is only touching the surface, and that's all. You know, he's been around for years, and he gets pretty deep, but he's still only just touching the surface. No,
I need to show probably too.
It's so
Russian
crazy how yeah.
Yeah, there's some information on him I found. He's like his brother. I don't know. Somebody was telling me some weird shit about him. I think that he's probably controlled op to a certain degree, but he has revealed some things that I haven't heard from other people. That do seem to be the case.
The only thing that's out of this world that they have to have controlled up on like some random YouTube channel, like, you know, they really go the full hog, you know, to to dupe everyone.
Yeah.
And at the end of the day, you have to wonder, what are they hiding? You know.
Well, yeah. Obviously, free energy is one of them. It seems like, I imagine, and it probably has something to do with the true nature of the Earth, which is what these guys were kind of getting around to. If you understood the way the Earth worked, you could probably have your own free energy.
Because they just go to like the extreme. Like, money is not an issue, and they spend so much energy, you know, fooling everybody.
Yep.
and they just keep doing it, and it's like a train wreck.
Right. Why do you think they put their finger to their lips? You know.
Cover one right eye.
Yeah. In the club.
And all the
They
numbers.
don't all know the secrets, but yeah, just to be a part of it. You know, there's certain. I bet there's psyop upon psyop. I bet even the people at the very top are being psyoped by the people above them to some degree. You know, because they don't have to worry about the common man finding out anything. If like three layers up from them, they don't know anything, right? They're convinced of something that they think they're hiding, but that's not even what's really, you know, what the real information is, right?
It's a real childish way to go about it, in my opinion.
Well, it's entertaining, I'm sure.
Yeah, I guess for some people it's entertainment. That's what it is, right?
It's a perverse way of doing it, but it works because you can you know, present it to somebody without the evil intent being so apparent. If it's like, we're doing this, we're lying, yeah, but we're doing it in a funny way, so it's kind of okay. Like, I think somebody was saying that on here just a bit ago about NASA. Like, they're pretty funny when you think about it. Like, just a funny thing that like, you know, I mean, it's so obvious once you realize it, but then you have to think, well, they're having fun with it. You know, some of the shit they pull off, it's just hilarious. Starting with golf on the moon.
Yeah, I think that's it. I think they're just having a fun, just like a good time, and to the expense of everybody else.
Sure.
Yeah.
And they have tons of ways of justifying it, I'm sure.
I think it's hilarious how you guys just think everything is fake. I think that's fucking hilarious.
I think it's funny you believe it all. So there we are. That's the crux of this whole conversation. Pretty much.
It's fake because it has to be. Everything has to be fake.
Yesterday I got furious in a restaurant. Hey, I went to this Hong Kong barbecue restaurant, and there was no one in there. It was just myself and my wife. So we sat down at a table, and it was a 4-seater table. It's sort of like the restaurant was shaped like a train, and the lady in the front. Well, first she pissed me off because she said, "Oh, I said I want to order some food now, and then I'm gonna take the menu and keep looking at it and order some for takeaway for my kids." So she said, "Oh no, you have to pay now." It's like, oh fuck, really? Serious? Okay, so we just stuck with it and paid and ordered, and then went to sit at a 4-seater table. She said, "Oh, you can't sit there. It's for 4 people." I was like, "What the fuck?" I was already pissed off by then. And then when she delivered the drinks, she had 2 masks on, and she literally like had her hand extended as far as she could with the tray, and just like almost chucked the drinks on the table without looking, like facing the other way. And I was like, "Fuck, we're leaving here." I was riled. And then what she did when she brought the meals, I was already ready to go by then, but my wife was just sticking, stay, and calm down. I was fucking getting red hot. And she did the same thing with the 2 plates. It was like barbecue meat on rice each. And she reached her hand out and looking the other way, and she put it in front of me all over my fucking. I had like a pad that I was writing on, and she stuck it on my pad, and then she got the second dish, and she put it on top of the other dish.
What the fuck?
Yeah, she was so scared of like getting the COVID. So it's like, what the fuck? I just demanded. I went to the kitchen. I went right into the kitchen and I told the chef to come out. I could had the place on fire, and the fucking police almost
Jesus.
turned up. I couldn't believe it.
She
Someone's
must
so
be jab afflicted.
I'd never seen anything like it. Oh, fucking hell. No, I did all of that arguing in Chinese. It was even funny to think about
Oh yeah.
it. Yeah. My Chinese is better than hers because she only speaks Cantonese really well. You know?
Well, 2 masks. I mean, she's ready to pass out. You know, she can't breathe. She's got
Exactly.
graphene running through her bloodstream, and she can't breathe.
And that was in the early evening. She's probably been wearing those masks all day long.
Yep. I can't believe that that even past. I mean, I guess they used it. I mean, it seems so archaic. You know, when you see just like the old pictures of the last time they did this. You know, with the people with their masks on, man.
Well,
How people
like
would buy it.
just before they partially got rid of the mask mandate, I went to order a coffee in a regular coffee shop, pretty good coffee for takeaway, and then I had to wear a mask to get in the door. At the beginning, I didn't wear one. I had to actually have a vaccine passport as well just to get in. And when I got to the till with no mask, he said, "Oh, can you wear your mask? And can I please see your vaccine passport?" And I said, "What the fuck?" Anyway, I wasn't happy about that, so I just gave her the money and I said, "I'll wait outside." I gave her $10 and didn't need the change. And then the very next day, that no more vaccine passport was necessary, no masks were necessary, and I just walked in, and just because the mandate had been lifted, everything was okay. Suddenly, the COVIDs don't matter anymore. You just say the word, COVID understands.
Yeah,
It's
yeah.
fucking amazing.
It is
People's like,
weird. We have to be
yeah.
careful what we say because we're not supposed to talk about this. But yeah, it's so crazy. You know that
Well, it's not
it was
really.
basically a show of power.
I'm not really
They're
talking
just
about
showing us who's boss. They're just showing us who's
I'm not
boss.
really. I'm not really talking about the COVIDs as such.
Yeah,
I'm
I know.
just talking about people's perception of things. You know.
Yep, I know.
Yeah.
Crazy. As long as the news says it's okay, it must be okay.
Yeah.
It's
Yeah.
officially okay.
Yes, like my 5-year-old and my 8-year-old, they had to wear masks and then they took it off and they don't need it anymore. But my 16-year-old still does, and I was thinking, fuck, this fucking this disease or whatever, it knows the difference between age, who it can
Yeah.
attack.
Right.
Like,
And
wow.
also it knows what time you're out, right? Because the curfew makes a big difference. If you're out after 10, it's going to get you.
Oh, and I have to wear a mask to go and buy a cigarette lighter from the convenience store. And I have to wear a mask to buy a donut from the donut shop. But if I go into the restaurant next door, I can just walk in with no
Right.
mask. Yeah, because COVID doesn't mind restaurants.
Right. Yeah, and as long as you walk through the restaurant, some of them that I've been into, you know, you have to wear it to your table. Once you get to your table, you can take it off. You're like protected once you're at your table, right?
Well, in any retail shop, you have to wear it, but in restaurants, you don't at all. You just walk in.
Well, you can't eat. You can't eat with a mask on, can you?
You know, I mean,
Well,
you
no,
can just
obviously
walk.
not, but it just makes no sense.
Yeah, it's like a cigarette lighter. You know, that's a dangerous situation, man. But
Like
food.
if somebody pees in the pool and you go to the shallow end, you're safe.
uh,
What happens if you actually get sick?
Oh, okay. Guy who
Like
believes
really bad?
everything. Maybe not the conversation for you. I don't know.
No, I'm just asking. What happens if you really get sick though?
Well,
People get sick all the time. I've been getting sick
40,
my whole life.
No,
I've
I'm saying,
my
what
whole
happens
life
if you
I've been
get
asked,
sick?
never had to worry about getting sick without a
Man,
medicine.
that's
47 years
well,
old.
you've been lucky. You've been lucky.
Well, I'm 40,
Oh, really?
What
47,
happens if
47
what
days
happens
old.
if you really get sick though? Like, I mean, you're just it's kind of like Russian roulette, right?
Nah,
I guess so,
I'm
yeah, because
40,
they put the fear out there. You can't, now it's a risk.
nah, I'm 47 years old, and I got the flu almost every year. There's
Yeah.
nothing's changed.
Actually, if you
You
get sick,
take
it's even better.
a
Then
risk
you're immune.
you take a risk every time you walk out your fucking front door every morning, my friend.
Right.
Nothing's any different.
And if you
Especially
get
with
sick,
those
you're immune,
those
right? So there you go.
Yeah, but
Uber drivers,
unfortunately,
yeah.
some people have gotten sick and they didn't recover.
Yeah, because they were probably put on
That,
a ventilator. All right, we got to
that
stop
happens.
talking about this guy.
It's happened every other year, mate. Like I said, there's nothing different. Just a different fucking disease.
I don't think so. Not like this.
Yeah, but yeah, don't you guys want to talk about something else, man?
You know what, COVID? You know how much the
Oh, come on, man.
yeah.
Now
You
you're
know how
saying
much
that
of
word.
the total
Let's
death
get
toll in
in.
Australia it was last year? Point zero,
It's-
0.6,
guys,
sorry.
guys, guys.
0.6.
That's the last we're going to say about it. Okay.
Yeah, let's go ahead and say how it hasn't. Let's go ahead and say how it hasn't killed anybody, and it's just
Let's
like the
not
flu.
talk
Yeah,
about it.
go ahead.
Let's talk
Yeah.
about the shape of the Earth. How about
Let's
There's
that,
talk
only
guys?
like
about
2,800 people, man, that died here. So
let's talk
Yeah.
about how Bono had a little concert in Ukraine singing about Ukraine. Did you see that one? Bono singing "Save Ukraine" or whatever.
I'm sure. It doesn't surprise me.
He flew into a war zone to have a mini concert.
Yeah, he's he's the biggest dweeb ever. My sister went to a concert and went backstage at a concert, and he came into the room and did like 3 twirls and like it was like so cheesy and weird. Like, I'm Bono.
Like him, they were saying like, you know how we're playing forward right now, but we're actually playing it in reverse. Because you actually start old and you get younger, and then
What's the theory there? What's the supporting idea there?
everything's
Movie.
inverted.
Well, everything's inverted, but obviously not at our age. We don't age backwards, so.
No, well, that's the thing. You think you're aging, but you're only playing your life in reverse.
Oh, I see. That's
Yeah.
kind of ridiculous. I wouldn't even entertain that, but it's interesting. It's an interesting sci-fi idea, I guess. Have you seen the movie Tenet?
Well, it's an interesting idea for people that can read the future, and the only way that can happen is if it's happened before.
Yeah, but if you did everything backwards, you'd be spitting things into cups. Doesn't work that way.
Okay, well.
Have you seen the movie Tenet? Tenet.
Mm-mm.
That's a good one.
That's
No.
I'm gonna watch that. Yeah, the amazing thing about it is there wasn't as many special effects as you would imagine. They did a lot of that where the actors actually walked backwards and did a lot of that kind of stuff.
Yeah.
I like my uncle. He did the moonwalk 1 year before Michael Jackson.
Is that right?
Yeah.
Well, Michael Jackson stole it from another old. There's an old black and white dancer that did that. I forget his name.
My uncle just used trick photography. He just rewound the
Oh,
video. But my uncle did the moonwalk 1 year before Michael Jackson. Yeah. Good old
here's
Eddie.
the original moonwalk video right here. I'll put it in the live stream.
What do you think Michael Jackson's doing now? Probably drinking some green tea up in the mountains.
Yep.
Writing more music.
Yep. He's not playing
You think
Dave anymore.
You think he's still alive?
Yeah.
What do you guys think happened to him? Like, do you
'Cause
think
it's
White
not
Michael was the same as
I can
Black
tell you.
Michael?
That's the thing
Yeah,
about
yeah.
in the States.
I really
not
want to hear
illegal
what you
to-
think about it, Dave.
It's not.
All right.
It's not
Here's the
Sure,
rundown.
you got something to say. Yeah.
He was involved with some people that were kind of this one lobster guy, I forget his name, but had control of his money basically, and he was kind of controlled in a lot of ways. He had a big thing with Sony going on. He was in debt, even though he was rich, and all this crazy money stuff. And it seems like he made a deal, or whatever it was that you do when you retire your name. I mean, you're just retiring your stage name. Michael Jackson's an industry. So if you're going to end the Michael Jackson industry, you have to have a staged death, and then a whole court battle that goes on after that to make it seem valid and get the ratings for the doctor that was sued and all that. There's a lot of weird things that went on it. But on the day of his funeral, he was on Larry King, it seems, as this character named Dave, who was a burn victim that Michael had helped out when he was younger. I'll put the link in the live stream. If you don't think it sounds like him, I'd be surprised. If you just close your eyes and listen to this guy, it sounds just like Michael, and he's saying things that only Michael would say. Like,
Well, you can
we embrace
I gotta see this.
that embrace lasted a lifetime. Like, only things Michael would say. This burn victim has more confidence for being on TV for the first time in an interview than you'd ever think possible. Right.
But that's not Michael Jackson's real voice, right? Like, he actually has a deep voice. Have you ever
right?
heard his real voice? Yeah, you should look up Michael Jackson's real voice.
kind of like a tranny
That's gotta
puts
be a
it
deep
on.
fake
Yeah,
voice.
he just uses that voice like when he's in interviews and stuff, but it's not how he really talks.
That's interesting. I bet it's a fake video though, because it seems like that's his voice. I don't know. I think he had a lot of hormones going on. But yeah, here's the interview. It's in the live stream.
But it's not
And
illegal to fake. It's not illegal to fake your own death in the United States
Nope.
anyway.
No, you're just retiring your name. It's just a legal fiction name.
Anyone can do it.
Yeah, and it just seems like with these people that have like a lot of fame, it's a smart thing to do, because if you're over the hill a little bit and your career's dying, but you're famous, you don't want to just become like a has-been and people forget about you. You want to have a big going out where your album sales go up and stuff like that, and they make a little cash on the ending of that career. Makes sense to do that. I think David Bowie did that. Prince definitely did that. Prince is playing the part of his sister Taika. Swear to God. Putting on a fat suit and becoming a woman. In fact, his last tweet to his fans was, "I've transformed." And he died in an elevator, right? Not going to let the elevator take me down, right?
Classic.
Yeah. And they use that fentanyl. They always use the fentanyl as an excuse. Definitely, and people say, "Oh, I bet you think Elvis is alive still too." Huh? That's like the triggered response people have. I bet you still think Elvis is alive. Well, Elvis is actually the most provably alive, in my opinion. You want me to link that? I'll put a link in for that. This guy is Elvis, in my opinion. Here,
Don't you think that he'd be dead by now, though?
no,
He'd be pretty old.
let me see. How old would he be?
Because he started off in black and white, man.
1935.
Definitely something going on with the Four Horsemen and Joe Biden. First, it was the white horse for COVID, and then it was the red horse for war, and then there's 2 more horses to go. And the next one's a famine and death. Just those polo shirts he was wearing when he had an interview.
Yeah, Bob Joyce. Bob Joyce seems he became a pastor. He talks about losing everything and all that, and I think that might be the one where he
But
talks
how
about
is
that. But
how
you hear
is
him sing.
Michael Jackson when there's
How
this
is
pictures here of him as a
It's
kid
just him in a mask.
with Black Michael?
No, there's a real Dave Dave. There was a real Dave Dave.
Yeah, yeah. Oh, okay, so you're not saying
He's
that's Michael
playing the
Jackson.
part of his friend.
He was at his own
He
funeral.
went on. He was on Larry King when they were showing the hearse take Michael Jackson's body to the funeral or wherever.
He was the blonde woman in the crowd.
That's what some people think. Yeah, we give him the thumbs up.
Yeah, there was lots of dodgy winking and people looking
Yeah.
back. They knew he was there.
Yeah, the profile fit the nose perfectly. But that's definitely, I think, Michael as Dave Dave on Larry King with the burn victim. And then the real Dave Dave doesn't look like that. It has a different voice. And that guy died recently, supposedly. But he got a little fame out of it, you know. So that was part of the deal, maybe. You can play me on TV, you know, or if you let me play you on TV, then I can, you know, then you'll get a little, he was an artist and stuff. So he got some sales from his art. But did you listen to that, Nate? Did you listen to the voice in that interview that I posted on Larry King? And then when Janet Jackson went on American Idol, she was definitely lip syncing to Michael's voice. So it could have been him singing at the performance, and then she was lip syncing. But you could tell it's his voice, and she's lip syncing. It was after his death. She was holding the mic up in front of her mouth the whole time. Here's that. Or like part of it was her singing, and then part of it him singing, I think. Oh yeah, Prince. Yeah. So Taika, Prince's sister, that was supposedly a crack addict, comes out of nowhere right after Prince's death. Am I still on? Can you still hear me?
Yeah, and she made it famous.
Yeah, she comes out with an album. He tweets to his fans, "I've transformed." Right? They say he dies, and then there's no pictures of him with his sister, even though he might have had one. And there's a different woman that is his sister, maybe too, but he's playing her. And maybe he's only sometimes playing her, and there's two of them. I don't know, but she comes out with an album, and as all of a sudden she's a singer. She's never had a career as a singer before, and right as soon as he dies, she starts singing, and the album's called "A Brand New Me." This one's pretty obvious.
It's good entertainment.
Yeah.
Yeah, it's good entertainment. In the scheme of things, it's pretty low profile for for conspiracy conspiracy theories.
Yeah. It's the world stage. It's part of the perversity of it. You know, the whole thing about men becoming women. I don't know. Like the two brothers that that were that directed the Matrix. They both became women. I mean, that is crazy.
Is that right?
Listen to that. Yeah, the Wachowski brothers. They're both women now. There's a funny story actually that I don't know if I've told on here, but this guy I met when I was serving at this sushi bar near Hollywood and Pacific Palisades. I met this guy named Bob Turr, and he was a helicopter pilot, also ex-husband of Princess Leia. What's her name? Anyway, I was talking to him, and he just kind of offered all this information. And he happened to know a guy I know from my high school back in Illinois, and I ended up calling that guy because I had his number, and he was working for WGN as a news cameraman. So that's how they knew each other, through the news business, because this guy was a helicopter pilot for the news station, and he was one of the two helicopter pilots pilots that followed the OJ Bronco. And he was in competition with this other guy that was also had footage of the Bronco going down the street, right? The one that they put in front of us with the, interrupted the Super Bowl or interrupted the NBA Finals to show us the Bronco, the OJ's Bronco going down the road. Like, what? You're gonna interrupt the NBA game? And remember that everyone was standing around at the fucking stadium watching this on the screen in the middle of a game. This is how much control these people have to put that in front of us. OJ thing, completely fake, by the way. The whole murder, all of it, completely fake, in my opinion, and a lot of people's opinion. It was all about the TV ratings, that whole trial. When do you ever put a trial on TV? Anytime you put any trial on TV, it's definitely for the ratings, and it can't really be legal because you're totally tampering with the verdict. Then putting a trial on TV makes no sense whatsoever as far as the legality of it and everything. There's a whole thing about that. If they have like a certain amount of stars in the emblem, like they have to have a certain amount of stars in the judges in the court emblem, and if it has less than a certain amount, then it's not official and it doesn't really count. It's just a TV appearance. Like they would use that for like the people's court and stuff. Anyway, Bob Turr, this guy, starts telling me about being a helicopter pilot for the OJ thing. And anyway, so the guy that I know, I went back home and was at a party with this guy, and I was like, hey, remember Bob Turr? Isn't that crazy? Bob Turr became a woman, right? He's a woman now. Like, yeah. He's like, you know what's crazier than that? Like, yeah, the guy that was competing with him in the other helicopter, that pilot, he's a woman now, right? So the two helicopter pilots that were covering the OJ Broncos thing have now both become women. And now they used to be in competition and hate each other, but they've bonded over this. What is going on here? too much soy milk or something?
OJ's dad was a cross driver.
Yeah,
Yeah.
and it's a whole cult of them. Isn't it like a whole family of people with this Baphomet type practice going on? I think seems like. I don't know, OJ's dad, huh? That's interesting. I don't know anything about OJ's dad. Well, OJ made a killing with that, pun intended, with the book and everything that came out. Like, I don't think he ever did any jail time, to be honest, ever.
Do you think he did it?
I don't think there's any murders. I think the whole thing was fake from top to bottom.
I haven't heard that. What are your reasons for that?
Well, if you look at OJ joking about it with the banana, and he's going, doing the psycho thing. There's theories about where Nicole Simpson went. Megyn Kelly, the news anchor, people think that's who she became. And Ron Goldman might just be the mayor or the governor of California. I'll put some picture references in the chat here since I'm on a roll here.
That's tough, man.
Yeah. It works better if no one dies. See, these things always work better if no one really dies, because then you can, there's no like blood on your hands. People are even buying into this new theory that it was the son that did it because the son had a knife in his locker, gym and stuff. Just playing it up.
Yeah, this whole OJ did it, didn't do it industry is, well, that's what it is. It's a industry.
Yep, race baiting. Totally a race baiting thing makes everyone, for or against the other race. It's all a divide and conquer tactic.
I'd say they're fucking with your mind, man.
You know that the whole slap thing with Chris Rock and Will Smith. Okay, so then think about what that does. First of all, there's no way a guy's going to go assault another grown man on TV, right? And they're going to let him go and sit back down in his chair and accept an award afterwards without getting some kind of, without being arrested, without anything. I mean, it's unbelievable that people would even believe that'd be like, that's the way it would have come off, like, or that he would have even tried to do that to begin with. But regardless of that, I'm not even mentioning it for that reason. But then Chris Rock happens to be at a Dave Chappelle show, right? And comes out and says something to the audience before a Dave Chappelle show. And then Dave Chappelle just happens to get tackled by an audience member. And it happens to be that the same security crew that worked the Oscars also worked the security for the Dave Chappelle concert. What more do you need?
It's red carpet ratings.
Right? All right, here's pictures of Nicole and Megyn Kelly. Ron Goldman. Gavin Newsom. Ron Goldman looks a lot like Gavin Newsom, that's for sure. Yeah, it seems like there is a reward system. You become a part of the world stage. You get to be a bigger part in another area of the world stage. And that is, you know, like, why would OJ volunteer to be thought of as a murderer? It's because when you're a part of that club, it doesn't matter what they think of you. You get the role as the bad guy. You just own it. You play the role as the bad guy. You know. And then we got OJ telling us something about, you know, put your mask on, all that kind of stuff. You have to play. You also have to do the little promos for their other psyops, right? Too bad about the drummer for Foo Fighters. That's too bad.
Yeah, what happened to him? Is there something else going
His
around?
heart exploded, supposedly. As far as I know, he's dead. I don't know. I don't just think everyone fakes their death automatically, but that seemed pretty real.
Well, I know he's
Wonder-
dead, or I know that the story is that he's dead, but you know, is
Yeah.
there anything going around that he's like that he died from some other reason or something?
Well, just that they were requiring the jab for everybody at their concert, and you know they're fully on board with all. They were at least fully on board with all that. And his heart exploded, so it's very similar to a lot of those soccer player kids that were dying heart attacks post jab. But of course, he was, you know, he was definitely into drugs, but not a drug that's going to make your heart explode in that way. I don't think. Anyway, I probably said too much.
So to keep your mind off the fact that the world's not spinning, bro.
I wonder if Bandsaw. Oh, did you want to say something else?
Nope. What are you saying about Manson?
Well, Nate had some other globe proof that he proposed earlier, and I was wondering if, yeah, like how they shot a neutrino through the Earth, and how the distance through the Earth is shorter than what it is on the surface. Bandsaw said that he was going to look into it. So I was wondering if Bandsaw came to any conclusion about it.
Well, I did slightly, Jerry, and it is a inconclusive test from what I can gather, and there are varying speeds of these neutrinos. Right, so it gets fairly close to the speed of light, apparently, but they do vary, and it is inconclusive. And they stopped testing these things in, I think it was 2012, I think. But from what when Nate was talking about it yesterday, he said they dug a tunnel, a cord, right? Apparently they dug a cord, and shot this neutrino from point A to point B, and it came up with X speed. But then when they equated the actual curvature, because when they shot it through the cord, it happened to equal the speed of light. But when they considered the cord, that's when they got the actual curve. That's when the figure reduced. And I picked him up on that when he was trying to explain it yesterday, Jerry. And he did admit that how he had explained it was slightly wrong, but the wiki page that he linked me to was, say, vague at best. It wasn't too
That's typical.
yeah, too descriptive with the information that I want. And look, at the end of the day, with it all, Jerry, there's a lot of jargon in there that, man, you got to be a goddamn astrobiography, chemistry, fucking physicist, knowing all these equations and bits and bobs to try and even understand what they're talking about to start off with. It's all written in a very, very convoluted way. But I actually was waiting for Nate to get back here so I could grill him some more, and hopefully he could put it in a bit more plain speak. It's a little bit more.
Well, he was here earlier. He was here earlier, and I actually talked to him about it. And he's not here anymore. I mean, he was just here a few minutes ago.
Well, he probably knew we were going to bring it up and debunk him again. I actually I sent him a message actually along those lines. I look forward to debunking him again. But yeah, the way he described it yesterday, like they dug a cord. Naturally, they dug a cord, right? Like they just didn't dig a tunnel; they actually dug a cord to fire this thing in, which was, I don't know, 12 kilometers long. But you know, these neutrinos too. These things are the things that are supposed to come from the sun as well, Jerry, right? And we're supposed to have 25 trillion of these things passing through our body at any one particular time. And they can penetrate anything, right? They can penetrate absolutely anything, from my understanding. So my question to him was, well, if these things can penetrate anything and, you know, go from one side of the earth to the other, pretty much, how do we know that the neutrinos that were actually in the tunnel were the ones that were fired from the neutrino laser gun and not ones just coming from the sun? You know, did we put, like, you know, a dye pack on them or something to be able to recognize the ones that were coming from the laser? So he too was going to do a bit more investigation and come back to it.
Do you know how big is a neutrino
I told him
in
it's
relation to?
I'm sorry, Carlos. Go ahead.
Yeah, like how big is a neutrino compared with an atom?
They're pretty small. They're smaller than a particle, a minus or minus.
Because it seems as though if it's that fucking small, I just don't believe anything about it.
Well, look, when we're getting down to that sort of size, yeah, you do kind of ask questions. But this is Nate's field. This is what he does.
And he's got a whole jar of neutrinos that he can count and he can see them.
Yeah, like there's very particular neutrino tweezers and a neutrino test tube that you got to put them in. Very, very small. Anyway, what were you saying, Jerry?
Yeah.
I was going to told them it's basically a maps argument. And, you know, with maps, you could take any 3D shape and any distance on there, and, you know, you could make it all line up exactly the same. So, like with like any shape, you could, you know, transfer the distances from one shape to another without losing any information.
Yeah. Like it's called the Minos experiment. And on the actual wiki page, it's got nothing at all in regards to the curvature of the Earth and how they compared the chord path to the curvature path. Absolutely nothing, not even mentioned there.
Yeah,
So I don't
because
know.
if they had that information, you'd be able to see how you could measure if there's a curve or not. And that hasn't happened so far.
Yeah. And the things apparently move at plus or minus 0.0012% the speed of light. So they're pretty much the same as the speed of light. Now, what medium are they talking about too? Because I'm kind of gathering that in a tube that is 12 kilometers long, that ain't going to be the medium at which they actually worked out that speed of light in that vacuum. They wouldn't have been able to pull a vacuum that small.
Did you say they travel slightly slower than the speed of light? 0 point something. Yeah, just slightly slower.
Well, their very first test was it worked out to be slightly quicker than the speed of light. And then they did multiple other tests, and they got like I said, a plus or minus of 0.0012% of the speed of light. So it's not very conclusive whatsoever. But
Because there's
anything,
not supposed to be anything faster than the speed of light. Yeah.
well, not that we know of. Not that we know of. Like apparently the speed of light is the fastest thing, but that's only what we know. There may be something faster than the speed of light, like one of these neutrinos or a bloom pino or whatever the case may be. Ouch. Ouch.
Because the way I see it is, I come from the position of, like, I don't know what the shape of the Earth is, right? So any data that we get, you could make it fit any model. So I'm not necessarily doubting any of the data. It's how we represent these distances or whatever.
Yeah, it's interesting that you posted it a few months ago. I think is it Toulouse or Toulouse?
Yeah, Trulon.
Yeah, Trulon. You know, basically you can get any coordinate system and make it fit absolutely any shape, you know, whatsoever.
Yeah, like his site and what, like, because I talked to him through like DMs, and he really opened my eyes as far as, like, how models are made. And it's like, dude, we can't know without assuming like different things, like frames of reference and the nature of light and what space is. Like, we don't know. So, it was a real head trip. But I had to come to terms with it.
But the actual experiment that that Nate was referencing, they like I said, they closed it down in 2015 or 2016. It got decommissioned and stuff for whatever reason.
Well, Godric is here. I wonder what he thinks.
Hey, what's up, guys? How's it going?
What's going on? Have you heard this latest argument from Nate?
No, tell me about it.
Okay, so these researchers in Minnesota and Illinois shot neutrinos through I think a vacuum tube from, like, over the span of like 700 miles or something. And the distance that it took under Earth, in other words, a chord line from one spot to the other, is shorter than the distance traveled on the surface of the Earth. There's a picture somewhere in chat if you scroll up.
Is it? Can you post it in live stream? I'm not sure I follow you. What do you make of it?
Me personally, I think it's a maps argument, and with distances, you could you could represent distances and paths on any 3D shape, and it would be exactly the same because we don't know what there's like bumps and there's Coriolis and all, so we can only model like all motion.
I just want to know who the engineers are that actually made this chord line, because they've got some secret technology on making a chord line.
Let me ask you this: what do neutrinos have anything to do with it?
The speed of the neutrinos to get from point A to B. So over the length of this vacuum, which was, let me try and find it.
12 miles.
12 miles, thereabouts.
I think that.
Yeah. So 12 miles in a straight line. It went X amount of speed. Well, apparently, if it had have travelled the curvature route, it would have taken longer. So, so now you've got to say to yourself, well, is that how they set up the experiment? Like, did they build a tunnel, dig a tunnel that was a chord, actually, to test the speed of these things to see if it was going to be shorter from quicker from point A to point B than what it would be on the surface? And did they build a tunnel on the surface that actually had a curve that was 12 miles long to test the same sort of theory? I doubt that. So to say that they actually just dug a tunnel underneath the ground, and it was 12 miles long, does not mean a thing, really. It's just a tunnel that was 12 miles long.
It's just a straight tunnel, and they have nothing to compare it to. They can't.
No.
They can't say, well, this is a chord, because they can't prove that there's a curve or not.
Mm-hmm.
So it's kind of a meaningless. Like it doesn't have any essence, really.
It might be maybe slightly more believable if they had built a tunnel that was 12 miles long that started at the surface and exited the surface, and there was a big hump in the middle of it, of Earth, maybe, but they didn't do that.
Correct me if I'm wrong. What they're saying is they shot neutrinos 12 miles in a straight tube underground for 12 miles, and that covered more than 12 miles on the surface because it was curved. Is that what they're saying?
No, they're saying that the speed at which these neutrinos took to get from point A to point B over that 12-mile length would have been longer. And they're not saying it in the experiment, Godric. This is what Nate is saying. If it had have actually gone the whole length, that curvature length, those neutrinos would have taken longer if they had gone the actual curved length. But that's not why they did the experiment at all. The experiment was not to prove the curvature of the Earth.
Well, it'd be good if someone could come up with a neutrino laser, because apparently it can penetrate anything.
Exactly.
But I wonder if you could actually use it as a tool to give you data which will allow you to know if it's actually what it's penetrating and when it's penetrating, so that you could actually see if you're going in a straight line or not. Do you have to have it in a vacuum?
Well, apparently it was done in a vacuum, but who knows what sort of vacuum they can pull in a 12-mile long tube.
Well, I thought I heard that neutrinos don't have a long life. Like I thought that I heard that they die out over a certain distance. That they don't, like, if you fire them through imaginary space, they wouldn't just go forever like light does. They would just diminish.
Neutrino sounds like some new healthy cereal. Breakfast cereal.
Tastes like a chocolate milkshake, only crunchy.
The experiment wasn't to prove the Earth. What was it? What was the experiment for?
Oh, if I know.
That's the only thing I can think. They're just trying to tell you that it's a ball. I can't think of any other reason why they would
Because it sounds
dig
like the
12-mile trench.
it sounds like the Lego structure. They try to say the Lego structure is perfectly flat, except that the elevation from sea level is
Oh, here we
exactly to the point where it would curve if the Earth was a sphere. So
There
it's
he
very
is.
similar to
go.
me. That 4 miles is 12 miles.
I knew the bait would work. I knew the bait would work.
Yeah, Nate, it looks like you're gonna have to go back to the drawing board, man. This is pretty weak.
What happened?
Wow. Well, the usual, right? It just took a little bit of thought power, just a little bit of thought power, and a little bit of research. Actually, not much, about 15 seconds worth of research into to debunk to debunk this like now. So first of all, where in this experiment were they trying to prove the curvature of the Earth? Number one, right? Nothing is
Oh,
mentioned about that whatsoever.
so
And
as
and two, right? How did they know they were digging a cord? Is number two, right?
And how do they know that
And
neutrinos? How do they know neutrinos come from the sun? How do you know that they're not starting from the upper atmosphere of the Earth with some reaction?
okay, so when neutrinos come from, whether or not we know they come from the sun or not, that's not really that relevant. They do exist. They are a thing. We do detect them. Bandsaw, to answer your question, I never said that they did this experiment to prove the shape of the Earth. That wasn't the purpose of it. It wasn't even an experiment. It was a measurement, because all they wanted to do was measure the mass of a neutrino.
Yeah.
That
Well,
was the whole purpose of it.
you kind of did allude to that yesterday.
Yeah, I'm
Yeah.
presenting it as
Yeah,
evidence.
exactly.
Yeah, but
So you
they never did the
presented
experiment to prove
no, not
the
at
shape
all.
of the Earth. Yeah.
No, all
Yeah.
they did was fire things for 12 odd miles, and
Yeah.
you've taken. But if it had have actually gone 13 miles, it would have taken longer. You've extrapolated curvature into the experiment in a very sneaky and underhanded way, I must say.
How is it sneaky?
Right?
What?
Exactly.
But it makes
Very.
perfect sense, Fairs.
No, it actually makes no sense whatsoever, considering they only shot at 12 miles. And to turn around and say that these neutrinos actually would have taken longer to get to point A to point B if they had have gone 13 miles. Well, duh. Obviously, they would have taken longer. Like, who's going to argue that they wouldn't
Oh,
have
but
taken longer?
yeah, but Ben, so I'm talking about this specific one, the Minos
Yeah,
experiment, right? From
exactly. Yes.
Fermilab to Soden, it's
Uh-huh.
730 kilometers. It's not. It's way longer than
Ah,
that. 730 kilometers. That's the
yeah.
surface distance, right? If you had to draw a straight line on a map, regardless
Uh-huh.
of Earth being a sphere or flat, you know, the distance, a straight line between these two places on a map, is 730 kilometers,
Uh-huh.
right?
And these
Now
things traveled in a perfect
they
straight line,
drew,
did they?
yeah. Now underground, they built a perfect straight line between these two places underground. But it turns out the tube they built underground is shorter than the surface distance. But
Okay.
it still connects these two places. Now,
Okay.
if underground a straight line is shorter than the same straight line on the surface, that must mean that the surface is curved.
You're getting ahead of yourself. Now, firstly, how did they draw a perfectly straight line underground for 735 kilometers? Is number one question. How did they do that?
What do you mean? I mean, we can put
What do you mean? What do I mean?
hang on, we can put fiber optic cable in all across, you know, shorelines, right? From
In a
Europe to Africa, from North America to South America. We could easily drill a hole underground for 700 kilometers. Like come on, that's easy, man. So
what a
that's not that
perfectly in a perfectly straight line for 735 kilometers? No, we can't do that. We can't do that at all.
Why not? We can't. Why not?
Because we're
I mean, we
we are mere mortals. That's why we are mere mortals. Right? We can't do it. We're lucky to be able to do it for 5 meters, let alone 735 kilometers. Come on,
You
a
think so?
perfectly straight line for 735 kilometers. Yeah, nah. You got
Yeah,
to do
it's
better than
about
that.
450 miles. Yeah, give or
Yeah,
take. Yeah,
perfectly straight. Perfectly straight.
perfectly straight. Yeah, like what's I don't see
Per-
what the issue is. Ben.
the fact is, it's perfectly straight for starters. Like, no wiggle room in there. Not just like a little bit of a dog leg here or there. It is perfectly dead straight.
No,
Yeah, exactly. See, now you're having to think about that one, going because you made a
no. I
wiggle
mean,
room.
it's perfectly straight. Like I don't know what else to
Really,
tell you, man. So
really.
yeah,
I want to
I
see
mean,
a
you could look up
citation.
this.
I want to see a citation where they actually dug a perfectly straight tunnel for 735 kilometers.
I have a
Perfectly
question.
straight. Yes, go, Jerry. Jump all
Could
over
you
me.
okay, so since it's perfectly straight, could you see clear to the other side with like a telescope or something?
Yeah, they shoot the beam so that the neutrinos hit the detector that's all the way on the other side.
So there's no horizon, right?
I don't know. I don't think so. I would have to think about that, Jerry, but I don't think there's a horizon. Oh, I think if you
And
could see far enough, if there was enough lighting, you should be able to see the other side.
and now you've got the other problem, right? Because yesterday, right? Because these things have mass, right? We discussed this yesterday, right? These things have
Uh-huh.
mass, right? And now, from going from 12 mile, we're going to 735 kilometers. And you suggested that such a short distance, they wouldn't really get affected by gravity. There'd be no curvature in their path whatsoever.
No. What I
You,
that's not what.
yes.
All right, let me explain myself. Let me explain myself, man.
You
So,
better.
firstly, these things are traveling at the speed of light, and they have a very little amount of mass. It's
Uh-huh.
almost
Yep. Minute.
non-detectable. That's how.
Exactly.
Yeah.
Yep.
Yeah, but they have mass, but it's almost non-detectable under certain circumstances, right? But they are traveling at close to the speed of light, at a
Exactly right.
relativistic speed. And when you are traveling at such a speed, mass attract mass doesn't work anymore. We don't use Newtonian mechanics at these type of velocities, at these type of accelerations. We
Really?
use special and general relativity, yes, because Newtonian mechanics won't give you accurate predictions, accurate results at these
Really?
speeds. That's why we saw it using Einstein in space time. That's the
So you
whole. That's what we mean when we say that Einstein didn't replace Newton. It's just that Newtonian mechanics can't make these accurate predictions at these kind of speeds. That's all.
so are you suggesting that if I stand on one end of a diving board and run fast enough, I can run off that diving board, right? And keep my horizontal line and not curve down whatsoever, just in thin air, because mass won't be attracting mass. I'll just be running in thin air all the way across that pool because mass isn't
If you could
attracting mass
travel
anymore.
at the speed of light, for sure, why not? You're moving at the speed of
Really?
light there, so yeah,
Really?
but
Okay.
weird things would start happening, and we don't need to go into what these weird things are
I've
that
Yeah.
will
got a
start
question.
happening. But
Well, definitely weird things would be happening. But now we're in a tunnel that is 735 kilometers long. That is what is it a vacuum? Is it a vacuum?
Yeah, I've got a
I
question like
no,
about
it's
these
I don't think it's a
neutrinos. So
vacuum
how,
because there's
mate,
Okay.
people inside working within the tunnels, so it's not a
can
vacuum.
you
They can breathe.
like I'm a little bit confused about this neutrino. Like apparently they can come from the sun, which is above us, right? In one direction, from
Yeah.
up to down. Yeah. Like so, how do they get this neutrino and isolate it and then fire it and actually and fire it in one particular direction across this tunnel at almost the speed of light? What mechanism would they use to make it go that fast? And
Jeez.
how did it start from a standing
Okay,
still?
A
you asked me
slingshot.
to explain a lot, but all right, I'm explaining it. But there's a picture I need to post that will
Right.
help me
So
explain the
now,
fundamental mechanism.
so now we have this neutrino traveling through a medium, right, which is getting affected by a medium that is not getting affected by gravity, that
Mhm.
travels in a perfectly straight line all the way down the center of this perfectly straight tunnel, which ain't perfectly straight because man built it, and it's bouncing all the way off the sides of this tunnel all the way along till it gets to the other end.
Yeah, and you had it in a jar and you put it in a loaded gun, which can fire something to that speed.
Told you, Nate. I was excited, Nate. I was excited that this was going to be it. I really was.
The what?
Neutrinos, to me,
Relax yourself.
it's
I've managed to
really
answer
powerful.
all of your questions. You guys haven't found nothing wrong with it yet.
I
So,
don't know.
Really?
um,
It
yeah, like
seems
okay,
like
so I mean, I basically explained what the experiment was, what the consequences of it were, and I've
Uh-huh.
managed to answer all of the questions around the neutrinos, how they can move so fast and not be affected by gravity.
yeah, but
I know
how did they fire it?
by the whole mass attracting mass idea. So how they fight it is they so I just posted two images showing how neutrinos can be made in certain situations, such as with the sun. What would happen is that you would have two hydrogen atoms pushed together, um, and they overcome the electromagnetic force, which is trying to repel them. The strong nuclear force takes over, and this turns into a helium atom. And as it turns into a helium atom, energy and a neutrino is released. And this is happening, thousands of times a second within the core of the sun. So billions of neutrinos are being produced all of the time through this process. And because they are being pushed out by all of the energy within the sun, and because they are almost massless, they're able to travel at very fast speeds, close to the speed of light. So they leave the sun, and because they have no charge, they aren't affected by electromagnetics, and because they're almost massless, they have a very weak interaction with baryonic matter. That's why they're able to go right through you. You know.
So
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 what
these,
they. Uh-huh.
So do
these
they have a acceleration? Do they speed up, or are they instantly going that speed like photons?
They're instantly going that speed.
boom, that's pretty quick. So do
Mhm.
these things like light? Do they get bent around and pushed around and pulled around planets as well, and stars?
Neutrinos?
Yeah.
What do you? No, a neutrino isn't a photon, so
Well,
So
it's
they're not
not.
affected by gravity.
I know. Well, no, they have to be affected by
What?
gravity because light is affected by
They
gravity.
are affected by gravity in a very different way. So what a neutrino will experience, because it's traveling at these, relativistic speeds, is it'll experience length contraction and time dilation. So if a neutrino is traveling from Earth to Mars at close to the speed of light, what will happen is there'll be length contraction in its direction of motion. So if you were an observer watching the neutrino on your horizon, what you would see is Mars would seem to move closer to the neutrino. The neutrino would seem to be standing still, and the space between it and Mars would appear to contract. And the neutrino, from its point of view, it would experience Mars coming towards it. It wouldn't feel.
Oh, you're roboting.
Wow.
Cut out. Yeah,
What
there
do you
we
mean?
Do neutrinos have like good personalities? Because
I'm
I
lucky,
tell you,
lucky this
they
is
sound
recorded
like
because he's going to remember all that.
they sound like vicious little bastards to me if they're
No.
going through me all the time.
It's not. So light or photons are affected by gravity, but neutrinos have a special property that they're not affected by gravity.
No, they're affected by gravity the same way. So what I just described for a neutrino is the same thing that would happen for a photon. A photon doesn't experience time and space because it's massless. So for a
So
photon, everything happens instantaneously. So it
okay, so
experiences extreme time dilation and extreme length contraction. It's
all right,
traveling at the speed of light.
so we know light is affected by the medium at which it travels through. Right, that's a given, right? Yes.
Yes.
Okay then. So this tunnel, right? What sort of medium was this tunnel that it traveled through? Because it wasn't a vacuum.
It was normal. It was normal. Normal
Tunnel,
air. Yeah.
normal
Yeah. It was just a
tunnel air.
tunnel. Yeah.
Okay,
Yeah. Normal
so
tunnel air. There was normal air down there. Yeah.
okay, and
Made of
this tunnel
clay.
and this tunnel air was consistent all the way through it.
So remember what I said. Neutrinos, because they are very massless, are not affected by the electromagnetic force, right? They're not affected by charged particles. So they can move through a medium without being affected by it. That's the same way they can travel through you is the same way they travel through air. They have a neutral
How
charge. They don't interact with charged particles. They only have a very weak interaction mediated by the weak nuclear force. So they just travel right through the air, right through you, right through me. We don't affect it the way we would affect light, because what happens with light is light travels through charged particles, and the photon is emitted and absorbed by the electron, which is a charged particle. It has a negative charge. So that interaction is what, in a way slows light down. But with a neutrino, that doesn't happen because it doesn't interact with electrons. It just travels right through.
so how would you compare like the waves from your Wi-Fi router with a neutrino? Are they on a similar size?
I think a
Because
neutrino would have a way higher
your
frequency than
Wi-Fi
Wi-Fi.
signal, your Wi-Fi signal can go through anything, right?
Yeah, it's a very long, low frequency wavelength, so yeah, it can go through walls and things.
So it's just a frequency, actually, isn't it? It's not a
What
particle, is it?
in neutrino? No, in neutrino is a
Yeah, it's
particle.
just a
But
frequency,
obviously,
right?
particles it has a certain type of oscillation. I mean, it does have a frequency. All
Yeah, I
matter has
mean, if you
some sort
haven't
of
actually
frequency.
picked one up in your hand and actually proven that it's a particle, then I would say it's a frequency.
No, but we detect them. It's just it's
Yeah,
hard to
you can
touch them
detect
because
the
they go right through
frequency
you.
too. So, what device are you using? I'd say it's a frequency detector.
Can I ask something else, Nate?
Yeah, so
Uh-oh.
What's are there applications to this? Is there like a so what factor for the ordinary human right now that, like, I don't know, do you put it into windshields? Does this help you
no,
calculate
not
You can drink it
no. This is, I
with
mean,
vodka.
neutrino. I mean, it's kind of brand new science.
They're a
There's not much
breakfast
we
cereal.
can do
We've
with
already covered that.
neutrinos yet. But the whole purpose of this measurement, the Minos experiment, was just to measure the mass of a neutrino. But in the setup of a measurement, they indirectly prove that Earth is a sphere.
And
Yeah.
I would like to know
That's quite good.
how much mass does a neutrino have after that experiment?
You can Google it. I don't know off the top of my. I don't
I
remember off
mean,
the
you're
top of my head.
talking about this experiment. The whole purpose is to find out how much mass it has, and you don't even know how much mass it has.
I don't even know what its
I
mass would
forgot,
be
bro.
measured in.
I forgot.
Very,
It would be
very,
measured.
very little numbers. I'm gathering.
Yeah, very little. Very little. Yeah, I think it would be measured in EVs. You wouldn't measure that in grams. Like the same way we measure the mass of an electron, it's not in grams.
How do you measure the mass of a Wi-Fi router signal?
Like, electron volts? I don't know. Why would you want to measure the mass of
Well, because that's more
an electron
relevant
of
to our
a Wi-Fi
day-to-day
router signal?
lives than some fucking neutron, neutrino.
Yeah, like I said, we're still trying to understand what all these things about neutrinos, so they don't have real world everyday
Hey
applications
Nate,
or
hey Nate,
any sort of utility right now.
um, are you still a student of the subject, or are you still at university, or?
No, I'm done, but I still work around it.
What do you do? What's your work around it, if you don't mind?
Stuff. I don't really want to talk about myself though. But yeah, writing. Are you familiar with the Minos experiment?
I don't understand even the first part about all this kind of stuff. It's fascinating listening to it. It's I think joined halfway through, but it's fascinating listening to it.
Okay. So let me catch you up on it. If you scroll up a little bit in the live stream text chat, you'll see there's a image I posted showing a line between Fermilab and Soden.
Oh yeah.
Yeah. So the whole they wanted to shoot neutrinos through this underground tube they had built between these two locations, right? So the distance is about 450 miles to 735 kilometers
Awesome.
on a map between these two places. But when they drew the tunnel underground, they realized the underground tunnel was 12 kilometers shorter, but it still reached these two places. So if you have two straight lines, right, and one line is shorter than the other, but it still reaches that place, then it must mean one of those lines is bent, curved.
Correct.
Yeah.
How
So
did they
that's the
measure the?
implication of it.
How did they measure the tunnel?
Guesswork.
But
I think they just
yeah,
guessed
but
it.
the
Eyeball
yeah, but the
heel to toe.
yeah, but the intention of the experiment wasn't to prove Earth was a sphere. It's pretty obvious from this experiment that it shows that.
But they are still part of the Illuminati cabal, obviously, because
Yeah.
they proved that Earth was a sphere, and that's what Illuminati cabal do.
Yeah. Do that. Yeah, I feel this is pretty damning evidence. You know, like I don't know.
Yeah, well, they first have to show us neutrino, and then we might start thinking about it.
In order for me to accept any one bit of proof, you must show me first a proof for a totally different thing that wasn't about this conversation. I think I admire your determination.
I think you just missed the conversation then, Eggshells. That's what it was about from the start.
Right, but you don't need to hold a neutrino to come to any conclusion about a tunnel, do you?
Yeah.
I don't know.
Like even
neutrinos?
We just show it exists, don't you?
no, we can't hold neutrinos. They go right through your hand. But even
Yeah.
if neutrinos didn't
how did they
exist,
fire
the
it?
tunnel is still there. They still built this tunnel, guys. It's the
I
tunnel that
would tell
matters,
you one thing. I
not
would
the
tell you one
neutrinos.
thing. Like, you can measure light, right? And it doesn't. It's not. There's no mass in a photon, apparently. But this neutrino can go. Light can't go through anything, but this neutrino can. So, what fucking magical device are you using to measure something that can go through anything?
Bro, the neutrinos don't matter. It's the tunnel you should be focusing on. Right?
Nah,
Like, I
I
don't know
want to
why you
know.
guys are
I mean,
dodging, ducking and
this is
diving from the
magic
tunnel.
material that you've got in this device.
If they were shooting
measure a
water
neutrino that
or
goes
if they
through
were
anything,
shooting
wouldn't
ice
it just go
cream
through
through the
the device?
tunnel, it doesn't matter. What matters is the tunnel itself, man. Come on. It doesn't matter what they were shooting through. They could have been shooting pony farts through it, you know? No one cares.
But
We
we still
it's
didn't
the
tell them that
tunnel.
the tunnel was straight, do we? You said
It
you
is
didn't know it
straight.
was straight.
You could be
It
shooting
is
blanks into that tunnel.
You should
Yeah.
dig a Wibbly tunnel through the earth and say, yo, the earth is round. Cool.
What?
Well, what it is evidence that the kind of people who should know on the kind of engineering feats or maths or of the people on the planet who should know whether the Earth is curved, they seem to find that it is, and it is only amongst those whose jobs don't intersect with the shape of the Earth that think it's flat. And this is a good example of people who should know it because they had to make a very, very long straight tunnel. Seem to say globe.
Yeah, like that would make travel around the world much faster if they just dug fucking cord lines all around the world, and we would get to France much faster.
You get we wouldn't. 12, so you get a 12-kilometer discount over a 735-kilometer journey, but you had to dig a dead straight tunnel with only one entrance and exit to get there. And this was deemed to be more efficient. I think we could see something like that.
But they actually did have to correct for Earth curvature when they dug the channel tunnel here. And that's only, 28 miles, I think.
And was that like a drop of 1 inch per 8 miles?
No, because that's a tangent line from a curve, isn't it?
You know, the accuracy in engineering to even think about measuring that type of a difference, like like 1 inch. Oh my god, it's like if you get a rock in between your just a tiny stone in between two plates of metal, you know, that's not noticeable. It's gonna put you off. just the deformity in the metal itself is going to put you off. You're never going to get that level of engineering.
So all of a sudden, tolerances are a thing. I love it.
They are a thing, and they also they're not something that they're not something they can rely on to say that they've even measured the Earth's curvature.
Why?
Because there's too much error involved.
Well, how do you know that?
Because the distances are so great, you can have one pebble in between two plates of steel over a kilometer.
Yeah. That's fine that you could potentially have something that would bring an error margin into a measurement. Don't have a problem with that. Why do you think they cannot account for that?
Because they made the mistake in the first place by not noticing it.
Well, again, can you give me an example of where they didn't notice it?
Because they have fucking imported fucking Filipino workers.
That's not an example of where that's a straw man at best, an ad hom towards Filipino engineers at worst. I'm asking for a specific example where this had an effect on an outcome. Do you have one? You made that claim. No is acceptable, and I'm not going to hang you by it.
I just don't think it's possible to be that accurate.
Okay, so why do you feel that your argument isn't strong enough that you had to distort your evidence to try and make your point?
No, you're on the wrong track. What we were talking about is these new magical neutrinos that can go through anything, and they've got this magical device that can measure it, but it can go through the device.
That's not the conversation we were having. We were having the fact that errors come into measurements, which I totally agree with. You know, we have our tolerance for the instruments involved, and it was you basically saying that we cannot account for these error margins in any sort of boundary, and I'm trying to figure out why you think that. That's the conversation we're having, mate.
My conversation is like, what the fuck is this neutrino, and how do they know it's what it is? Why can't it be comparable to a frequency? And how fucking big is your Wi-Fi frequency anyway? Is that a particle?
Well, that's total non sequitur from what you're talking about, because a frequency is just, again, it's another measurement that we're taking.
What is it? Is your Wi-Fi frequency a particle?
Well, there are particles involved in it, yeah.
What, you mean the medium that it's going through?
No. That's part of the electromagnetic spectrum, isn't it?
And I bet you they're measuring the neutrinos in the electromagnetic spectrum.
Why do you think they're measuring neutrinos in the electromagnetic spectrum, considering neutrinos, by definition, have a neutral charge? And magnetism only affects things with charge, whether it be positive or negative. So again, I don't know why you're getting down this route, mate.
It's very fairy tale to me, man. It's a big fairy tale.
Cool. That's a lovely opinion, and you're totally entitled to it. I respect that.
I am entitled to it because I haven't seen any evidence otherwise.
But you're making claims to evidence to the contrary that you can't produce. Is that reasonable?
They're not claims. Not claiming anything. I just don't believe it.
No, you made a claim that the fact that we couldn't account for these errors, and you said you had an example, and then when pushed to provide it, you decided not to and changed the subject.
What do you mean when you say we? Were you doing the experiment?
I've done some experiments in my life.
So did you dig the tunnel?
That's not an experiment. That's a feat of engineering. I think you
so you automatically take the side of the neutrino scientist.
Well, I don't think I take the side of anybody. I'm persuaded by the evidence at hand.
You just believe everything that is handed out to you on a big silver plate.
No, I just said the opposite to that, didn't I? I'm very specific in what I say, and I back up the shit that I say.
Because gullible,
you're
they
kind of running away from
Yeah.
the argument right now, callers. You're just making it personal.
Yeah, well, it's just there's just too much. There's too much bullshit. To be honest,
What's the bullshit?
this neutrino bullshit.
What about it?
Show me one.
Okay, so that's cool. Show me an oxygen molecule. Show me a molecule of carbon dioxide.
Yeah, that's actually something that you can see in the microscope, right?
Have you ever done that?
Why would I?
Well, are you just believing what people give you on a silver platter?
I mean, people just spend too much time investigating nonsense.
Yeah, you just fucked up there, don't you? So I guess the natural follow-on question from that is, why is your silver platter better than my silver platter?
We are all one. Yeah. I am you and you are I.
I'm really not you, mate.
Everything is consciousness.
No, it isn't. There's the conscious and the unconscious. So we've already got separation in those two categories. So that's a false statement.
There's also the subconscious, which is in the middle.
Ah, so you agree that everything isn't consciousness then? Whoopee!
No, it's all consciousness. They're just divided into three.
Welcome back, Gus. Welcome back.
So, we can all sit here and make vague, nebulous kind of statements about, what our opinions are. That's cool. We can all do that. But
my platter's shinier than yours. There you go.
I guess the point of the statement there is, so what?
Yeah, well, I want to know what White thinks of a neutrino. What's your honest opinion? Is it a thing?
I wouldn't have a clue, mate. It's a story. I don't know how true it is.
I think they're pushing shit uphill.
Why?
Because there's no end result. There's no essence to the story, and there's actually no reason to even go down that path.
What, the understanding of how what stuff is made of seems pretty fundamental to me.
But it's all in the imagination. It's just made up.
Well, can you provide any proof to that claim?
I'd need proof from the other side to show that
Then
it's
why
real.
make the claim?
It's not a claim.
You made a claim.
When?
When you said it's all made up. That's a claim. You do realise that, Bamboo?
That's a statement.
And a claim. A claim can be a statement as well.
You know, I used to be an English teacher, right?
Yeah. You know that I speak English, don't you?
You do. You speak absolutely English.
And I speak it pretty well.
Some dialect.
And some dialect. In fact, some dialects.
I'm pretty edgy tonight. I had a fucking bad experience, and I'm drinking. It's supposed to be a tequila sunrise, but it's a vodka sunset.
Sounds like a plan.
Nice.
So are you saying that a claim and a statement have to be mutually exclusive? exclusive in the English language?
The way that I said it was.
Really?
Mm.
How does it not entail that when you say something is not the case, that that is not a claim?
Wow.
Or something is the case, then that is not a claim?
How do you prove that you're not insane?
With word salad.
A number of ways, but generally consensus of how I operate within society is a reasonable way of saying it. But then again, what is insane? You know, we can go down that rabbit hole. Is insanity not conforming to the norm of society? What if society itself is insane?
I think you got that spot on. Absolutely.
Yeah. It's a philosophical argument I've heard a number of times, mate. See, I'm very into epistemology and ontology.
Well, is the nature of man evil or good?
Neither.
That's what I tried to say in
Evil.
my thesis.
I mean, it's not you can't create the nature of an entire group with any with any specificity, which is what I can't say. So
That's
sorry
what
about that.
You can say it.
Well, you just make generic terms which tend to be fairly vapid and not very valuable.
Right, good or bad compared to what is the
Some of them
question?
are pretty bad, man.
Yeah, good about compared to what?
We're originally bad, but we teach ourselves to be good. Is that better?
Well, why? I don't think, my kids have never been particularly bad. They're pretty nice. Have been all their lives.
They haven't fought over a toy.
They're not exclusively pure and innocent. Never made that claim. But what I'm saying is that individual actions we tend to evaluate, and you can put labels like good and bad on them if you want. But generally speaking, my kids have been taught the best that I can teach them. That's what I've tried to do with my kids. And one of the things that they understand is they're responsible for the shit that they do. And shit has consequences. But when you sort of start to want to say, this is always good, this is always bad, then you start to get into an objective standard. And the trouble is, all standards of morality have been written down by man. However you want to say that they may have come from a divine source or not, they're still in our subjective interpretation. So objectivity is a bit problematic with that particular issue.
So would you say, you said that man, when they're born, neither good or evil, but neutral.
No, I just said, I didn't say when they're born. I just said as a group. You can't sort of say that a group is A or B. You can say, well, we see a bias in the group towards A or B, but you can't say the group equals A or B. Do you understand?
臭味相投. It's a there's a saying in Chinese. It means in English it's called what is it? Birds of a feather flock together. So it's really like who you hang out with. That's the type of person you are.
If wishes were horses, beggars would ride. Did you know if ifs and buts were pots and pans, then you and I'd be tinkers?
You manifest your own reality, and there's a it's up to your own will at the end of the day. But the people that are ruling this world don't have any empathy. They're just narcissistic. How do you say that word?
Narcissistic.
Yeah.
Narcissism.
Yeah, that's right. So this is what we're dealing with.
Well,
in this
again,
world.
that's another claim. I don't know the truth of the validity of it.
Well, it's a real thing, right?
What is?
Narcissists.
I think there are people that have been judged to be so. Does that make narcissism in itself a real thing? It's a pattern of behavior it's just a pattern of behavior we're given a label to.
All that means is that people love themselves. They look at themselves in the mirror, and that's all it means.
No, it's more than that, but...
Oh, I agree with Dross.
How
Wow.
is it more?
Shit.
I'm fucking logically consistent. Yeah, I mean, it's back to the insanity thing. You know, it's a perspective. I mean, there are some things that are at the end of either end of that kind of bell curve of behavior. And the thing is, the further away from the center you get, the less acceptable that behavior comes, and the more likely it's going to enact a social reaction. Because people get scared of things they don't understand. Or those people can be scary because they're dangerous. You know, we all had a mate when we were teenagers, early 20s, who was the guy that used to just fucking love getting into a ruck. And he'd drag everybody in with it. Now, does that mean that we were all up for that ruck? No, it means he was, and, you know, he dragged the rest of people in because of group loyalty into that problem.
Herd mentality, mate.
Yeah. Well, it's a little bit. I mean, I think that those type of situations are a little bit more than herd mentality. I think that's more about a group dynamic. And there's a difference between being a member of a herd, a sheep, if you like, and just going along because everybody else is, and actually having loyalty for an individual within the group. I think that's where friend dynamics come a bit different from herd mentality. Right, so I think I have to go because I think I should be in another meeting.
Oh, just before you go, are you gonna would you, if you had a choice, would you learn Russian or Chinese right now? And if you had to learn one of them?
Neither. I'd much prefer to learn cuneiform in Akkadian and Sumerian. And if I was going to learn Chinese, well, I can't learn Chinese because that's not a single language, is it?
Mandarin.
Husho. I'll learn an obscure dialect.
One of the 56 dialects.
But probably if I was just being merely a material individual in the reality that we live in, chances are I'd probably learn Chinese of some form, Cantonese, Mandarin, something like that. It would be more useful.
Don't bother with Cantonese.
Learn Russian just because it fucking sounds good. No other reason.
Vodka. Yes, vodka.
And it would really help when you buy the army surplus stuff online to actually be able to understand the manual that comes with it. That'd be really good.
Look, we all have narcissism, just some people hide it better.
That reminds me of a saying: we never really learn how to, grow up. We just learn how to act in public.
Right? Just think if people knew what you were thinking all the time.
There wouldn't be any friends. Nobody would be friends.
We'd be very suspicious of each other.
Well, either nobody would be friends, or the friends that people had would be, there for life. Because you know what the other person is thinking all the time.
There'd be no more little inner voices and little inner demons, questioning yourself. It'd be very different society, that's for sure.
Yeah.
Just think you couldn't lie to anybody. Or unless you really...
Nah.
can control your thoughts, you can do it, I guess, if you were practiced at it.
That would be difficult. Very fucking difficult. You have to control your dreams as well. Good luck.
If you believe your own lies, you would get away with it.
Yeah, but the subconscious in the dream knows the truth. Anyway, that's an interesting thought.
I think we all put on this poker face. Most of us don't share our thoughts. We just kind of have a facade of what we show the world, but not show the inner self.
An avatar, definitely, mate.
Right? It's like
Unless you've got a close relation, you know, a wife or something, in which case they might see the true facade.
even my wife doesn't know what I'm thinking.
Oh, I bet she does. And if you live with her long enough, she will.
Does anybody know what sea level is and how it's determined? Like in real life, not what they say it is.
Say that again.
What is sea level and how is it determined?
I'm not sure, but I do know that it varies. The actual level of it varies. It's not like a one datum line. Like the thing that stays the same is the geoid.
Do you think they can see and detect neutrinos at night?
What's up, dudes? What up, J Dog? Can you guys hear me?
Loud and clear.
All right, on. My mic's coming in pretty good.
Like a whistle.
Or is it kind of shitty?
It's good.
Oh, cool. Hey, so about that glow earth, man?
The one that banging on about all the time. That one.
The one that what?
The one that banging on about. The very persistent
I
one.
only know of one, man.
I think sea level is determined through barometric pressure at various different, spots on the Earth.
Hey, I like how flat earthers, I like how they equate sea level to meaning it's flat. Because otherwise it'd be called sea curve.
Wouldn't barometric
That's
pressure
hilarious, bro.
wouldn't that vary like in a desert or in the ice or in different temperatures? So how can that
Yeah.
even be sea level?
What?
I don't know, but I think the big guns are going to start coming in here soon, so you could ask them.
I don't know. Maybe if I try to get that.
I mean, the way I just have a very layman understanding. A sea level is supposed to be like if you're at the beach, sea is right there. That's the level right there. That the level is right there. If you're in the ocean, you climb up the mountain, you're 400 feet up. Then sea level is 400 feet down. However, if you went, let's say, 50 miles into the into the continent. Now what's happened is you've climbed up over this ball. So sea level is not at your feet. Sea level is below you. So it wouldn't work on a ball. It wouldn't. Am I wrong? If you're on a continent and let's say it's 100 miles or an island and there's sea to the left to you and to the right of you, well, the sea level is going to be below you because you're on top of this globe, higher in elevation than the water level. Am I thinking about it wrong?
I mean, that's pretty intuitive, but I think it's a little more complicated than that. I'm not entirely sure. Maybe
You can claim that the sea level is a level from the center of the Earth. The problem with that is we don't know where the center of the Earth is exactly, especially not to the foot. So that won't work.
well, yeah, that's the geoid, but like sea level is different from that. I think Malaman could help us with this. See, he just got here.
Just got here. What do you need help with?
I'm asking, what is sea level and how is it determined?
Yeah.
Sea level? It's it's just a reference for elevations.
Yeah, but how do they determine it?
Elevation from what, though?
It's a certain place. It's a certain location. And is it near England? Why are you asking these crazy questions when you have to Google, bro? You can know anything you want, bro. All you have to do is just let your little finger Google it.
What if you don't trust Google?
Well, where do you want me to get you the?
Without having to rely on appeals.
Yeah, bro. Do you want him to do it for you?
But
You like
Godric,
people
if you
telling
want
you
to
what
know,
to do?
if you want to know what the sea level is, or mean sea level is, and you're asking me, I can't Google you the answer, give you any answer that I can get from Google. What answer can I then give you? Something that's subjective to me.
Why do you not use Google? Why do you explain to me in layman's terms?
Okay, it's the surface of what the mean surface of water, the mean elevation of the surface of water. There you go.
And wouldn't that vary on the globe?
No, the mean doesn't vary.
Yeah, it would.
Why?
Because if you're, this is how I see it. Just correct me if I'm wrong. If you're at the beach, and you're in the ocean, the sea level's right there at your feet, for example. But if you climbed a mountain, for example, 400 feet high, then now you're 400 feet above sea level because the sea level's right there. But
it's not. I mean, that's not mean sea level.
Continent, hang on. You went into the continent 50 miles, and you're on the surface of it. If it was a globe, well, the sea level now is far below you because the globe is curving. So, how would you even verify that? If it's below you, let's say a mile, or I don't know, 1,000 feet because of the curvature, how would you confirm that, rectify that? How would you know what it is?
But when just saying, but are you talking about mean? Are you talking about sea level or mean sea level?
Oh, is there two kinds? I didn't know there's two kinds. Can you explain it to us without Googling?
Yeah, man. I kind of see it. Do you see it, Mom?
My connection is shit. Can you hear me now?
Yeah, but tell me if I'm wrong.
Yeah, I
But
can hear you.
if it's a flat
Oh, now
plane
it's back. Yeah.
and there's
Hey, can
bodies,
you hear me, Mom, man?
Yeah, I can hear you now. So, Godric, I was asking, do you
All
mean
right.
mean sea level or sea level? Which one do you mean?
is there more than one?
Yes, because mean is the average. It's not like sea level. You can have sea level with tide high or tide low, so two different sea levels, but the mean sea level is the average.
Well, we wouldn't want to count the tides. That would be confusing.
What?
We wouldn't want to
But you
count
can't.
the tides. That would be confusing. So it would have
Okay,
to
okay,
be
then we're
average.
talking about mean sea level. And that's not what you see when you go to the beach.
Why not?
Because you have tides, you see the water higher or lower depending on the tide or the waves.
Right,
So
but
that's not the
if
mean.
the water, hang on, but if there's no tides, then it's the sea level.
Yeah, but where is there no tides?
When
Which
the water's
ocean?
still. How about like on a lake, Lake Erie?
But Lake Erie is in the sea level.
Why not?
Because it's a lake.
So you're saying bodies of fresh water do not equal bodies of salt water? Are you serious?
No, Jesus Christ. So mean sea level, you can have a lake that is 100
Nah,
meters
man.
above sea level.
Dude, he's obviously trolling you, bro. He's like wasting.
Yeah, it's just weird. Like, what's the elevation of Lake Erie?
I have no idea.
Okay, but if it has an elevation above or below mean sea level, then it can't be sea level.
Correct. Continue.
Yeah, so then the Lake Erie isn't sea level.
So are you saying all freshwater lakes are at sea level? Or just Lake Erie?
No, there can be one that is at sea level, but I mean, you'd have to measure it to establish it.
Are you saying all oceans are sea level? There can't be a higher elevation for an ocean? Is that what you're saying?
No, I'm saying that oceans also change because of tides. So they're not mean sea level.
Hey, stop
The
for a
mean
second.
is the average.
Stop. Listen, I'm being serious, okay? Don't mention tides, okay?
Are you?
No, it's pointless to do that.
Yeah, but hold on.
A tide will bring the water up.
Hold on. Oceans have tides. So if you're talking about oceans, then you're talking about tides.
Dude, have you ever been a teacher?
Sorry, I didn't catch that. What was the question? Do I ever what?
You just confuse it if you
Dangerous.
use tides, because now this is going to be higher. So obviously that's not accurate.
Sure, yeah. If you talk about tide, you're not talking about the mean sea level. You're talking about the actual physical sea level.
So start fresh.
It
What is sea level?
should be mean sea height.
Sure, you can say that it's mean sea height, but it's just labeled mean sea level.
But is it sea height from what?
Yeah, but level conflates it.
Or is it sea height from what? From what?
The height? No, it's the reference. If you're talking about, let's say there's a hill or a mountain, you're saying that it's X amount of meters above mean sea level. So the reference is the mean sea level.
But that's not telling you how to get mean sea level. How do we get it?
Sure. How do I get it? What do you mean, how do I get it? What do you mean on that?
Sea level. How do we get sea level?
I mean, I kind of don't get your question. Like, how do we get it? Like, take the average of the elevation, like the average of the sea elevation or the elevation of the water in relation to, let's say, the land, and there you have it. And that's a kind of weird question.
Hey, Mallman, I think there is an actual city that's like the bellwether for where it starts, and then you kind of base it off that. You know which city I'm talking about? It's somewhere in Europe. I know that for a fact.
They have the mean Amsterdam Pale, where they have like the height marks in the in Amsterdam. That's just for Amsterdam. It's not a it's not for the global mean sea level.
It's it's worldwide, dude. It's somewhere in Europe.
No, I don't know. I've only heard about the Amsterdam. But there is like if you we can't Google, but if you Google, like there's the theoretical mean sea level, which is for different places. There's N2000, which is a third leveling of Finland that we use. So that's for Finland.
They measure from Finland.
That's what we use for elevations over here in Finland.
Sorry, what do you use for elevation?
N2000 system.
What is that?
That's the elevation profile for Finland, where we get the elevations from, the mean sea level for us.
How do you get that?
You just calculate the, measure the average height of sea level.
Yeah, but measure from what? Are you going like from the center of the earth, from the
Oh, you
floor?
use the land. You use the land to establish it.
Land, and you go to the ocean, go to the beach. You measure, say the land is 0, and then you measure the sea level. Is that what you're saying?
No, that you can have a datum point on the beach, and you can see how much it changes in relation to that datum point, and then you get the average, and that's your average, and then you go from there. That's your sea level.
So they have a datum point to the ocean surface of the water, and then you go
an
from
average.
there.
Sure, yeah, the average.
So now now let's say they do that. That's fine. Here's my question: if you go 50 miles inland, you haven't gone up in elevation over this curve, over this ball.
What?
Right?
I don't get what you say.
So the sea wouldn't be level from where you are now. If you're 50 miles inland, it wouldn't be level. Because you're talking about what? 2,000 feet of curve?
Topography. No, there's topography.
No. Topography is mountains and ditches and hills and valleys. The water would be, let's say on a globe model, it would be on the surface, right?
It would curve,
but now
yes.
you're going to a different location on this globe, right?
Yeah.
So you're moving away from the sea, and you're moving away from the level of the sea.
No. Why would you move away from the level of the sea?
Because you're going over this supposed curve. You say it's 2,000 feet curve.
Yeah, but the water curves too.
The water curves, and so does the land.
Yeah, on a globe.
So if it's curving, there's no place where it's level.
No, level is curved in a globe. Because
Level is
the level,
curved.
water level. Yeah, means sea level. Sea level.
Height.
Like, can you draw that, like, on a piece of paper?
Draw you curved water on a piece of paper. Why can't you take Take the picture, the blue marble picture. There's curved water.
Right,
You
but
can go
if
with that.
if let's say this the patch on the left is, let's say it's level or it's curved, either one is kind of confusing. But and then you go to the right, let's say you go to an island or a continent. Those places aren't level because you're bending around
They
a
are.
pole. How
No,
are they
but
level?
hold on. Because the surface of let's say there's a planet that's completely filled with water, it's flooded, the whole planet. The whole planet is level, even though it's curved. Because sea level would be curved. Because that would be sea level. So now add some land to it, and it's still level, but there's topography. That's why I said topography, because that's all the hills and valleys and shit.
This is what I think. This is what I think when I think sea level. Now, just correct me if I'm wrong. You have a bowl with water, right? On the left side, you have another bowl with water on the right side. If you fill those bowls equal with water, and you're on a flat surface, then both those waters are level. Okay. Now put those
Why you
balls.
bring two balls into it?
Hang on. Put those balls in a beach ball, and now they're not level. They're bendy.
What? Now I have 3 balls? Just stick with 1 ball. Why do you have to bring in 3
Two
balls with
balls.
water?
More
Yeah, and a
comfortable with
beach
2
ball.
balls.
Because
2 balls and a beach ball.
in one location, you could technically get sea level, just like you said, you get datum from the ocean, the average of the height of the water is sea level. But the moment you move inland, your sea level's gone because you're in a different place now. You can't measure from one to the other. It's not level.
I can.
It's
I
bendy.
can use a water level. I can use a water level.
Okay, so now you're insane gravity now. Now you're saying center of the earth.
Hold on. You're talking about the globe. So, of course, I'm talking about gravity. If you don't want to talk about the globe, then I'm not interested because then we're not talking about reality.
No,
But I
let's
accept.
admit it. To get sea level, you need gravity and you need center of the earth. Is that what you're saying?
Sure, and if there is a globe, then sure, we have gravity and a center of the earth.
No, to get sea level.
Sure, and on a globe we have sea level.
No, that's to get horizontal.
I'm trying to figure out if you need gravity and a globe and the center of the earth to get to sea level.
You don't have to have gravity, you can just have relative density, but sure, you need a globe for sea level to be curved. I mean, if the earth is flat, then sure, sea level would be flat.
And the earth is curved, sea level would be curved.
Yes, obviously. And how could it not be? How can you have a globe Earth with flat water?
Okay, so you have an island, right? It's 100 miles, right? And on one side you have an ocean, other side you have an ocean, right? We know where sea level is on the left and on the right, but now you go up the mountain, right?
Yeah.
Now you're in the middle of those oceans, right? The flat plain in the middle of those oceans is not level to the other bodies of water.
Where's the flat
It's
plain?
high. If it was a globe, it'd be higher than those other oceans on each side.
No, what flat plain are you talking about?
I'm just making a concept, right? If you have an ocean
Sure,
on one
but I
side,
don't understand
an
your
ocean on the
concept.
other
There's an
side,
island.
and you have an island in the center.
Okay, hold on. Let's take it step by step. You have let's say, a circular island.
Yeah.
On an ocean. Okay. How high is that island from the surface of the
It's
water?
perfectly flat.
Okay, perfectly flat, not level, but just flat, just horizontal.
Stay flat for the basic example.
Okay. And
Left
how
side
high?
you have an ocean. Right side you have an ocean.
Sure. How high is it from the ocean at the beaches?
It's zero sea level.
Okay. Well, then it's under the water because from the center it would be below sea level because it's flat, a flat spot on a globe.
So it would be under the water. See, now this is confusing. So it would be under the water now because of sea level.
No, it's not sea level. You said it's flat.
Yeah, I said that.
Yeah. So if it's flat spot, if you saw a ball, if you have a ball like a golf ball, and you take a piece of it away, just saw it flat, then it's under the surface. It's just simple geometry.
Yeah, it would be under the surface. If you etch off a
Yes,
surface
slice
of
it.
a sphere, it'd be under the surface, right?
Yeah, so that's your island, because you said that
How
the
do you
beaches are zero
rectify?
elevation.
How do you rectify sea level if you're on land and there's no sea around? There's no ocean around. How do you measure sea level?
How do I measure it? I would use GPS, but you can use water level. You can use
GPS.
differential leveling. Differential leveling. It's a lot of ways. But yeah, I would use GPS because that's very accurate and easy. You can just use your phone.
Yeah, I'm just trying to learn this. I guess I never learned it, and as you can figure, you're gonna get a lot of different answers.
Sure. I mean, not from Globers, but I think
GPS.
from Flat Earth, there's a lot.
The thing is, we don't believe there's satellites up there, so we
Yeah,
have
it doesn't
obviously
matter.
have a problem with that.
Yeah, but the way that the GPS works is irrelevant to the data that you get from it. So if you get elevation data from it, it doesn't matter if it uses towers or whatnot.
Well, let's say it uses towers. How would the towers know what the elevation is?
I mean, that's a good question.
Because it's on the ball curving.
No, but no, hold
It
on.
works perfectly on a flat
Hold
plane.
on.
If it was a flat
Hold on.
plane, it would be no question. You can
No, but
measure.
hold on. I'm not saying that the GPS uses towers on a globe. You're saying that it uses towers on a flat Earth. I'm not saying that it uses satellites to me.
Yeah, that's great. That's fine. That's fine. But how would it doesn't matter what it uses. How would GPS know where the surface of the Earth is?
Because it has mean sea level.
Actually, no. I'm sorry. How would it know where water level is?
No, mean sea level.
It would work if you're in the sea, but again, go 50 miles inland. How does it know? If there's no water around,
system.
no sea around,
Because the GPS doesn't need water to be there.
and you're curving over a curve, how would it rectify the sea level if there's no ocean around?
Because it figures out your location in 3D space. They have a.
Because it knows the radius. It figures the radius in there. Is that what you're saying?
No, it knows where everything is in
GPS
3D
knows
space.
the radius of the Earth. So if a radius, then this is where sea level would be if sea level was here.
Sure.
I'm just, call me confused. Like, I'll put it another way. Let's say you were tasked to find the sea level, right? But you're on a continent, and there's oceans to the left and to the right of you, which are 50 miles away. You knew the medium of the ocean at the ocean. But how do you find sea level if you're on a continent?
Sorry, I was in a shop in a counter, so I couldn't talk.
If you're on a
So yeah,
continent, how would you find the sea level? You're not around the ocean. You would have to measure some kind of curve.
I would use GPS.
Right.
But if you say that I can't use GPS, then I would use differential leveling.
How does GPS know the elevation?
Then differential leveling. Use water level or theodolites or any other way that you can transfer it. Just level.
I'm sorry if it sounds redundant. I don't get it. I don't see how the GPS would know water level or even the elevation.
Because it knows your location in 3D space. Because it knows its own satellite's location with 3D space.
So what you're saying is you'd have to figure out where all the other towers or satellites are and equate to all those other towers and then come back and get your sea level.
No, it just knows where you are and it knows where they are in relation to the Earth. So it knows where the sea level is, or the mean sea level.
Measuring on a ball. This is the whole point. You're measuring on a ball.
But it doesn't matter if the satellites know where they are in relation to the Earth, then they know where Earth is in relation to me. And by that they know where I am in relation to the Earth.
And how do they know where sea level is around the curve?
On the curve. They only want to know, if I want to know my elevation, they want to know where sea level is at my location. I think it's still besides the point. We can just use water level to transfer elevation or the level.
You know how you have let's say you have a hole in the ground, and next to that hole you have a lake. If you poke the hole if you poked up, let's say, a tube from the lake to the hole, and the hole was lower than the sea level, then that lake would drain into that hole. If that hole was higher than sea level, the lake would not drain into the hole. Now, to me, that makes sense. That works perfectly on a flat plane. But if you're curving every so miles, that's not going to work. There's going to be no level.
No, there would be level.
Not one that you can measure that I can see.
No, hold on. Let's say the Earth is flat and you're in the middle of a continent. How do you get sea level?
This is the thing. You would go to the sea. You do like you said, the datum that you said. You go to the middle of the ocean. You get an average of how the height of the water is, right? And then you can just basically measure a plane, just go straight across. If there's a 200-foot mountain, then that mountain is above sea level 200 feet.
How do you go straight?
Hang on. If you get to another ocean, guess what? Since it's flat, it's the same sea level as the other ocean, right?
No, but how do you... But you asked me, how do I get sea level?
What?
Hold on. You asked me, how do I get sea level in the middle of a continent? How do you do it?
Well, I'm telling you how I do it on the flat plane. If you had a continent...
No, you didn't.
Huh?
No, you didn't. You didn't tell me how you get elevation.
Yeah, I did.
In
You go
the sea level.
on the left. That's flat. Get the
Okay.
medium. You put a datum in the center of the water. Figure out the average
Sure.
height of the water. You can do that, right? And then
Yeah,
since
on a globe
it's
too.
flat plane, you can just go right across and get the whole plane from that one point.
Hold on. How do you establish? How do you keep that elevation?
Because you just make like if you were a surveyor, that's one way. Just you can measure a straight line from one lake to the ocean to the next ocean to the next mountain. It's a straight line, so it's level. But if
Sure.
it's curving,
And
it doesn't
on a
work
globe, why doesn't it work on a globe?
because it's curving.
Okay, what would be different then?
You're not level with anything else.
What would be different?
Your elevation is different. If I took a beach ball,
Why would it be different?
I take a beach ball and you make an equator around the center, right? That's 90 degrees, correct?
What if I took to take what?
Take a beach ball, put a line around the center. That's the equator. That's 90 degrees, correct?
90. What do you mean 90 degrees?
You're not following?
No, I mean it's 360 degrees. It's a
Take
circle.
a beach ball, put a circle around the center. That's the equator. The North Pole is 0 degrees. The South Pole is 180. Follow me? 360 would be if you went from the North Pole to the South Pole.
Oh, okay. Yeah, now I get it. Yeah.
360.
Sure.
Follow me?
Sure. So it's a lot. Yeah.
The equator would be 90 degrees. Yes.
Yeah.
Okay. Now, so now we have a beach ball. We have the degrees. If you're in Ecuador, on the left of this beach ball in the equator, 90 degrees, and you have a sea level there. Then you go to the North Pole, which is 0 degrees, which is you'll go in the top of the ball in this case. Let's just say you're talking about a beach ball in front of you, just for this example. Those two places aren't equal. They're not level. One is much higher than the other one. Let's say you're looking at a beach ball head on.
No, they're still at the surface. So the elevation is the surface, so it's zero elevation.
So now,
That's
okay,
your
so
datum.
now you're talking about from the center of the Earth. This is what I don't
No,
get.
no, I'm talking about the surface. The surface is zero.
From the surface.
Yeah. That's your mean sea level, zero.
Okay, so you have to find what the surface is.
What?
I mean, if it's a mountain, hill, plain, if it's a
Yeah,
continent.
then it's measured from the mean sea level, which is the surface of your basketball or beach ball.
So you can maybe get like that's actually a decent answer. You can maybe get like a average height of the surface of the continent, and that would be
Yeah.
sea level, because now you're talking about being on a globe, no water around. You have to figure out what the height is of the average surface of that continent.
Yeah, if you stick a bubble gum on a beach ball, you can measure the bubble gum's elevation above the surface of the beach ball, and that's your continent.
Right, but I understand that the average height of the surface of this continent is not related to the ocean on the left side of the ocean on the right side, which you can measure sea level. They're not related because
No, but
this is a different area.
the sea level doesn't stop. It's a mean, it's an average. It's not a physical water. So if I'm inland in my car, I have an elevation above mean sea level, even though the sea is 60 kilometers away from me. But I still have an elevation above mean sea level because it's a theoretical datum. It's just a datum.
It's theoretical.
Yes. Because there's no sea below me. That's what a datum is. It's not like the mean sea level is an average. It's not an actual, just there's no way you can go to mean sea level and have water there every time because it's just mean.
Hey, Mallman.
Yeah.
Hey, what city is your elevation at?
What? You're cutting out, I
What
think.
city? What city is your elevation?
What city is my elevation?
Yeah.
I don't get that. Like do you want to know the city?
What? Like your city? Like, what's its elevation?
What's
The elevation of the city? I don't know. It changes obviously because there's topography in the city too, but I'm not sure. I haven't checked.
Well, like in Denver, they call it the Mile High City, right? I don't know if you knew that, but in Denver, that's its elevation.
Sure. Yeah, I haven't
How
checked
did
the
they get
elevation.
that?
I think they can use differential leveling to establish elevations and do maps and shit, but I don't know how they specifically got that elevation. Not sure. Fuck me, you know it's.
I can Google it. I can Google it too. I'm just, since you guys are talking about it, should not being
Yeah, I don't know how they got the specific elevations for different cities. No. Jesus, you know that it's summer when they're doing roadworks everywhere, and you're fucking. I'm gonna get late from work for this. I think it would be better to ask surveyor or just research the thing, Godric. I can't answer you any better. There's people who can answer you much better.
Thank you. You did okay. You gave some good answers. I'm just trying to. I'm trying to take what information we're given and see if I can verify it for myself. That's what I'm trying to do. You shouldn't need a survey. You know, it should be something that anybody can do. Just like you shouldn't need NASA
But you
or
can.
rocket scientists
You can.
or physics experts to know if the Earth is round or flat. Anybody should be able to do it.
Sure, you can do some tests, but I mean, you said that you don't want to use Google, so it's kind of hard for. Like, what can I do?
You can use Google as a reference, but I wouldn't trust it with the answer that Google gives unless we can confirm it ourselves.
Come on, man.
Yeah, but
Who said you can't use Google, bro? You're just being a. Come on, man. Serious, bro?
Godric said it.
No, man. Hey, hold on, dude. Because how did he hear about the flat Earth if he's a flat earther? He got it from Google. Did you guys hear me?
Yeah,
we heard that he got it from Google.
Google is fine.
Yeah, you got.
Fine. We just have to be able to.
No, you got your flat Earth from Google.
What I'm saying is,
come on.
Google's fine, YouTube's fine. We got to be able to confirm it ourselves. We don't just take these answers on trust. Because you know what? Real knowledge doesn't take trust.
There are ways you can falsify all these things. You can just do it.
Dude, it's like
if you
it's like the flat earthers don't believe anything. Like, no matter what. Like, ISS. Nope, ain't gonna believe that. Oh, we went to the moon. Nope, ain't gonna believe that. Like, nothing, dude. Like, oh, we got a radius value. Nope. Hey, you guys just deny everything.
If you can't verify yourself,
you guys like
massive appeal to authority. That's all it is. You got stories.
There's a lot of evidence for the globe, and then you just say, nah. A lot of things that you can do to test it.
Dude, I am a flat earther, dude, because I understand how easy it is to be a contrarian skeptic. It's very easy to keep snowballing into every single thing can be verified. But at some point, you have to realize there's experts that are smarter than you, that are working on these problems longer than you have for hundreds of years.
Yeah, that's what I go with.
Hang on,
but it's not only that, bro. Because look, we got a ISS floating around the world, which means that it's taking pictures of the whole world as it goes around it, meaning it's orbiting a sphere. Does anybody not understand that?
You said experts. Does it take an expert to know if the Earth is round or flat?
No, you picked up on one word I just said, but I made a point about the ISS is orbiting a sphere, and nobody wants to like entertain that. Like, hello.
I don't know if the ISS is doing anything. How can you verify that?
Well, okay. You know how like your car right now is resting on the ground in your driveway, right? It has its place.
Go to my car. I can drive my car.
You can go to your car right now, and it's going to be right where you left it, right? Well, the problem with the ISS is it's a spacecraft in space, and it's not resting anywhere. You see the problem here? Like, you don't realize.
It's
Well,
just
that's
stories
according
unless
to
we
you,
can
bro.
verify for ourselves.
Well, you can verify it for yourself because you could see it up in the sky if you really wanted to.
And you
It's
can
being
verify.
tracked. Yeah, it's being. I've seen it for myself. I've literally seen it. That's why I'm not a full flat earther. That's why I haven't went full flat earth. Is because I went to a stargazing event and I seen that motherfucker up there with my own eyes, and that's always bothered me. Now you could say it's a hologram, you could say all this, you could say it's a light in the sky, but then you're just fucking making excuses. And you're not really answering how or why it's up there. Like
How
how
about the distance? The distance claim. They say it's 230 miles away. Do you think you can see something 230 miles away?
You can do the math on
why
that.
would you expect not to? No, hold on, dude. Like then you're gonna get into like another problem with optics. What do you know about optics, bro? Like, did you design your eye? So how can you like? Okay, I asked you a question. Did you design your eye? No, you didn't
I
design
don't know
your
much about
eye.
optics, but I have common sense. You can't see nothing from 200 miles away.
No, your common sense does not give you a manual on how to operate your eye and all of the facets and the specs of your eye. You don't know the specifications and details of your eye and its capability. So why the fuck are you even asking to expect to see something from a certain distance away? Like now you're just bringing up more deniability. Like,
But hang on, don't you
man.
think the moon is more than 230 miles away?
Yeah.
I don't care. I don't care.
No, the other guy.
Roger Godric.
And no, the moon is not 200 miles away.
The moon is less than 230 miles away?
Yes.
That's a local moon.
How did you determine that?
Oh, come on.
I'm just guessing, but when we take the dog cam up there, 120,000 feet, we see the sun.
Yeah, bro, this guy's
hang on. We see the sun.
Right,
we don't see the moon at that height. We don't see stars. So probably the moon and the stars are just some kind of light cast through the firmament dome, which is around probably 100 miles up, 150 miles up.
Okay, you just mentioned that. Okay, now you're guesstimating and like, maybe. But you just said dome. But where's the proof of your dome? I don't see a dome up there.
I don't have proof, but
how did you verify this? How did you verify this dome? Did you go there?
I don't have proof, but when I look at these rockets bending over and going,
okay, then what? Well, why don't you use the same logic?
So
why don't you use the same logic?
So if there was a dome, they're avoiding it. These rockets going up, bending over. That way they don't hit the dome. Can't prove it, but that's what I'm thinking.
Godric, with the ISS,
you
can
can't
take
prove any of this either.
But Godric, you can take the side.
Man, dude, like, this guy just said something about a dome, but like he doesn't want to apply the same scrutiny to his concepts when he says dome, and then we ask, well, prove it, and he said, well, I can't prove it. Well, he's doing the same thing to the ISS, like by saying it's just a light in the sky. So he's being hypocritical.
My dome is a belief. It's not science. Okay, it comes from the Bible, the firmament.
Oh, there. Okay.
What?
I'm taking it as given. I'm trying to prove it.
There you go, bro.
Why can't radar hit the dome?
I don't know that I can or can't.
Yeah, yes, because when you shoot a radar signal at the moon, you get a result back that it's.
The truth is, I don't
very
you can do it
several
yourself,
100,000 kilometers away.
I'm sure
that's something
you don't know
do.
either. I think you know what the answer is given in Google is all you know.
But hold on, with the
no,
ISS,
I don't have to do every test.
Yeah, but with the ISS, you can take the claimed size, check the angular size, and then just do the math using laws of perspective and the zoom in your camera, and you can get the apparent size degrees. So you can know that it's how far away it is. It's just simple
Can you
math.
now? Thank you, by the way. Can you do that with me because I don't have the knowledge to do that. How do we do that?
I think
Maybe
there
term.
is some info about it on the internet. I haven't done it myself because I can't ever see the ISS from where I live.
Well, we know it's what 300 meters long. So take it. 240 kilometers is, or 240 miles is 400
Roughly
kilometers.
Know that you were told that. There's no way you can verify that.
Use
No, but we
400
can
kilometers
check it.
and 0.3 kilometers as the sides of your the sides of your triangle, and solve the triangle.
So, if you're
If that's
looking
your
at a
angular side.
distant ISS, right? The ISS could be smaller and closer as opposed to larger and further away, and you see the same result across. You see the same result if you observe it, whether it's closer and smaller.
Okay, so
whether it's
do you think the
farther away
ISS
and
is in the atmosphere?
result observing it. Yes.
So you think the ISS is in the atmosphere?
No, I understand that it could be much
But it's
closer
still,
than claimed.
but
and
it's still
smaller
traveling at 17,000 miles per hour.
farther away, 200
Yeah,
miles.
and we'll agree with you. We'll agree
I don't
with
know-
you for argument's
I don't know
sake.
about the atmosphere.
Does that mean it's in the atmosphere?
I don't know.
You don't know very much.
What you're seeing about the ISS could be a superior mirage cast by the plane Sophia.
How superior mirage gets cast by something.
That's how you make a mirage is cast by something.
What?
Like a projector.
Jesus
An inferior
Christ.
mirage.
If you think
Do
about
you know
it,
what these words
ISS
are?
only crosses a few continents, so you'd only have to fake it over a few continents. You can't see over the water because nobody's over there. They don't go over the North
Yeah,
Pole.
there are thousands of boats on the water right now. You know that for this lie.
I'm just guessing. I'm
For
saying
this-
they can take it. I don't know how they can do it, but they could do it. I just don't know how to
No,
prove it.
they can't. For this lie to work, hundreds of thousands of people in international trade have to be lying. All the people in
When you
space
say
programs.
they can't. I think you're naive.
Why is that?
Because when you say somebody can't do something, right? There's no way you can really know. It could be a trick.
No,
it could
because
be foolery of some kind. I don't know.
No, because
But
you
to
can
say
test these
someone
things
can't do
yourself.
something, I think that's a big assumption.
Yeah, and here's the guy that guesses at how far the moon is because of a camera.
Yeah,
So,
yeah. I'm
no,
not any kind of, expert. I'm just regular guy, layman guy, and I have my doubts. I'm trying to
do you
confirm
think pilots?
to confirm them.
Do you think pilots and airlines guess at where their destination is, or do you think they know?
Guess what? Pilots, let's say commercial flights, are told where to go. They can't do joyride. They can't go the way they want to go. They're given a direct route. They have to follow that route. Okay.
Right. Why?
So they don't even know where they're going. They're going the route that they're told to go. They can't do any
Yes.
experiment.
Why are they told to go that route?
They make their own flight plans though, so they
Because
really
there's
do know
flight
where they
path
are.
that's given to them. That's why.
Okay. Are you good? Sorry. Say it again.
They have to follow the flight path that's given to them.
Why do they follow
How
that
many-
flight path? Does it have to do with saving money on fuel?
Definitely
How many
not.
flight plans have you seen or made or planned, Patrick?
Wow. Definitely not. How are you so
bro,
definite about that?
Are you a pilot, bro? Huh? Are you
not
a
a
fucking navigator? Huh? Okay, then
I'm
shut
not
the fuck up, bro.
But he
Serious,
said definitely not. Why are you so definite
Okay,
about
then.
this
Telling
that it's
you,
not
a
to save money?
pilot cannot just fly wherever they want, especially commercial pilots. They have to follow the
How do
path.
you know that, dude? How do you know? Are you a pilot?
I said I'm not a pilot.
Okay, then how do you know about
Flight
this? Then?
once, and we went
Who
wherever
told
I
you?
asked the pilot to go.
There's flight paths. Okay, the flight paths are all the same.
Why? Why are there flight paths?
Why is there flight paths, bro? Okay, let's answer for him. To save money, the most direct route.
No, he said
it's not
definitely not. I don't know how he knows definitely. Well, that's what I'm trying to find out. He's an expert, apparently.
You're naive if you think that all flight paths need to be shorter routes. That doesn't. You're just saying
why
it saves money.
Yes.
There are more important things than money.
Sorry?
Have you watched the Dave Wise? Wait, hold on, dude. I think this guy has watched too many Dave Wise flat Earth videos about a flat map that that supposedly these pilots are flying different routes that seem to be different on a globe versus a flat Earth. This guy has been
brainwashed.
Yeah, he's just been brainwashed. There you go. Yeah. But he's never
it's easy to wash
verified
your
it for
brain when there's
himself.
not a lot there.
The pilots could be flying these paths that, according to them, would prove a globe Earth.
Which they do.
And there's no way they can tell for sure because they're flying these flight paths, and everyone flies these flight paths.
You don't know anything about aviation.
I got it, bro. Hey, I figured it out why he believes that. But look, let me tell you one thing. What's his name? Glaric or whatever? Gloric? Godric? The pilots have to plan for their routes. They can't just jump in an airplane and say, okay, here's this little line, kind of like how you do in your Google GPS that we're all spoiled with. Pilots don't have, I don't know exactly what they have, but I'm pretty for sure, based off of their professionalism, a pilot has to plan the route accordingly.
And
So
their
what that
logistics
means
guy has
is
to determine how much fuel they need.
Yeah, they know the weather patterns and everything along the way so that they can predict the time.
Sure,
and they're
that too, yes. Yep. Uh-huh.
Yeah,
but this guy's thinking, no. This guy is thinking, they're flying on a flat Earth map, dude. I know it. I know he's pulled out his fucking.
The people on the plane know what time they're going to land.
I think it's a flat map, and they're taking these scenic routes to make it look like it's a globe.
There you go. I fucking called it. I called it.
And that way you can't tell if it's farther from.
Why would they waste money?
You can't verify because you have to fly. You have to fly the flight path they're giving you. They can give you a.
Why would they waste money taking the scenic route, and why would they go greater than the speed of sound in planes that can't get anywhere near it?
There's things more important than money.
How can they go faster than the speed of sound?
I'm not saying they do. But I'll tell you what.
To do the distances you claim?
Hey, these commercial planes, guess what? They can fly 400 miles an hour, but they can fly 550 miles an hour. So guess what? They can get to someplace shorter or farther by flying different speeds. So if you think
what they can't do is fly 770 miles an hour or greater.
I'm not saying they can.
Yes, you are.
If you take a scenic route, okay, on your globe map, you take a scenic route, and it took you, let's say, 10 hours, right? Well, you can take a direct route, and it will take you 5 hours. And then if you fly 400 miles an hour, you'll get there sooner. If you fly 550 miles an hour, you get there farther, slower on a 400 miles an hour. You fly 550 miles an hour, you get there faster. So there's really no way you can verify.
Do you think we don't know the distance from Toronto to LAX to Miami Airport?
I don't think you know the distance on the flight path. No, you might know the direct distance.
How do you know this is all happening, dude? Like, how do you know for sure? Like,
I don't know for sure, bro. And here's the thing: you don't know for sure.
okay, then. So why are you even why are you muddying the waters?
What it is.
And do we know the distance from Toronto to from YYZ to Frankfurt Airport?
It's Frankfurt, London.
No, Frankfurt is Frankfurt in Germany.
Sorry, Germany. That's a distance. I would
That's
say
the main
no.
hub.
I would say no.
Okay, so my friend who makes that flight twice a week doesn't know when he's going to get there.
He certainly knows. If he's flying it twice a week, he certainly knows when they're going to get there. What he doesn't know is if he's taking a scenic route. What he doesn't know
really
that if his plane is bending, is continually reorientating around a curve. That he doesn't know. But doesn't know if it's a direct,
you said scenic
line
route.
to the target, or if it's a scenic route going around it, making him think that he's going around a globe.
What are you talking scenic route? When you say scenic route, what are they looking at? Like they're looking at different scenery? You know the word scenic, right? Why do you say scenic route?
Direct route versus scenic route. Direct route is the closest between one line can get to another play, A to B in one direct line. Scenic route would be to go curving, for example, around and then appear, land in the place by making a curve. That would be a scenic route.
Do you have proof of them doing that? Do you have flight class and evidence of that?
No.
Or are you just making up plausible deniabilities for planes not doing what they say they're doing? You don't have proof that they're doing this.
He thinks pilots and airline companies spend more money just to keep alive for some reason, but he's not naive.
No, but he doesn't have any proof of this, dude.
Not only does he not
have any
proof, he doesn't have much knowledge.
Listen, with these things, you have to use your better judgment. That's all. We all have common sense. We all have our judgment. Just use your better judgment. If someone's lying to you,
we obviously don't all have common sense if one of us thinks they want to spend more money.
Dude, nobody's lying to you, bro.
it's just think about it. There's no way you can know the distance between Frankfurt and what was the other one? Toronto. Okay. Because you don't know.
Said LAX. Yeah, you can.
Hang on. You don't know.
Why can't you know that?
Right?
Yes. And they have GPS as well. You know that, right?
What about GPS?
How do you know why do you say they can't know the distance? What if they've traveled it before and they've measured it?
But what does he mean by what do you mean GPS? What the fuck does that mean? Do you not know what GPS is?
I think a GPS is a system that's designed to fake a globe when it's really a flat plane.
How does it do that?
That's GPS.
How does it do that? Is that your expertise as well?
I'm not expert in anything.
No, that's apparent. But why do you think it does that?
I think it's flat, and they're making it look like it's a globe.
How does it do that?
I don't know how it does it, but
you know that it does it.
You can easily fake it.
No, somebody told him. Somebody told him.
You said it's easily done, so explain it.
The data they give you is if it was on a globe, but it's really a flat plane.
What data do they give you?
They take their GPS and they wrap it around the sphere when it's really actually a flat plane. That makes sense, doesn't it?
What data do they give you?
Hey, who else is talking to this guy? Can I get your
Data
name,
is
dude? Because I can't really look at my phone.
Oh, I'm Brad. And sorry, what's your name?
What's my name's Flat Daddy. Hey, what's your name, dude?
Brad. Like
Oh,
Pitt?
Brad. Hey, Brad. Nice talking to you, man. Hey,
Yeah.
well, we're not really talking to each other. We're kind of trying to have a talking to this flatty. But hey, dude, I have to admit, dude, I am a flat earther at heart. But really, dude, I mean, when it all comes down to it, I'm a glober. And I understand what this guy's doing, man, because I've let myself fall into the trap of denying everything. But I just wanted to, real quick, before we continue with this guy, we can continue with him because I mean, it's going to be the same narrative with how we talk to this guy because he has no proof of anything. And I just wanted to say something real quick that yesterday I was having a debate with Jeremy. Well, Jeremy was in the room and I was talking about the ISS and he was denying everything about the ISS. And he had no proof of his why he was had his ideas, but he had many denying little, you know, whatever. Many things he can deny about the ISS. So I just wanted to say it's easy to deny something and it's hard to explain something as well. So I think if you don't let yourself get carried away with just deny, and try and like understand something, and that way you can explain it. Because if you can explain it, you thoroughly understand it. So he obviously doesn't thoroughly understand how GPS works. So
I think
maybe he should start there.
I think that's a little unfair. I think what you're doing is you're denying Godric's emotional desire to wish the world to be flat.
Yes.
Well, he can
wants
wish whatever he wants.
But to do so, he denies everything.
Well, that's easy.
No, but dude, but look, man, I did the same thing he did. Is I watched one too many Dave Weiss videos, and I watched that video where he talks about emergency flight paths, and he puts both paths, one on a globe Earth and one on a flat Earth, and then it's like, wow, that's the direct route. Is the flat Earth that flight path? Why did they take that?
He didn't do that, and you didn't watch those videos.
Yeah, he put
did.
it on
He
the
admitted
Mercator
it.
projection, didn't he? He didn't
No,
put it on
whoever said he
Google Earth.
didn't.
I like Dave Weiss.
No.
Yeah,
no,
there's a CGI. There's a fabricated CGI video of Dave Weiss doing that. And it's not real. It's fake, and it's done by the lizard shape changing Illuminati people that control our lives and eat children. Prove to me it's
All right,
otherwise.
so bullish is the contrarian for the day. I guess we've got it.
No. I'm just showing Godric how easy it is to deny things stupidly.
And can we get Godric to explain GPS for us all? Because I'm sure we're all interested.
I couldn't do that. I'm sorry.
But you said it's easy. So
well, maybe that's where you should start, bro. Maybe you should try, bro. Like, go away for a while and look into it. You might find something. I don't know. I don't know about it, so that's why I can't tell you either. But I'm sure there are experts that have more well qualified than I have that have really dialed in to the GPS whole system and really figured it all out very good.
But he said it's easy. Do you want to retract that statement and say maybe it's really hard to fake a globe?
It would be very easy.
Okay, explain it then.
Well, like, For the most part, the GPS is just from the cell towers. Like if we're in Los Angeles,
No, it isn't.
there are cell towers everywhere, so it's all cell towers, right?
There are not
If you
cell
go in the
towers
ocean,
everywhere.
hang on. You go into the remote areas of the oceans, they use satelloons, right? So just satellites that are weather balloons with helium. They're up there. They could be in a fixed point, like against the dome, or they can be floating around in a
Okay.
local area.
I'm aware you didn't know where Frankfurt is.
And
No,
they can you can
you're
get all
talking
this
bullshit
info.
here.
Instead of being orbiting satellites, which are 200 miles away, you're really getting a signal from something right around 10 miles up.
Hey, is he finished?
And they have those wherever they have communications. They have either cell towers or satelloons, and
Hey,
that's
can you guys hear me?
that's your satellites.
Yeah, we can hear you. It's just he's rambling on about nonsense.
Sorry,
So
it wasn't
do you know there's a country? What is the country directly north of you?
me, Canada.
Yeah, it's a huge country, right? And we only live in a very small part of that country.
Go on.
Okay, so there's a mine up north called Raglan. It's near Deception Bay. Why do they have GPS there, but no cell phone coverage?
That would be satelloons.
It's 100 kilometers from Deception Bay, which is near it's northern Quebec.
What would it matter?
Why can you get GPS everywhere up there?
Because of satelloons. You know, they've got these balloons that are up there that nobody makes and nobody sees launched, and no records have for it, but we know that they're there because that's how you get GPS. Because without that satelloon there, you wouldn't get GPS. I mean, are you this silly, Chucky?
Yeah, I know. And you can name the 30-some GPS satellites and 50-some GNSS satellites.
No, hey, hold on. Hey, does he have proof of satelloons? Like right now, like can he track them?
The proof of the satelloons is the fact that we have GPS in those remote locations. Come on, Glad Daddy.
I'm pretty sure he's not aware that you can actually find out if you have the right GPS, find out which satellites are sending information. And there's only a certain number of those satellites. Are you aware of that, Goddard?
I thought there was like 5,000 satellites up there orbiting. Are you sure there's only a
They're
few?
not all GPS
satellites. And GNSS encompasses all of them, and there's I think 84 or something like that.
If you want to tell me about GPS satellites and that there's 84, I'll listen. I don't know how many that's
GNSS
supposed to be. You want to tell us about that?
Okay, so
I don't know how many.
How many satelloons do you need to cover the entire Earth?
I heard that NASA has like more than 10,000 satelloons.
Okay, so why are there only 80?
You heard?
Hang on,
Wait, no. Hold on, Brad. Hold on, Brad. Wait, this guy just made a positive claim, dude. Citation.
I said I heard that.
Motherfucker.
I said I heard it.
Yeah,
you said I heard it. I don't have proof.
Hearsay, bro.
Fine. But by the way, do you think there's satelloons up there? Because a lot of globers believe in satelloons also.
No globers believe in satelloons. What we believe in is the fact that
I'll say I don't know.
For me, I have evidence and proof for weather balloons. I have evidence and proof that we've sent satellites up into low Earth orbit and into geolocational orbit around the Earth. And some of those early satellites that we sent up, you could inflate to be a reflector because it was easy to store something packed up and then inflate it and then let it go than to take it up inflated because it was pretty big. So I don't know of any satelloons, as you would call it. That is something that is not well defined to be Godric. So if you can point out who makes them and what they're used for.
Weather balloons.
So weather balloons are not satelloons; they're weather balloons. Okay, so that's great.
I call them satelloons because they carry the satellite signals that you would need to communicate.
And again, that's another claim. So we know that weather balloons go up, they launch regularly. In fact, they launch very close to where I live in the UK. It's one of the places where we get metal for launching them. They're carrying telemetry equipment to gather atmospheric information for weather. So great, that's pretty well documented. So where is your documentation that they're carrying GPS? They're carrying out the function of a GPS satellite. Where's your documentation for that?
I don't have it, but
Sorry,
you know what?
I
You
can't see my
mentioned
phone. Is that farmers?
satellites, right? You mentioned satellites. How do we confirm that these satellites are up there? Can we do that?
Sure. Yeah. I mean, for me, when I worked in the North Sea, I used time delay reflectometry when I was hooking up oil rigs to satellite communications, and that told me how far away that object was.
Is that Farmer's Boy there?
No, that's not Farmer's Boy. IB Druss.
Oh, sorry. Oh, Druss.
We just
sorry.
sound a bit alike.
Yeah. Apologize.
That's all right. I got well, Farmer's Boy. It's good.
So what do you know about satellites? Just because you've worked with them? Come on.
I know. I don't
How
know
do
much
you
about
know?
satellites. What I do know a lot about is TCP/IP and RFC 1509 and RFC 1512.
But you also
I'm a bit of a fucking expert.
Didn't you use directional antennas to aim at those satellites?
Yeah.
And you knew where they were?
Yeah,
That's weird.
and the time delay between my signal leaving that oil rig being received and then processed by the satellite and then being transmitted to the data center then receiving those packets, that gives me a round
you
trip.
Actually might, and you probably even knew the name of the satellite at least at one point.
Yep. Yeah, it was an Inmarsat satellite.
It wasn't called Satelloon 562.
No. It was also
Weird.
at least 30,000 kilometers away.
So Goddard, do you still think you know a lot about Satelloons? Is he licking his wounds?
I mean, it's a personal anecdote. It's experience I've had.
I don't know a lot about satellites. That's just the theory I have.
So why did he point it at a specific spot in the sky?
All I said is that to replace your fake satellites, you can easily have satelloons. It would do the same thing. That's all I said.
Did you?
No, it's not.
Did you hear when he said he measured the distance away?
Oh, so I'd like to see that. Maybe you can show us how you do that. How do you confirm that? How
Sure,
it's a process.
It's a process.
Orbiting satellites as opposed to local satelloons. How would you know?
It was geostationary for one thing, and that would be very difficult to do with any form of balloon. It didn't move in comparison to my location.
Can you explain geostationary so we're all clear?
Yeah, so basically it doesn't move in relation to me.
Right, so there could be a satelloon up there just in one spot above the wind.
Can you show me? Okay, cool. Now show me how you keep a weather balloon, because that's what you claim that they are, in a single spot. Show me.
You know that we had a dog cam up there. It wasn't really just kind of hanging out up there above the wind.
Also for decades.
120,000 feet.
No. I'm asking you to show me a balloon kept in one spot by a piece of technology that is used in a weather balloon. So you claim that they're weather balloons,
when I looked into it,
and I've seen weather balloons launch. They don't really seem to have any motors or anything like that on them. It's just a big fucking balloon. So what I want you to show me is how is it maintaining its singular position?
When I looked into it, there's wind and there's jet streams. Above both of those, there's basically no movement. So if you can take a balloon higher than that, you basically will be in the same place. And when I looked into it, NASA had balloons that could stay up there for 9 months.
Is there atmosphere up there?
It would be a thin atmosphere, yes.
Okay, and how far away is that spot you're talking about?
I think it's around 150,000 feet.
How much?
I believe it's around 150,000 feet.
Okay, so why did he get a distance much farther than that?
That's where I believe his information is corrupt. I don't know how he would know.
how's my information
how
corrupt
would you even know
when
the difference between? How can you prove they're orbiting satellites 200 miles away, or
no 30,000
local
kilometers away?
saloons?
30,000 kilometers, Godric. That's the distance.
How many miles is that?
23, 25, something like that.
25 miles.
1,000.
25,000 miles.
Yes, we're talking 30,000
Yeah,
kilometers.
I don't know how you can confirm that.
Because of RFC 1509, which is Network Time Protocol.
So
Just
the
under
data can be
20,000.
corrupt. Is there anything else?
No.
How can the data be corrupt?
Yeah.
If you can't go there to verify it, it could be corrupt. It could be giving you a
He
false.
did it.
It could be telling you it's 30,000 kilometers away when it's really only 130,000 feet away.
Well, again, you want to say what if? Fine, what if? So in that case, I'm going to hold you to the same standard. What if there are no satelloons? What if this is all just an invention in your mind? As you have never been there to personally verify any of this, why are you trying to tell me what is? Why are you not holding yourself to your own standard of evidence and say, I don't know?
I could be wrong.
He's asking how you verified it.
I could be wrong.
It could be corrupt data. How did you confirm it's not corrupt?
I'm not saying I'm not wrong. I could be wrong, but I'm just
Sure. The way that I know that the timings weren't corrupt is the synchronization between the timestamp at my data center, the timestamp on the satellite, and the timestamp at my source, and that round trip configuration.
My theory. I'm just trying to prove yours. That's all. Timestamps can be corrupt data.
He's done a pretty good job of quote unquote proving it.
So
now
that's
that
the first thing.
we know it's accurate.
Because when you deal with TCP/IP, you have something called TTL, which is time to live. And every packet basically has a decay point where if it gets too much latency, it will just be ignored by the recipient. So one of the things you care about is the latency between your send, your receipt, and your retransmit when you're doing satellite comms.
How would you prove that it's 30,000 kilometers instead of 130,000
Sure,
feet?
because the timestamps on the packets being sent and being received by the data center and the intermediate carrier of the satellite between are all synchronized.
It could be giving you a false reading. It could be telling you
They're all synchronized with each other. It would throw up an error if it did that.
So instead of connecting to 30,000 kilometers away satellites that are geostationary, you're connecting to satelloons that are 130,000 feet up. How would you know the difference?
Because the timestamps would not correlate.
How do
You understand? It's sending the time to him, and he measures the. Do you understand what he says with the timestamp? What information is that satellite sending him?
That's what I'm trying to find. That's what I'm trying to find out.
Why don't you already know this?
I don't know about correlating timestamps. I'm asking him.
Okay, it's sending him exactly the time, and he measures the difference when he gets that to the actual time.
It's better than that. All three devices are on the same time cadence, so they're all on the, that's what Network Time Protocol does. It basically coordinates clocks between network devices.
That would work 130,000 feet away.
Yeah, it would, but the trouble is the amount of time that it takes to go 135,000 feet is somewhat different to going 30,000 kilometers.
What if they retard the signal to make it seem like it's going farther?
Then that would show an interruption in the TCP/IP stream of information, and it would be recorded because that packet would have to be opened, ingested, and spat out again, which I would see.
And you would have to retard the signal before you knew you were sending it.
Let me just end this part with this. So you don't think you could be fooled?
I think anybody can be fooled on anything. I think the likelihood of me being fooled on this is incredibly slim.
Fair enough.
you're just doing what I call absolutism. Well, if it's possible you could be wrong, therefore you must be wrong. Therefore, my argument for a flat Earth is now reasonable. That I'm afraid is bollocks. Because what you basically said to me in this conversation, Godric, is I don't support the flat Earth. I just want to argue against the Earth being a globe.
That's true. That's true. But we do have some flat measurements like
No.
like the Rampion windmills. You know about that in New England?
No. I mean, again, you
Cheers,
can
guys. I'll
say
be back
you
in a
have
bit.
flat measurements, but I'm going to hold you to the same standard that Jeremy holds me to. Is that a physical measurement or is that an optical measurement?
Optical.
Well, optical measurements don't seem to cut it with most flat earthers because of refraction, and you don't know what the optical corridor between you and those objects are. So it might look flat, but obviously it's not actually where it is because that's what refraction does. It moves stuff around from its physical location.
Right. So what we do with refraction, we know there is refraction. We take observations where it's coolest and driest. That would give us the least amount of refraction. So refraction we control down to a minimum, so it doesn't affect observation.
Well,
So
again,
if you go in the morning, when it's dry and cool before the sun comes out, that would give us the best, lowest amount of refraction and the best observation.
Yeah, but there's still refraction there, isn't there? So unless you do that physical measurement, what do you got really, apart from just some dodgy pinhole camera, or fisheye lens doing it?
Not really. And when you add in dodgy there, it makes me feel like you're pushing an agenda because we don't see too far. We see just as far as we can see with the optics we're using and what's physical or what's optical in front of us. If there was physicality in front of us, we would never see past that.
Yeah,
now we might, if the light, hang on, the light might be refracted over that physical object a tiny bit, but not as far as what we're seeing. So you have an issue there. Either refraction is way different than what you're telling us or teaching us, or there's nothing physical in the way. It's all refraction, basically, optical.
So when you say a tiny bit, what, 1%, 0.5%, 1/4%?
You can put whatever you want on it. We have observations that are way further than what we would ever see with whatever percent.
Mm-hmm.
That's the issue. There's no physical water or land in the way.
And how was that worked out?
What do you mean how that's worked out? We calculate it with the refraction measurements that we're given.
Mm-hmm.
You say it's not having to do anything with R, it's having to do with what we know how light goes to the more dense layer, then you have an issue there.
Look,
you can't say that anymore.
Okay, look, this is what I don't get. Like, you don't hold the same standards when you say, hey, how are we supposed to see the ISS when it's 240 miles away? But yet, when you say, oh, we see the Chicago skyline, you're basically saying the same thing. Like, why can't you, like...
Not really.
Why is it any different?
I'm not, anyway. I'm not. I didn't mean to cut you off, but you're saying something that's not true about me.
So you don't have a problem with the ISS being 240 miles away and being able to see it?
Well, I do have issues with you saying that it's a reflected light from the sun, and it's not, it's not doing things that we would expect reflected light off a shiny surface to be doing, which the ISS isn't really a shiny surface. Now, if you're saying we're seeing the light from it, then yeah, I would have another issue with the inverse square law of light. But seeing further as you look up instead of seeing further as you look out through the more dense layer.
Cut you off real quick. When did I ever say anything about reflective
You broke up. But my point is, you're going to see further. The less the angle is, the more you look up through the less dense atmosphere. Of course, you're going to see further. But the more you look out into the most dense layer of atmosphere, you're not only going to not see as far as if you're looking up, but the object in the distance is going to reflect light in a way that it could create optical illusions, which we know exist. So less optical illusions are going to be created as you look up, but then there becomes a question in the medium itself. So if I'm looking through atmosphere, gas, and particles of dust as I look up, but they're not as much, they're not as dense, then yeah, I'm going to see more clearly with less optical illusions and probably going to see further. But once you get into the, beyond Earth's atmosphere, what that medium is, I don't think you know that. And if it is some type of crystal-like dome up there, or super solid, or a super fluid type medium up there, then yeah, you're going to be fooled a lot. And you can prove that to yourself here on Earth. You don't have to go to space or speculate or use theory.
That's why we sent weather balloons up to the edge of our atmosphere, and why we sent satellites in space here.
I got one better than that, Foolish. Hey, Foolish,
Sure.
We got the Soyuz rocket that has went to the ISS. What about that rocket? It's when you said a different medium. Now you're just claiming that it's something that you know nothing about. So why would you say
No, not
what
really.
it is?
You're lying about me again. Don't put words in my mouth. You can group me into a group if you want. That's your problem. But that's not what I think at all. I don't tell you what I know about the ISS.
You just said about the medium of space.
Yeah, I said
you weren't sure.
If the medium is different, we would be fooled. That's not saying I know the medium is different. You seem to have a bias wanting to put things and group me in a group and then argue against something I don't say. That's a you issue, not me.
So you don't say much then, huh?
What are you saying? I just said everything that I think, that I know. I know we see further when the medium is less dense. For a fact. I can prove it to you. I know. Hang on. You seem to just want to spout. Are you asking me something? I know.
Yeah, I'm asking you.
Yeah, I know. But you can wait till I'm finished. You can wait till I'm finished if you're not too excited. Like, keep your cream in your pants for a little bit. I've just opened my mic. I'll be gone in a second. And then you can go back to spouting whatever you want about people. I know when we look over a more dense layer atmosphere like the marine layer, we're not only going to not see as far as we would if we looked up at a different angle through a less dense layer, but that light being reflected, that information that's trying to get back to our eyes, which goes to our brain, which is interpreted by our brain, is going to be distorted in so many ways sometimes that object appears upside down or a different shape or a different color than it would if it was higher in, our atmosphere in a less dense atmosphere.
What are you trying to tell me? What are you trying to say? I agree with you that optical observations are useless. Have I already?
No, that's not true.
So what are you trying to say?
What I said. Why are you putting words again? They're not. I've never said they weren't. They were useless. I said we're easy.
What the fuck are you trying to say? Get to a point, bro. Like, make your point. Stop telling me what things
relax,
are.
Black Daddy, please relax. Stop screaming into the mic, please.
Bro.
Calm down, bro.
We'll fucking make a point, dude. So
can you name any of my points?
With it.
I bet you're so excited that you've been screaming your pants.
Just
okay.
You're just telling me about
can you go on mute then? You're just interrupting and disrupting and telling me I haven't made any points. I've made several points. You're just too dumb or doing this on purpose so others can't hear my point. Which is it? Either go on mute. Yeah, I know, because you keep talking and getting so excited. You can't
I'm
hear
not
any of my points.
talking.
Okay, what was one of my points? What was
Whatever, man.
Yeah, you interrupted
Whatever,
every
man.
time. Yeah, there you go, interrupting again.
You're
Can,
really not saying much.
yeah, can
Anyway,
you name
before
my
you
main
came
point?
in here,
You
we
haven't
were
said anything. You haven't
before
said
you
anything.
came in here. Before you came in here, we were talking. So
Always.
why don't you go away again?
Yeah, there you
We were
go.
talking with
Moderator.
Foolish.
Oh, yeah, I'm here.
All right. Yeah.
What are you doing, Flat Daddy? Relax. Let Rakia finish his shit, and then you can go.
Yeah, that's what I said. I said I'm fixing to leave. He can go back to spouting his stuff. He still interrupted like every time I tried to talk. He doesn't even know my main point, which I'll restate it again. We don't see too far. We see exactly how far the conditions dictate. When you change that angle and you go into a more dense layer, like looking over a lake or an ocean, rather than looking up at something in the sky, then you're changing the conditions. Those objects over that long distance, over a marine layer, let's say, are going to appear different than if that same object was at a different angle, or you change your angle, you go up. So the density of the, yeah, you cut me off again, dude.
So what, bro?
Hey,
Just shut
yeah,
up,
so,
bro. Shut
Hey
the
guys, I'm
fuck
gonna
up.
go. Good night. Thank you
well,
for the conversation. I'll be back tomorrow.
yeah, this is
See you
strange
later,
that
bro.
this is allowed to happen right now. I came in like 5 minutes ago. This dude is
Mute,
obfuscated and
Rakia. Go ahead.
interrupted and
Rakia, I put him on mute, bro. I put him on mute.
I said my piece, but good luck. One guy, right, was doing it the whole time. But I think
That is
everyone
busy
will
doing
agree,
shit.
and I think everybody kind of agrees with that. I don't think I'm saying anything that both sides don't agree with, but the point is that we don't see too far. We are seeing further than what y'all's model dictates, and either refraction is a lot different, like the up and down, like light being reflected down towards the more dense layer isn't true, which me and Jeremy don't think it is. I mean, you can easily prove that sometimes the more dense layer is up. Why wouldn't the conditions be reversed sometimes? Of course the water would be warmer sometimes and the air would be colder, or the air gets colder as it goes up. The air itself, just by itself, is warmer usually at the ground than it is, 100 feet. Go fly and go 1,000 feet up in it. You don't need a heater. You don't need an air conditioner anymore. Just open the vent. It's freezing. 9,000 feet. You need a heater.
And the
So
pressure is much lower.
anyway, I enjoy the conversation about optics a lot. I think it's very interesting. The optical illusions that are created by the conditions are amazing. That's what first got me interested, and everything, because I saw a bridge from very close, 6 miles, that instead of being straight and above the water and, not curving in any direction, it's a parallel bridge. It was bent laterally towards me, and then also vertically down to where it appeared to be underwater. Now that's just a mirroring effect, we know, but it's not upside down. Like, you just change your angle. Yeah. But what I'm saying is, I'm making my point. You change your angle or change your height, that your viewing angle, or the sun gets to the other side of that bridge with everything remaining the same, then that view is going to be different.
So how can
Well, I'd like
any
to
of
do-
your observations ever be taken serious? If you know there's so many variables, like you just mentioned, if the sun is at a different angle, if the water temperature changes, different, you named like many variables.
Right, I get what you're
So
saying.
why is that? Yeah, it's obviously unreliable. So maybe you should, like all the flat earthers, should tread the waters lightly, no pun intended, because you can be fooled by what you see.
I think most flat earthers do know that. I think it's the other side that needs to realize that you can be fooled in what you see. That water appearing to be higher than a bridge or a boat blocking it bottom up isn't actually reality. It's an optical illusion caused by the conditions of the day. Thank
You don't know that
you
though.
for
You
making
don't
my
know that
point.
though.
Oh, I do know that in the way that I can go
Hey,
on a
you're
different day and
roboting.
it's not blocking it. Something's going on.
Sure.
All right, brother.
But yeah, but either the flat or the curved is the optical illusion. It can be either.
Well, okay, fair enough.
And is he roboting or is it me?
Either
I
than
think
what we're,
he's
yeah, you cut me off right in the middle again. Because I
you're
have,
roboting. You're
okay.
roboting Rakia. Did I cut out?
No.
Is that better now?
Ah,
Yep.
it could be, yeah.
Yeah, either the model is way smaller than what we're told, or it is an optical illusion. Because I have observations that don't prove the shape, but they do prove that if that physical water is blocking the boat that I'm shooting, then we're living on a really, really small Earth. Now, what makes more sense, because I've seen and can reproduce optical illusions from that distance, that it's just the conditions of the day creating a view that's not reality.
But
And
I
keep in
think
mind that just a few moments back, you did call into question whether or not light bends toward the more dense medium in a density gradient. What's interesting about that is I provided you somebody verifying that light in air bends toward the more dense medium. I find that odd.
it's well established that it does go to the denser medium. And I think, like, if you assume that the Earth is flat, then the curvature is an optical illusion. And if you assume that the Earth is curved, then when it doesn't curve enough, it's an optical illusion. And I don't know how Rakia has established the first case, that the Earth is actually flat and it's an optical illusion that it looks like it's curved.
I measured water. Water is the key. Water has to
How did
curve
you
on your
measure?
bottom.
How
Using
did you?
horizontal. Yeah.
Sorry.
Anyways, yeah, you know how to measure.
Hmm?
Yeah,
How
if
can you
you're
measure
if you're
water
calling optics
without
into
water?
question and then you made a measurement optically, then you're calling your own measurements into question.
Now, there's a big difference on looking 1 foot or looking 1,000 feet, right? You
How
would
did
have
you
to agree.
measure? How
Yeah,
did
I
you measure
use
water?
calm down. That's the same question like 6 times in 30 seconds.
Not a single answer.
Yeah, because you were asking the question the whole time. And I would say
Sure.
you've heard how I've measured it. But if you haven't, I use very precise man-made tools that are designed specifically to create a horizontal plane and measure down from that plane to the surface of the water. If that surface was curving at all, you could measure it, tell it. I use the
Okay.
same
How?
tools. Hang on, I'm almost done. I use the same tools and methods used to determine elevation changes. So they have to be pretty accurate, right? Either that or our elevation are not accurate.
Okay. Sure.
I'm
So
gonna
if
have
you
to.
use something.
Y'all can ponder on that. I gotta go. I'm at my job.
No. Okay. Fair. Let's see later. I think if using something that's used in like the distance of 50 meters, for example, then the error margin would have to be very small.
Smaller than a millimeter for sure.
Yep.
The cool thing about drop with distance is that the further you go, the more of an angle that you're supposed to observe from horizontal.
Yeah.
still a bit annoyed that after coming to an agreement with Rakia before about how light behaves through a density gradient, today, suddenly he doesn't agree with it. It seems like he wants to agree with things only on a particular day and then change his mind later.
Whatever suits the narrative.
What about you, Doofus? Have you changed your mind?
Are y'all
Changed
talking
my mind about what?
Y'all talking about me instead of talking about the argument, right? That's cool.
Have you
Right,
changed
I
your
was
mind about the light through the
specifically
density
talking about
gradient?
light bending toward the denser medium.
Yeah. About that. About how you
That-
said you could have warm air inches above colder water consistently.
I didn't use those words. It certainly wasn't
Well,
what I
that's
said.
basically what you said, right?
No.
That the temperature.
No, I said that the temperature of the air right next to the surface of the water, and I'll use the English language for this again. The temperature of the air right next to the surface of the water will be the same as the temperature of the water just under the surface of the water.
And just above that, you said it would be warmer, right?
It can be if the water is colder than that air. Yeah.
Mm-hmm. And that warm air is consistent, right? You're not just talking about just a breeze that comes in every once in a while.
I get that you didn't quite listen to what I said last
simple
night.
question,
But
man.
what I said
He's asking you a simple question.
But what I said specifically,
Listen to that.
what I
man.
said, but what I
No
said
screaming,
specifically
thanks.
last night, I get that you guys want to interrupt me, but here we go. What I said specifically last night was that the body of water could be colder than the air above it.
No, we weren't talking about the body of water. We were talking about the surface of the water, which is the same temperature as the air right beside it. And you said right above that, just above that. Like you didn't specify exactly how many inches or feet. You did you said there was less than 6 feet or something that you would have consistent warm air. And I'm asking you.
No, that's not what I said.
So the warm air that you were talking about was just one sporadic or the one-off warm breeze that comes in?
Dude, I said that it is possible for a body of water to be colder than the air above it. Those were the words that I used.
You could have
and
a
that's
gust
the
of warm
specific,
air.
That's the specific set of words that I will always use every single time.
No, we were talking about the bending of light towards the more dense medium. We weren't just talking about a sporadic gust of a warm breeze. So you know damn well what we were talking about. You were trying to say that there was a layer of warm air inches or less than a few feet above this water, above colder water, consistently.
Yeah, rewind the stream.
Are you still standing by that?
Why don't you go ahead and rewind the stream? And where I did mention that the water could potentially be colder than the air above it. Those were the words that I used, and they will always be the words that I use every single time.
Yeah, if that's what it means, why figure about it? If
So
that's
in terms
what
of light
Doofus
bending
means, then we should go with what Doofus says now.
I'd like to ask Doofus a question.
Okay, go ahead.
Do you think the tops of cloud? Oh wait, percentage. You might have been robot. You want to try again? Anyway, I'll go. Maybe come back. Doofus, do you think that the tops of clouds are following the curvature of the surface of the Earth, and also adhering to how we see, kind of in a circle, which would also make them appear curved?
I'll accept that topic change if you go ahead and address a different topic with me. Like, why would you say that the light through a density gradient maybe possibly doesn't bend toward the denser medium when we definitely went through and showed you that it definitely does?
I'm not. That's not what I'm saying anyway. But I'm not trying to change the topic. I'm trying to point out why, if you answer that as yes, the tops of clouds are following or curved because they're following the surface of the curved Earth, and also that we see in a curved path or in a curved way. That's why the tops of the clouds appear curved. They would even appear curved over a flat plane, just not as much. Why the hell would we listen to you about anything else?
Okay,
About
that's
light.
not precisely what I said, though.
Okay, what did you precisely say about the tops of clouds, viewing it from altitude, how they're curved and why they're curved?
Okay, I didn't call out the clouds at all. You added the clouds. I was talking about the haze in the distance. And the haze forms in a uniform set of conditions over that observation, that specific one that I shared. And in that uniform set of conditions that they form in, that haze forms in, it's a certain distance above the ground is a certain intensity. And since that's uniform from left to right, and the haze itself appears to be curved, the only conclusion to possibly draw is that the horizon underneath of that haze is curved as well.
How can you say the only conclusion? Because you also give, in the same sentence, usually, a different conclusion in that that's how we see in a circle, so that would make it appear curved, even over a flat plane. You seem to be contradicting yourself.
No, because what I said was if we somehow make up a reason for why it is that we only see so much of a flat surface, and if that reason made any sense at all, when we get out to that distance, that would form a circle because it's the same distance in all directions from us. And that would be, that would appear curved to us, but not as much as it would if the Earth were spherical. And my photograph matched the curvature of a spherical Earth, not a flat plane.
So when you said just about 30 seconds ago that that is the only way that that could happen, and then go to tell us how it could happen because we see in a circle, you might want to take back that you said that's the only way. The haze, not the clouds, although the clouds are doing it too, which is very strange. You don't want to talk about that. Are following the surface of the Earth perfectly, is what you just said, with the radius that we're given right now.
Okay, you can rewind the stream because I'm talking about the horizon's curvature.
Yeah, the haze at the
on
horizon,
the haze example.
You can't even tell what it is.
I mean, I can certainly tell that it's haze. Yes.
Okay, so it is definitely haze. It can't be anything else. And that's the top of that haze is following the curvature of the Earth, and that's the only
curvature of the horizon.
So that's not the curvature. The curvature of the horizon is following the curvature of the Earth underneath it. That's what you're saying, right? Perfectly
I'm being very
to the
specific.
radius. Yeah, I
I'm
know.
being very specific with the words. I'm being specific with the words that I use, which is that the haze is in a uniform. Thanks. That the haze is in a uniform set of conditions. That the amount of haze with altitude is consistent from left to right in that observation. If the haze is curved, the horizon is also curved.
So we're not talking about the surface of the Earth, right?
We're at least, at a minimum, talking about the horizon.
Okay, are you calling the horizon the surface of the Earth where the ground appears to meet the surface? I mean, where the sky appears to meet the surface?
Okay, but the horizon is the last part of the surface of the Earth that you can see, yeah.
Right, and why we see in a circle, even over a flat plane, in your own words, is because we see in a circle, right, at distance. And that could be curved.
The words that I actually used, if we make up a reason for why we can only see a certain distance on a flat plane, those are the words that I used last time, and they're the same words that I'm going to use this time.
You didn't say if we make up an excuse. You said that's exactly how it would be seen over a flat plane. It just wouldn't be as much.
Right, and when I said that the first time, I specifically used the words "if we made up a reason for why we can only see so far."
Take that bet. In our conversation at Geo's, when I went through this with you, with everybody, and we had a very civil conversation, that's not the words you used. You said even on a flat plane. Yeah, interrupt.
Take the bet.
Go ahead.
Take it.
On that night?
Yep.
On that night, that's what you said? Okay, how much?
Let's go with $150. Just
deal.
Value.
And say the exact words again. If we come up with an excuse.
Right. When I mentioned it to Geo, if we had to make up an excuse for how...
Not to Geo. When me and you were talking at Geo's, remember that civil conversation me and you had? Everybody
Right,
was
Geo.
surprised how civil it was. I'm not talking
Yeah,
about when you
Geo.
talked to Geo. How would I know what you said when you talked to Geo? I'm talking about when you talked
Because
to
you were
me.
there. Yeah, because you
No,
were
no,
there.
that's not what I'm talking about. I'm talking about when you and I had a conversation. You said it would even happen over a flat plane this way. It just wouldn't appear to curve as much.
Right. And if we had to have a reason, if we had to make up some reason for why we couldn't see as far on a flat plane, these are the words that I used. And when Geo butted in, it's the exact same thing I said to him.
So did you say over a flat plane it wouldn't curve as much? Because that's
Right.
what
It
I'm
would,
saying.
yeah. And it was because specifically you had to set some sort of ground rules, which was that for some reason over a flat plane, for some reason we can only see so far. If we had to
And
make
why
up
would
that
that be?
reason, well, I don't know, because you guys don't really have optics because you choose to ignore them.
That's a lie. I've been talking about optics all morning, and you're going to lie like that? You're a fool, man.
Right.
Everybody hears this.
All morning, you also said something like, "What if light
Don't
doesn't
try and
bend toward
change
the
it.
more dense medium?" Yeah,
Don't
no,
try.
I'm not
I've never
changing
said that.
anything.
I've never
I
said
know
that.
that. I know that you said specifically that. What if light doesn't bend toward the more dense
That's
medium?
not
You
what I
said those
said.
words. Yes,
That's,
those definitely are the words you said this morning.
calm down, okay? Because even if I said it, that's not what I'm saying. I'm saying that the more dense medium isn't where you think. Light isn't always bending down. That's my point. Can
All right,
also,
so
under certain conditions, hang on, bend up is my point. Now, if you want to try and obfuscate around that and make me seem not as smart or whatever you're trying to do by saying I don't think light bends towards the more dense medium, then that's a you problem again. That's you lying. Because I never
okay,
say
but you
that.
did actually say those words, and I'll go ahead and mention that, as any surveyor will know, being next to a surface is not a good way to do it. It's no bueno. What you
I'm the
do
one
is
who's saying
you get up away from a surface to get out of those unstable conditions, 20
Yeah.
feet above ground level or higher, and you get some consistent conditions.
You get more consistent conditions. Yeah. I've said that from day one. Yeah. I'm the one showing low level observations being all distorted. Remember? When you lie and say, I don't think optics are whatever, I don't deal with optics. You know, when you just lied a while ago about me again. So, anyway, why should we, if you think that the Earth, let's just conclude. If the Earth was a flat plane and you were at altitude, would the horizon appear curved?
If we had to make up some reason for only being able to see so far, yes.
So it would. Because of the way we see, right? In a circle.
Well, why is it that we can only see so far over a flat surface?
Because you're looking through a medium, and we can't
Okay,
see
that's not
forever.
enough
You
to
would agree
cause
with
you. Well, that's not enough to cause you not to be able to see forever. Because for instance, a glass like fiber optic cable, that thing, you can shine light through that for miles and miles.
That's
So you
not
can
what we're.
definitely see through a more dense medium much easier.
Yeah, light attenuation. I mean, there's many different reasons, but I think you, being so smart as you are, would agree that no matter what the shape of the Earth, you can't see forever, son, because you're looking through gas particles, dust particles. I mean, a myriad of things. So why are you arguing this point?
Well, it's curious then that the distance that we can observe of the surface increases as we gain altitude. Because
Yeah,
if we
because you're
know, for
not looking
instance,
through as much stuff.
because if we know, for instance, that we can see through dense media, that we can go and shoot light through such media and over miles and miles, but somehow on the surface of the Earth seems to still get in the way of things, there must be something else going on.
So you have to prove that the surface of the Earth is doing that and not be optical. And when we're at altitude, why the horizon would appear curved, as you say it, however you want to say it now, because that's how we see in a circle, right? You see 360 degrees at the same distance. That creates a circle, which gives the illusion, optical illusion, that the horizon, which isn't curving, would appear curved. Correct? Thank you
You
very
just said the
much.
horizon would be curved and not curved.
No, I'm saying that's what you say. because of how we see in a 360 degree. I'm not saying I agree or disagree with you. You
You
told
said
me
the
that
horizon is not curving. That's the words that you used.
I said the horizon appears horizontal, but when you get up to distance, you say, get up in altitude, you say because of how we see in a 360 degree radius, that horizon, which appears horizontal at a lower altitude, would appear curved at a higher altitude because we're seeing further and we see in a circle. So even over a flat plane, the horizon would appear curved, just not as much as your exact words.
Right, not as much as observed. In fact, what I observed was that the curvature matched a spherical Earth and not a flat plane.
Okay, so by saying right, you agreed with what I said. Over a flat plane, it would appear less curved, the horizon. But what you're observing from your picture, from altitude, from an airplane with the camera you use through the glass, through however far you're seeing on that day, match the curvature of Earth perfectly.
Yep.
So on a different day, when the conditions are different, does it still match the curvature of Earth perfectly?
From 34,000 feet, that will look the same on any day.
What a joke. I'm done.
I mean, you could say you're wrong or come up with some reason why it wouldn't look the same on a different day, but go ahead.
Or I could let the audience who just heard you say that the tops of haze at 30,000 feet as you're looking through hundreds and hundreds of miles of atmosphere is appearing to curve because of the curved horizon of
I mean, it makes sense because
Earth.
haze. Oh, you're roboting.
And
I guess I'll wait for your internet to get better. Okay, never mind. I'll just go then. The haze forms in conditions, and you have to explain to me how the haze got there in the first place. If you think that the conditions could be uneven from left to right, then you'd have to explain why. But if I'm going with the assumption that the haze that's there forms under the same conditions from left to right, and the fact that that haze is curved definitely lends to the conclusion that the horizon behind that haze is also curved.
or that you're on a flat plane at altitude and you're looking out and the way we see makes it appear curved, right? Or that, which is what you said.
If we had to come up with some reason for why we could only see so far.
So there's not just one reason, right?
I mean, you can try and come up with however many reasons you want.
Well, you came up with two. I think that's plenty enough. One being the top of the haze following, conforming, whatever words you use, to the horizon, which is basically the surface of the earth, curving, or it's how we see optically, how we see in the distance over a flat plane.
Are you having the same conversation as me?
Yeah. You said both of those. Multiple times.
Right. That's not for reasons for how far away we can see.
Well, if you can't figure out that we can't see forever because we're looking through a dense medium, it gets less dense as you go up. That's why we see further, but we still can't see forever. I can't help you.
Right. And as I explained already, even a more dense medium like glass, we can see for miles and miles. Light can get through it. That's not a problem. It's not the more dense medium that causes us to see less distance.
Okay, on your model, why can't we see forever?
Because the Earth is in the way.
Okay, but at ground level above the Earth, like there's an object taller than the curvature of the Earth that you're looking 1,000 miles. It's 1,000 miles from you, and you're high enough where you should be able to see the top of it. Why can't you see it?
You said the less dense medium doesn't cause us to see less farther. You've never heard of light attenuation?
No, they play dumb when it comes to that. And I said that earlier, and he just breezed on past it. Like we should be able to see forever.
Right, depends on what medium we're talking about specifically.
Have you
Because
ever heard of
density
the
alone,
attenuation
it
of light?
depends on what medium we're talking about. Because
The
specifically,
atmosphere. We're talking about the
if
atmosphere.
it depends on what medium we're talking about. Because
Yeah, the
specifically,
atmosphere.
when we have more dense media like glass, which is obviously about a lot more dense than air, we can shoot light through it for miles and miles. So the
Yeah, so
density
obviously,
alone is not. So the density alone is not sufficient to say why we can't see as far.
and that's why I added
The
that it's not
attenuate.
just the density. Yeah.
Have you ever heard of the attenuation of light? Heard of the attenuation of light?
Light attenuation is a thing. Yep.
So more dense medium would cause what? The light to just keep going forever, or would it make it stop?
Depends on the medium, because obviously wood attenuates light a lot faster than glass.
So you agree the density does attenuate the light, and we can't see forever through the atmosphere, or through glass, or through wood. Thank you. I agree.
That's not what I said. Thanks.
You said wood was more dense than
Don't
glass.
get too worked up, bro. Don't get too worked
No, I'm
up, man.
good.
These guys ain't even worth arguing with them.
Well, that was my whole
Well,
point.
it would be great if somebody would stop misrepresenting what I said. What I said specifically was
y'all
that
misrepresenting
that
us.
more dense. That what I specifically said was that the density is not what's causing us to not see as far, because glass is very dense compared to air, but we can shoot light through it for miles. Why?
Where have you shot light through glass for miles? Robotic.
Optics? Yeah.
Shot light through glass for miles of glass.
Fiber optic cables,
You
or
shit
glass
up?
fibers.
You just make dumb shit up, or what? Is that what you do?
Fiber optic cables are glass fibers. Let's try that again, see if you actually heard me this time. Fiber optic cables are glass fibers.
It's just shooting light through glass for miles.
Yep.
And you just agreed. You use a block of wood more dense than glass, right? And
Is
how
it?
light? Well, is that what you said? Is what I'm asking.
No, that's not what I said.
Fiber optics are hollow. You lying fuck.
No, there you have a glass fiber on the inside. But thanks for your input.
Well, it's not the same anyway as looking through the atmosphere. He's just trying to obfuscate away from the point that you can't see forever through the atmosphere, gases, particles.
But the density of a medium, is not what causes the light to
It's
have a
one of the
maximum
factors.
distance.
It's one of the
No,
factors.
not really. Not really. Not even any
Okay,
of the factors. Because
fine,
a more dense
fine,
medium like
whatever.
glass, because a more dense medium like glass allows light to travel a lot further than we can see on the surface of the Earth.
Awesome. What is the okay, you're going to say Earth curve, right? But I'm not talking about the physical block. I'm talking about the atmosphere. Why can't we see forever even when you say we're on a sphere? Oh, smart one.
Like what specifically?
Whatever you're saying it is, genius. You're saying it's not density, fine. What causes it? Because we all know you can't see forever. So what in your mind is the cause of you not being able to receive the reflected light, the information, right, that you're supposed to receive, that you say we're receiving no matter what, unless the Earth gets in the way? What causes it not to be received when the Earth isn't in the way?
Well, for instance, we have observations where the surface of the Earth in silhouette behind the sun can be observed 275 miles away, while both are at very high altitudes. So we can for sure see through atmosphere at least to 275 miles.
Dude, are you thick? I mean, seriously.
I would like you to actually address what I said.
Yeah, we see things different ways due to the conditions. That's my whole point. We also see things disappear that are obviously not obstructed by Earth or anything physical because of the medium we're looking through. I'm asking you, what causes that if not density of the atmosphere, the medium?
Okay, if you were actually paying attention, what I brought up was an observation through air for 275 miles. So no, not the atmosphere.
Okay, why can't you see things 300 miles or 500 miles through that same atmosphere?
But because the Earth is in the way, typically.
No, atypical, when the Earth isn't in the way. See, you just don't want to answer. Everybody hears it. You're
No, I
stuck.
already did. If we can
No,
see
you
at
really
least
didn't.
275 miles away,
Okay.
then when we can see at least 275 miles away in our atmosphere, and we are down at the surface, and we can't see 275 miles away, it's not the atmosphere that's the cause, clearly.
Yeah, it's more dense when you're lower, right? You're looking through more thick atmosphere.
And as I just went through, the density is not a cause for us to not see as far because a more dense medium does not cause the light to stop.
You mean fiber optics doesn't make the light stop, but the atmosphere does.
You can claim that if you want, but at 275 miles away, but at 275 miles away through the atmosphere, clearly the light can get as far as 275 miles.
So in your the point that you're making, hang on.
Hold on, Rocky. You need to stop raising your voice.
He's okay. The point that you're making, because we can see 275 miles in your observation, that we see forever.
No, the point is that we should see farther than we see when we're close to the surface of the Earth.
No, that's obviously not true. But at wherever you were when you saw 275 miles, you're saying you don't see any further because Earth got in the way?
You see, the most recognizable object you have in your field of view is 275 miles away. At a minimum, 275 miles through the atmosphere is possible. So it's not the atmosphere that causes us to not see far down at the Earth. We also ruled out density, because a more dense medium can cause us to see for miles and miles.
This is beautiful.
But if we ruled out the atmosphere and the density for why we can only see a few miles at ground level, what do you have, Rakia?
You want me to come up with an excuse for your fantasy model? What are you saying?
No, I just want you to come up with an excuse for reality.
Yeah, reality is the layer and the angle is different when you're viewing down on, like in the marine layer. No one denies this. I don't know why you are, but what did you see at 275 miles? What objects did you see? A mountain.
Mm-hmm.
And were there
sun silhouetted behind it?
It was the tallest thing in the distance, right?
Yep.
So that's why you're seeing it, right? If there was something taller, you would say like 500 miles. You would say you would see that.
Well, at a minimum, that observation shows us that through atmosphere we can see for 275 miles. So when we're down at the surface, say, well, 50 feet above that surface, let's get reasonable then. If we're 50 feet above that surface and we don't see for 275 miles, the atmosphere is not the cause.
Yeah, so genius. When you go to see that mountain at whatever altitude you were at 275 miles, and you go further away and gain altitude where the Earth isn't in the way because you're gaining altitude to see over your Earth fantasy ball, and you go further away from that mountain, is there going to be a point where you can't see that mountain?
I mean, it'd have to be... Yeah, that's not helpful. It would have to be that you'd have to have a different observation point. I mean, we could discuss that if you've got a different observation. I certainly have one already.
An airplane?
Right, the 275 miles that you can see in that observation clearly shows us that the atmosphere can allow light for 275 miles.
Yeah, at a certain altitude. Yeah, I agree with that because it's less dense.
Right, and if we get down to the surface, the density has changed by only a small factor, but we can only see for 4 or 5 miles on typical conditions. So the atmosphere is not the cause.
It's two causes, actually, but you're ignoring both of them.
Okay, what are those two causes? Because if it's atmosphere and density, I've already ruled both of them out.
You ruled them out by going in circles. I've been sitting here listening. Yes, and that's you. and that's great. But you don't get to project that onto me and stick it to me and make it mine. I don't want it.
Okay,
Don't
what
have
I'm
to
working.
take it.
Okay, well,
The
what I'm
medium?
working with is observations of reality. In
The
observations
medium.
of reality, we can. In observations of reality, we can definitely use. In observations of reality, we can definitely use. In observations of reality, we can definitely use observations. Jesus Christ. In observations.
Yeah, I wasn't
Yeah,
done.
you're muted, and
You cut
whoever
me
you are,
off and you
you can't be
started off
over talk.
gaslighting me.
Hey, talk people. All right, screaming over the top of people is not going to help. But please don't interrupt people, guys. Come on.
Dude, the gas.
Please don't interrupt Doofus as he spouts off this nonsense that as we get lower through the more dense atmosphere, we should be able to see the same as if we gain altitude. When their whole spiel is you got to get higher, even his spiels, you got to get 20 feet or higher to get above that more dense atmosphere to be able to get see further and get better measurements. He's like a walking contradiction.
Well, let's say, for the sake of argument, that the air down at sea level is 2.5 times as dense as the air at the observation that I mentioned. If the air is 2.5 times as dense, but we can only see 1/50th of the distance, it's probably not the density, is it?
It's probably not linear then, right? Is what you're saying?
Well, because density doesn't cause light to have a maximum distance. As we pointed out earlier, with glass, which is way more dense than air, you can get observations of light many miles across.
Can get more observation. I don't even get what he's saying. I don't even
Optics
care what
is
you're
one of
saying
them,
now.
though. That's the thing. He cut me off before I could finish. The air that we have, the gases, and the density down here is one thing. And our limited optics, the physics of optics, how our eyes actually work, how optics actually work. These things are the limits.
All right, if you want to bring up optics itself, let's go ahead and get into that topic. Which direction does light bend in a density gradient where the highest density is below?
What does that have to do with the physics of optics and the limits of actual optics that you have? Optics is visual, because if you were blind, you wouldn't have them, would you? You wouldn't have optics at all. You'd be using
What
other
does
stuff.
optics have to do with optics? That's your question.
No.
All right. Which
I
direction does
haven't
light bend
asked
in the
one
density
yet.
gradient with the highest density below?
I haven't asked a question yet. I've made
Right.
statements
Which direction
that
does
are
light bend in
being
the density gradient with the
twisted.
highest density below? The correct answer is down. That's anybody who knows optics knows the answer is down.
Dude,
Is cold air more
gaslighting.
than hot air?
What if it's being magnified? What if there's magnification happening? Is it still going to make the objects appear lower?
All magnification is due to refraction, so you're asking about refraction.
What if it's
So if there's
reflecting?
magnification, is the object going to appear higher or lower? Or mediums on the
Depends on
bottom.
the specifics of the magnification, which, by the way, is caused by refraction.
Sure. So we can have refraction, and we might have the object appear lower, not higher, right?
Only on conditions that the atmosphere is upside down for a particular optical corridor.
If there's magnification happening, only on conditions that there's magnification happening.
Again, magnification is caused by refraction.
Yeah, sure.
Well,
So if magnification's happening, the objects will appear lower, right?
If magnification is happening, you have to know the specifics of the optics involved in order to determine which way it's going.
Yeah, but dude, optics
happening and the shit appear higher, you think?
You have to know the specifics.
Get loud.
No, you don't.
Okay.
You don't. You just have to get a camera and zoom in. As you magnify that object, you have to adjust your camera lower because it makes the object appear lower. You don't have to know any conditions. Just go get a zoom camera and do it.
Okay, that's not necessarily true, because if the object that you're zooming in on is slightly above the center frame as you zoom in, it will go higher and higher until it gets out of frame.
So it goes higher and lower when you're magnifying it.
Right, you have to
Or
know the
anyone that's dumb
specifics
enough
of the
to believe
optics
a
employed.
goofy motherfucker telling you that they know it. Anyone that's dumb enough to buy some shit where somebody tells you that something's higher or lower than an actual position, and then they tell you that you don't know the actual position, that's just dumb on your part if you believe that shit.
No, he just
It's
also
funny that
said
you
that
couldn't
the
address
angle
what I said,
matters.
though.
Yeah, I'll address it. Center frame angle is different. If you magnify something where your angle is one way, it's going to appear higher, and if your angle is below center frame, it's going to appear lower. Right?
Cool.
Just like a
Cool. This
camera.
doesn't. Yeah, cool. This doesn't have anything to do with the atmosphere.
Sure it does. Things get magnified, and you're looking at them at different angles. Genius.
Right. That's your opinion.
No,
He's
that's a
talking
fact.
about optics. Hold on. Because the problem is he keeps gaslighting. Every freaking time somebody says something, he comes back with some gaslighting crap. And
No,
that's
I'm just using
ridiculous.
optics. It's not
Optics
gaslighting.
are very simple. Optics uses line of sight. Line. Lines are straight, buddy. So I don't know what you're talking about. Now,
I
to
can show you
invoke
light bending in air.
refraction using
I can.
straight lines is to say that you can't now not trust your own eyes, which is bogus. Because if we couldn't trust them, we wouldn't have them.
All right, let's try this real quickly. Light is easily demonstrable to have a curved path in air. We can easily show that, correct?
No.
Surely you've seen a hot car roof before.
So you're talking mirages, optical illusions, back to still optics. And medium?
And the light is not following a straight path.
Isn't that an effect that's caused by particles getting more excited by heating up in a particular area inside of a medium? So the optical illusion is caused by one, heat, two, medium. Interesting.
Yet the light is clearly not following a straight path in those examples. You can choose to ignore that if you want.
An optical illusion doesn't negate the straight line from your head, those two balls inside your head called eyes, right, to the phenomena occurring, which is obviously an optical illusion.
All right. So let's see if you can answer this question honestly. Is that the shape of the sun?
Let's see if you can stop gaslighting when you talk and talk like a man. How about that?
Is that the shape of the sun? Yes or no?
I'm not, one, looking at what you're talking about, and two, going to answer questions that start with gaslight and presuppositional crapola.
Okay.
Let's
so the
see
answer
if you
is
can
no.
be honest.
The answer is
so what you're saying is I'm a liar. So then what are you doing talking to me?
right. Maybe not necessarily.
Right.
Maybe not necessarily a liar, but intellectually dishonest. What we're looking at here,
Again,
that you choose.
you're back to gaslighting.
What we're looking at.
Why?
What we're looking at here. What we're looking at here.
Stop talking. First gaslighting somebody. How about you talk
Dude,
like
stop
a man?
yelling. Stop yelling at
Jesus.
us. It's fucking obnoxious.
Dude, the gaslighting is unreal, and the fallacies are deep, bro.
Okay, so I'm going to get my chance to respond whether it hurts your feelings or not. What we're looking at is not a circular sun. It is distorted in some way. Now you have to address the fact that the light that came from the sun and reached our eyes clearly did not take a straight path. So no, optics is not all about straight lines of sight. If all lines of sight
you
were
started
straight,
off. You started off with gaslighting, so I muted you, so I didn't have to listen to that crap. So, without gaslighting, try and talk like a man. If you're going to be honest, if you can, if it's getting personal, one, you're in an ad hom, two, you're in fallacy land, and three, you're just being rude. Act like you have some manners, dude.
All right, it's your opinion that I employed a fallacy. What I did was I demonstrated
it's a
in
statement
air.
of fact.
It's your
You made
It's
something
your
about
opinion
somebody else.
that you are. It's your opinion
Yeah.
that I'm using a fallacy.
I don't give a shit.
Okay, it's your opinion.
So stupid. Dude, I had to mute you again. You gotta stop yelling.
Yeah, but
You're
he's
yelling
only
over,
speaking up because he's being
yelling
overtalked.
over people. Hello, why are you over talking me now? If someone overtalks you, you can't just yell over them. It's not how it works.
Well, then control the overtalking.
Yeah, I'm getting on it, but you can't. I don't care. You can't just scream at people. He's been told time and time again.
I get that I'm stepping in and cutting him off, but he's also using fallacies. He's also being very rude, and he's gaslighting from
Puddles,
go.
what fallacy did he use?
I just told you. Go back and listen to the recording. I'm not repeating
No.
myself to you.
God's teeth. Okay, so he didn't do a fallacy. I accept that.
Hey, I told you, go back to
you're
listen to the
prepared to
recording. I'm
restate.
not repeating myself to you about that. It's not happening.
Of course. What fallacy did he accuse you of, Doofus?
Oh, am I finally unmuted? Okay. Right. So if I'm describing an observation through air and I show conclusively that the object we're looking at is having light coming from it that's not following a straight line, which fallacy specifically did I use?
Because I didn't hear Cuddles mention a specific fallacy, which is why I asked the question. Doesn't look
and
like he wants
optics
to go
is
to the detail.
right. And optics definitely involves lines that are not straight, lines of sight that are not straight. Otherwise, glasses wouldn't work. This is pretty straightforward stuff. Obviously, light passing through our atmosphere can take a path that's not straight. Now, where it becomes interesting after that is we start looking into the specifics. If we start inducing gradients, if we start changing the density of the air, we can observe exactly what a change in density, a gradient, will do to that light. We can do that by inducing it in many different ways, and we always do it with just air. So we can definitely demonstrate that when such a gradient is set up, that we know which way that light is going.
That's a gradient.
Like
I
said, anyone telling
change.
you have an actual, like I said, anyone telling you they have that something's higher or lower than an actual position and they don't know the actual position, they're either dumb or they're trying to pull one over on you. Anyone that's dumb enough to fall for that shit deserves it.
Right, and with that statement there, what you're saying is gradient index optics, a field of optics, is bullshit.
Now, what's bullshit is you telling everybody
don't
that's
fucking
listening that
gaslight me or try to play me.
doesn't matter.
Hold on, don't try to fucking play me like that. My statement was my statement. I didn't say anything what you said. Okay, don't try to pull some bullshit over on me because I called out your bullshit.
Right, so the gradient index optics, that specific field of optics, works with what light does through a gradient of refractive index. The easiest way to change that is to change the density of a singular medium. That's easy to do, and I know for a fact that when we have a density gradient where the highest density is below, that I know for a fact, off in the distance, objects appear higher.
In the meantime, anyone that's trying to tell you they know if something's higher or lower than an actual position and they don't have the actual position, they're either stupid or they're trying to pull one over on you. And if you're dumb enough to fall for it, you deserve it.
Right, and gradient index optics, the field of optics known as gradient index optics, tells us that it's going to be higher. It doesn't matter what your opinion is on this subject, Jeremy.
An actual position, or are these the people that are trying to fucking pull one over on you? You were dumb enough to fall for it.
So gradient index optics is not someone trying to pull one over on you.
One more time. Anyone that's dumb enough to fall for someone telling you that they have something higher or lower than an actual position and they don't know what the actual position actually is, they deserve it.
Right. But gradient index optics specifically tells us what direction light will bend through such a gradient. And it definitely tells us that through a gradient where the highest
all day.
density is below that, and a gradient, when the gradient is the highest density below, distant objects observed through that gradient will appear higher.
Meantime, anyone that's telling you that they know something's higher or lower than an actual position, they don't have the actual position, is either trying to pull one over on you or they're dumb. And if you're dumb enough to fall for it, you probably deserve it. You do this all day if you want.
What you're saying
If you
is
do
that
this all
gradient
day,
index
if you
optics
want
is
to do this
bullshit.
all day, that's fine.
Doofus, chill for a sec. It's simple, right? He's saying that light always bends no matter what. So go tell that to the snipers and the hunters and the people who literally use optics, which is line of sight, which is defined not only in the manuals for the rifles, but for the large artillery, the guns on the planes, and literally everything else we have here to do with optics, like theodolites and such.
Right. But Jeremy's current contention is that a gradient index optics, a field of optics known that we definitely use to make things that are useful, that field of science is bullshit because somebody's trying to get one over on him.
He's telling you that something's higher or lower than the actual position, and they don't even know the actual position. They're, like I said, they're either dumb or they're trying to pull one over on you. And if you're dumb enough to fall for it, maybe you deserve it.
And your statement flies in the face of
Do
gradient
this
index
again.
optics. Yeah, we can do it
keep
again.
straw manning that.
But you keep making the
strawmanning.
statement that just because you don't know the actual position, you can't have an idea of the position. You can
I would like.
You can know things about a position without knowing the exact position.
I would like White to identify exactly, specifically, where I straw man Jeremy.
He's like, I can throw a ball into my neighbor's yard, and I don't know where exactly it is, but I know it's within my neighbor's yard. Like, you can have
Where
information
you
about
said
it without
he said
knowing the
the whole
actual
field of
thing.
science is bullshit. He never said that.
Well, the implication is there because if gradient index optics cannot tell me conclusively that an object observed through a density gradient where the highest density is below appears higher than its actual position, that he's telling me that gradient index optics is bullshit.
How do you know there wasn't an inversion? How do you know there wasn't an inversion at play in that particular
You
observation?
got to understand, White. These are the same guys that are telling us they don't have the actual position, but they know things are higher or lower than it. So you got to expect shit like this from them.
Right, and your statement flies in the face of gradient index optics.
I don't know the exact position of that airplane flying, but I know it's above me.
Right, but the issue with the whole refractive index chart is that it's the beginning of it is a misnomer. Beyond a certain point, resolution is more difficult. That's optics. That's physics of optics. The limits therein within optics. The happening of optics, right?
Yeah.
Very simple. So the further you try and look.
I would really like you at some point to actually look into optics for reals.
So Cuddles,
Bro,
if optics say that it's gonna be bending downwards, then optics say that it will be above its actual position.
It depends on what's going on. You're getting into a point. All right, so 200 feet, not a problem. 200 miles, little bit difficult. You may have some phenomena between you and it, a change in pressure, a change in heat, a change in something that may cause an optical illusion. 2,000 miles from point A to point B, you're definitely going to have some type of optical illusion between you and them.
But wouldn't the field of optics be studying this and know about this?
Bro, if we built a telescope to look from South America to the tallest tower in Canada or the tallest building in Canada, we could do it. But one, it'd have to be up in the air. It'd have to be elevation because you got to get over the rest of the mountains. You need line of sight to the object. And two, it's
You
going to
know
be
the
massive.
second tallest structure. You know the second tallest structure in Canada is only about 380 kilometers from the CN Tower, right?
Well, then we can look at New York then.
That's farther.
But it's a bigger clump of buildings, bruh.
No, why don't
Larger
we look at the
target to light
superstack
up.
in Sudbury while it's still there?
I mean, pick the object. Pick a location, pick an object. 1,000, 2,000
The
miles.
superstack in Coppercliff, Ontario. It's 500 meters tall.
How big?
How big is 500 meters, are you going to ask?
No. I mean, like the structure, the outside.
How wide?
Right.
Does that matter?
Well, it might. Over distance, you want a larger object. You want to be able to resolve it. What you're trying to do is resolve the light that is hitting the object so that you can see it clearly. So either you're going to A, light up the object, or B, you're going to need a bigger one because of the distance. Everything is trying to mirror. Everything.
Yet he thinks he knows about optics. Does it matter the width? Of course it fucking matters.
All right, let's try this again. Let's try this one more time then. If we have optical media that light can travel through over miles and miles, and we're down at the surface, and something that's less dense doesn't allow us to see as far, clearly the density is not the problem.
The changes going on inside the gradient are. I've pointed that out 3 times now. 4, actually.
So at 20 feet above ground level or higher, you have observations that are made through a much more stable gradient.
All right, but the issue, you say optics aren't line of sight, but then you've got hunters, snipers, ballistics. These things work on line of sight, all of them. I go hunting.
They work with crosshairs too. Yeah.
I don't aim up or down, below or above, wherever I'm pointing at the deer. I point dead at the deer at 300 yards, and I just adjust what I need for fall. That's it.
You must miss everything if you're not accounting for refraction.
I got a stack of deer heads over at my brother's house.
I bet you have.
For terrestrial observations, refraction is at most 0.1 degrees.
Saying that, you can keep saying that, but you don't have an actual position. So I mean, you're just it's you know, this is that thing where I said some guy's telling you if something's higher or lower, or how much off it is of its actual position when they don't have an actual position.
And again,
I get that. I
don't
get that
need
gradient
the
index. I understand that gradient index optics is something that you don't like. I understand that. You've said it several times.
And you don't need to know the actual position to have information about the position. I don't know the actual position of the airplane, but I know it's above me.
Cray.
You gotta love a statement that starts off with "you don't know." Gaslighting, really? Is your first go-to? Horrible.
Right. If I ask you a question about basic optics, if I say which direction does light bend through a density gradient with the highest density is below, and you don't have an answer, it is safe for me to say that you don't know.
I can ask you a question about the pin in a gun, in a specific gun that you've never seen in your entire life, because you don't know anything about guns at all, even though you might own a few. That doesn't make any sense.
No,
Well,
but
there's a
if you make a
difference between
super,
When the topic in question is about basic optics, this isn't even really complicated optics like Rayleigh criterion or any other criterion. This is just about which direction light changes direction in.
it's a bit like saying, does a centerfire gun have a firing pin? Yes, yeah, it's that kind of basic shit.
or like
You
how
know,
do you fire a gun? You pull the trigger. If someone doesn't know that, they know nothing
Squeeze.
about guns.
Well,
It could
squeeze.
have a heater that just
Squeeze.
ignites it via heat.
There's so much
Like-
better things to talk about.
But what he's showing is that if you don't know the very fundamentals of something, that is the same as not knowing that subject.
Right,
If you-
and that's the
Yeah.
thing. That's back to gaslighting. You don't know the fundamentals. I'm going to try and hound you until you know, what I want you to know. And it's annoying. It's stupid. And
Well, then-
it's unprofitable.
Well, you can admit you don't know and say that you don't want to talk about that topic. That would be fine as well.
Bro, starting
you
off with
can't-
gaslighting, one means that the statements to follow are generally false. Gaslighting is what criminals generally do when they're about to start lying. That is a
Okay.
statement of fact, and it is. There's plenty of empirical data for that.
Accusing of gaslighting is something
There's
that
also a statement of fact that if you don't know which direction light changes direction in through a density gradient, that you don't know basic optics. That's a statement of fact.
That's great. And you're the only one saying I don't know. So congratulations, sounding
Well, you
board
would
that
know.
you are.
You could come up with an answer to the question when I asked it.
I don't have to answer your questions.
don't have to, but
Right.
the conversation won't progress real well.
I know.
And even
Right,
then,
since-
you have.
since-
Go ahead.
Since that's something, that's something that that question is something that's you can easily verify yourself. You can take any experimentation you want to induce a density gradient and observe which direction light bends in and which direction objects in the distance are displaced in. Those are things that you can independently verify. I'm not gaslighting you. Those definitely happen.
I'm waiting for proof of measurement of curvature in any kind, anywhere.
Well, wouldn't we know
Proof
how
of
the atmosphere
any-
affects our observations in order to do that?
Doofus has one. He has the tops of haze curving, which he equates to Earth curve. Moyak man, does light travel through a less dense medium further or a more dense?
Further?
Yeah,
I don't really know.
Yeah,
You
because
don't
wood
really
is less
know.
dense than
I would
gas.
say probably a little bit less far, but that's extinction of light, which is
Light
something
is
that we don't experience very often.
Okay, you take a flashlight at ground level and go 100. You go to whatever distance away. The conditions of the day would dictate that light, you can't see it anymore, and then you go straight up. The viewer and the light go straight up. You think you'd be able to see that light again?
Because the Earth is spherical.
Yeah,
I mean, it's not always
Hang
true
on,
to say that.
Moyak man was addressed the question.
If it goes straight up against a dark background versus a somewhat lighter background at ground level, I would say you'd probably see it higher up against the dark background. It's all about
Well, you're
contrast.
going up into
It's
a-
all
a
about
less
contrast. I don't know how much
So it
effect.
has nothing to do with
okay, yeah, goodbye. You're going to talk to yourself. Have fun.
Yeah, I know you want to answer.
Well, he was
So
trying
the
to
less, you think there's more dust particles at ground
Shut up.
level or in the upper atmosphere?
Rocky was trying to answer you, right?
Yeah, I'm sorry. I got a little excited in the fact that he was obfuscating and not answering. He was talking about the background and everything else, where the question was about the density layer. So he actually wasn't answering. But anyway, I digress.
Right, but you're using observations on Earth as though the Earth were flat in order to prove your point that the Earth is flat.
No, I didn't mention anything. Wrong again.
Which is called a circular argument.
Wrong again. I started at the surface. It could be a curved surface or a flat surface, whatever one your balls get off on, and then go up into less dense atmosphere. Would you see further? The answer is Of course you would. And when these guys say, "Oh, I don't really know about density causing that," blah blah blah, but they know about every other thing, they're lying to you.
Glass is denser than wood, but you see further through glass than through wood.
Yeah, density is definitely not a factor here.
It's not the atmosphere. We're talking about the atmosphere. Seeing through the atmosphere, not seeing through glass or wood. Nice try again.
Right, but clearly density through that observation is not the problem.
How light travels through atmosphere. What part of this easy question can't you smart people get?
Right, if you're
Every time you
purported,
try and change that, proves that you're either dishonest or dumb.
okay, if your purported cause is density of the atmosphere, and we can show you that density of the media is not the primary factor, and that in fact we can see farther through a more dense medium than air than we can while we're just standing on the surface of the Earth, then that means the density is not the issue.
No, not the primary. You said primary. So is it secondary?
That's, I mean, I said that
Yeah,
density is
there's a
not the
reason
issue.
you put primary in there to give yourself an out. I know all your tactics, man.
I
Because
didn't
you
say
use them
primary.
so often, that's all we do is look for them. And
Okay, but I didn't
you
say
can't help
primary.
yourself. Yes, you did say primary.
I'll take that bet.
I'll take it right now for 5,000. It's 30 seconds ago. 1 minute. You want to do it? Timestamp this, Jeremy. You want that bet, sir?
$5,000.
5,000. He said primary. Anybody else want to take it? I'll give you odds 3-1. Y'all are either dumb or y'all are robots, and y'all's total thing is, oh,
But
I didn't
that's an
say that.
insult. So it's.
I don't remember saying
I think you
that.
can get a mute for that insult now.
I mean,
No,
not
I
only is
didn't
he
say that.
insulting, he's also speaking over people and yelling. That's three things at once, but okay.
So we're talking about me, right?
He can do it because he's a flat earther. So good.
Yeah, that's so wrong. That's stupid. I get muted all the time. Try again.
Not today.
Yeah, but
I'm
you're not
sure
being
that
right
proves
now,
the point.
so...
I'm not sure that proves the point you think it does, Rakia.
Okay, I'll ask you then. Okay. Does the density of the atmosphere have anything to do with how far we receive reflected light? Information.
So you want me to guess,
I would
right?
say no.
No, I want you to use your knowledge. You know everything about everything else. Put your thinking cap on.
No, I don't. I'm in doubt. Remember?
So we're going to talk about that now?
We've had a long
You're not going to
discussions
answer?
about doubt.
So we're not going to. You're not going to answer.
He's giving you an answer.
No, he wasn't. He was talking about the doubt thing.
Is this conversation
I'm going to
going the
answer
way you
no
want
if
it
you
to?
want an answer.
Because this is why the conversation becomes about you, because you ask somebody a question, then you filibuster their answer, and then you go, why are you making it about me? It's like, because you won't let people talk.
You still haven't answered.
Okay, I don't know.
I would say for me,
what do you think?
The density is not the issue. It's the how much of that light is absorbed by the medium that it's in. So, you know, good example, if I've got something that's very dark, like black as a, you know, color, then that's going to absorb a lot more of the light than, you know, an object that's, say, white. Now, if I'm getting some of that turbidity, to use a Jeremy word, in that atmosphere, which is doing some of that absorption, then I'm not going to see as far. It doesn't matter on the density of the media itself. It matters about the absorption of the light by the medium.
Okay, so the absorption is a factor. Okay, I would agree. What about the refraction, does a more dense atmosphere refract light more or less than a less dense atmosphere?
It's a good question. I don't know. Yeah, like would particles add to density, or is it just the density of the air because the particles are pretty much like stopping it and scattering?
I'll answer that question for you, Rakia, in a nice, simple, easy term again. No, the density of the atmosphere doesn't affect the refractive index. It's the changes of density in that atmosphere that do that. So if you have greater changes, then you're going to have greater amounts of refraction.
Yeah, so the more, hang on. That was addressed to me. So the lower you get, the more refraction you get, which would mean you're not receiving, what?
No. What if you listen? I will repeat my answer again. So the density of the atmosphere in itself doesn't actually matter. It's the change of density within that atmosphere that matters.
Right. But at the surface, you get the most change. You agree?
Not necessarily. No, I'm not sure that I'm gonna. I'm not sure.
Oh my
I'm
God.
going to just no because I don't know. You know, asking me things that I know, and I'm happy
Y'all
that
seem to
that's
know
a
everything
knowledge
about
claim.
refraction. It's settled science.
Rakia, why do you do that?
Because I
You
think
don't know
it's
everything
funny.
about. No, you
I
don't
think
know
it's
everything
funny.
about refraction.
I never
Nobody
claimed to.
else in here knows everything about refraction. Most of us in
Dude,
here are fucking
for years,
skeptics.
how
Most of us in here
7/6
are
R
fucking
reflect
skeptics.
light at
So,
ground level.
can
That's
I
why we
finish
get
my
distortion
point?
more at ground level.
Can I get some moderation in here?
Guys,
Because
one at a
this is
time,
just
please.
fucking
One at a time. Thank you.
Yeah, Ricky, you kind of need to,
I'm being polite to you, Ricky, and you're treating me like a fucking cunt. Stop it.
Yeah, I've been treated like a cunt for years. Get used to it. Nice try.
Okay, so two wrongs make a right in Rakia's world. So that reason.
I just don't think it helps.
Talking about Rocky again as I go on mute again.
Yeah, it happens a lot, doesn't it, Ricky?
Can you guys hear me talking? Can you?
I can, Brandy. That's why I shut the fuck up.
Why is everyone trying to overtalk me? I've got no idea. All right, so everyone, take a breath. All right, let's get a bit more respectful and let's get back to a conversation, please. All right, take it away, foolish.
I use cunt in the friendly buddy sense.
Yes, well, let's refrain, right, and get back on track, please. Thank you for your time and consideration.
Thank you, Banter.
I think you were finishing off foolish. Do you want to finish your point and then Rakia can respond?
I was thinking actually that particles held in the air, you could also say might.
Go ahead. Just go in front of foolish.
Yeah.
Or did you go over me? Foolish wasn't talking when I started talking. I know he was invited to, but I'm allowed to share a thought, am I not? Foolish, is it okay that I spoke just now?
Well, I gave the floor to foolish, right? And I was waiting for him to respond, and you just did kind of jump in.
And the problem that just happened then was that I spoke in empty space after you said foolish, not that Rakia charged in yelling again so loud his mic clipped.
Well, I was about to jump in and say I gave the floor to foolish, not you. So before Rakia got in there, so okay. So do you want to take it away, foolish, or do you want to hand over?
No, I was actually just taking a phone call, and I was happy for other people to pitch in. I mean, the only point that I was making, Rakia, is that you asked me about stuff that I know, and I know that changes in density. Whether we get the most change in the density of the medium at the surface or somewhere else on Earth is something that I just cannot categorically sort of comment on.
Everyone says the closer you get to the surface, the more distortion you get. That's why you don't do low-level observations. Yeah. I don't know why y'all are fighting this. Information is light. Light is information. Yeah. I almost got it out. Almost. It's only 4 people that jumped in. So that's getting better. It's usually 5, but I'll keep going. I don't know why this is.
Sorry, can anyone else hear anybody else talking apart from Rakia? I can't. I'm a bit confused.
No, writing is jumping in with a little comment here and there.
I just said yes. Oh, come on.
Well, then
really,
don't. Well, then
guys.
Yeah, it's called clipping.
No, writing. You know he doesn't like it, so why do it when you know that he doesn't like it?
Hang on.
Right?
The logic I'm hearing from you right now, Bansor, is you know that he's a petulant child, so
listen to this guy. Why is this allowed?
Come on, we can all interject from one another's.
I will mute. Just let him finish what he's got to say. For God's sake.
What is he? He's such a child.
You're doing it on purpose.
Oh, he said it again. Called me a child again. As he just childishly just cried about me clipping him. He clips me. But anyway, I'll move on. I don't know why we're even arguing about this. Doofus just came up with you got to get 20 feet above. 50 feet would be better. The higher you get, the less distortion you're going to get, the less refraction. Because the air is less dense, we're going to see further. Right, the light can travel further, so you're getting that reflected light information to your brain. I don't know why people are even arguing against
So,
this. This is, yeah.
so what we
I
will
was done.
agree with, or what I will agree with, I'm not going to speak for everyone. What I will agree with is that right by the surface is the most dynamic region, and therefore that's where we'll have the most change, which means the most refraction. But then when you go off the surface by a little bit, like a few 10, 20 feet, then it starts getting very non-dynamic, and
Fair.
that's where you don't get as much refraction. That's what I
What
will agree
changes?
with.
What changes?
It's not as dynamic. Right at the surface is
It's
where, for
less
example,
dense.
no, it's the dynamic. It's the point that it's less dynamic.
Why can't you say it? It's more dense at the surface and it's less dense as you go up. It's called
So
density
that
gradient. They
no,
call
so
it. You are the one who's taught me about the density gradient, and now won't
yeah,
say it.
so that is true that there is a density gradient, but that is not the reason for what I'm talking about, the refraction. The reason for the difference in refraction is the dynamic nature of right by the surface versus higher up.
Fair enough. Does light travel through a more dense medium or a less dense medium?
What do you travel? They can travel through both. What do you mean?
Speed.
If you're above the pool looking through the air, can you see further than if you go underwater?
Yeah, underwater you can't see as far as in air. Yeah.
Is the water more dense than the air?
Yeah.
Thank you.
That's weird because I can see through the glass.
Yeah. I've seen some really clear glass that you can see through further than through water, and glass is more dense than water. Thank you.
So it's medium dependent then, right?
Clearly, there's more factors than density.
Okay, but it's medium dependent. Glass is more dense than water, but you can see through glass further than water. I would agree, okay? So is the atmosphere made of glass more or water more? And I'm done. You don't have to answer that. I think everyone knows, and I'm done with y'all trying to obfuscate this point.
Glass. Definitely glass, Ricky.
No. Yeah, it's more glass because here's the thing. Glass is silicon dioxide. So it's got two oxide, and air is more oxygen than water. So there you go. It's more glass than water.
Oh, nice. I wouldn't have thought of that one.
That's what y'all are going with? The atmosphere is more glass. It has more glass particles or whatever you want to call it than water?
Well, ask stupid questions, get stupid answers.
You say if you take it down to the elemental level, Rakia, you can say that it's got more in common with glass than it
Yeah,
does
that's
with
why I said you don't have to answer. But your whole claim was how we see through glass, and we're talking about how we see through the atmosphere. So that's why I was pointing out. You bringing up glass has nothing to do with how we see through the atmosphere.
It shows that density cannot be the thing that matters because glass is more dense, yet you see further through it.
No, that's
It's
not
not
what we're
irrelevant.
talking about. We're talking about the more dense the atmosphere is, not if glass is more dense than the atmosphere. It's obfuscation again, as I pointed out. This
That's
is all
not
y'all have.
obfuscation.
Well, whatever it is, you can name it. It's bullshit.
No, it's a point based on the fact. So let's get to the end of your argument. So you're saying that because the air is more dense at the surface, therefore, carry on.
The light coming back to you is more distorted, and we don't see as far. Period.
Okay,
Yeah, and we've
so
given our contention with that. That it's not just the density, it's the dynamic nature.
Yeah.
No one, and I mean no one, even 10 miles from me, has said that that's the only thing of that density is the one cause. Nice try again. We're talking about how light travels through the atmosphere, not glass, as it's been brought up several times. We're talking about if the atmosphere is more dense than another portion of the atmosphere, how light would travel further or less far, be more distorted or less distorted.
Sure. So I can give
I
can give a simple example. You're not going to like it, but I can give a very simple example just using the atmosphere that kind of has a bit of a problem with what you're trying to say there. So I can be halfway up a mountainside, and be in fog and can't see fucking anywhere, even though that atmosphere is a lot less dense than it would be 1,000 meters lower down on the surface.
Fog is a physical object, right?
No, fog is a gas, effectively. Well, water
It's not
vapor.
physical.
It is physical, yeah. Water's physical.
Well,
So gas or fog is a physical. I'll ask again, as you said no, and then agreed that it's physical.
Like
so
the
you're putting
atmosphere.
a physical object in front of the
Like the
light,
at-
like a
like
cloud,
the atmosphere.
or fog, or a
Is
tree, and trying to say how we don't see as far. Nice
Is
try.
the atmosphere physical?
I would say yes.
Cool. So what then?
And so
And the more dense, or the angle and everything else, density is not the only thing. That's why your fog example doesn't matter. Some things travel through more dense objects, just like glass. I would agree. I said I agreed a while ago. We're talking about at ground level how light travels because there's more. That's more dense than if you go up.
But don't you think that the point that I made, it's about, what's being absorbed between A and B, where the light's coming from and where it's being received?
Dude, am I in a Twilight Zone? Y'all's
I don't
whole
know.
claim is we look up towards the stars and we can see them because it's less dense. And now you're arguing with me that that's not the reason.
No, we're saying we see the stars are less refracted because you have less of a change as you look straight up. That would
I'd
be
say
the true
Raphael would
statement.
never know because he again never didn't let me finish my point. But carry on, mate.
Yeah, it's not a problem of density. We have a huge density gradient looking straight up, and yet we see really little refraction.
Indeed.
Okay, so I'll ask again. If not density, what is it?
Does it increase in density or does it decrease in density?
So sorry, but should I answer Rakia's question or the new question?
Both.
Okay. Well, so first of all, Rakia's question. So it's not just a change in density. You would need a change in index of refraction in a what's the word? The opposite of parallel. I've forgotten the word. What is it again? I'm blanking on the word.
Parallel.
So when it's not parallel, it's
perpendicular.
Perpendicular. Thank you very much, Jerry. So it is about the index of refraction perpendicular to the path of the light. That is what's important. So when we look straight up, even though a change in gradient does result in an index of refraction, that index of refraction is parallel to the light ray. So it doesn't matter. What we need is for it to be perpendicular to the travel of light. And that's why, especially when you look far off into the distance, well, now you are looking perpendicular to the gradient, and therefore it will have refraction.
Because you're looking through more dense. If you add up all the density as you look up, you're looking through a thick, dense atmosphere at low level, but then you quickly are looking up, so you're getting out of that, getting less dense and less dense, so you see further. As you look parallel through that dense layer at surface, you're looking through more and more and more of it, more distance through, trying to look through more of that dense layer, and light just doesn't travel as well. The information doesn't get back to the viewer, and it's not just the density, it's a lot of other factors. That's where the more turbulent area is also, because that's where the gases are mostly coming from and mixing and whatever.
So
and then you get reflection, refraction, diffraction, you get angles are different. You add all that in, and of course you're not going to see as far at ground level. Remember? That's what y'all told us, go up on a ladder,
Yeah, so what I'm talking about is the effects of refraction based on where you're looking. You're talking about other things on top of that, which is like how far can you see before the light gets completely absorbed or attenuated. These are two different questions.
Well, that was the conversation, but refraction is part of that, right? Light attenuation and refraction are kind of like brother and sister. If the light is being refracted to where it goes over your head, you're not going to see the bottom of that boat. Or
Yeah, but that would be more. It would be more that the light is missing you rather than it's being absorbed. That's why I'd say it's different.
being refracted. No, it's being refracted. Yeah, it's part of it. I agree.
But it's like saying that the reason, like, so yeah, sure, both can be reasons you don't see something. If the light is absorbed, you can't see it, and if it's not hitting your eye, you can't see it. But I wouldn't say that they're like the same, or like they have different causes for them.
Yeah.
Do you not agree?
Yeah, they do. I agree. I just said I agree.
Thank you. Thank you.
But they're joined together, right? They're all of how we view an object at distance, especially at low level over a marine layer, is going to be more distorted than if you were in clear air in a mountaintop, dry air. You know why? Because the conditions are different.
Yeah.
Oh well, where were you an hour ago? Thanks for agreeing.
But I've also very clearly said that it's not just about the like absolute number or absolute level of density. It's about the change in such and the change in these conditions and the fact that it's more dynamic near the surface. That's why it's not as simple as saying more density, more refraction. It's different than that.
If you look, man, I don't even understand what you're saying now, because if you look parallel, like over water, it's more dense, right? You're looking through a more dense layer, and you're looking through the same distance, let's say 100 miles. If you go up and look through a less dense layer of atmosphere, you're obviously going to see more clearer of that 100 miles. Hello? Parallel. Remember, it was your example.
Yeah, but what I'm telling you is
that's just angle, right?
No, I'm trying to clarify that it's not just the absolute density that's there. It is the fact that it is more dynamic. It has a wider change in density versus up higher up.
Yeah, I agree. More change in density. Yeah, it's more turbulent.
Exactly. So it's not the fact that it is more density as an absolute. It is the fact that it's more changed. It's more dynamic, more turbulent, these things.
Well, you're able to have more change because it's more dense. Jesus, man. Everything affects it. The atmosphere, if it's more dense, the thermal energy, the magnetic properties, how much it collects, how much gas is mixing and being turbulent in that gradient area, that corridor makes a difference, because you can look out parallel over an ocean and have a downdraft or a temperature change 10 miles away, and then have another one 20 miles away, and you're going to get some funky things going on. Miraging, superior. I mean, buildings can appear upside down, so can boats. They can appear to float in the air. The sky can be mirrored or appear to be water, and the water can appear to be sky. They blend in over distance, actually.
So why would you take, like, say, an image, you know, like the Isle of Man or something where you could see 200 miles away? Why would you take that as what it is when you know all the effects that refraction can do to a observation?
Who says I don't take it for what it is? It is refraction. It is miraging. It is how we see over 200 miles during that particular conditions when that video or snapshot was taken. Yeah, I know this for a fact because I do it myself. And I go out on a different day, just a couple of days later, or sometimes the next day, or sometimes 6 days later, specifically, when the conditions have changed, and that same object from the same distance appears totally different.
But then the logical conclusion is that if we know that light can have such dramatic changes, then if we know light can have such dramatic changes, then there's no such thing as seeing too far.
I'm the one who said earlier, where were you an hour ago? We don't see too far.
Yeah.
We see exactly how far the conditions of the day allow us to see. Now, if you're going to say Earth curve is in the way, then I will have a problem with that, because we see way further than the geometric Earth curve would allow us. And y'all say that's the object being loomed up in perfect condition. That is not possible.
This is
It can be loomed up.
exactly Flat Earthers' point that you cannot use optical view to be able to determine whether the Earth is a globe or flat. Because
Well, I agree with that.
Yeah,
right?
But that's
It's
different
not a
than what
measurement.
Rakia just said, that it cannot be the geographic or the geometry of the globe cannot be the reason we don't wouldn't see that far. But that is incorrect because of the fact that we know light can bend, and therefore what would stop it from bending around a curve, making us see quote unquote too far on a globe.
So there you go. That's the thing, though. You're trying to make it seem that the Earth it's a globe because the boats go over a horizon. We saying you cannot determine whether the Earth is a globe or flat by just optical view.
And I agree with that.
Boats don't go over anything. They go into the thicker, like more atmosphere. They go into the distance.
But now you're making a wider claim than what we observe is bottom up obstruction. Now
yeah,
I
of course,
agree
because it's more dense.
Hold on. I agree that we see bottom up obstruction, and that on its own does not prove globe or flat. It proves neither.
What else can cause it?
So there's two main things that I would personally think could cause that. One would be a globe, a geometric thing, and the other would be the upwards bending of light. Those are the two things I am aware of that could cause that.
And the upwards bending of light, or even the downward bending of light, could cause it because of the turbulent, more dense, more turbulent atmosphere at that ground level. Because if you get a downward bending of light, that would distort the image bottom up also, because you would get more reflected light going over the viewer at certain angles. And once you increase that angle, you're not getting as much of the information going over the viewer. And then sometimes it would be refracted up, depending on the conditions of the day.
But hold on, I don't see how that's
It's the same thing as when we see too far, because it's either flat or it's just refraction. You can't use it's either flat or it's round when you have either obstruction or no obstruction. You can only say there's something, the dense medium or whatever refraction is causing the issue, not the anything of the Earth itself.
How light acts is I mean, over those short distances isn't going to matter with the size that you say it is. When an object is 10 miles away, whether it's a flat plane or a curve, I don't think it's going to be that huge. I think conditions are going to matter more than the shape. I don't ever really bring in the shape. It's not a shape issue. It's how something, close to you can appear obstructed bottom up, and then on the next day it's not, and then something far away from you can do the same thing. It just logically seems, unless you're going to say that physical water is curving, and the object in the distance, because you can see the bottom of them on this particular day, is because they're loomed up, or you can see the top of them and you shouldn't because they're being loomed up due to refraction. But on the other day, they weren't being, what do you call it? They weren't thinking. That doesn't make sense.
Well, but so what I'm saying is, from the observation alone, yes, we cannot distinguish whether it is a looming over a globe or whether it is a refraction over a flat Earth from the observation alone. That's why I believe that when we look into the nature of refraction, the nature of optics, that's when we find our answer.
Yeah, you can have looming and sinking on a flat plane. You can have the curvature of the horizon appearing to be curved due to the way we see, thank you, Doofus, on a flat plane. I actually tend to agree with him on that.
Wouldn't it just lead one to go, I guess, relying on observations of this sort is ill-advised?
Yeah, you would need to go measure that curved water. If you're going to claim that water is curving into the distance and obstructing something bottom up, then you need to measure that curved water. Until you do that, no thanks.
But
we know it can be refraction.
And I've been fighting with Huey and Nathan about the whole black swan thing. I'm like, look, man, any observation you make of the black swan or any conclusion you make that it's a flat Earth because of the black swan, you're not taking into account all the factors of refraction.
Well, if you're saying it's being those oil rigs and that little buoy next to the oil rig, that white buoy, that's actually an anchor, I think. You think that's being loomed up? Then you need to come up with that, man, because that's a tough one. It just seems
Well,
like
what about the white swans, dude? What about the other pictures
The
that
black
are white
swan.
swans?
The black swan proves what we've been saying all the time, that the horizon is
Hold
not
on, guys.
hold on. The horizon is not a physical location. And y'all been always saying that it
Okay.
was a physical location, that was Earth hump. And we were saying no, it wasn't. We could see further than that because of the depending on the on the day or whatever.
yeah, they've given up their physical location. There's
So
no
if there is,
geometric location on a globe anymore.
Well,
if
no.
there
It's
is,
all refraction.
Wait, what are you talking about? There's no physical location. Like every time like you guys bring up the black swan, you don't want to recognize that there are white swans. There are other pictures where there's minimal refraction, and the oil rigs are where they say they are. Like they're not far off in the distance. It's what
It has nothing to do with oil rig.
Huh?
What are you basing your minimum refraction on?
The black swan has nothing to do with the oil rigs, but
Okay, what does black swan have to do with them?
with the horizon.
Okay, yeah, the horizon.
distance.
When you look at those white swans, it's right around where it should be.
Right. So what? So your horizon moves.
There's no question. The only problem you guys have is the black swan. Hence, why you call it the black swan.
Oh, so what? Does your horizon move back and forth?
to me, it just says this is a bad. If the horizon isn't a physical location, if it moves depending on the conditions of the day, it just says to me, don't trust it either way. And it sounds like what on the flat Earth side is saying, it's not a physical
100%.
location.
Yeah.
Refraction does exist.
Exactly.
It's very unreliable when there are these white
Yeah.
swans. But then the moment it switches over to the black swan, they're like, "That's my baby there."
Yeah, you don't
we can trust
understand.
this one. To me, I would just throw them all out.
It's our baby because we showed y'all that the horizon is a physical location where y'all thought was Earth curve, where y'all thought the Earth the boats used to go over.
Yeah,
Isn't
honestly,
it?
I did think that. I did think that, and it did absolutely teach me something. It showed me something very interesting. But now what you've got is a solid explanation for that. Lots of examples of light behaving bizarrely over water, even lots of flat earthers saying this method for determining the Earth's shape is shit.
Yep, we wasn't determining the Earth's shape. We were just showing you it isn't an Earth curve. That's all it was.
Well, that's changed a lot, right? Because as you said, it was your baby. That's why I understand flat earthers, having such a hard time giving it up. I think it converted a fair chunk of people that staring at that image and going, "How the hell can the horizon be there?"
What the
You've got a
hell are you
valid answer
talking
now.
about? Solid evidence of the horizon behind the solid object, which cannot be argued the distance. Try again. This is a killer
can I
for
ask
your
you then-
radius. Your radius dies at the black swan.
Can I
Period.
ask you like a couple
Well,
of
real quick,
questions,
if
quick
you-
fire essay, just yes or no
After-
questions?
Go for it.
The problem
So
is that
you've seen
the
the
head of
white
NASA
swan, yes?
doesn't know this.
The white swan, no.
Okay? You've seen the black swan, yes?
Yes.
Okay. Can somebody put a picture of the white swan in the chat? I'll describe it to you in the meantime. It's the oil rigs with the horizon about exactly where you expect them. On that day, what do you think is happening? Do you think light is probably bending?
On every day, whenever you go out, by the hour, the conditions change. That's what I've observed. Now, you have, this is where you guys have a problem here with the swan, right? Now, it doesn't prove a globe, but it does prove that your horizon is beyond what you say it is. There's no way around that, bro.
So the question is, if you look at the photo at 11 minutes past the hour in the chat, it's 11:11 for me, portal hour, would you say that what we are seeing there we can use as a solid evidence for the shape of the Earth?
I don't know. I don't know the conditions. I don't know how the water was. I don't know. All I know is that
If you don't know
what's
the
damning
conditions,
for you,
you cannot
eggshells,
trust it.
eggshells, what's damning for you, right, is that these locations are solid. We know where they are. There's no getting around that.
Yeah.
It looks like
So
there's a
when
lot
it
of
comes
curve
to-
in that
The
picture.
problem is that NASA, the head of NASA, uses what you just agreed doesn't actually articulate the globe very well. They use that as perfect proof of the globe, and then go on TV and expound that information to everybody.
They use a photo of oil rigs. What are you saying they go on? I'm just saying photos and how far we see and behavior of light over the surface. Even many flat
Going
Earths
over
agree is
the
a bad
horizon.
method for
Boats
measuring the
going
planet.
over, they
When it
literally
comes to
said boats going over the horizon in their explanation.
Right, but that they disappear behind something is different from taking
It looks like
measurement
too
to
much
determine
curve
exactly
between
where it
those
is.
two in that picture.
But so you would agree,
Occlusion
though,
is
that the head of NASA doesn't have a really good argument for the globe in that sense?
Okay, so I just want to finish my questions for SE.
But that was all I wanted to say. I mean, because you're arguing with the head of NASA here, who says that it is a good
Well, that's
reason.
not what I'm talking about, and I'm
be
not here to
globe.
defend the head of NASA. I don't care. I'm sorry, Fuzzy.
You're agreeing
SE,
with them.
what rule do you use to determine that you can trust the black
Go
swan?
ahead and ignore it.
but
That's fine.
But because you don't know the conditions of the day, you're not able to trust the white swan. How do you
I
choose
don't only go with the black swan, right? I've been to the beach myself, and I can tell you 100% certainty that the boats do not start disappearing at 3 miles. It's game over, man. There's
But
no way
I'm just
around this,
talking
bro.
about the black swan at the moment.
Yeah, the
With
black
the
swan.
white swan, you
It's
said
a
I won't
fact
trust that because I don't know the conditions on the day. On the white swan, you do trust it. Do you know the conditions on the day?
No, that's not the question. The question is this: we have multiple, dozens and dozens and dozens of picture of the oil rig, which we know the location, and we have the horizon behind. It's game over, bro. Now you can show me one picture of the. Hold on. You can show me one picture of the conditions. I don't know if it's a swell or I don't know what you have there, but in reality, you can't go against it, bro. You have a fixed position in the water, which we know the exact distance. There's no way around that. Don't fight it, bro.
Here's the
You look
difference.
silly
Seems like
doing
too
it.
much water between those two in that picture.
I wouldn't say that the white swan is a picture of Earth curve. I would say given A and given B, this is a bad method. So I'd throw them both out. It's not that I'm trying to
Seems like
defend
the
the
white swan
swan.
picture
It's
is invalid.
Yeah, but they both seem like a bad method.
But I think it's weird
I'll be sure
that
to call NASA. I'll be sure to call NASA and tell them that their method is bad. Or maybe you should, if you've just discovered
I mean, if
this.
you
Maybe
could just
you should
show
tell
me the
them.
bit where NASA says that, go for it. But I don't think they really talk about the black swan.
So you think Soundly's
they're both
observations
going
are
over-
not
no.
Earth curve?
No, they say specifically boats going over the horizon. What they specifically say.
Let me make this clear again. Occlusion, I think, is a different issue. I do think that is solid evidence of something happening. How far you see, it seems like both sides agree that just looking to determine the distance from me to something, looking horizontally near the surface is a bad method. It seems that we agree that, but on some days when there are some pictures that are interestingly among the minority of pictures you can take if you point your camera that same direction on different days, you choose, yes, actually today is the day we break our rule about which sources we trust. Today is the day we accept this photo from BMSLB 69 or whatever it is.
So it's not you agree it's not a great method either way. So the head of NASA should probably know about this.
Sure,
That
if
it's a
they
bad
use
method.
that method, if they use that method to determine the distance to the horizon or the shape of the Earth, then they're idiots. Yes, I'll tell them. You give me a phone number, I'll call them up and let them know they're idiots.
Yeah,
Of course they do.
I would like to hear the quote from them.
The people that has satellites in space, in order to measure the Earth, they just stand on a beach and eyeball the distance to the horizon.
Assume.
I don't think that's the case.
No, but they do teach people how you do the horizon. Navy, military, all of them teach horizon methods.
Horizon
I don't
methods
know why
to determine your distance from the horizon or celestial navigation?
Well, both.
Different things, right? But they're different
Yeah, but they teach both. And do you? So since you agree that observations aren't good, so you think Soundly's observations of what he calls Earth curve isn't Earth curve?
I'm still stuck on. I'm fascinated still by that point of this. They teach in the Navy horizon methods. Could you tell me what those are? I've never heard
Well,
of them before.
when we're talking about how far we see, you have to go up to see further over the horizon or to the horizon.
That's true.
And if something's beyond the horizon, you can calculate that distance based on the radius of Earth.
It's true.
Yeah, that's the bit I'm struggling. That they say if you can eyeball it, then it's this far from you. Because I imagine they would say if you can eyeball it, you've got to do a bit of guesstimation based on refraction.
Anyway,
okay, maybe you can answer Rakia's question now.
So Soundly's observations aren't Earth curve then?
Maybe, I don't know. I don't know what they are. But it seems like
You've never seen Soundly's observations?
I may have. They don't jump to mind. I'm not.
The bridge and the power line?
I've seen photos of that. I don't think I've seen the.
Yeah, that's what I just asked. His observations, his
Can
photos.
I just ask you something?
Oh my
It sounds
God.
like we agree with one another that observations close to the surface are a bad metric.
Well, that's
Would you
what I'm
agree with
trying to
that?
figure out. That's what I'm trying to figure out. That's why I'm
Yeah,
asking you.
If that was his method, like I haven't seen his video. I'm sorry for that.
Okay, have you seen B-Ball's pictures? Have you seen B-Ball's pictures of 8 feet above the turbulent water of the bay wherever he's at, looking at the buildings and the buildings are obstructed bottom up? You've seen those, right?
So occlusion, I'll say it again, really slowly for the cheap seats at the back. Occlusion is something different that I do think is valid. What we're talking about is using it to determine your distance to the horizon.
And that's what I'm asking you. B-Ball is using it. Yeah, you cut. I mean, are you done? Just maybe give a beep or something. I'm sorry for cutting you off. Go ahead.
Well,
I wasn't trying to be ugly.
Using it to say here is a large object that is obstructed, that is a different thing from saying here's how far away the horizon is based on where my photograph gets.
Okay, let's say he's using it as here's the bottom of the building being obstructed by curved water. It's a low level observation. He's 8 feet over turbulent water, whitecaps. Would you agree that? I'm asking you a question. Why you cut me off?
Because I've given you this answer about 5 times now.
Once
more.
Anyway,
just once, please. Please.
No, don't repeat it. Do not repeat it.
Is,
don't repeat it. That's not the answer to my question. So what is B-Ball saying, you think? I'm asking you what B-Ball is trying to say, in your opinion.
You shouting stuff at me.
Rakia,
all I got you is cutting me off before I finish. That's all I have.
You two guys shouldn't engage. It doesn't go on.
You did interrupt him. You just interrupted him in the middle of asking a question. Whether he's asked it again, he's obviously trying to get to a point.
I'll ask somebody else to be fair. SC, when B-Ball posts his pictures of low-level observation over turbulent marine area corridor, what is he saying he's proven?
He's saying that the water is blocking I don't know how many floors. He's saying he's proven Earth curve.
Earth curve, right? Wow, that was easy.
Now, does anyone else? I just posted what he asked for, where NASA is telling us that boats going over the horizon. It's their big thing.
Again,
1 minute.
Just please, let me make this super clear. The horizon occluding something, covering something appear to disappear into the horizon, I do think is a reasonable demonstration of curvature of Earth. What I'm asking about is a method of determining distance to the horizon based on observations close to the surface. Please let that be last time. So yes, if it's blocking buildings, I think that's good. If it's showing that the hull disappears hull first and you can bring in a smokestack, I think that's solid. I think that is really good evidence of something. If it's
so back to Rakia's question about the bridge eggshells. Do you agree with the measurements of that bridge?
I don't know what bridge you're talking about.
Sorry?
I don't know what
bridge he has no clue about the bridge. Although Blue, Soundly, the Pontchartrain Bridge is talked about on a daily basis where he's here listening and hearing it and seeing it in chat, I'm sure, because he's here all the time, but has no clue about Lake Pontchartrain Bridge.
What? Is that what he's claiming?
I think so.
Eggy boy, come on
now. I don't remember saying any of those words. I just remember saying I don't know how long the bridge is. I've never
24 miles.
Any bridge.
It's 24 miles.
Okay.
You know how I know?
Is he better than me?
No, because I've been here more than an hour. just like you, and you're going to claim you don't know the distance of the bridge, or that the Sagittal is 90 feet, or that Stanley did 3 years study on the bridge. You don't know any of that?
Seems like
to be
fair, I didn't know
those
the
are
length of the bridge.
I'm sorry.
If I were a
baller,
one at a time, boys.
We're talking about a topic that's brought up here every day almost.
You got two or three people that chat a lot, and those 2 or 3 people are always kind of keeping things going. And there's other people that just want to say a statement or two, like me.
Yeah,
go ahead,
jump in.
Yeah, I was just going to say, in all fairness to riding, if I were a baller, I would not claim sound leads. I would act like I didn't remember it too. I would act like I had no idea that those pictures were ever claimed.
That's a good point. I'm sorry to talk over. My one question is, does it seem like Soundly's photos are ridiculously fake? That's all. Thank you.
Well, before we move on to that, in all
They're not
fairness to
fake.
riding, I have been in this game for a while, and I didn't know the length was 24 miles either. So
No one even mentioned the length of him.
I don't think
no one even mentioned that. We were talking about if he knew about
disingenuous, Riding. You're being disingenuous.
Can I have a go, please, guys? Bansal? Maybe? Okay, I'll just go. I don't think knowing or not knowing the length of a bridge, particularly a bridge I haven't measured myself, is indicative of much. All I was saying was a pretty simple point that I think you get percentage, which is I think it is a bad method if it is determining the distance to somewhere, but if you're showing occlusion, that's different. You get the point I'm making, don't you, percentage?
I just got here, so I haven't listened to any of that.
Riding, you're lying. You know about the bridge. You just choose not to talk about it.
I don't know its exact length. Come on, did everybody here know the length of what silly gatekeeping?
Not
is
at
that?
all.
You've got to know
I have
the
no
length of
idea
the
the
bridge
length.
in order to be able to converse here.
Who asked you the exact length? Who asked you the exact length?
Yeah,
you brought up you didn't know the exact length. No one asked you that. I don't.
Go ahead, Bansal.
Well, the question initially was posed: do you know of the bridge, and do you know of this picture and that picture? And you said right off the bat, no. And
no.
That's what you did say. Right?
You can hear him, Bansal. You can hear him laughing behind his voice. You can hear he's doing it on purpose.
I know the bridge, but do I know every measurement that anybody's done of the bridge?
No.
No one asked you that.
No one claimed that you knew every detail. No. You're scoffing in the background, but no one said, do you know every detail of the bridge? Right.
I don't even think anyone asked you the total length of it. You brought the length up.
What?
Yeah, Riding, your tell is up, bro. We have you. We have you pegged now. We know your tell.
Can make one of those bets with me? Bet me the cash again about who brought up the length of the bridge.
Well, then we would be even because you lost the first one. I don't know who. I was asking you who.
$5,000 cash bet before.
Who brought it up? Who brought it up?
$500.
Who asked you the total length of the bridge?
You did.
You did, Rakia. I'll take that bet.
Let's go $500.
The first I heard of the length was from you, Rakia, but I just got here, so.
Okay, cool.
Okay, wait, guys. I just came in real quick.
Still don't have an detail.
I just wanted to ask.
That was so weird, Rakia. You just
okay, Eggshell. So do you agree? Get the length.
And then just randomly you brought up length of the bridge is bizarre.
Okay, Eggshells. You don't know the length.
I don't remember anyone bringing up besides you.
Wow, you guys. Who's the mod here?
We're arguing in the weeds here. Why are we arguing into the weeds? Okay. At some point, hold on.
Fuzzy Ewok first. Then
what's going on,
yeah, let's go back. Let's go back. Okay. I know for a fact that you. I'm trying to bring it back because we're in the weeds.
Bansal wants to make a mod announcement, and then you go right after.
Exactly. We've got to start talking one at a time, guys. So we've got to be a bit more respectful and try not to overtalk each other. So jump in, Fuzzy, make your point, and I think JD may have wanted to make a point after you. If I heard him, I think he was trying to get in too. So.
I'll go third, please.
All right.
Just wanted to say that all this arguing into the weeds is playing in. Doesn't matter. Okay, the point has now been lost. Let's bring it back to something specific. Okay.
Yeah.
I know for fact specifically that you asked where you would want to see where NASA said that you can see boats going over the horizon as proof of the globe. No. And I presented it to you, and you brushed it off.
No. What I
said. You did ask for that, right? You did ask for that, right?
No. Let me make it.
Let him respond, please.
I'll say it again. if it's occlusion, I do think that is a good method of determining that the Earth is curved. If we're using an observation to tell how curved it is, i.e. how far away the horizon is, that is a bad method. Again and again I said this. I don't know how many times. Please, somebody.
But
just
all right,
make a
so just
soundboard with it and put that button on it.
For clarification,
Explain
then, but
why
before,
one's good, one's not.
You said
Sure,
before, though, that it's not that all of these observations are not good methods for proving anything one way or the other.
Yes. If the method is the second one that I have a problem with, then that is a bad method for proving anything either way. If it is the first method, then it is a good method for determining either way. That's my opinion. I'm not saying it's fact.
So
that's my opinion of the two.
So when it helps your argument, it's totally cool, and when it doesn't, it's doesn't matter.
When there is noise in the results, throw the results away regardless of what they say. Throw the white swans out with the black swans. Even though the white swans are more numerous, on most days you get the white swan images, throw them out too, because it's a bad method. That's all I've been saying.
Okay,
this is why
just to be clear then, so every children, all the children that learn about boats going over the horizon are learning a false sense of knowledge.
Somebody else help me here? Because he's talking about obstruction again, right?
Okay.
Well,
let me just.
I just don't understand how
JD had a point, and then SC was next off the bat. If JD doesn't want to make a point,
I agree. I agree. We should get back to the shape of the Earth over.
Right, but the obstruction is the shape of the Earth. Like, it's pretty clear, right?
No. In your model, it is. Obstruction can be atmospheric. It can be physical. It can be whatever. Yeah, I don't know why you said that. That was pretty much a lie. But let's take ships. Ships the same size. Oh, I'm sorry. SC was next.
SC, let SC jump in, please, buddy. Thank you.
It's okay. Let him go. I'll go next. Go ahead.
Hold
on. Let me just make a point real quick.
Hang on. No, I'm going if SC isn't, because I was already talking. If we make ships the same size, they're the exact same ship, and you put them different distances away from a viewer, the top of that ship is going to appear lower in the distance, correct?
Sure, yeah.
Okay, so the further they get away, the top of them are going to appear lower and lower and lower. That has nothing to do with them going over the curved water. And then the bottom of them, because of the distance and your angle is changing because of the distance, and you're also looking through turbulent air over a longer distance, the bottom would appear to be obstructed. Wouldn't you agree?
I can help sort out the logic there. It seems that the logic is you're looking at the top of the sail and going, that doesn't change, that gets smaller. But what you're doing is you're looking at the thing we both agree on, not at the area we disagree, which is the hull, the opposite end of the ship. Now, if you go to the hull, yes, I would expect that hull to rise up if you want, in my vision, and it will keep getting smaller and smaller. What I expect with the laws of perspective is it will do so at a trigonometric rate. There's no known law of perspective or thing I've come across that would cause it to be obstructed bottom up.
So you don't think the atmosphere and the angle change is going to cause things to be obstructed bottom up?
I think that can happen at small levels. The fact that this always happens to things when they get far enough away, I think is strongly indicative of something.
Well, let me tell you how he's wrong. Oh, go ahead.
So something inside the horizon shimmering up and down, or determining, as I keep saying, the distance to the horizon, bad method. But seeing something obscured by something else, I do think is more reliable, yes.
Well, I'll tell you how he's wrong. The atmosphere conditions of the day do matter. And the more turbulent, closer to the surface something is, and then as you rise up, it gets less turbulent, does matter. That's why on some days you get this clear bottom-up obstruction, and on other days with the same object, such as the sun or a boat, you get this blinking out, like this fading out. It never disappears bottom up. It just starts to fade out and be, what is his word? Collusion? Light extinguisher. Light extinguisher. I can't say it. Right? You just lose the information. And that is dependent on distance, the angle of the viewer, the source light, the conditions of the day, because every day you can go out and stand and have that same object go away from you the same distance at the same rate and at the same angular of the light source. You're at the same elevation, And because of the conditions of the day, the view would be different almost every day. Now, the reason like B-ball gets the same type view almost every day, and I'll say almost in the fact that it's never the same, it's just the amount it changes is different, is because his conditions, water temp and air temp, are usually the same. They don't drastically change, so you don't get those weird up and down movements as much as you would in, let's say, over Lake Pontchartrain. Thank you.
All right, I just have one thing to say, and I'm going back to bed. I heard a tactic being used in writing. You're really good at tactics, and I commend you actually for using it. But I think we should try to nip it in the bud unless they're already using it. But he's calling all the observations, the more numerous ones, white swans, where we see this curvature, right? And that the black swan is the one single example, which I heard somebody else saying that maybe not familiar with. I've explained this to you before, right?
Just jump in.
I hate that they I hate that they call it the right.
No, nobody wants you to jump in.
Let him finish.
Nobody wants you to cut off.
I've said to you before, writing, I hate that they call it the black swan because it makes it seem like all of the other observations are more numerous white swans showing curvature. And that's not the reason it's called that. It's called the black swan because you only need one example of the horizon being too far for it to negate that all swans are white. But that doesn't mean that most observations are showing curvature and that that's what we usually see, which is what
trying to see.
Yeah, the reason for me thinking there are more observations the other way around is because that's what I've heard, that's what I've seen, and even BMSLB says on the start of the Black Swan video. Now, you don't see this very often. That's why I call them white swans, not because the analogy of the white swans versus black swans makes me think they're more numerous.
But you realize
that
that
numerous separate to that naming.
You're using it as a way of making it seem like this is the one exception rather than that it's all it needs is one exception. Yeah, which is why I hate that they named it that. I don't blame you for using it that way. I know you know the difference.
Yeah, I was probably speaking with hyperbole. I do know there are more photos out there where you can see further than you should. I do agree with that.
No, you never see further than you should.
Sorry,
that's a joke. We always see as far as we should be seeing.
I agree.
Let me ask you a question, because I didn't get in there before writing, if you don't mind.
That's true.
Okay, I get that you didn't understand the length. Put that aside. Now, are you agreeing or disagreeing with the measurements they took of the bridge and their determination that there's a curve there? Are you agreeing or disagreeing with them on that?
If it's the one I'm thinking of that is just a photo of the bridge bending and then buildings at the other end, I think obstruction is a reasonable method to determine curvature. I don't think that it never happens as a result of refraction, but I think that with observations for long enough, it always happens.
I didn't ask that.
Regardless of the conditions of the day. So I think
with all respect, writing.
Yeah. So I think it's okay to be looking down a bridge and seeing how high you can see on the other side because that's obstruction. I think it's different from going how far is the horizon.
I didn't ask that with all due respect. I asked, and I'll do it again. The measurements that Soundly and Kowalski took, are you agreeing or disagreeing? And do you agree with them when they say that's proof of Earth curve?
I thought I was just, maybe I probably don't know what Soundly's things were. I thought it was just a photo of down the Lake Pontchartrain Bridge.
You're not seriously claiming that you don't know the most famous picture of all of fucking flat Earth. You're not seriously claiming you're not aware of it.
I'm saying I do know. That's the thing I'm saying. That the sound. If you're talking about the image, I don't know the measurements. If you're asking me about measurements, no. If you're saying the photo, that focus stacked image along the Pontchartrain Bridge where the hump looks really extreme, yeah, I've seen that. I don't know what measurements.
The question again is: do you believe that proves Earth curve like they claim? Yes or no?
I think it's evidence of it. Yeah, I think it's good evidence.
And then you would have to say that the obstruction caused is the actual water, the actual bridge water that would cause an obstruction there, right?
Yeah, they believe it's the curve of the Earth.
Yeah.
So there's an actual thing causing obstruction between you and the viewer. If you were to be on that bridge, right? The actual curve would block you from seeing the other person, correct?
Yes, yeah, I think that's the case, yeah.
Okay, thank you. Thank you very much.
Can I ask a point of clarification from something you said earlier?
Me? Sure.
Yeah. You agreed that bottom-up obstruction could happen on a short distance, right?
Yeah.
But it wouldn't happen at a long distance. And I was wondering why.
Sorry then if I probably said that wrong. I do think bottom-up obstruction happens. I think it is usually, I think, things wibbling in front of what I'm used to thinking of as the horizon. But what I'm saying more is not that it doesn't happen further away, but that if once things get far enough, they are always obstructed bottom up. Whereas when it comes to that wibbling stuff, that goes up and down equally. Does that make sense? I'm not sure if I'm explaining myself very well.
Yeah.
Can I explore this further with you a little bit, or does anybody else want to have a go?
No, go for it. But all I wanted to say was that, yeah, no, I just want, and then go for it. Because you said that trigonometrically, as it gets further away, it would get smaller from all angles. Yeah. The worst of that angle, like the worst obstructed of those angles, is going to be the bottom, because that's where the most obstruction is compared to your view. So then even more bottom-up obstruction would happen on a flat plane, correct, at any distance, correct?
Well, that's the bit that I don't get. Like for me, vision with this tiny bit of wibbling we get from refraction.
It's just but you're also contending with the angle of your angle to the object in view compared to the stuff in front of you, in this case of water. Or if you're on the basketball court and your eyeball's on the floor, it's the basketball court. That is completely obstructing half of your vision. Right. That's so the most amount of obstruction is going to happen where the object meets the floor.
Yeah. So to me, a basketball court, I would expect like a ball as it rolled away from me. If that basketball court was flat, I would expect that it would never go, as Bandsaw described, like a 20-cent piece into a piggy bank. A coin slot.
But it would disappear bottom up. Right.
No, I would expect it to get smaller, angular size, top to bottom. While I could go with you as far as to go, yeah, once it gets really, really pinprick far away, then I imagine it would be so staggeringly close to the surface of the floor that I would struggle to resolve it anymore. But what I would expect is that the perfect arc of its bottom would always be touching or getting closer to.
I'll check that. I agree. I agree 100%. So if I've got a zoom camera, my eyeball is now zoom camera on the floor of the basketball court, okay, and I can see the arc of the ball where it touches the flat of the floor because it's right close to me, right, 100%. And I roll the ball all the way across the basketball court. Eventually, it's going to, like you said, when it gets to the far end, it's going to disappear bottom up because it's the resolution of the angle from where the ball meets the floor is so fine that you just struggle to resolve it.
Can't
and
resolve
like
it.
a blur. Yeah. Right. But then I change my optic and I zoom in all the way across the basketball court. Now I can see the arc where it touches the floor.
Yep.
But based on my optics before, it looked like it disappeared bottom up. Now, if I were to take that ball and make another basketball court and roll it even further, again, the same exact thing is going to happen. It's going to disappear bottom up when it gets to the other side of the basketball court, unless I get another zoom camera, correct?
Well, and then the zoom camera even has a limit, just like your eyes. And then a
you have to
telescope
deal
has a
with
limit.
like and then you have to deal with the atmosphere, the air conditioning of the basketball court.
Right.
I'm just assuming we're in a clean, air conditioned basketball court.
But that's bottom up obstruction.
Yeah.
So
why do you think that over a long? Yeah. Welcome to Flat Earth.
Because what I feel I see, I've posted at 40 minutes past the hour, doesn't seem like it's getting smaller such that I need bigger optics to bring it back into view. It seems to stay exactly the same size.
What are you talking
move
about?
Like a coin into a slot.
If something going into the distance, no matter what surface you're on, doesn't appear to be getting smaller due to angular size, then the conditions of the day are causing that. Perspective doesn't go away if you're on a flat plane or a ball, sir. But what you just described over a flat plane, as an object goes away from you, it appears to get lower in your vision or whatever, it gets smaller, and you lose the resolution ability bottom up because the angle gets smaller, is exactly what I've been saying for years and years, and y'all been fighting against.
And I just posted proof of that. Anybody want to see? I just posted proof of that.
Would be true if we were in a long hallway, and instead of putting our eyeball on the floor, we put our eyeball on our zoom camera on the ceiling, and we got a Velcro ball, and we rolled it on the ceiling, it would disappear top down, correct? Because optically, that's what would happen.
Yep.
It's where
and depending on the surface,
the object.
Put carpet.
I do get and agree with your point about the like if it's closer to that surface and your eyeball's close to that surface, then that's the first thing that's going to be nearby to get in the way.
That's what we're talking about the whole time.
Like if the sun, for example, we're getting further away, it's not just like one phenomena I'm looking for. Does the top of it get lower in the sky? I'm going, where does the bottom of it go? Is it changing angular size? How is it changing its movement? Because if it were getting further away, I would expect a whole slew of things in those slots, and it would be getting smaller at a
You don't have to expect anything. I posted a video of just that happening.
Yeah, you went to the sun just
before 4 miles.
You're making a lot of assumptions about what you think you might think the sun is. What is the sun? We don't know what the sun is, how it works, how it functions, what it's doing, and what's going on.
And you just said a physical. You just said a physical object, even in our atmosphere, not the sun. Like a basketball or a ship, sometimes doesn't appear to get smaller and smaller. It's due to the atmosphere. So why do you go to the sun and say, yeah, but y'all go to the sun all the time because y'all say it doesn't change angular size, but it still has the property as it goes away, it's going to get lower. Even in your model, you're getting further away from the sun, so it would appear lower in your sky because you're going away from it.
That's what I'm trying to say with this. It is you're focusing on some that, I do agree. It's going to get lower. Like the center of it is going to get lower, and it's going to get smaller. The top's going to get lower. You're focusing on the similarities. That's great. They are there. But what I'm trying to do is just list for you some of the dissimilarities. I expect it would get smaller at a trigonometric rate. I expect it would start dropping in the sky at a logarithmic or trigonometric rate. I would expect it to get the angular size to get smaller, and I would expect the bottom to never actually touch the ocean. From my view, get further. I'm putting atmosphere out of it for a moment.
What do you expect to get sun is?
Any object above you.
The sun actually is.
I'm so nearly done. I would expect that when you're saying I zoom in on it, I would expect to zoom in on it, finding it still way above the ocean. So while there are some similarities, there are some really glaring dissimilarities.
You can zoom into the sun when it appears to be set and it gets higher. It's not on the water yet. It's just the way you see, man. What are you talking about? This has been done.
I maybe we've seen different sunsets. I used to watch them a lot in India because there's so much smog. You can kind of stare straight at it and your eyes.
Oh my goodness!
At 40 minutes past the hour, I've posted what I'm most used to seeing when I've seen the sunset.
Yeah, we've all seen sunsets. We're talking about the sunsets where you can zoom in with a high zoom camera, and with your naked eye or with the zoom not out, it looks like it's gone halfway down or it's touching the water. And when you zoom in, there's a lot of sky underneath the sun and the water. It's just magnifying it, bringing it closer and putting it in more of an apparent position.
So on that GIF, take it when there's just barely a sliver above.
You didn't listen to anything I said, huh?
Yeah. You can bring it back in by zooming on. I'm trying to ask you a question related to it.
But not forever.
So if I zoomed in, let's say, imagine that GIF stopping when it's 2/3. Is it your suggestion that if he were to have a bigger lens, he would zoom back in and that disc would go back up in the sky? Or what would happen once it's 2/3?
Sometimes it depends on how far it is away. Every lens, every optic has a limit. And when an object, when an object gets too far away, it won't be brought back up. It is being, you're not going to get that information ever. That information is being, what did you call it?
Obstructed.
You can't make it out. No, you can't make it out. You can't resolve it. Yeah, because it's gotten too far away, and that bottom layer is through more. It's blending in with the surface, and it's in a more turbulent atmosphere. So your eyes can't resolve it. Your brain can't make it out.
So would it be fair to say then, if most people like you and Fuzzy, also feel free to chime in and say, that you feel that there does appear to be an obstruction that does look like Earth curve, but it is not due to Earth's curve? Would that be a fair assessment of what you're saying about these things being obstructed bottom up?
Yes, it would be me. I've seen water appear to be rising up, and it would, if I thought I lived on a globe,
I know
thought it
everybody's
confirmed it.
excited here, but I just posted a video, guys, of exactly just that happening before your 3 mile thing. Before I just posted a video of plainly stuff disappearing bottom first before that point. I mean, I have it, guys. I don't understand what you're arguing about.
I have it also with my shrimp boat.
Yeah, I do think that does happen before it. My thing is about obstruction beyond that point.
But it doesn't matter, bro. If it happens before that point, we know it's visual. We know it's conditional on the atmosphere, bro. It's very simple. You can go and see it yourself, eggshells. Every day of the week, man. I don't understand. You live near water. Go have a look.
It can be both. I mean, there's no problem. You can have mirages and curvature.
Yeah, no doubt. But you'll be able to measure that curveness very easily.
Yeah, you can. Just measure
yeah, you can. You say that. I bet you can.
Yeah, you can. Yeah,
I bet you can't. I bet you can't.
I mean, I can.
Yeah, I bet you can. I bet you haven't. I bet you never will. I'll take all those bets.
Yep, sure. I mean, how much do you want to bet?
Have you ever measured it? Let's start off with a win right off the bat.
Yep. I haven't. No. Have you?
So I'm one up. How much did we bet?
Nothing yet. You said that you want to bet that I haven't done it or I will never do it.
Yeah, and I said,
So how
let's
much
start
do you
with
wanna
have you, and you said no. So I'm one up. So you choose the amount you want to bet now. You're one down.
Yeah, for what I've done. Yeah, sure. Let's say that I can and I will measure it, and I will bet you 200,000 euros.
That's a lot of money there, Bubba.
Yeah, all I have to do is measure it, and I can go take two theodolites, point them at each other, so that the
That's not
verticals aren't
measuring.
parallel.
That's not measuring curved water at all. That's no method ever.
That's showing that water curves. Yeah.
With a theodolite. You're kidding, right?
Yeah. Why not?
How are you going to show water curving with a theodolite?
Because if verticals aren't parallel, then water has to curve.
Yeah, but verticals are parallel.
But they're
you got
not.
a problem there.
Yeah, but they're not.
Man, I don't know what to tell you guys, man. You live in a fantasy, man.
There's measurements. There's measurements of verticals not being parallel. Are there measurements of them being parallel?
Yeah, every single time. Yeah, every single time. You can hang a plumb bob anywhere you want. Hang one right next to it. It's going to be exactly parallel.
Okay, you said that there's
evidence of it. Yes.
Can you measure it?
Can you measure it? Can you measure it not being parallel?
Yes, that's what I said. That's been done.
Where has it been? You're going to tell me some mountain and one time somebody put a thing next to a mountain. You're going to give me that story?
Oh, no, that's not measuring verticals not being parallel.
Measured it from a star, measured the angle looking at a star. Is that the one you're going to give me?
No, that's not what I'm going to give you.
Which one then? Where was it measured?
When you point two theodolites to each other and the reciprocal zenith angles, they're not 180 degrees.
I said plumb bobs, not theodolites. Plumb bobs not being parallel. You said you can show it. Please go ahead, sir.
Yeah, plumb bobs are vertical, and a theodolite establishes a horizontal, so it's vertical.
I'm not talking about a theodolite. I'm talking about plumb bobs. You said that you can measure the difference in the angle of plumb bobs.
Aren't parallel. No, I said that verticals aren't parallel. That's what I said.
And what's a plumb bob?
Well, it's a piece of metal and a string.
Is it vertical? Is it vertical?
Yeah, it's vertical. Yes.
Can you think of anything more vertical than that?
Maybe something.
Why are you answering for stuff? It's like you can't.
Yeah, he's bickering now. He's trying to get an out, but I think that you can. a wind, and there's a lot of things that affect the plumb bob, like pressure, wind, a lot of things.
Yeah, let's say there's no wind. It's just beautiful day, and you hang two plumb bobs like 100 feet apart. In your model, in your brain, and you said it before, you can measure the difference in angles, and I call bull on that. I challenge you, all of you, any day of the week to show that.
Yeah, I can use theodolites and measure the.
I mean, Rakia must be rolling, dying of laughter in the truck. Be careful, don't have an accident, bro.
He will, yeah, he's not a surveyor, so surveyors won't laugh, but Rakia will laugh.
So show us these plumb bobs not being parallel, and you win. It's very simple, bro.
Yeah, I mean, there's a lot of measurements. I think Larry GPS made the measurements, or someone did it over a lake, showing that they are not parallel.
So somebody did it, and that's sufficient enough for you. Meanwhile, I'm sure parallel, everything you've seen, any those wrecking balls they have, any crane you've seen, and you look. I have a picture of 4 of them in downtown Montreal. They're all the same. They're all vertical, straight down, like a spider hanging on a web.
Yep. I accept that. Yeah, they're all vertical, but not parallel.
You see, this is a crazy statement.
Quick question.
Yeah, I mean, if you think
regarding your plumb bobs argument, SE, do you think that levels, spirit levels, usually indicate level?
You're kidding, right?
No, I'm asking.
You're asking me if I think that a spirit level indicates level.
Right. I mean, like plumb bobs, we said, if the wind isn't blowing on them and stuff and so forth and so on, that they would indicate plumb. And you can determine plumb from a spirit level, right?
Well, I see where you're going here, but that's not the issue. The issue is showing a divergence of the plumb bobs.
Right. Well, in this case, I want to show.
You're going with the perpendicular. Is that where you're heading? With the perpendicular thing? Is that where you're heading?
I want to try and determine whether I can use level directly instead of plumb bobs, because plumb bobs are kind of not a practical device for the real open world. So can I use a spirit level on a transit or an auto level or something like that to determine level at a location, and then I can compare levels across a distance?
I would say you can do that. Yeah, you can determine your level, of course.
Well, that's what they do with this, and it indicates the same thing as showing, since plumb is 90 degrees opposing level, right?
What? Say that again?
Plumb is a uniform 90 degrees from level, correct? Always.
I would say so, yeah. Mm-hmm.
So we could use level, and we use level in transits and surveying gear, and we find that looking over a distance that the levels do not align.
How can you
level is not the same
show that? Can you show that levels do not align anywhere? How can you say that?
That would be the best example I could think of in recent times was the main surveyor. He demonstrated that.
So you're let's get this straight now. You're telling me here now we have a hotel and there's a swimming pool in front of it, right? Now you're saying there's a hotel a mile away with another swimming pool in front of it. Are you saying that those swimming pools are different in some way? They're not level?
Isn't that the model that's been described to you 1,000 times?
So I just want to get that clear.
Right, isn't that the model that's been described to you 1,000 times?
Is that a yes?
Isn't that the model that you've been described 1,000 times?
I just want to be clear. I asked a simple question.
I just want to be clear. Is that model not what's been described to you 1,000 times?
So that's a yes. That's ludicrous, bro. That's just ludicrous what you're saying. You're saying one swimming pool has a tilt in relation to the other swimming pool, bro.
All right, go ahead, talk to yourself again.
Sorry, did I cut you off? My apologies.
Yeah, y'all started talking at the same time. He just needed an excuse to get out.
No, it wasn't about over talking. It was about
yeah, it's about you not answering a simple question and coming back. Is that the model that's been explained to you? It's been explained 1,000 different ways, sir. That's why he was trying to clarify. He asked you a very simple question. You wouldn't answer it.
Can you give me 2 different ways that it's been explained with 2 swimming pools on a globe? Just 2. You said 1,000.
Yeah, I have people that tell me they're living on a sphere, but the water doesn't curve. In reality, face to face, not on Discord. That's 2 different ways right there.
I haven't heard that one.
I have. Yeah, I agree. He's a glober.
No, he's not the glober.
Oh, yes, he is. Yeah,
he isn't.
He's got it in his mind. It's 2 different ways. He knows, right? When I ask groups of people, does water curve in large bodies like the lake that we just skied on or the ocean that we just went fishing on? When we went out 100 miles, did it curve down from the beach, or, is it curve? If that's what's causing the obstruction, why you can't see the beach no more? And they'll say, oh, hell no, water doesn't curve, but I live on a sphere.
I don't know where you see those people. They should be, I don't know, maybe
They should be put in institutions and their kids should be taken away, huh?
Almost.
Yeah, there you go. I know you'd say that because that's what y'all told us for years and years.
Y'all, I didn't tell you anything, so shut the fuck up.
Thanks, man. Hey, trigger much?
Let's keep it civil now. Let's respect the server.
Yeah, y'all is a part of my language here in Cajun country. You want to come down and talk to us?
Yeah, you're making a statement on a broad. You're including
Go
a
to
lot of
y'all.
people in what you're saying.
Go do
A
y'all.
lot of people
Y'all
haven't
call
said
me a flat earther every day.
Okay, calm down, guys. Come on.
So I think I can just say y'all talking about Islam.
I like that
Muslims.
saying. What's
Yeah,
up,
make
y'all?
fun of the way I speak. Yeah, and then say the F-bomb. No problem. It tells
No,
me
I
you're
didn't
triggered.
say that. Well,
Y'all.
theists, so Muslims, so y'all Muslims make with
Y'all,
that
I'm
word.
back now. You hear?
Wow, dude.
Come on. Oi, enough.
Don't
Let's get back
include
to
me in what he's doing right now. Do not
I'm
include me in what he's doing.
I am saying to everyone, get back on track.
Yeah, I'll get
I've
back
never
on
said
track. As we
someone.
see over a flat plane or water that's not disturbed, like it's static, you lose that information bottom up because your brain can't interpret it. The light, the information is not getting back to you, so your brain can interpret it. You lose that information first due to several different reasons, but the angle being one. Light does tend to go in different directions, up and down, depending on the conditions. So it can refract and diffract and reflect over your head, be mirrored, cause optical illusions. But all of that is part of how we see over a plane. Now, if we were on a sphere, of course there would be physical obstruction. But in detriment to you, all water in all directions would have to drop from horizontal in every direction at a certain rate. Good luck on that one.
Yep, it does.
That's not a problem.
Yep, like I said earlier, you just measure the reciprocal zenith angles and
You just point two theodolites together and voila, you got curving water? Yeah, I don't think that's how it works.
I mean, that's the necessary antecedent for the angles. Yeah.
If that's good enough for you, I'm fine. Hey, man, enjoy your life. But you don't seem to be enjoying it that much.
Sure, keep poisoning the well. So it's not the only thing that I have. I have distances on the surface, traveling times. There's a lot of evidence. Sun traveling on a straight line at the equator, at the equinox. There's tons of evidence. The sun rising southeast and setting southwest in Australia. I mean, there's tons of evidence for the globe.
Sweet. Why are you here? Seems like settled science to you. You're just here to help on people and tell them that even Globers, that their children should be taken away?
Nope, I never said that.
That's what you insinuated a while ago.
Nope,
yeah, because that's what's been told to me. And when I told you the story of that Glober that happened, and other people were agreeing, like, they didn't say it, but they were like, yeah, water seeks and finds level. It doesn't curve. Well, they're saying that they think they live on a sphere where water doesn't curve. That's an oxymoron. And when I asked if those people should be institutionalized and their children should be taken away, like y'all told us that my kids should be because I believed in flat earth. then
Did
you agree
Mole
with
Man
that.
tell you that?
Yeah, I never said that. So
You didn't. You just agreed.
yeah.
You said
Y'all
maybe
are
so,
okay with
or
y'all
yeah,
are okay
maybe
with
so.
who
Or
do
how'd you
things the
put it?
same.
You kind of
Y'all
nonchalantly
do.
said, "Yeah, that's probably true."
Sure. Yeah. So y'all,
Yeah.
y'all, theists, Muslims. I mean, we can get a lot of y'alls here, but I've never said to anyone that we should take your kids away because you think the Earth is flat. So
You just
So
insinuated it.
why do you
no, I
specify Muslims first? Twice now.
So yeah, there's a lot of. You asked why am I here because I have all these evidences. Why are you here?
I'm here because I enjoy the discussion. I think it's I've learned a lot from both sides, and it's amazing that some people think that the crazy way is that we live on a flat plane and water is contained like we see all over the earth. Like everywhere you go, you see the banks of the rivers, banks of the lakes, and water is contained. We also see that air pressure is contained. We see that all day long in our natural life, in reality. But the crazy way is to think that happens. And the mainstream way, or the non-crazy way, where you're not called crazy, is to say that you're a floating rock in infinite space surrounded by an atmosphere that's not contained. It's contained by a force that's not a force that keeps the gases from going up as they went up before. It stops them in a magical position and holds them there and contains all the other atmosphere, creates a gradient. And the water that's on that ball on the outside of the container, the sphere, the land that's underneath it, is being held on by that same force. Now, if that force was that strong, yeah. So anyway, I'll stop there. I think that's enough.
an excellent kind of like synopsis.
So I think I'm here just because I learn a lot too, and I think it's real that yeah, there are people who say that the Earth is flat because all the evidence show that it isn't, and like people who say that every example of gas pressure we have in nature is that it's contained, and there's not a single evidence for in nature where you have a container for gas pressure, because when you go outside, there's no fucking container. So, and with the water in oceans, you can never see, I mean, you can see a lake that's contained, but when you see an ocean, you can never see all the sides, so you can never see it contained. So, I mean, it's weird to me what you said. Obviously, no one says that gravity is a actual force.
I would have put Buddhist first myself.
What?
I have no problems
It's
calling
not a
gravity
force
a force.
It's not a force now, right?
I just think it depends on how you're discussing it personally. I think if you're talking about Einsteinian mechanics, then we don't consider it to be a force, it's an effect. But when we're looking at Newtonian physics, we treat it like a force. It still works.
That's a problem. Two things for...
Depends what argument you want to invoke to what argument you bring to the table.
Yeah.
You kind of just like, oh, which one today? We'll take the left one. We'll take the left door. We'll take the right door. Which one's going
Well,
to
no, it's no difference between having a diesel power car and a petrol power car. They're both fucking cars. It's just the fact that, you know, when we're dealing with the left-handed Newtonian petrol car, you know, that works very happily on petrol and it's very descriptive. But when we want to go on an uber long journey, you know, then that diesel car's better for that journey generally. And but we can't put petrol in it.
Well, it's
They're
kind
both
of
still
funny
fucking cars.
when you saw some lights in the sky that didn't quite equate to the equations that you wrote. That you had to write some more equations to make those lights in the sky move in a particular way to match that equation. And now all of a sudden, now you have an Einsteinian relativity.
No, that's nothing to do with.
That's exactly what happened.
Nothing to do with Kepler.
Observations didn't match the twinkles in the sky. That's what happened.
And the difference, and the difference is that petrol actually makes the car go. Gravity doesn't actually do anything.
I don't know.
When
I let something go,
same thing with diesel, right? But gravities are completely different. Nice try there, foolish.
When I let something go, something seems to make it accelerate.
That's pretty simple.
Now you're changing it completely because you know that the gas and the diesel are just
I
not right.
wasn't
Correct?
talking to you.
Oh, I'm sorry.
That's okay.
If you let something go in a river that has a current, which way does it go?
It goes with the current.
With the current, right? So if
it'll
there
react
was a
to the force
current,
that's being applied.
yeah, if there was a current, if there was a current in our atmosphere that was going from a positive to a negative, and the ground being the ground, would it go in a certain direction?
Yeah, I don't have a problem with that. If you want to say that's the cause of what we label gravity to be, have at it. But you're still agreeing with me. You're still agreeing with me that regardless of whatever the underlying cause of it is, when I let something go, it accelerates towards the ground.
Oh yeah, I know that for a fact.
In a
I'm
very
52
fucking
years
predictable
old.
way.
I know things when you lift them off the ground and you let them go, they're going to go back to the ground. The question is the cause of that. And do you agree that that could be an electrical force?
No, because there's lots of stuff that doesn't seem to have. Again, that would require a conflicting charge between what I'm dropping and the ground.
Oh,
so
really?
the way I could test that, well, negative charges will repel each other, won't they? So if I could get the same charge, the positive or negative charge in the object that I have in the ground, then it should fucking float, or actually be pushed away from the greater charge, depending on what charge differential is.
Well, how it's being demonstrated now by scientists is that, like, you have a person standing up, that negative charge that charge that's closer to the ground is smaller than the charge that's above them, and then that gradient goes over the person. So it's kind of like pushing down or pulling and pushing. Yeah.
Yeah, that's not that differential you're talking about is not an actual charge. That is a potential difference.
Okay. But it has potential, and the further you go up, the more potential it has to go back down, right?
No, there's just a greater potential difference between the ground and the altitude you're at as you go up higher.
So you're saying that potential. You're saying that potential energy can't be turned into anything?
Let's get back onto point. No. We've seen multiple ways that we can do things.
So
like
it can be turned into.
Sorry, can I actually fucking finish a point before you interrupt?
Well, we can conversate.
Yeah, but you're not. You're just jumping in as soon as you think you've got a point.
No, I think we were both doing that. It was a good conversation until you said the F-bomb.
Not really.
No.
Yeah,
I just wanted to get back to the original point, which was the fact that if it was the case that it is just the charge that you're talking about, then we could actually demonstrate that by using something that is charged positively or negatively in the same way as we think the attractor to be, and that object should be repelled by the attractor.
Well, I've seen things that have been applied to charge seem to appear to get lighter or heavier, seem to levitate or go down towards the ground. Like when they're up, a charge is applied and they go down, or the opposite happens. When they're on the ground and a certain charge is applied, they go up. Is that the demonstration you're talking about? Or when someone puts... Yeah, go ahead.
What I would want you to do is to take something like my cigarette box, which I have in front of me, just drop to the table, give that the same charge as the ground, and make it fucking float.
Okay, why would it have to be a cigarette butt? Why couldn't if it's an example of something that's already been done that might be a little lighter because we don't know how much charge it needs, or we don't have the ability to do that, but the atmosphere does.
Oh, then
because I don't think we see cigarette butts float in the atmosphere.
No, cigarette box.
Oh, box. Sorry about that.
Well, with your example, Rakia, you're saying that you've got, I think it's 100 volts per meter.
Yeah, I think something like that.
Okay,
it's new to me.
Okay, so 100 volts per meter. So that means that between your feet and your head, if you're really tall, is going to be somewhere around 200 volts. I touched a Van de Graaff generator and raised my potential up to like 50,000 volts, and I did not float in the air, nor did I become twice as heavy.
Oh yeah, no,
or thousands of times heavier.
There's different factors in that. Absolutely, I think we're more grounded. I mean,
Yeah, but I'm thousands of times. Thousands of times the amount of potential difference, and I'm not appreciably changing weight. So electricity can't be the driving force in gravity.
Oh, that doesn't. I mean, just you saying that doesn't add up. I mean,
again,
really?
all we need to do is to get something that we can put a charge through. If the Earth is negatively charged, we put a positive charge through that object, and we should see it gain. We should see it being repelled by the attractor.
we do see that when charge is put into something, things float, or you take the charge away and it comes back down. I've seen it.
I'm just talking. I'm not talking specifically where you can take something like. I think they've done a propellerless drone, which is using a particular mechanism to give it some lift. That's not what I'm talking about, because that is not just purely based on a differential in charge. That's based on a different principle. I'll try and remember what it is, but I think I know the stuff you're talking about there.
I've seen a balloon do it. I've seen a balloon do it.
You've seen a balloon do it?
Yeah.
Mm-hmm. So I'm talking not something that's almost as light as air, or even maybe in some cases lighter than air as an object. I'm talking about something nice and robust, like my little metal tin.
Why would you want to move away from the balloon if that's actually doing it? We could start there, couldn't we? If you attach a current to a balloon and it reaches its equilibrium, it's just floating in the air, and you turn on a positive charge, let's say, I don't even remember which way it is, and it goes higher, and then you take the charge away and it comes down to floating again, it's equilibrium, and then you turn on a negative charge and it goes towards the ground. Wouldn't that be proven that the charge is what's doing that?
Yes, I agree that it would be. However, it's a minute force. It's a minute amount of change.
Yeah.
That's why you need a balloon that's in equilibrium, so that you can have something just like the Cavendish experiment. You want to try and eliminate the forces that are acting on it. So you go with a balloon in equilibrium. Then any change you make to that balloon, however minor, will make it move.
Well, you can put it on the ground and then add a charge.
Well, this is why I wanted to use some. This is why I wanted to use something robust, like my tin that I put my makings for cigarettes in, because that's way heavier than air, which is cool, and we could then measure the amount of charge that it would take to make this thing levitate. So that's what I'm interested in. I mean, you can go with these ambiguous sort of things. One, I know that things like, static electricity or minor forces, like a little bit of heat variation, won't be affecting this experiment because the object is too massive to be affected in that way. So no, I don't want to use your balloon. I want to use my tin.
Well, that was my whole point, though. If charge can be added to make things go up and down, then we can start figuring out how much charge, how different things are affected differently, right?
How do you know that there isn't a coincidence of thermal energy and this increase in electrical charge, which is then pushing that balloon up?
Well, no, I think it needs to be looked into further. And like I said, I am new to this, but I have seen it. If it is true, that is interesting that just by applying a positive or negative charge, that difference makes it go up or down where otherwise it wouldn't go up or down. Like, that's interesting to me. And then when you tell me there's electrical charges getting greater as I go up in the atmosphere, then I think that would create a gradient that would create an acceleration in the downward motion.
I really wish you'd look into the concept of potential difference. I mean, do you understand there's a difference between energy and potential energy, yeah?
Oh, sure. Stored energy, potential. There's a lot of potential energy in static, but like some of the motors and things that you can put a ground in the earth and run a wire up and run, motors that are easily moved.
I'll just give you a really simple example of potential energy. I lift up this object to X height. I let it go. I've now created potential energy by lifting it up. I've released potential energy by letting it go.
Yeah, it's trying to get back to where it was at rest before you moved it. Of course, you put that movement, that energy into it.
It could actually hit the Earth with enough force to embed itself in it and be lower than its original resting point.
Yeah, but that's something different.
No,
of course it
it's
could.
not.
That would
It's
be
going
medium
beyond.
dependent. Yeah,
that's going beyond what you claim to be its equilibrium point.
Not really.
If it was just its equilibrium point or its point of origin, I'd pick it up, I lift it up, and then I let it go, and it will always land back in the same place.
Man. You know that's not true.
And it wouldn't create any marks in the earth. And
that's not
no,
true.
It's not.
You know that. You're overstating
so,
that. You know that's not true.
So
that's why acceleration. Acceleration is the key, right?
Well,
it's still accelerate. If you just lift it up a little bit, it's going to still be accelerating when it hits the earth. So it's also going to have more energy.
When I'm holding it in my hand, it's...
Yeah, I was almost done too. I mean, see, we both do it, but I'm fine with it. You drop a bowling ball from 10 feet and drop it from 100 feet, it's going to make a different impression on the same medium of where it hits, right? The earth. Or if you put ice plates underneath it, it may break.
You let me know when you actually asked a question and you actually want an answer to it.
You let me know when you want to talk about what I want to talk about, and don't obfuscate away from the point that if there's charge put to an object and it goes up or down, then maybe charge has something to do with how our atmosphere makes a downward vector, because as you go up, it has a higher charge, and as you go down, it has a negative charge, smaller and smaller.
Okay. Yeah, I can address that real quick. What we can do is we can set up an opposition to that potential on Earth. We just have a 400 volt plate, and the potential between that positive 400 volt and some grounded metallic plate above it is greater than the potential that's measured here on Earth. Right? So things going in the opposite direction should happen in there. Things should start falling upward.
Yeah. Things do fall upward.
That was exactly the point I was trying to make, Doofus.
Yeah, but we've set up a potential difference that is in direct opposition to the Earth's potential difference. And when we drop things like wood or bits of metal inside of that potential difference, they still go down. They don't go up.
They'll go down. Yeah, due to what?
Well, obviously not the potential.
Well, you say gravity, right? I'm fine with you saying gravity. I was comfortable saying gravity for years. I don't know why you're not. Okay, so take away the gravity. You're saying take away the electrical potential. Okay, fine. Now take away the gravity.
That's simply fine for me to falsify your presumption that potential. It's simply fine enough for me. It's simply fine enough for me to falsify your presumption that potential difference is what causes objects to fall by setting up a potential difference that is in direct opposition.
If I exactly said that, I would say that the increase in electrical charge as you go up and down, decrease as you go down, and the Earth being the ground would cause some type of vector. Now, I'm very new at that thought, but it does start to add up a little bit. But we definitely have energy.
That vector, and it didn't do anything.
Well, we definitely have energy, though. Energy in the atmosphere. Energy causes movement.
What if What if you have a battery that's full and empty? Would it weigh differently using this electric thing?
Oh, nice.
I don't know if you can measure it, but it seems like it would. I mean, if you're taking away the charge. Yeah. Okay.
Just put a scale under it.
Maybe yeah, but I don't know if the scale. Yeah, come on, man. I don't know if we can get down to that minute scale. And I think it does matter the amount, how heavy the object. Like I said, I think we've had this argument before. A charged battery weighing more than an uncharged battery, or the opposite, whatever. I don't know that.
Okay.
But I do know that if you put charge into certain things, like a balloon or aluminum foil, or even so that's just static charge. I don't think that's what they were hooking up to it. Now, I understand how static, rubbing things, friction, static. That also has some effects on things. But I don't think that's what this experiment was about. And the one that the guy took a drone up and took a wire up and ground, made a ground and put the positive to a generator and it turned, or some other things that showed that the atmosphere had energy. I don't think that's static. Could be. The scientists didn't call it static.
What is it?
Just charge. We have more charge in the upper atmosphere. So the more you can collect, the more you can bring down to the ground and turn a motor. At the ground itself, there's not enough charge to turn that motor. But as you go up, where the charge increases, you can have enough energy to turn the motor.
A persistent potential difference is called static, by the way.
Yeah,
Okay.
I think it's static. That's why you have static ports on airplanes. That like airplanes, you have static ports because of the static electricity in the atmosphere.
Yeah, we have them on our wingtips. I have it on my boat. I put an antenna basically taller than anything else. So we ground everything because of the friction of the water and the moving metal parts and all that creates a ionization, maybe? Is that what it is?
It's static. It's just static electricity, I think.
Yeah.
But I think that I'm not an expert, so.
Yeah, I'm not claiming to be either. I'm just saying it was very interesting that we're finding, I'm finding out for the first time that there's a increase in energy charge as you go up. It's scalable. It's linear, it seems to be. And that you can grab that energy and run motors at the ground. Drive a nail into the ground, put a copper wire to the negative, and put a wire up in the sky and put the positive on the positive side, and the motor turns. Cool as shit. Call it static. You can call it whatever the hell you want. Still neat. Still new to me. But now, if you're going to tell me that gradient of charge going from upper atmosphere where it's a lot more than on the ground doesn't cause a vector, a current, that's what they call it, right? Current.
But I
don't
know how.
From high elevation to low elevation in charge, that current headed towards the ground wouldn't cause things to move in that direction, then I'm going to say you're wrong. I'm saying currents do cause that.
Hey, Rakia, as I'm supposed to keep things on track and not go to personal attacks and hash up old history like this.
This is personal attack.
But I think the basic problem you've got is if that was the case, you could do exactly what I said, which is you could use the opposite charge to have an object repelled. It's a shame that it's not based purely on electromagnetics. Otherwise, we would have flying cars today.
Mm-hmm. Oh no, I think that's the basis of them saying we will have flying cars like the Jetson. We were promised that by now because of the potential they saw in the atmosphere where they could harness that enough. They just haven't done it yet. Hell, we're just now trying to figure out how to freaking harness enough power in a battery.
Are you joking? We harness huge amounts of power in batteries. In fact, actually, what we do is we harness huge amounts of power in capacitors, vast amounts.
Yeah.
Enough that I could actually, I could get enough charge in a set of capacitors that I could vaporize your body pretty much and make a very loud bang. But yeah,
that's great how you brought that up. That's awesome. But that's pretty recent, right? How you can vaporize my body with two capacitors?
Not that recent.
No.
So how many years?
We've been using
a century.
Yeah.
So that's recent, right? In scientific terms. I mean, we're billions and billions of years old. You're saying a century.
Well, I think you were the one that introduced them recently.
Yeah, so I mean, normally recently, I consider recently, Rakia, just so we get this right from now. If I'm talking recently colloquial amongst ourselves, that's kind of, within the last 5 or 10 years, maybe. Within my lifetime, that's fairly self-explanatory.
One lifetime in science is not recent? Come on, man.
Yeah, capacitance.
Well, again, sorry.
Yeah, capacitance has been used to perform a form of arc welding for quite a long time. This is definitely not something that's recent.
I was
thinking of the London Underground system that we had in the UK that was fully electrified in the 40s and 50s. And some of the largest capacitors I've ever got my sticky little hands on came from there. So I've actually had 100 farad capacitor.
So now we're arguing about
Yeah,
what recent is, if it's 10 years, 5 years, or 50 years. Yeah, it's recent. It's not thousands and thousands and thousands of years ago. It's pretty recent technology, right? Like more, so much recent.
You make recent whatever you want it to be. I gave you my sort of definition. Generally, when we talk about recent events, we're not talking about stuff 100 years ago, are we?
Yeah, it depends on what you're talking about. Yeah, it depends on what you're talking about. It depends on what you're talking about.
Cool.
Right.
When we
Isn't it? You jackass. You want to have a civil conversation, and then you want to cut me off, ask that question, and then repeatedly say, are we? You sure you want a civil conversation?
Yeah. It was recent enough when we were talking about the promise of flying cars, like back when that was actually being promised to us was the 40s and 50s. And when we brought up examples of the 40s and 50s, now that's too recent.
No, I think 40s and 50s, when you talk about certain things, it's a long time ago. Seems like a long time. I was just born then. That's a long time. But when you talk about how we're harnessing electricity with capacitors, yeah, I don't think that's, I don't know.
Which is a longer time.
And it really didn't go, I didn't mention capacitors. The other guy did, the guy that wants to have a civil conversation, but keeps interrupting and being uncivil. I was talking about batteries, the storage of batteries, how recent things have changed, in the last 5 years. Now that's recent.
In what way do you mean things have changed, Rakia?
Well, the rare earth minerals that we're now finding holds energy and can be produced in such a small, like in the iPhone, make your battery last long, or in a electrical car.
Yeah, so you're just talking about not the fact that we batteries are a recent thing. It's just the fact that we've managed to make batteries a lot more efficient and a lot smaller. In the last 20 years.
Yeah, see how that is can be termed recent, but the actual battery is not recent. That's from a long time ago. So it depends on what you're talking about.
Right, 1899, they had an electric car that had a 30-mile range, which was pretty impressive for 1899.
Yeah.
They were planning on running New York taxis off electricity originally. And that goes back to a similar sort of period, late 19th, early 20th century. But, batteries have been around for a while. Some people would argue the Baghdad battery is an example of that. I'm a bit questionable on that one myself. But, the capacitors and the ability to generate a huge amount of charge, we've been able to do that for a pretty reasonable amount of time. Yeah, certainly over 100 years. And actually closer to more like sort of 170, 180.
Wouldn't a Leyden frost jar or Leyden, I think the Leyden jar, be an example of a capacitor?
Yeah. So, so again, all I'm saying is that if your theory was correct, Rakia, then we know that same charges repel, opposite charges attract. Fundamental point of electricity, something we've known something we've known fairly recently in geological terms.
So my theory is, so we're all in agreement before y'all put too many things into my statement. Like, the higher we go in the atmosphere, the more charge we have, which at ground level will be less. That would create a current. That's my theory. Do you agree with that? That's not current?
No, because it's a potential difference. And that's why I keep begging you to look up what potential difference in electricity actually means.
Okay, what creates the current, the flow?
Break down the dielectric
there. I mean, lightning is a flow of electrons, but that happens only every now and again.
I'm talking about high energy to low energy current. Would that be?
Well, the interesting thing with lightning is it flows from the ground up into the sky and back again.
So that's not current. What I'm explaining isn't current.
No, that's definitely an exchange of charge. We don't have a problem with that. It's the fact it's going from the least to the most, from the most to the least in a reciprocal path. So it streams upwards into the sky, and then the lightning strikes down.
I'm not talking about the lightning. I'm talking about the flow of current from
Flow of current
high to
is
low in the atmosphere. Would that be current?
no, there is no flow.
Where
It's
at?
potential difference.
It's generally
Yeah, where is
static.
it flowing, Rakia, specifically? Specifically, where is it flowing?
I still don't see the relationship between gravity and electricity myself. I don't know why we're even talking about electricity and gravity.
Well, in his balloon effect, you could actually measure the amount of force that's imparted on a material, based on charge.
So
but it's minute. It's minute.
Something that I forgot who it was that said that the lightning flows from the ground up and then back down. It's actually the opposite. The part you see is from the ground up, but it flows from the top down first.
Actually, they got to look at the step leaders and then the actual bolt.
Yeah, it's both.
I'm always happy to be corrected. I never claim that I'm right on fucking much. Unless you want to talk about the reign of Ashurbanipal, then I'll probably fight.
Let's talk about what's water made of.
Nobody in here has a question about that, do they?
Water's made up of water droplets. Surely that's the smallest thing I can get.
That's like Moyak, that statement's like, nobody here surely has a problem with helium having weight.
True. But just on the curiosity side, does anybody here have a problem in water being 2 parts hydrogen, 1 part oxygen?
See, what I have the problem with is when they try to replicate that I never see them drink the water when they put hydrogen and oxygen together and make some kind of liquid.
Well, perhaps some people do.
Nah,
so you question it.
Shout out.
Like I seen them recreate this. They say this is water, but I've never seen them. Well, look, it's water. Take a gulp.
Because usually it's in the form of vapor afterwards.
No, it's seen enough to make at least a gulp of water.
Really?
Yeah.
Most I've seen with it are you got the explosion that you would need to make up and let's say a 1/4 ounce of water would be a tremendous amount. I guess if you burned it over time, like from a HHO torch inside of a container, you let it condense. You could do that, but if you try and set that all off in one time in an experiment, you'd be blowing up the person in the room with a 1/2 ounce of water.
I said it was at least a freaking small gulp.
If you got an example, I'd like to see it. I'm be burning it over a period of time because trying to detonate it would be an incredible amount of energy.
I just put a video in the live stream that makes some good points about it. If you guys want to pick it up.
Keep in mind that 2 parts hydrogen weigh less than 1 part of oxygen.
Significantly less.
Way, way less.
I think water is in the class of its own. Has some crazy properties.
Really? What's unusual about it?
Well,
there's an arbitrary thing about it freezing at temperatures that we normally have, but there's even other materials that do that.
Well, for one, when you freeze it, it expands.
There's a couple of things that do that.
Liquids, right? I think there's another liquid. I forget which one it is, but it's very, very rare.
Yeah.
Well, hydrogen peroxide will do it. I mean, that's not far from water, but it is something that is different from water.
Well, it is a property that's strange, right? He said, name me one, and I did. I believe that qualifies.
The thing is, we have other things. The thing is, we do have other things that do that. It's just a matter of the crystal lattice structure of the solid form of it, and
which is based on water.
And we find plenty of things that will expand. It's rare, but it does happen.
Okay, so then I was correct. It's a rare property of water, something strange about water, and those other things.
But it's not. But it's not something that puts water in a classification all on its own. Other things do it.
The other thing that's really weird about the other thing that's really weird about arguments like this, the weird thing about arguments like this is every single material has unique properties. That's what makes them unique, their own entity.
You don't think water is unique?
No, every single chemical, every single atomic element has unique properties.
I love it, man.
Unbelievable,
you can bring up anything, and they're going to argue.
Anything.
What's wrong with that?
What's wrong with every scientist in the world basically agreeing with you, but then saying water is very unique, like more unique than almost anything you can name, and you're somehow agreeing and disagreeing with it all at the same time just to argue with SC. It's like an amazing phenomenon that goes on here.
Well,
no,
what you're doing is
what
you're
happened
putting.
Was he said, what happened was he said water was in a class all on its own and nothing could be like it in any way. And one of the ways it was different than all other things.
I don't think that's what he said at
was
all.
It expands when it freezes.
I don't think that's. I think you're lying now.
Well, I think you're trying to be personal and not being a very good mod. So we can continue forward with this, or you continue to swing shit.
I'm not a mod here.
Oh, I'm sorry. I thought you were a mod.
This is Rakia complaining. He's like, well, what's wrong with your sister country, Pumpkin? Y'all have a problem with kissing sisters?
Now you're being racist towards Southerners, y'all. Y'all, take it easy now, y'all.
Hey, if y'all want to put words in SC's mouth, go right ahead. But I don't think that's what SC said. It was my statement.
He said water is a classification all on its own. He was asked what's unique about it. He said that it expands when it freezes. That's not unique.
I said one of them.
Rare,
would you like me to give you another one?
Yeah, he gave you another example.
Have you guys heard that water can retain memory? Have you heard that one? You can use it like a storage. I heard that. I don't know how true it is, but they say you can use it like a hard drive. Okay, all right. I'm not going to die on that hill, but it's just another unique property that I heard of water.
So far, your unique properties of water are something that's not unique to water and something that's untrue about water.
Okay, do you know what the water cavitation? What happens to water when we bring it at, I don't know, say 33 feet?
Cavitation isn't a matter of depth. What are you trying to say here?
Just laying you out some properties of water. That's all.
Right, now, if you're saying that water, given its weight, increases pressure every 33 feet to the equivalent of an additional atmosphere, then that's just a unique property due to the physical properties of it, not necessarily anything that you couldn't say. Oh, if you did the same thing in Mercury at 33 feet, it would have this many atmospheric pressures. It's not really that unique. Not special in the way you're trying to make it seem.
All right. So you don't think water is special? The thing that keeps everybody alive?
I didn't say that. I didn't say that at all. It's just that the way that you're attempting to describe it isn't really giving us this class all on its own feel that you started off with.
So there's nothing special about water in your opinion. Okay, got it.
There's special in how we use it. Everything has its own properties. You know, potassium in your body isn't necessary.
Water is just water.
Your life. It's unique in its use in the body.
There we go. That's a good one.
You can't live without potassium.
Can't live without water. Water is
Can't live
70%.
without potassium.
Water, they say, 70% of the globe. Water
Can't live without salt.
establishes level. So many things like the cavitation, the memory retention, the freezing expansion. I mean, you know, I think water
None of
plays
those
a
things are
very
unique to
major
water.
role in. It delineates, like, let's say, zero, like the pressure. You can go under and get low pressure. Get high pressure, go above, get low pressure.
Right. None of that is unique to water.
Not unique to water.
Yeah.
Okay, water isn't special in your view. Got it.
And see, would you stop saying things like that? It's just that you're not naming unique things about water. You're naming a lot of things right here that are either false or not unique to water. That's the issue. You keep saying water's in a class all on its own, and here's the reasons why, and then not giving us anything that makes it unique on its own.
So the expansion part somehow didn't capture, like everything else contracts, but water expands. That doesn't do it for you.
Right. There's other elements, as already mentioned. Yeah, there's already other chemicals that have already been mentioned in this very chat that do the same thing.
And you said peroxide, and you said it's based mostly on water, correct?
It's a close relative of water. Yeah.
Okay, so I'm correct then. It has a unique feature, right?
No, because that's not water. That's hydrogen peroxide.
Which is mostly water.
No.
No. Let's see. You're talking about a mixture of hydrogen peroxide, like 5% dissolved in water, but pure hydrogen peroxide will expand when it freezes.
What's it made out of? What's the base thing of hydrogen peroxide?
It's still made out of oxygen and hydrogen. It's just not
water,
in the
right?
same. It's not in the,
water.
No, not water. Not water. Not fucking water. What part of that is hard for you to understand?
So hydrogen peroxide is made through a catalyst of the reaction of hydrogen, H2, with atmospheric oxygen, O2, to produce hydrogen peroxide.
And it has different properties than water.
So 2 O's instead of just one?
So it's not based in water. Hydrogen, you said before it was, now you're saying it's not based in water.
No, it can be mixed with water.
Yeah, when you get
adding double the
bottle
oxygen.
of hydrogen peroxide, typically it's not 100% hydrogen peroxide.
That would be bad.
That would be very reactive, very caustic. It takes the paint off of mail trucks.
It explodes when given the right conditions.
It's diluted
so pure
with water,
hydrogen peroxide expands. You guys are saying pure hydrogen peroxide expands when frozen?
Let's take a look at that.
Has a different freezing point also.
Look, we're here to learn. If that's the property, that's the property. I mean, that's that. We can't argue with physics, right?
You do all the time, though.
Can somebody Google it real quick and see?
Give me a second. I'll do it.
We don't even have to go there. We can always just go ahead with silicon, gallium, germanium, plutonium, bismuth, plutonium, lots of other ones that have nice big expansive crystals, as opposed to them being in their liquid state.
So all those expand, all those liquids expand?
Yes, whenever they freeze.
Okay, then I will have to modify my thing. Okay, I'll look into it further. I thought, if not the only, like one of the few things that expand.
I never get past this. Also, why is something being unique so important to you? I mean, like I said, everything has its unique properties. So if you randomly, from that list of unique properties, decide to pick it up and say, this one does this.
So,
I don't understand what that uniqueness means to you.
I'll answer that. You mean to tell me if water, and I'm saying if now, I could be wrong, and I will correct myself if I am. You mean to tell me that if water is the only liquid on this universe that we see that expands when frozen, you won't think that that's a thing to look at, that's a weird and unique property of it?
I wouldn't think it.
Well, obviously not.
The importance of it is something that, like, I wouldn't put much significance on it other than the utilitarian nature of it. It's not like it has a magical significance. It's a.
We're not saying magical, but you wouldn't want to find why this is, like, you wouldn't
Oh,
want to.
absolutely.
Yeah, that's all I'm saying.
And it's because the crystalline structure of it is such that it's bigger when it forms crystals.
All right, good. I don't go against physics. If you can show me something that is, well, I'd be foolish to go against it, right? Totally foolish.
He just gave you the reason of why it's unique.
Yeah. So those other chemicals, those other liquids that you said, you guys, you checked it. It is what you said. All those other liquids do expand. That's a fact.
I didn't check it, but I did find that one of the caveats when they say is the only a non-metallic material that expands. So that's
so there's a unique property right there. Yeah.
But it's not unique amongst elements.
I know. I read it somewhere. I don't make shit up, bro. When I say something, I don't just.
Yeah, I was about to read the same thing he just read. Water is the only non-metallic substance that expands when it freezes.
There you go, gentlemen.
But that's now putting an arbitrary link in there. Now, well, besides metals, which make up a quarter of the periodic table, water is the only unique one, and I just don't know.
It's unique. He said
it. He said it. Yep, we got him. You got to admit, mailman, that Moyak, if that's the case, it's a unique thing, man. I mean, just admit it, accept it. It's physics. I mean, I was going to accept it the other way if you guys showed me proof the other way. And
it's unique if you exclude it to a group.
Right.
Yeah.
If you say water is the only substance we know of that expands when it freezes, that statement would be false.
Okay, then I'll have to modify non-metallic. Thank you for increasing my knowledge. Thank you.
I mean, I wouldn't compare water to a metallic item to start with.
Yeah,
okay.
Yeah.
Well, almost all metallic items can be made into a liquid.
Right. And mercury is metallic too, right?
Does mercury
think about it, guys. Everything alive needs water. Everything.
Okay. Everything alive needs some form of polypeptide chain.
Some form of what?
Polypeptide chain.
Polypeptide chain. Can you elaborate on that?
No, not right now.
It's essentially he's saying no things exist that are living without protein.
I guess that's true. I don't know, really. That's beyond my pay grade.
No thing living can live without oxygen. Well, that's not true.
That's not true. That's not. And they also thought that no living thing could live without the sun. Remember that? They thought nothing could live without the sun. And then they found out those deep sea vents that found creatures living without sun, just surviving on the minerals that the vents, and they had to classify a whole new system of life. You guys are aware of that?
That's the beauty of science. It is.
We are.
Fascinating, huh?
Very.
I remember when I saw that, I was dumbfounded. Like, what? Life without the sun? Yeah, it's possible.
I was going to say, and depending on how you look at cavitation, air conditioners that use Freon or some equivalent fluid, they boil under very low pressure. So basically they're cavitating.
Yeah, so are propellers of boats. It's another form of cavitation. Ask Rakia.
Right. Right, but that's water. We're talking about things that are not water.
Which thing did you say? Sorry, say again?
Freon or some other refrigerant.
Okay, yeah. You're probably right about that, yeah.
In fact, I would think that almost any liquid would cavitate at a given point. Like mercury would definitely
under
cavitate
pressure,
if you pull a
anything.
pop too fast through it.
Probably right, yeah. Under under low pressure, I imagine, yeah, just about anything would. Any liquid.
Mercury is a bit an odd one. I think it would just sublimate, but I could be wrong.
That's metal based. Yeah, that's true. I wonder what would happen with mercury.
Evaporate is the term I was looking for. Whoops.
Right, but if I was to like spin a propeller and it at 10,000 RPMs with a tip length of 6 inches, outside of having hellacious thrust, at some point it's going to be pulling a vacuum behind it. What would the mercury wouldn't be able to keep up with that vacuum? It would slam in to that pocket just like cavitation.
This is for SC. I wanted to ask him a question since he said can't argue with physics. Do you believe that the molecules are floating around orbiting each other? Because if that's the case, wouldn't that mean that like on a macro scale, the planets would be mimicking the same behavior?
I'm not sure how to answer that question. Are you comparing molecules moving with a planet orbiting? Is that what you're doing? Like the atom, for example, the orbital thing of an atom? Is that what you're saying?
Well, okay, you know how you have molecules that attach to each other? What do you think they're doing? Like, do you think they're like orbiting, or how are they like holding onto each other and like
by electrostatic?
Well, that's a good question, bro.
So you don't so you don't think that the atoms are actually on a smaller scale orbiting? Like they show like let's just say for instance like on The Simpsons. You don't think
Sorry.
No, I understand your question. I can answer it. Well, that model, the orbital model of atoms, has been superseded, no? If I'm not mistaken. They no longer use that. They use a cloud probability model. I'm pretty sure I'm correct on that.
Yeah, you are.
Oh, there's the man, the chemical man. So, yeah.
I'm not the chemical guy, no. That's Jay, so RV.
Oh, you're not? Oh, sorry.
I mean, unless you're trying to say that, unless you're trying to say that that gravity is electrostatic.
No,
because he's saying the molecules being held together, like in their whatever model he's trying to come up with, that would be electrostatic, wouldn't it?
Yeah. I mean,
actually, they say it's the strong nuclear force, if I'm not mistaken, that keeps them intact. The strong nuclear force.
Yeah, the strong nuclear force keeps the protons together with the neutrons within the nucleus, but that's not what binds one molecule to another. That would be electrostatic forces, so like ionic bonds, covalent bonds. So it's interactions between, for example, with ionic bonds, it would be the interactions between ions. So a negatively charged particle and a positively charged particle would exchange charges and bond. But with covalent bonding, they would just be exchanging electrons within the electron shells. So it's all electrostatic. Well, I don't want to say electrostatic, but electromagnetic type of bonding.
But I want to ask the guy that asked me the question, was that a sufficient answer that I gave you? With the orbital old molecule model now being superseded by the cloud probability model? Is that a good answer for you?
Actually, I wasn't listening, but okay, I'll take that as an answer. That's cool.
Yeah, that's exactly what they're saying now, believe it or not. They changed the
Yeah,
orbital
I know
model.
I know what they say, but it's just, I just
That's a
wanted to
fair.
see where in your flat Earth paradigm, your beliefs are rested. So that's cool. At least you believe some things of science, right?
What?
Well, I'm not. What are you talking about?
Oh,
I believe the solid science, not the pseudoscience. Don't get me started on black matter and black energy, dark energy. I mean,
which is all
the science
hypothetical.
we believe.
Well,
I believe.
wouldn't the cloud, what you're talking about, wouldn't that be hypothetical as well?
Yeah, of course. They don't know. They have no clue. Do you think they actually know that there's a nucleus and a proton and a neutron and something orbiting? You think they know that for sure? You think that's a fact?
No, that's why I'm questioning you on it.
Yeah, and
I
I'm
don't believe
giving you
it either.
same here. I don't know that that's true. I'm just giving you what their thing is. And another thing, I'll give you another question on this model. What keeps the electron from slamming into the nucleus? What force?
What force? What?
The electron is negative, right? Or is it positive?
Electron's negative.
That's negative, right?
It's a negative charge, yeah.
Right. And the nucleus, you have the positron, which is positive, correct?
The proton, but yes.
Sorry, proton, my bad, yeah. Now, what keeps the electron from slamming into the neutron? The proton, sorry. See, there's a lot of unanswered questions, guys.
Slamming into it? I don't understand.
Well, shouldn't they attract each other? If one is positive and one is negative?
Yeah, definitely. But it's not to say they're going to attract and touch. It's just if you have a free roaming electron, it'll be attracted to a nucleus and then sit within a certain energy state, orbiting. If you want to use the old model, orbiting the nucleus in a certain, energy state. Yeah, until all of the different parts of the electron shell are filled out.
Yeah, but what keeps it from not slamming into the nucleus?
The energy state it finds itself in. An electron or anything wants to be in its lowest energy state as possible, right? Principles regarding the actions of least resistance, Lagrange
they don't
paths
want to
and
be
whatnot.
jogging around.
So,
they want to be neutral. They want to be calm. Yeah.
Exactly. Yeah, it doesn't want to have too much energy. So if it's too close to the proton, it's going to be too energized, you could say. So there's a certain distance or certain positions it wants to hold in its quote unquote electron shell around the nucleus, where it'll be in its most stable state.
Yeah, and we know that when you excite it, right? It goes into an excited state. It jumps closer to the nucleus, I believe. That's the explanation. And then when it loses its energy, it loses it in the form of light, and it goes back to its original orbit, shall we say, for a lack of a better term.
Yeah, you could see it that way.
Well, that's the explanation. That's what science says today now. But why I brought it up is because somebody asked, what's my opinion between that and how planets, and I don't see any connection in that. That's why I brought up, they used to think it was an orbital model, and then they got that wrong. Now they think it's a cloud of probability. They don't know where that electron is. Could be anywhere.
Just pulling shit out of their asses and just see if it sticks.
Exactly. Yep.
Mm-hmm.
Interesting.
I wish Jace was
agree,
here.
man. I'm not arguing with you on this because notice all the Globers are quiet right now, thumbing through their physics books on the cloud probability and whatever other science you have. So
Just give them 5 minutes; they'll become expert.
Yeah, I'm not making this stuff up. I'm just reciting the current understanding of an atom.
Adamant.
Adamantium. I'm telling you, the more you look at this stuff, the more you're going to realize that these guys that we think are so smart, and they're educated, but there's certain things that they don't know. It's just guesswork. There's certain things that we will never know.
Yeah, I'm gonna say rephrase that because being smart and being educated. I mean, learning the subject is different than actually being smart.
Yeah, agreed.
well, it doesn't matter if the subject is true or not. You can be able to recite. Hey, you can be able to recite bullshit, but if it's bullshit, you're still spewing bullshit, bro. Doesn't really matter.
Nathan Oakley. Excuse me, something in my throat there. My bad.
You mean spewing bullshit that's useful and practical and produces products?
Yeah, a good way to measure
your smartphones and your computers work off of all of this stuff. Like, I want to say what you guys are trying to say, man.
I mean, a good measure if you're just memorizing bullshit or if you have actual knowledge is to see if you can do stuff with that, right?
Is that you?
For example, if you're making shit up about celestial navigation, I guess you won't be able to find positions, right? And if you actually know what you're talking about, I'm pretty sure you can. That's a pretty good way to distinguish if you're making shit up or if you actually have knowledge on that.
So can we apply that to the heliocentric model in entirety then?
How about finding a planet due to gravity?
Oh no, we don't have to apply the same criticism to the heliocentric model. It gets a pass.
Who's not applying to heliocentrism?
I know, that's my point.
Oh, that's what you're saying. I mean, can you elaborate?
Yeah, you should apply that same level of critique to the heliocentric model.
And why this? I mean, well, I'm not criticizing just the model. I'm just telling you one person is talking about something. A good way to tell if they're just regurgitating bullshit or if they actually know is to see if they can do stuff with what they're saying. Right?
Yeah, like all the claims of the heliocentric model.
Yeah, like if you just put planets in orbit, you can know exactly when a solar eclipse is going to happen and to who, and at what second it's going to start and what second it's going to end. That's one thing you can do with it, right?
And the path.
Yeah, exactly. Well, when I said to who, it's like the whole positions.
That's funny. Solar cycles. I heard the solar cycle came before the whole orbital thing.
Sorry?
I heard the solar cycle came before the whole orbital thing. Been by the what was that?
Doesn't predict the location. Or the exact.
And or the second it starts, or the second.
Oh, so we looked at it a lot more and we calculated a little bit more. Okay, but I mean,
it's not just a different calculation. It's a whole different model.
No. NASA says they still use it.
Yeah, can you back it up?
Yeah, I could give you.
There are SARO charts on the NASA website.
I'm not saying there's not. I'm just asking if you can like back up that's how they know when eclipses are going to happen and where.
Yeah, this has been done for a long time. Man.
Can you post
one? Back that up.
That's what it's for. The whole reason it exists.
No, we're saying about predicting the location and the second starts and the second it ends for each coordinate. We have that with the heliocentric model.
Yeah, we have that with the geocentric model. It's called the Antikythera mechanism. Does all that and some.
No, it doesn't predict the moment it starts and for which location. It just gives you.
It literally does. It literally
just gives you a date.
From NASA.
It was used to wait. Time
right,
out.
I might be wrong.
Navigate.
So
listen. It was used to navigate. So how would they not know their location?
Not their location. I'm talking about where the location that the eclipses are gonna happen.
That's right. When it knows your location, it factors in when you're gonna see the eclipse, man.
Okay, so can you post that?
Oh, they already did actually.
I'm curious now. Can you post that?
Jerry posted it before I did.
What's the actual real use of actually knowing and being able to predict a eclipse? What uses of it? Like if I'm a dairy farmer, like what use is it that I need to know when an eclipse is? For argument's sake,
I'll give you one use.
That's beside
so you can look at it.
Well,
if you're a conqueror, Bensa, if you're a conqueror and the natives are about to kill you and slaughter all your men, you could use that and say, "Look, God is with us."
Is knowing the shape of the earth. I mean, that doesn't really. I don't know what the question means.
Dude, we get the hate that's in your heart. You don't have to let it out every chance you get about flat earthers, man. It's all right. We all have different beliefs. Thanks, man.
Do you secretly love us, bro?
Yeah.
We,
I mean,
your dreams
all morning he's been piping up with just stuff like that.
We still love you, bro. It's okay.
I knew I was dumb way before you did, brother. I don't need you to tell me.
But I don't know. I just jumped in here and heard someone saying the way to know if someone actually knows something or is just regurgitating bullshit. I'm like, bro, what? Dude, are you blind, bro? I mean, when you talk about the heliocentric model, it's a regurgitation of theoretical reification fallacies that constantly update and change. And people come in here and they just remember the script, the narrative that supposedly is going on in space, and they regurgitate it. So
I think a good example of what Bacon is talking about is like Nathan Oakley and 10th Man talking about how the sextant only works on the flat Earth, but they've never demonstrated and refused to.
Yeah, that's not what I mean. They're saying you create a horizontal plane, a baseline, to work off of using the sextant, which is exactly true. To get that 90 degree from the flat baseline, horizontal.
Yeah, but they also make claims about the process of finding your position. That only works on a flat surface. And I found no one that can actually do that using a flat surface. And using a globe, it's pretty straightforward and it works like beautifully.
I'll agree with the ballers on this one. That is not a good example of proving a globe. I'll agree with you on this one. And I've said it many times before.
You're a man of real integrity, Rocky. That's what's up.
Well, what we're saying is we're being lumped into a group. Y'all have to bring up Nathan Oakley and whoever else. It's never our, you'll never hear me and SE go, oh, well, Nathan Oakley said so, I believe this. Y'all have to bring that up as a
Yeah, but it's the same way you'll never hear us say Neil deGrasse Tyson said this, that, or the third, but we keep on getting accused of reading a script,
Yeah, because it's NASA script. So
that's official. That's different.
But I've been in here and I've heard Globers disagree with NASA.
Why do
I have to follow the official thing?
Yeah, we don't all march in lockstep with what NASA says.
Yes,
it's the same way.
Yes, you do.
There are flat earthers that disagree with Nathan Oakley.
Name one thing you disagree with NASA on, then.
Oh, there's so many.
I don't know what NASA claims.
If there's so many, then just name one.
So many.
Just one.
It should be super easy.
So many.
Yeah, so it was just a statement made by you. That
I wonder
not
what
everyone
NASA says about the universe. If NASA says that the universe is 100% an isolated system, I might disagree with that. I'd say they don't know that.
Yeah, exactly. Things like that I would definitely disagree with. Their interpretation of the cosmos, the axis of evil cosmology, that's a bit sketchy. I mean, it's a lot of things NASA say that we don't agree with, but those are things that are on the far-fetched, cutting edge of science, things that even NASA admit they're not 100% sure about when they make these statements. You know.
So you're not disagreeing with NASA then? If they say they don't know it, and you say, "Look, we don't know it," then you're still agreeing with NASA. Try again. If NASA says they know something for a fact, you guys will literally regurgitate and believe that exact thing, and everyone in here knows it.
Depends on the claim. If NASA came in tomorrow and said that the Earth is flat, I would say fuck off. It isn't.
Oh, good one, man. We don't need a hypothetical, completely unrelated and unrealistic. Let's try a real.
Well,
real
you are hypothetical and unrealistic when you say that everything that NASA says we agree with. So
everything NASA claims to know for a fact, you guys believe in 100%.
No, that's not true. Prove it.
Name one. Name one.
No, that's not me proving a negative. You prove the positive. Yeah, you made a claim.
Hey, what's it? You name one. That you're
How am I
not
supposed to
saying
know
that you
what
agree.
you
made a claim.
Name me your model. Tell me your model. Come on now.
My model?
You name one.
Yes,
since you making
Oh,
this
you're doing the reverse on Witsit.
So here's the thing: we're talking about the eclipses. Does the heliocentric model accurately predict not only the days and times of the eclipse, but the path that the eclipse will take across the surface? Is that true or false?
It's not a prediction if it comes after the observation, is it?
Like it comes before it as well.
comes
No, it doesn't.
Yeah,
what do you mean it doesn't? We have a list of when
it's a reoccurring cycle, man.
It's a cycle, dude.
But we can predict all the eclipses that are going to happen next year. That's a prediction.
Yeah.
We haven't
It's a
observed
cycle.
it.
Been happening for years.
Yeah, but the cycle. One
The question
second.
was does it or not. The question was does it or not.
Yeah.
No, because it comes after the observation of the cycle.
Yeah,
The fact that
it doesn't make
You
it
know
not a
it's
prediction.
true from the 2017 eclipse.
It doesn't make it not a prediction just because there's a cycle.
We can use the globe model to predict the orbit of Pluto. We haven't seen a full orbit, but we can predict where it is tomorrow, and it's accurate.
Pluto.
Yeah, I think the contention is that if it's a cycle, then it's not a prediction. I think that's.
But we haven't.
This dude just brought up
seen a cycle.
That's
It's not a
exactly
cycle.
it. It's a
But that-
cycle.
which is a
Yes.
cycle. It's not a cycle.
It's a cycle.
The orbital time of Pluto is
That's
200
just,
years, so it's not a cycle yet. We haven't observed a full rotation.
So that's a non sequitur to eclipses, huh?
Oh, but it's a prediction made by the globe model or the heliocentric model, and it's accurate.
It's something we can't even
And it's not
observe.
a cycle.
How do you know it's
You can
accurate?
observe the Pluto. You can observe Pluto though.
Really?
Use a telescope, yes.
Wow.
That's how we know that it is there.
So we can observe it, but we didn't observe it. That's why the prediction's valid.
No, we have observed it, and we've made predictions based on the heliocentric model of its path, and it is on that path.
Okay, so a relative relationship of motion in the sky proves that the Earth spins in a vacuum. That's your claim?
Nope, that's not my claim. I'm saying that we haven't seen the whole cycle of the planet Pluto, but based on our assumptions, or let's say assumption of the globe model or the heliocentric model, those turn out to be accurate. Because
How do you know they turned out to be accurate if you can't see the whole cycle?
Because you can predict what it does tomorrow.
But you can't see it, so how do you know if it's right?
You can see it because you can use the telescope to see it.
Okay, so then you can see the whole movement of Pluto.
What are you doing?
You haven't seen
I'm
a
pointing
full
out the
orbit.
stupidity in his point. Are you not
No,
listening?
there is no stupidity. We haven't seen
Yes, there
a
is.
full orbit because the orbit time is 200 years.
Okay, so you don't know if you're right or not.
But we
Yeah,
can make
I'm
predictions, and they are accurate.
You don't know if they're accurate.
We can predict
my
the
God.
orbit tomorrow. We can check it tomorrow. It's correct tomorrow. And
Okay,
on
so
and on and
you looked at how much it's moved over a certain amount of time, and then used math to fully finish out an orbital path, and now you're saying you know it's right. It's
Because
so
you can
ridiculous.
test it. You can see it tomorrow at the exact location that you predicted it's going to be.
Can I address something was said before?
Yep.
I was reading about the Saros cycles, and it doesn't help you with the location. It's a cycle in which the moon is going to be at the same point in the orbit relative to Earth's orbit, so it's gonna likely have a very similar eclipse, but it doesn't have to match the position on Earth. The position on Earth changes drastically from one to the next one, and
The
also
anti-compara mechanism.
One second.
Well,
One
you're
second.
just
You know,
skating
I
past
was just addressing Saros cycles, which was what's provided to me when I asked for it. So and they shift. So if you try to predict many eclipses from that same date using several cycles, it only works for a couple next. The other ones are no longer going to match eclipses. So it's not it doesn't allow you to make as many predictions as a heliocentric model.
Yeah, so you can use the anti-Kythera mechanism, and you can
you
literally
link that
know.
one so I can take a look?
No, I'm driving.
You want it linked?
Just look it up, man.
I don't know how to
I
spell
like
that.
the anti-Kythera mechanism. It shows that the moon is causing the eclipse because it shows that the moon is in front of the sun.
You guys are incapable of honest conversation. You guys always change the subject to something else. Like the point I just made was as a form of rebuttal to what he claimed.
That?
Yeah,
No,
it's like
you're using the anti-Kythera mechanism, which shows the moon moving in front of the sun to go.
you doubled down on the non sequitur. What a cool story. ANTIKYTHEREA. Okay, well, this dude interrupt the spelling too. You guys have impulse issues. So whenever you said that it can't, only the heliocentric model can predict where it's at, I corrected you. You're objectively wrong. The Antikythera mechanism can show you where the eclipse is going to be observed.
Cycles.
Well, in addition, it doesn't actually show you the path of totality.
And it's
I think
also
the
based on
it would be like a planetary type device.
Hey, does the Antikythera mechanism show you where you'll observe the eclipse from? Yes or no?
I don't know.
Oh, it doesn't give you any coordinates or anything.
Yes, it does. So it's actually used, it doubles as a navigational system. So that's how you know where you'll see the eclipse based on your location. That's an input in the system. So try again.
Does it show you that the moon is causing the eclipse?
What? So every time you get boiled down to being wrong, you change the subject.
No, answer the question.
No, I'm asking a question.
You're changing the subject. Answer my question first. How about that?
No, it isn't. No, it's a question. No,
Answer my question first.
Well, I already answered it, but ask it again.
Can you use the Antikythera mechanism to know the location in which you will observe the eclipse? Yes or no?
No.
Okay, so you're just wrong.
Okay, I'm wrong.
Yeah,
so
that's
does
right.
the anti-Kythera mechanism show you that it's the moon that is eclipsing the sun?
It's the moon and the sun and the eclipses all have a relationship with eclipses. Yeah, for sure.
Okay, so it shows that. Okay.
No, it doesn't show. It just shows that there's a relationship. Yeah.
No, it shows that the moon is in front of the sun.
It just shows a relationship between them. Yeah.
Sure. Yeah, the moon is in front of the sun.
The big point was that you guys said the heliocentric model is the only way we can know where we see eclipses. That's patently absurd and wrong. Admit you're wrong.
Yeah, the anti-Kythera is based on a globe model, so sure.
No, it's not.
It is.
So where did you? Okay, I'm just trying to find. I mean, if you remember what you read, that it can predict where it's going to happen. So I can read the same thing. Do you remember where you find that?
No, there's tons of information on it online. I don't remember where.
Yeah, but I mean, it takes a while to go through tons of information. Maybe
it was a navigational system, dude. They used the navigational system, and then they could look at the sky.
That.
Oh, it's common sense. It's common sense, isn't it? It's common sense, isn't it?
I'm not challenging that.
No.
I'm just asking where I can find something that backs up what you're saying. Maybe there is out there. I just didn't find yet. I'm just asking because maybe you can help me speed it up. But if you don't remember, that's fine. That's fine. That's fine.
Let me just read a passage from the Scientific American about the Antikythera device. It says, much of the mechanism's design relies on wisdom from earlier Middle Eastern scientists. Astronomy in particular went through a transformation during the first millennium BCE in Babylon and Uruk, basically Iraq. The Babylonians recorded the daily positions of astronomical bodies on clay tablets, which revealed that the sun, moon, and planets moved in repeating cycles, a fact that was critical for making predictions. The moon, for instance, goes through a 254 cycles against the backdrop of the stars every 19 years, an example of a so-called period relation. The Antikythera mechanism design uses several of the Babylonian period relations.
Okay.
Right. Where do we get to the part where it describes the observation location or a path of totality?
Yeah, it's used as a navigational tool. So what you do is you have your location, and then it tells you what you're going to see in the sky and when. Wow.
I'm not sure if that's how it works. Because
Okay,
Yeah, I would
well,
like to see that,
your
actually.
incredulity is irrelevant.
Yeah,
Right. I
I
would
mean,
actually like to see
if
that
it's just
happening,
based
though.
on cycles, it's probably do something similar as the serial cycles, right? Because that's how they work. So
No, way
if,
more
if
intricate than the Sero cycle.
no, I know. I'm talking about specifically about eclipses. I can see that the how do you call it, Antikythera mechanism is not just about the sun and the moon. It has takes into account many celestial bodies. So of course it's more complicated than that. But I'm specifically talking about eclipses, right? So
Yeah,
if it's
it
based
tells
on
you what color
cycles,
the eclipse is going to be. It tells you when you're going to see it and where you're going to see it. I don't know. Can you guys not use Google?
yeah,
Yeah,
we're using
I'm
Google, and
currently
we're
looking at
struggling
the
to
thing.
find what you're saying.
Okay, well, I'll have to get it for
I'm
you
currently
later.
looking at the thing, and I'm not seeing where on it you would find
Well,
your
it's funny how
location that you would have to be.
before you even looked into it, you knew it
I'm
was
currently
wrong.
looking at the thing, and I
We're
cannot
not saying it's
find
wrong.
where you would. I'm currently looking at the thing, and I cannot find where on it you would use the information presented to you to find a location or a path of totality for an eclipse.
Was it used as a navigational tool? Yes or no?
Used as a tool to predict the motion of celestial bodies.
Was it used as a navigational tool? Yes or no?
Not the question.
I haven't
That is the
seen that
question.
anywhere.
Okay,
I
so
haven't
now
seen
you know. Now you know they had them on chips and used them for navigation. So now
You
you guys
you're
learned something
saying
today.
Did they?
Show us where it states that. Show us where it says that about
The people where what says that? Do you even know what it is? Do you know how we even figured out what we know about it? Show me where it says it. It shows your ignorance. The problem is you guys all said you
then do
know
it.
that I'm wrong
making
before
a claim.
you
You're
even.
not backing up.
Oh
You're
my
wrong.
god! I thought I was talking.
It's not red herring the conversation. I mean, if he's asking where it states that, what you do now is that you say where it states that. That's all. That's all the answer you
Where
should be
what
giving.
states that? Where what states that, smart guy?
About eclipses.
What
All right, here's
states it? What are you talking about? What states it?
What makes
Yeah,
the
exactly.
claim?
Stupid question.
I wasn't
Stupid
making
question.
I wasn't asking the question. He was asking where you got it, where you got this from, right? And instead of answering where you got this
Okay,
from,
well, hold on. I've got something.
Oh,
If you want something from live signs, the anti-ephemeral mechanism could not only predict the timing of eclipses, but also reveal characteristics of those eclipses, such as the amount of obscuration, the angular diameter of the moon, which is the angle covered by the diameter of the full moon, and the position of the moon at the time of the eclipse. That's from live science, what they say about it. Is that
yeah,
Cool. I'm still waiting for where it predicts the path of totality.
I mean, that's not surprising because if you have cycles of a moon orbit, you know the angular size keeps getting bigger and slow, bigger and smaller, bigger and smaller. That's a repeating cycle. If you know which is the current angular size of the moon, it's pretty easy to know if it's going to be an annular eclipse or a total eclipse, for example.
Yeah,
so that doesn't change a lot what we're saying.
This thing is admittedly not fully understood. Okay, so when you say where does it state that you haven't
Stop making
researched, you
claims
should
about.
probably not talk about things.
Stop making personal claims, man.
You know, I'm going to
That's
leave, and
annoying.
it certainly won't be that you.
which you're breaking up? What's this total? Why is this totality so important?
Right,
No,
we only have
path
one
of
thing available to us so far that gives us the path of totality, and that's the globe model. If we have something else, I would love to see it.
Why is it so important? Was the question.
Because
that was answered.
What we have available to us is one model, the globe model, that gives us the path of totality in advance. I don't have anything else that works.
That's the whole thing, Bansar. They're trying to discredit this and say only their magic works. That's what the whole idea is. Yep.
And my question still remains unanswered. Why is it so important?
You can pretend that my answer was not answering your question, but I did answer your question.
Look, you don't have to like it. Some people with togas 2,000 years ago figured this stuff out. They beat NASA to the punch. You don't have to like it. That's just the way it is.
What he said was,
let me just address Benson. The reason why we're this is important for this conversation, is that before we are talking about making a distinction between people just regurgitating bullshit and actually having knowledge. And the distinction came from the distinction pointed out was that if you actually have knowledge, you can do stuff with the things that you're saying. And then Whitsitt said we don't apply that to heliocentrism. So we gave eclipses as an example of that.
Okay.
That's why it's important for the conversation.
Okay, then, but saying that you know when the totality of an eclipse is gonna be is what we program something. So now we are just repeating and regurgitating what someone else has told us and using that information. Like,
So
we
current
don't know this.
The globe model predicts all of these things, including the path of totality, the angular size of the moon, sun, path, all of these things. If it's not correct, or if there's another option, then any other option should not only explain what we see, but also do better than the current model, or at least the same. If it can't do the same or better, then it should be rejected.
My point still remains. Why is it so important that you have to know when it is?
Well, one works and one doesn't.
The reasons that he just said. If we don't have anything that can do that kind of prediction that the globe model can do, then it's not as good as the globe model.
That's what it's all about, Bansaw. They want to hold up their model as the model.
Yeah.
Again,
they're the ones that figured it out. So nothing else could be as good as theirs. That's what it's all about.
If it doesn't explain the same or better, then it's not as good. That's the whole point of what I said.
Yeah,
Some guys wearing togas. Hey, 2,000 years ago, some guys wearing togas did the same. I know it burns you. I know it burns you inside, but they did the same thing 2,000 years ago.
No one
so
said.
far as
No one
presented,
said
they didn't.
you can't have a better model.
Basically, what you're saying is now we have a slightly better computer that can make a few more predictions than what they did 5,000 years ago.
It's not just
that's not true.
Well, no, that's basically all you're saying, really.
I get you understand that.
Use.
It's
if you
not just a
replace
matter
the
of
word
precision.
model with computer, then sure, but
the globe model predicts better, and it is better. That's great.
Yeah,
Thanks, Bansaw.
You can apply the
this, and I'll give you something else to argue. How about the gears?
Let me just
make the gear system.
Hold on, let Bacon finish, SC, and then you can.
Okay.
You can just use computers to run like those old methods. You can use computers to run Cyro cycles with any precision you want. It's still not going to be any close to what you can do with the globe model. Go on, SC.
Jump in, SC.
SC?
Oh yeah. Okay. Now my question: how about the gear system, which current science, current people thought that it was 1,000 years after it was actually invented, and when they discovered this mechanism, they were all astounded. So they got that wrong, right?
They got what wrong?
Gears. They thought gears. Gear. You know what a gear is?
Yeah.
Yep.
They thought that it happened in Europe somewhere, right? But when they found gears that were 1,000 years prior to what current science or current archaeology thought. What do you guys have to say about that?
Okay, so they were wrong by 1,000 years. Cool. I mean,
I'm glad. Okay, fine. Yeah, exactly that. They were wrong.
Yeah.
If it's from the 2nd century or 3rd century BC, that still doesn't change the fact that it does not do what the globe model does.
It doesn't matter. It did what you think was done 2,000 years ago. Maybe not to that precision, of course. We get better as things go along, but it did do it, correct?
Well, see, the thing is,
it didn't give us the path of totality, so no, that's incorrect, SE.
Hold on. You jumped all over left lane.
Yeah. I mean, the thing is about being wrong is not such a bad thing But being wrong and not admitting it and continue to profess accuracy when you're not right, that's a
Who
problem.
said? Hold on. Now you're being silly. Who said about accuracy? And you're going on totality. You're fixating on one thing and one thing only, right? What
the
we're
thing the
telling
globe
you
model
is
does better.
hold on. What we're telling you is the gear system of the sky was thousands of years ago. Eclipses were predicted thousands of years ago, and apparently 10 to 20 years in advance, the Antikythera mechanism was able to predict this. So, not NASA. It was done
It could not give
way
you the path
before.
of totality. It could not give you. It could not
That
give
was
you
already
the
addressed.
exact time. It was just a very general idea of when it was happening, and also the Antikythera mechanism does not predate. The gears on it do not predate when we thought gears existed by 1,000 years. Aristotle
How
wrote about
many?
gears.
How many? How many?
We have evidence that China had gears as far back as 2700 BC.
Metal gears like that? Like a mechanism like that? Are you sure, sir?
Yes.
He just had gears. Not that mechanism, just gears, right?
So this is what you're going to do. Instead of saying, what a wonderful mechanism, what a remarkable thing, you're going to try to do everything to go against it.
Why is this guy
This is
talking
why
over
I'm
him?
here. This is why I'm here, to expose people like you.
Like none other. I never said that the Antikythera mechanism wasn't something cool and interesting. I said that it is a lie to say that it predates all known ideas of gears.
No, it's not a lie. The gear systems, metallic like that, were the first time they were. That's the earliest known mechanism, like a clock mechanism. That's the earliest known. If you can find earlier than that, I will stand corrected.
It's actually described as an ancient supercomputer. That's how it's described by science forums, as a supercomputer.
It's an analog computer. Yeah.
That was the IBM of the day. Yeah.
Okay.
It's compared to any other one, which was like none.
You're trying to poo-poo it by saying it was an analog computer. It's an ancient supercomputer. Why not embrace that? Why are you trying
Because
to
that's more subjective.
Put it down.
That's a
Compared
more subjective
to a clock,
claim.
it is a supercomputer, sure, but it is an analog computer.
Okay, it's an analog computer, but it's a supercomputer. That's how the science forums
What does that mean,
describe
Benzo?
it.
What does that mean to be a supercomputer?
A really good computer. That's what it means.
Okay, it was a really good analog computer then.
You know what it means?
Very good
means
analog
yeah,
computer.
we agree with that. It's a
it
very
means
good
showing
analog
you
computer.
guys won't give an inch. You're just gonna try to poop. Just gonna try to poo-poo everything we say. That's what it shows.
Only the things that are bullshit.
Yeah, right, the thing that was mentioned long ago in this conversation was that there isn't an alternative that gives us the path of totality.
So you're fixating on totality. You're not going to acknowledge the marvelous, absolutely astounding machine.
Marvelous.
We've
all acknowledged that.
But that's not the conversation.
Yeah, we already
acknowledged
that the device does what it does, and it does it very well. The problem is, what it does is now we're looking for things that match reality better. And what we have, the globe model, does that.
So you just want to fixate on one thing that your model does it better than that mechanism.
That was the topic.
Yeah, because it doesn't match reality. Actually.
Well,
that was what we were talking about. We were talking about
Yeah.
predicting eclipses.
Well, maybe if these ancient people had information from Australia, the Philippines, Japan, all this other information thrown into the mix as well, this might have been an ancient quantum supercomputer if they had all that information to work into their gearing, right?
Problem is that it is not
that was
electric.
random.
So.
Just think of the brains that it took to do that. Man.
I know.
Just think of the genius that it took somebody 2,000 years ago. Just imagine that, man.
Yeah, they were wise. They knew a lot about astronomy.
And the fact that it doesn't do what it doesn't do what the heliocentric model does. Just keep deflecting from that fact to marvel on the device. We're not worried about the device. It is marvelous. It's really cool.
It's fantastic. Even you could even say it was so far ahead of its time. It was a tragedy that was lost when it was lost.
Now we're talking.
Does not take away from the fact that it doesn't do as much as the heliocentric model when it comes to predicting different things about eclipses.
Oh, what's the name of that model?
2,000 years later, yeah, obviously. I mean, that goes without saying. It would be improved upon, right? Obviously.
What's the name of that model in which, like, the sun goes around the Earth, but the other planets goes around the sun? What's the name of that one?
Geocentric.
It's like geocentric.
That would be a Tycho Brahe.
Geocentric, but geocentric, they all go around the Earth. The one I'm saying is like only the sun goes around the Earth. The planets go around the sun. It's like the same, exactly the same as heliocentrism, but it fixes the Earth in the center.
Yeah,
it's like a Tycho-centric or something. Tycho Brahe's model.
What's the name of
that
it?
one?
It was one of Tycho Brahe.
Yeah. Where the sun and the Earth have their own special little loop-de-loop type thing.
I hate to throw in a little monkey wrench biblically, but in biblical terms, we worship basically and think that the Son of God is our Lord and Savior, and y'all put the Son at the center of everything, as religious groups like Christianity and other groups that y'all call religions put the Son of God in the center of everything, and then in your model again goes against religion and puts the actual Son as the center.
The heliocentric model is not a religion. Nothing to do with God.
Right, but Christianity and everyone else
makes no claim about the salvation of souls, the afterlife, or the supernatural. Heliocentrism does not deal with religious topics, supernatural topics, or issues of the soul. Trying to link the two together
I didn't say
using
anything about
English
the
on words like that is ridiculous.
Yeah, I didn't say anything about the specific model. I just said the one where the Son is in the center, where the Son is the Son of God, right? The Savior is the center of Christianity, or a lot of them. The model that is put forth as mainstream is the sun itself. The light in the sky is put in the center of everything. Everything revolves around that. You see the comparison I'm trying to draw there? I mean, surely y'all see
A
that.
stupid one, yes. Thanks, appreciate it.
How's that stupid? It's very easy.
Stupid. Because because they're not even remotely similar to each other. One of this is about predicting and seeing natural events in the sky by creating the most like reality. By creating a model that's most like the reality we observe, given the things that are going on. The other one is the other one's about the other one's a theology based. The other one's theology, and somehow you're trying to link this theology and compare it to a natural observation and model. And it just doesn't
saying
work.
how it is compared. Not that I'm doing it. I'm saying that's how people do it. The sun is the most important thing, and science says that it's the baseline. It's the center of everything. It's what everything revolves around. Yeah, in our universe it is.
There's no most important thing in science.
And moons orbit respective planets. So I mean, it's not like everything goes around the sun.
From my reference frame, the Earth, right, from where I'm standing, it looks like the sun is moving across my sky.
Yeah, but if you were to do any sort of further breakdown and actually map out what's going on, you would know that that's not the case, because if that were the case, you would have a bunch of contradictions.
I would? You sure?
What?
Yeah.
I don't think
you
so.
would you would, especially considering you could go to Australia.
If I go to Australia, the sun is still going to appear to be going across my sky, sir.
Yeah, but it's going to rise set south of.
Yeah, but you're talking about position. I'm talking about the actual movement.
I'm talking about the actual movement. Are you trying to say that it's moving across? Are you trying to say that it rising south of east, traveling over my head, and setting south?
Yeah, well, you're talking about apparent positions. I'm talking about the actual movement of it. It seems like it's moving, and I'm not. Like, I'm looking up, and it looks like the clouds are moving above me. But in actuality, the clouds could be stationary, and I could be moving underneath them. It's kind of strange to say.
You said
Except that you could
actual
include
or
that one
apparent
because.
path, but
Go ahead. Sorry.
it's just Rakia. You said that he's talking about the apparent path, but you're talking about the actual movement. How do you
No,
know
I'm
that
talking
it's
about
actual
I'm
movement?
talking about my apparent path of the sun too, because I don't think it's in its actual position. I think it's being projected in, but it does look like that projection is moving across my sky.
But it's just apparent, right?
Projected in and can't detect a source.
Yeah, the apparent position, but the actual movement it comes from my east and goes to my west.
But that's apparent motion. You don't know if it's actual motion or apparent motion. If the path can be apparent and not actual, then the movement can also be apparent and not actual.
Nice own goal there.
Say that again, that last part about parent and not actual.
Yeah, if the path is apparent and not actual, then the motion also is apparent and not actual.
No, that's not true.
Well, how do you know that it's actual and not apparent motion?
Yeah, I mean, we see things where we see them, and we see them doing things we see them. We see them in motion.
Yep, so we see the path, it's actual path, yes.
So you think the sun is on its actual path, even?
Yeah, the GP, it's GP.
So you're saying, to be clear, I want to understand this. The location is apparent, but the path it takes is actual.
Well, I think
No, he's equating what Rakia is saying, because Rakia is saying that the movement is actual and the path is apparent.
Yeah.
When in fact you can't, and when in fact Rakia can't differentiate what would be apparent or actual when it comes to the motion.
Well, I see the trees moving. I think the tree is moving, like the branches are moving. I see the clouds moving. I think that I'm stationary. I'm sitting still in my truck, and the clouds are moving above me. And I think the same thing about the sun. I don't care how y'all break it down. Is that cloud that I see in its actual position from my perspective? I'm not sure, but I can see it moving, and I think I'm still, right? I don't think I'm moving. I'm sitting still in my truck.
So is that cloud actually there where you see it, or is it only apparently there?
Yeah, I don't know. Y'all can break that down how you want, but the cloud is moving. I'm not.
But if it's not actually,
Go ahead.
Well, I argue, right?
like if it's not actually there, how do you know that it's actually moving if you don't know its actual position? How do you know that it's actually changing?
We can argue about everything you want to argue about. I'm talking about the movement.
Sure. How do you know that it's actually moving and not apparently moving?
Yeah, I don't think you get it, right? You're just trying to be funny or silly or something.
No, it's just trying to show that you're holding a double standard.
Not really. I'm saying I'm sitting still,
but
things above me are moving. I don't know what standard you're talking I'm doubling down on.
If you're in an airplane, does it appear to you that the ground is moving?
What if I'm in a truck sitting still in a parking lot and watching things above me move? Let's talk about that, because that's what I brought up. If you want to talk about airplanes, you can bring it up later. I mean, I guess after we finish this.
Sure, I brought it up. How do you know that the ground isn't moving and you're actually moving?
Well, what I'm asking is, why do you agree with me that the clouds moving, around us or above us, but you don't agree that the sun is doing the same thing? Although it seems to be like, we're looking, we're observing, and we're seeing the same thing. One thing move above us, the other thing moves above us.
Because we have far more evidence than just looking at something and saying, "Oh, look."
We do.
Yeah.
Okay, we can track the cloud, right, as it goes across. We can get the angle measurement. We can do all that. Approximate its distance. Do all that. We can do the same thing with the sun, right? What else?
We can follow the sun's GP. We can be right under the sun, flying around the equator,
and
on a straight line.
And would you have to be? Would you have to constantly, if you're following it from sunrise to sunset? I would imagine you would have to be constantly correcting to the right, which would be towards the north, right?
Not at the equator, no. Obviously, no.
You would at the equator.
No.
At the equator.
Is that in theory, or we got some evidence of this?
You can just get at the equinox, at the equator. You can just put a stick on the ground and see that the shadow is a straight line. So the sun follows a straight path.
Well, yeah, the shadow of a stick in the ground at the equator where the sun is going directly away from it at a certain distance, that's fine. But that's not tracking it all the way around. Come on, man.
That's tracking it for half in rotation for 12 hours.
Come on, bro. You can't slide that one by me.
So there is no sunlight that we look at the equator.
Say that again.
Are you saying that the sun isn't visible for 12 hours at the equator at equinox?
Yeah, I don't know. I've never done that observation.
So you can't say that it's not true.
I don't know. I don't know how many times you want me to say that. I don't think I've ever been on the equator. Watch the sunset. No, I probably haven't.
Sure. Okay. So you can't say that it's not a thing.
No, that's why
you can say that you don't know.
Yeah, that's why I said I didn't know.
You said it.
I did?
Yeah,
I said,
you said that you can't
man, I don't know about that.
Yeah.
I don't think that's me saying
No.
I think I clearly said I don't know like 5 times now.
You said, hold on, you can't prove that one on me. That's what you said.
Right. You can't. I don't know if you know that. Do you know that?
Yeah, you can easily.
Okay, post it. Post the evidence. Post your video or whatever you got. How you know it?
Video?
Here's a good one that's right in the chat.
Yeah? And what does that show?
Yeah, that's a good one.
That a stick on a shadow on a stick doesn't do what? Movie. Get longer?
That's the thing that I posted. The most recent thing.
Yeah, but what he was saying, when you put a stick in the ground, the shadow doesn't get longer on the equator? Is that what you're saying?
No, it gets longer from dusk to dawn. It's a straight line. So the sun follows a straight path.
Oh, I see what you're saying.
To west.
Yeah, post that one. That would be a cool video to show. You
want a video of it. So every people who actually know this and live at the equator, they just don't know.
Well, no, I'm just saying people that do things like that video it. I'd like to see it. It's interesting to me.
He's just asking for proof of claim, right? So Matthew Learns used to always claim that satellite dishes at the equator point directly up. It took me 2 seconds to go on Google Maps, drop a little guy for Street View, and prove that this is not necessarily the case, right? So all he's asking for is, do you have a video or any evidence to back up your claim? I don't think that's too much to ask.
Well, yeah, satellite dishes are not pointing straight up at the equator.
Oh my goodness.
Excuse me?
Yeah, which satellite dishes are not pointing straight up at the equator?
Are you in front of a computer, and do you have the ability to use Google Street View on any cities at the equator?
Like in Ecuador, for instance?
That would be the case.
Okay, those are pointing straight up. As all of I've seen of Ecuador, those are pointing straight up.
All that you've seen, yeah. If you Google satellite dishes on the equator, you'll get images of satellite dishes pointing up. But in reality, when you look at Google Street View, they're not all pointing straight up.
I think his point is you've probably seen a meme made by a Glober showing Ecuador satellites pointing straight up and making the claim that all of them do. And you're repeating it now that you don't actually know that they all do. Neither do I, but.
No, I've definitely observed parts of Ecuador.
Parts, yeah, keyword parts.
Just disproved you, man. Why would you?
The parts that I observed, the satellite dishes were pointing straight up.
So you don't know that all the satellites in Ecuador are pointing straight up. Thanks. Cool.
I would like to see some that aren't.
Well, look it up. He told you how to.
Or
Google Street View, homeboy.
A random position of Ecuador, right? I could go find the same positions I'm already aware of and find the same thing. What I'm looking for is a specific location if he's got one in his mind.
Yeah, that's kind of what I was wanting the video of that other guy's claim because I think it's interesting.
Yeah.
I'd like to see that.
It's called proof of claim, right? I told you could do it if you're in front of a computer. I am outside right now on my phone. I can go inside, get on my computer, and give you a city, and you can go look around for yourself on Google Street View.
All right.
Yeah, why wouldn't you just go look? No. How about you just go look or stop talking about it?
Right. Again, the parts of Ecuador that I have observed have satellite dishes pointing straight up. Again, if I go look on Google Street View, I'm going to probably find exactly that. Now, if I do that, and I come back here and I say, the thing that I saw is still on Google Street View, then I would still need a specific location where they're not pointing straight up.
Hey, how about you go check it before thinking you know everything, man? Have you ever considered that? You have a bias, right? And so it's very obvious to everyone here. You just have a bias. They should all be pointing up, so you just can't fathom that they wouldn't, and you're actually afraid to go look for it.
I don't even think all the satellites pointing up in a certain place would prove anything anyway. But yeah, that's just me. I'm crazy.
No, but it's just really it's a rebuttal to their claim.
Yeah.
Yeah, I couldn't find any videos of the sun. No one's recorded the sun at the equator.
No one's recording 2022 now, man. You could pretty much pull out a hat, anything, and I could probably find a recording of it.
Well, 24-hour sun in the Arctic.
I'm just saying, in this day and time, man, there ain't much that ain't recorded.
There are 24-hour sun videos in the Arctic.
Are there?
Allegedly, yeah.
Are they real?
I don't dispute that they're real.
What about the Antarctic one?
Those are clearly
bird
fake.
cams, bro. We have pigeon cams, bear cams, ant cams. Are you kidding me?
Let me explain why they're clearly fake. So the one in the north can be done like 1,000,000 times, and it's not edited and chopped up. And there's like 2 or 3 of them ever claimed from Antarctica, and they're noticeably doctored. So to laugh so hysterically like that just shows how detached from reality you are, bro.
So there's many videos on the Antarctic.
No, there's not. There's just a few, and they're all doctored.
Oh, there's many.
Define
many. Did the clouds stay the same for 24 straight hours?
No. There's
so if
one video.
So what that one's fake though.
But there isn't one where the clouds are stationary for 24 hours, I think.
Yeah, the clouds come back to exactly where they started, identical clouds as when it first started.
Because
that's impossible.
Sure.
That's impossible.
Yeah, because it's the same video starting all over again, but it's cut wrong.
No, it's not starting all over again, buddy. It's just at the end of it when it comes back to. No, it's not.
Well, how can it not be the same video starting all over again? If the wild clouds are edited,
it's edited somewhere. It's edited somewhere in the middle, dude. You can't have the first frame and the last frame match up. That means it's spliced somewhere in the middle.
Oh my God, it is scary. Y'all can't think this.
What do you mean how?
Yeah,
you guys defend everything. You can be a globe earther and not defend every freaking baseless assertion, and it makes you guys look bad.
Well, can I
take away your ball?
Do you guys have the video? Because I believe.
Let me look it up.
I know where it was spliced. I know. I think I remember. It was like spliced somewhere.
Whatever, man.
I think the disheartening part is you never see a globe earther admit that it's clearly not legitimate. They'll never do it. They'll stop talking about it before they do that. And so that's just kind of off-putting to any intellectually honest person, right? I mean, it's weird. It's weird. Like, I don't agree with every flat earther's claims. You know what I'm saying? Like, you don't have to defend everything. It makes you guys look bad. I'm just actually trying to help you.
Yeah, it's okay to. I don't believe this part about like I say about the sextant, right? Feel free, man. You don't have to agree with everything.
Yeah, I'm not agreeing with everything. I mean, there's no if I make a video that is 24 hours time and it actually loads, and then I cut it wrong, it would have the loop. You'd have the first frame and the last frame be the same. I don't see what
I posted the video.
Yeah, now you can't even make up stuff anymore. The video's right there.
Yeah, I'm not making any stuff up.
You're gonna go down swinging though.
Do GIFs loop?
Yeah, GIFs loop. So
hey,
every GIF is
Whitsit, if you want something interesting to go check out, look at YouTube documentaries and type in the Antarctic expedition. In about 7 minutes and 33 seconds in, or 7 minutes and 44 seconds in, They talk about how there's 3 hours of darkness every night during the summer.
Wow.
So how's that
Yes,
possible
there is.
with a 24 hours? How is that possible with a 24-hour sun in the summer?
Yeah, it's
Because
definitely
they're
not
talking
possible.
about the northern summer. They're not talking about the southern summer then.
They're talking about southern summer. They're talking about the southern summer because the only way you can bring tourists down there is for the inlet to open up, so you can have the ship travel to the peak or to the shoreline. That's only possible in the summer months. Got it, bud?
So are they okay? Post the video.
Go down swinging, bro. Go down swinging before you research it.
Go to YouTube documentaries. It's called Free Documentaries. YouTube Free Documentaries. There's a whole bunch on that free documentary channel called YouTube Free Documentaries. Type in Expedition Antarctica. Go to 7 minutes and 33 seconds or 7 minutes and 44 seconds, depending on, I don't know. There's a discrepancy there for the 10-second time. I don't know why, but you can hear it in their own mouth. They have to navigate in the darkness for 3 hours every day during the summer. How is that possible with a 24-hour sun?
So which one? It's the world's most dangerous places called road trip Antarctica. No.
It's literally called Antarctic Expedition or Expedition Antarctica. One of the two. I think it's called Expedition Antarctica. And it's a free YouTube documentary, 7 minutes and 33 seconds in or 7 minutes and 44 seconds in. They're driving a ship, sailing a ship, and they're discussing how they have to go through this inlet that's only thawed out in the summertime, and there's 3 hours of darkness every night.
Yep, I found it. I'm gonna check it out.
And then I have another book written in 1958 talking about the stations in Antarctica and how all the scientists had to brave the long, dark summer months. How is that possible if there's a 24-hour sun? And this is all researchable. It's all there for you. So
I think I think if it's not in the middle of the summer, then sure there can be 3 hours of darkness if there's 21 hours of lightness. I mean that's what we get in the north too. If it's not midsummer, you get X
and
amount
then there's
of
also if you keep watching that documentary, there's another documentary with Admiral Byrd, which also they claim there's 9 months of darkness in Antarctica. 9 months of it, they all documented. So we've got 9 months of darkness. You've got 3 hours of darkness.
How do you say that it's all documented? How is it documented?
So it's on YouTube. All this stuff, all these old archaic videos from all these expeditions are all on YouTube now. There's a channel called Periscope, and you can type in Periscope Antarctic Secret Treaty or Antarctic Secrets Periscope, I think, and you'll get a ton of Antarctic videos. They show you, dude, exactly what's going on there. So I don't know how it doesn't exist in the 50s. No 24-hour sun, but seeming after 1959 when DARPA got into play, there's 24-hour sun. And the first guy to document the 24-hour sun was a Boy Scout by the name of Scott Sipple, S-I-P-L-E. Go look him up. He's a Boy Scout, apparently. The first guy to get the time-lapse footage of the South Pole in 1957. So, there's lots of interesting things going on there.
I just screen recorded it. I screen recorded it. You got no excuse. It says it point blank right there, just like he said it does. So if there's why is there 3 hours of nighttime or darkness?
Darkness in the summer. Because we have that in the north too. Yeah, we have that in the summer in the north too. I mean, there's just a few days.
So it's impossible to have that. It's impossible. Oh, there's only a few days where it's 24-hour light.
Yes.
Depends on the place. Some of the places in Antarctica are not in the direct South Pole location.
Yeah, and how do you have 21 hours of sunlight in Antarctica on the flat Earth? If 24 hours.
Oh, you don't actually see the sun. You don't actually see the sun. You just have light. So good try.
Yeah, in the documentary, in all the stuff that I've documented in earlier explorers, including starting around the 1500s, 1600s, there is no visible sun above the horizon. That's what's documented. There is light, but there's no visible sun past the horizon. They can't see it. This is what's documented by earlier explorers. You can go fact check this yourself.
Sure.
Well, hold on.
What's the time that they went there, and what's the location?
This is another example of you guys going down swinging just because you have a religious.
No, we're just asking for specificity. That's what you like specificity.
Yeah, substantive specificity. You don't see the sun, you just see the light. Those aren't synonymous. It's very simple.
Yeah, that's just a claim. So.
No, that's a fact.
Where's it at?
Is it?
Where do I find this fact?
Video.
Where do you find this fact? I've talked to someone that used to be stationed there for NASA. Does that count? Literally. Let me guess I don't. Let me guess I'm making that up.
Oh, no. It's okay. I know a guy in Finland who's been there in the summer and seen the 24-hour sun. Do you accept that?
He did not see the actual sun in the sky for 24 hours.
He did. He said that he did.
Oh, he said he saw the sun. Not that it was daytime for 24 hours, but he saw the sun in the sky for 24 straight hours.
God dang, wait it.
Yes.
God dang, wait it. What? What?
Oh.
What?
Stupid bugger.
Which is it? Is it the sun or the light? That's a very big difference.
It's the sun. No, there's no difference, but it's the sun.
There's no difference?
Between sunlight and sun? Well, sure, one is causing the other, but sure, it's still sunlight and sun.
The question would be, is the sun itself, the circular thing that you see in the sky, visible above the horizon for 24 hours? I could see it's feasible in northern Finland.
Yeah, in northern Finland, yes, you can do it. Not where I live in the south, so I've seen it in the north, but not over here.
Why are all the videos of it doctored then?
What?
Well, the videos in the north are not doctored, so why are all the videos in the south doctored?
No, they aren't. You can go to, there's a channel that has all the, many webcam recordings from the south, where there's 24-hour light. No problem.
Oh, they have a 24-hour time lapse, so that's not doctored?
No, he said 24 hours light. Yeah. He just said 24 hours light.
Sunlight, 24 hours sunlight,
so not the sun above the horizon. Yeah, cool.
So you're saying because it loops?
Because the webcam isn't rotating. So it's sunlight. You can see the sun, then it goes out of the frame, but it's a sunlight.
Wow. So that's I'm going to help you out here. That doesn't help you.
Okay, so you're saying that on a flat Earth you can have 24-hour sunlight in Antarctica?
Correct.
Okay, well then why is this even talked about? Why is this even talked about? Then you can have 24-hour sunlight in Antarctica.
I'll talk about it. No, not sun. You can have 24 hours of light.
Daylight.
You can't see the sun for 24 hours. Do you need crayons, or are you just being dishonest?
Okay, so that's an ad-hom. So
no, it's not an ad-hom. My argument wasn't
24 hours of. I was talking. So you said that you can have 24 hours of sunlight in Antarctica on flat Earth.
24 hours of light, yeah.
Sunlight.
Just daylight.
What's the difference between sunlight and daylight?
Just as a tidbit here of information, a lot of earlier explorers wrote about a lot of refraction effects. One explorer wrote about orb anomalies due to some sort of refracting of light. So there seems to be some sort of strange phenomenon with light and refraction in the south as documented by earlier explorers.
Yeah. Coffee cup caustic would easily explain it on a flat Earth, so you're going to need to prove the sun's there. It's very simple.
What? Coffee cup caustics don't explain it.
Why not?
Because any point inside the coffee cup you will see the light source.
The sun wouldn't be circular.
Yes. In any point inside the coffee cup you will see the sunlight.
So you're saying that the light can't reflect around a circle outside an outer edge of a circle with the coffee cup caustic?
No, you'd see the light source.
Yeah, the light source wouldn't be circular anymore.
Well, good thing that we don't see the sun for 24 hours. We just see light.
So then it's not acoustics or coffee cup acoustics because you'd see the light, the sun then.
No, you don't see the source of the light everywhere. On the other side of it, it's just the reflection of the light around the container. So what are you talking about? I can do it right now. You mean to go do it for you right now and send you a video? I can literally do it with a little flat Earth model over here. You want me to do it for you?
Sure, do it so.
Are you slow?
From within the coffee cup caustic.
Yeah, hold on. If you say that it's coffee cup caustics, then you need a physical wall that is reflecting the light that you can't see through.
Yeah.
Show that in reality, please.
that
Show
you
me
can't
that in
see
reality.
through?
Yeah.
It doesn't
Do
have
you
to be
see through
something that you
coffee
can't
cups?
see through. You don't even understand the effect.
I do understand the
No,
effect.
you don't.
So if you see through it, then you see the light source. Then.
But not all over it. You think you can see across the whole Earth? You're an idiot. You think you can see across the whole Earth?
Hold on. Your coffee cup acoustics, if you have a see-through glass, you will see the light source from everywhere inside that cup.
You can't see across the whole Earth, buddy.
Yeah, that's why your thing is horseshit. It doesn't work.
Does everyone here understand why he's wrong?
I don't know why he's thinking he can see across the whole entire Earth, ignoring his angular limited perspective. Why do you want to ignore a perspective claiming that you can see across the whole entire Earth because you don't understand light?
It's weird.
Understand your vision is limited first, buddy. Yeah, but understand your vision. Everything is going to come. Everything is going to be translated through your perspective, your field of view, which appears to be like a circular dome. Your field of view appears to be a circular dome, right? So you can't see forever. You can't see for thousands and thousands of miles. Agreed, right? A small observer on the ground has a. What's that?
I said I don't agree because I can see the sun. I can see the sun and the moon.
Okay, so you can see the moon, therefore you should be able to see across the whole entire Earth. Do you understand how illogical that is, right?
That's not what I said. You said that I do agree that I don't see for thousands and thousands of miles, and I said no, because I can see
across the plane of the Earth. You said I see the moon, therefore I should be able to see thousands of miles across the plane of the Earth, right? That's your equivocation, right? Yes, you just admitted that's your equivocation. I can see the moon, therefore I should be able to see thousands of miles across flat Earth, right? Or if the Earth's flat, right? That's your equivocation.
No.
Well, then explain it to me.
Let him answer, Data. Let him answer, bro. I'm trying, Data. Hold your horses. So if this coffee cup acoustics is a thing, and if say you have a coffee cup and you have the acoustics, you can see the light source from anywhere inside that cup if it's a see-through cup. There's no point where you don't see the light source.
Okay, so
there you go. I just made a video for you.
When do we ever see the above picture of the caustic cup? When do we ever see that?
But Twitch just posted
okay, yeah. So you're looking at how light can be refracted. You're looking at light can be refracted in a circle, right? That's what the caustic cup example is showing you. How you can have a light source at one side and how it can refract back to the opposite side, right? That's the understanding of the caustic cup. Do you understand that?
Reflect.
Yeah. Yes, and you can always see the light source when that's it.
I just posted a video.
Yeah,
right. And if you observe from the surface,
I just say.
Yeah, if you observe from the surface of that, the light source is no longer just one little circle somewhere.
So you think if I'm on the other side of this model that I can see the light source? You guys are actually deluded.
No, wait it. You're saying that the sun is at the surface of the Earth. That's retarded.
Say again?
The sun is above the Earth. In your video, you had the sun right at the surface of the Earth, and that's not the case because it's above the surface of the Earth.
It's not right at the surface. This is all to scale, buddy. This is all to scale, buddy. So do you know how high that container would be relative to the layout of the land here?
No, hold on.
Do you know how to do? Do you know how things work at scale?
Yeah, I know. When you had the light in the corner of the thing, or the edge of the thing, how high was it from the surface?
It doesn't matter.
It does matter. That's my point. It does matter.
It's not on the surface. It's above it, and I can actually go higher and aim it toward. Look, I'll make another video for you, so I'll just refute that, so you can just keep looking ridiculous.
Sure. Just make another video where you have the light not on the surface.
Yeah, it's super easy. It's super easy.
It's not on the surface, though. It's above the surface, obviously. And here's the thing. In that map that you're seeing there, in that video, even if he has it an inch or two above the surface, that could be 3, 4, 5, 6,000 miles based on like the scale for the map.
Exactly. But here's one of it all the way at the highest part of it, so you can just be completely wrong.
So have you put a camera inside that dome of yours? And
I have tried that, yeah.
If you see the light source.
It's very difficult to do that. So I tried to use a GoPro. Do you know how difficult it is to do that? It's basically impossible, isn't it? Have you ever thought of questions before you asked them? Here's another video.
Yeah.
Why is it just a pity? Anyway, there's a screenshot. You see it? You see it? You see how high the light is? You see how the light... Wait, admit you were wrong. Admit you were wrong.
And you can see that light from everywhere on that surface. Everywhere. So you are wrong.
No, you cannot see across the entire Earth. That's very, very dumb.
Right, but your scale model, you can see the light from everywhere.
You can see it all right. Yeah, you're stupid.
You don't know that if it's based on perspective. Even if you put a camera in there, you would have to measure the aperture of the lens and all of that, and that would be equivalent to having like a 2,000-mile aperture.
No,
in reality,
the aperture doesn't. The aperture won't change if that's visible or not. You just have to point to that direction.
It will.
Regardless of the aperture.
100% will.
Regardless.
Hey,
let me
Bacon,
finish.
Yeah, I know
let me
exactly
finish.
what you're saying, bro.
So you let me finish, and then you'll know that. Regardless of the size of the aperture, if you point to the direction of a source of light, you see that source of light. The aperture is not gonna change the position of something that you're pointing toward. Go on.
You wouldn't see it across the whole Earth. Any type of argument is literally dumb.
Can you?
Well, then
so
your
representation then doesn't match reality.
Yeah, your example is shit because you can't scale it then. So it's a problem on your part.
Yeah, good one. So you admit that this effect would cause there to be light around the whole edge? Yes or no?
This would make the whole Earth light lit up in the same time.
The whole Earth is still dark right here in my picture, man. What are you talking about?
But you can see the sun from every point on that surface.
No, you can't. If you're on the other side of this container, that would be many, many thousands of miles away. You're ridiculous.
Right, but your scale model then doesn't match reality.
Yeah, you wouldn't see that setting or rising from the horizon. You're just gonna see it fade away if that's your explanation why we don't see it.
Yeah, it would be always above
You have
the
no
horizon.
idea how perspective works, do you?
I
None of you guys.
definitely do. Okay, when you build your own render, you can say that.
Okay, so you built your own
perspective render. Is simple. Yeah, perspective is simple trigonometry.
Right,
simple trigonometry. So what angle does something become no longer visible? What angle in the human eye? What angle? What is the smallest angle that the human eye can resolve?
The angular resolution of the human eye?
Yes. What is the smallest angle?
The theoretical smallest angle is 0.007. That's based on the 500 nanometers at the 0.5 centimeter aperture. Using the 1.22 times lambda over diameter, you'll get a theoretical 0.007. That's what the theoretical maximum angular resolution of the human eye is. Now, its visual acuity is anywhere from 0.16 degrees all the way to angular resolution of 2 degrees, depending on what calculation we're using and what theoretical number we're going to start with.
1.22 sounds familiar.
Keep in mind,
where else do we use 1.22?
Keep in mind that we're talking about perspective. Angular resolution is not perspective.
Yep.
Angular resolution is an effect due to angles of light to the human eye. That's a fundamental. Now, perspective, perspective in the way that the appearance of the convergence of light happens to do with the convexity of our lens and the focal point that our eye is designed to deduce information from. So when we look at objects,
it has nothing to do with objects.
We have an apparent effect. When we look at objects, we have an apparent effect happening that's not actually happening in reality. It's only happening optically, which means all objects appear to converge into a neutral point of the eye. That's not actually happening, fellas. It's an optical illusion. So is the sunset. So is any object disappearing. It doesn't actually disappear. It's just past the limitation of resolvability due to the optics of our eye. So any object that is moving away, that's lower to the neutral point, will appear to converge up. Object above the neutral point will converge down. This is a byproduct of optics.
Stop it.
So when you have a calculation for angular, you're claiming perspective is easy trigonometry. That's bullshit. I can force perspective.
You're just gishgalloping.
I can change. Stop. I'm not done.
Brenda, please
Brenda,
please don't interrupt.
Brenda, I will mute you this time. If you jump right in interrupting people, I'll mute you.
The point is you can force perspective by using architectural designs. In other words, you can show smaller angles, like for instance in a hallway, you have a convergence point much faster than a horizon line. Do you know why? Because the angles in a hallway are much smaller than the angles on the surface of the earth looking at the horizon. We can force perspective this way and force convergence. It isn't happening, boys. There's nothing converging now. What you like to do is escape in your mind and think the earth is perfectly flat and therefore no undulations. And therefore, if I have no undulations, I should be able to zoom in as far as I can see. That's not reality. A 1 inch undulation of the ground. I'm almost done.
Come on, enough with this. He's just gish galloping.
1 inch of undulation along the observer's perspective as it rises up into the neutral point of the eye will block objects in the background due to the convergence of light. It's an optical effect. That's what that's what we see with our eyes.
Anything.
It will block
everything you said.
It will not.
Not from perspective.
Hold on just a second, because the first thing that you said at the beginning of all of that bullshit, the very first thing you said was that the appearance of convergence.
You got no argument, dude. You got no argument.
Data.
Data.
I do not want to mute you, please.
Yeah, no interruption.
Continue.
The very first thing that you said was that perspective, the appearance of things converging, had to do with the convexity of our eye. However, a pinhole camera has no convex lens in it at all, and you still get that exact same effect. Perspective has nothing to do with convexity.
Data.
The perspective effect that you see has nothing to do with convexity of a lens.
So again, the circle aperture will provide that cone shape. The convexity of our lens allows a focal point for us to focus in a close range and a far range. That's why we have a convexity of the lens, so we can bend the light and focus it into a point. The aperture itself will have banding and blurring effects based on those subtended angles at the distance of the object to the observer. The object too small, that subtended angle of the light becomes too acute. It bands around the eye. It's unresolvable. It still compresses into a focal point due to the convexity of the lens, the operation of the lens. The aperture of the eye will, because it's circular, will have a pinpoint perspective point. The optic of the lens helps you focus that in and out. The fundamentals of it, however, all objects will converge into a vanishing point. The surface of the earth, to maintain a horizontal position, has to have a horizontal reference frame. This is what we see consistently over and over again, is a horizontal reference frame. What also we see consistently is the optical effect of the ground appearing to rise, not at a linear rate, based on trigonometry after a certain distance. It seems to appear to have an exponential rate at a certain distance, which means perspective isn't exactly 100% like trigonometry. There is an apparent convergence there. In trigonometry, you don't have parallel lines appearing to converge. That is an optical effect. So that means
hold on, you have evidence?
That means that apparent convergence of parallel lines has a frequency or a point of resolution due to optics that's not equated for in your calculations, not equated for in your globe model, period. It is negated.
Data.
I can actually use the understanding of perspective.
Doofus, I think Bacon was trying to get in. Doofus.
Bacon was trying to jump in.
All right, in trigonometry, parallel lines, when projected onto a 2D surface, they do converge. That's how you get perspective, by projecting a three-dimensional environment into a 2D surface. Just saying that in trigonometry parallel lines don't converge is not what perspective is. That the perspective is just the projection, and you do that
in reality.
You do that using trigonometry.
A trigonometric law.
Hold on. Bacon
Go on. No, now I did. Go on, Doofus.
Right, I can use the knowledge of. Right, I also can use the knowledge of perspective, as stated just now, to create a 3D renderer that can render 3D objects to a 2D plane, so that I can see them, what they appear on my monitor. I can look at that 3D representation on a 2D surface through perspective projection. I can also use the knowledge of optics for things like Rayleigh criterion or whatever criterion I want to employ, because there's more than one, to give me some sort of maximum angular resolution. Those two things I can do given the knowledge of perspective and angular resolution that I already have. However, what data has, I can't do that with. I don't have a formula to account for perspective from data. I can't. There isn't.
Yeah, so the formula has been hijacked. Again, the ground appears to rise at a rate of 0.666. Do you understand that? So if the mathematical quantification of perspective has already been exposed in an exponential function as 0.666, then that is the function that's used exponentially to calculate the apparent position of optics you call horizon, which is an optical position due to angular resolution in the Rayleigh criterion, which you can be deduced from 1.22 times 0.000005 divided by 0.005 equals 0. Whatever radians it is, times it by 57.3, you end up with 0.0069. If I take that 0.0069, just round it up to 0.007 for maximum theoretical angular resolution due to the Rayleigh criterion, multiply by that tangent, or sorry, divided by the tangent of 3 miles, I end up with 24,911. So I ended up with using the Rayleigh criterion, I can end up deduce the apparent circumference of the Earth. Interesting. Now, here's the thing with the Rayleigh criterion, the horizon isn't based on physical Earth curve. It's based on an angular limitation of optics. Yet I can deduce the apparent circumference of the path of the sun using the Rayleigh criterion. When we know the apparent junction of the horizon isn't a physical location, it's an apparent position due to optics. So if you want to take a calculation on apparent position and deduce a circumference from it and then claim it's a ball, sure, I can show you how to do that using the Rayleigh criterion. Now, if you want to predict hidden drop using a linear function, I can show you how to do that well. Just add in 5 arc minutes to 8 arc minutes of refraction. Use a calculation to convert it to radians, multiply it over the distance, and what do you have? Maybe a fucking hidden drop that you want to account for refraction, but you want to use an exponential function instead, which is based on perspective, and then claim it's Earth curve. Fuck you, your gig is up.
Right, I didn't get any definition for perspective that I can use for creating a 3D render.
0.666, dude. Times it by the mile of the distance. Do that. You'll get whatever pretend hidden drop that you want on an exponential function hijacking perspective. The ground appears to rise, doesn't actually rise. Like a hallway, you have an apparent convergence much faster than the horizon. Why is that? It's because your eye works off angles of light. Do you understand? So I can show you that your eye is subjected to angles of light, and then undulations due to perspective, like putting my thumb in my eye, can block a building 10 miles away, the bottom of it, very easily. Even if my thumb is a mile away from me, it's still a physical object that light cannot resolve, that any object past it that's larger that's resolvable due to the angle to it, you can see, but you can't see my fucking thumb blocking the bottom of it, can you, a mile away? That's how stupid you guys are.
Because your thumb's the actual physical obstruction.
Calling.
Right,
but that's how dumb you are.
If my thumb can block,
if my thumb can block out a car, why can't it block out a 150-foot building a mile away? Why can't it? It's a physical obstruction, is it not?
What?
Yeah, nobody says that it can't. However, there's specifics to geometric situations. So if I'm, for instance, a
geometric situations. What specifics to the geometric situation?
Data, he was about to answer you, Data.
If I am a 6-foot observer and I have a 6-foot wave in front of me, any distant object, no matter how far it is away, I cannot possibly geometrically have more than 6 feet of that distant object obscured.
Okay, again, buddy. That 6-foot wave that's 1 mile, 2 mile, 3 mile apart from you will still appear to converge into a neutral point. It's an optical effect based on light. It isn't actually fucking happening, right? So if it isn't happening, there has to be an optical understanding of what's going on. It's called an optical illusion. So objects that are blocked bottom up, it's an optical illusion.
Come on, Joe. Fine. Just pretend that I didn't say what I said.
Earth curve, it's an optical illusion.
Right.
That's creepy.
So in the meantime, don't address what I said. Got it.
I addressed perfectly. You don't have an argument. The fact is that a thumb can block out a 6-foot car 26 meters away. That means that if my thumb is also 26 meters away, it can block an object bigger behind it, but I can't see my thumb. Definitely, I can't see the fucking thumb a mile away, but that thumb there is still going to block the bottom of a building a mile past it. So you guys are just so stupid. It's terrible. It's terrible. Dude, can my thumb block out a car in front of my face? Yes, it can. So that means if it can block it there 26 meters away, then 1,000 meters away, the thumb can still do the same thing to a larger object past that. So which point are you claiming that it's
where a 6-foot obstruction and a 6-foot observer where you're on a flat surface, verified flat surface, where you can obscure more than 6 feet of an object behind it.
Okay, so you want to try a practical demonstration for yourself then? Then take a camera, lay it on a flat surface, and put objects in front of it and move it away. You'll see an apparent effect happening, which is you'll see objects that are far apart from each other appear to converge in a foreshortening manner. How are they doing that? That's optical, right? That's because light is squishing the information, right? Due to a foreshortening effect, because it's optical. It's not really happening. So if you see that effect increase the farther it goes, you know it's not really happening, but what's causing it? Oh, it's called light. Light, buddy. Yeah, light. Light is perspective and how it works. So if you're not going to acknowledge that light and objects in the foreground can block out objects in the background, and you have an apparent illusion called the apparent rising, which is not actually rising, right? Like in a hallway. If you add in all of those effects, it's very easy to see how the undulations can foreshorten to the foreground, rise up to the neutral point, and block any object larger than it beyond it. You can demonstrate this for yourself. It's a pathetic argument. It has to stop. You're lying to people about optics. And you're a tiny little turd claiming you can measure dip or drop 3 miles away.
Enough.
There you go again, Dad.
Don't. Enough with it, buddy. Seriously.
I would suggest that Dad get out his pencil and paper and show us an orthographic view of what he's talking about.
I've already done videos for you, Left Lane. I don't know if you've seen them, but I'll give you something to try. Okay, here's a foreshortening effect that you can understand. Okay, take a camera, lay it on the ground, grab a piece of tape, and make a T mark on the ground with a piece of tape. And then what I want you to do is raise the camera and lower the camera, and you'll see a foreshortening effect to the tape. In other words, the tape will change width and size. It doesn't actually change width and size, but it appears to. Why? Based on light.
That says nothing about obstruction.
So that's just an example to understand how light will appear to reduce size. Now, if you take structures, it does the same thing, Left Lane. Whether it's vertical or horizontal, the effect is still the same. You'll always have a foreshortening. The subtended angles of light appear to compress and make objects look like they're joining each other, which also causes distortion, all kinds of optical effects, which cannot accurately be, well, you can, to some degree, you can, depending on the quality of the lens, you can do some type of pixel measurements to get an approximate. But even still, depending on where you're measuring a building, what lens is used, you cannot get a proper pixel ratio. So anytime you are looking at all this information, you are analyzing an optical effect. They're not. It's not reality, dude.
Okay. Anyway, we understand how perspective works. All right. You don't understand.
Okay. So what causes the ground to rise? What causes the ground to rise? Is the ground really rising, or is it light causing the ground to rise?
I think Brenda was actually speaking, please.
Brenda, what?
Oh, sorry.
Are you fucking serious?
You sound exactly like her.
Well, I know Raki is silent, so I must be telling the truth.
Anyway, so what I was saying was, before I was, called Brenda, not that that's an insult. I'm just saying, like, I'm not Brenda, I'm fucking Arma. Anyway, yeah, I mean, yeah, the ground rises, at least, to eye level appears to do so anyway, yeah, because it's an angle. I mean, the angle that you make.
What causes that? What causes that? Earth curvature or your eyesight?
Perspective. It's perspective.
So not Earth curve then.
What?
So not Earth curve, right?
Why Earth curve? Okay, first off, Earth curve wouldn't rise. Okay, on it, like doesn't make any sense. All right, perspective though would
make any sense. Can you show me an Earth curvature calculator that doesn't have the ground appear to any Earth curvature calculator doesn't have the ground appearing to rise?
Bacon. I mean,
So-
not bacon. I mean, Data. You got to let him finish.
Yeah. So, Data, the reason why I'm saying that is because I'm saying, okay. So, what was the question again? You said why is it rising or some shit?
I'm done with this guy. You guys can
No,
have
because you literally said Earth. So what is that's not Earth curve or something like that. You're somehow equating Earth, saying
Dude,
that
I hope
on my model
Facebook's
Earth
paying you
curve
good.
should rise up
I
or
hope
something. That
Facebook's
doesn't make any
paying you
sense.
good. Buy some XRP with your Facebook money.
You just worded it weird. Like there wasn't a proper argument there. All right, but anyway, yeah, we would also expect on a ball Earth for the horizon to rise more or less to eye level because of perspective. Once again, all right, you make an angle to the surface, whatever, and you find that it's going to it's going to rise. I mean, I could show you this orthographic. I'm not really good with words, but I could show you orthographic or whatever, side view, whatever. That the angle would make it appear to rise more or less eye level.
Yeah, what causes that again? Perspective, right? Which is optics, not Earth curve. Thanks.
Where does the Earth curve come into this? Like, I don't.
Oh, it's his red herring. He doesn't know how to answer that.
I think
it's a red herring. Look at your Earth curvature calculators, and you guys have an arc in there.
No one's talking about Earth curvature. We're talking about your distorted understanding of perspective.
Which means there's a hump rising in between the two observers on your model.
No, there's no elevation change between the two observers.
There's an elevation change to the land.
No.
It doesn't hump up then?
Sides are the same.
No.
But there's a drop. Is there a hump or a drop? Which is it?
There's no elevation change.
There's a hump or a drop, right? From the linear, right? There's a measurable linear drop. You can measure that drop, correct? That's what your claim is. So does it not necessarily? Okay.
Yes, Jaron showed that you can measure the drop and see it.
Oh, so it's a drop. So that means there's a hump.
No, there's no hump.
There's no hump. How do you get the drop?
Is there a difference between a hump and a drop?
It's a double drop hump. That a double drop hump.
Yeah, just a contrarian.
There's two different humps, SE, for the two observers looking at each other. There's two different humps.
No, you're just misunderstanding. You're just misunderstanding.
Make a hump.
No, you're just misunderstanding the model.
Oh, that's great. So, what in your model? What makes the ground appear to rise up?
The ground doesn't rise up.
Right on. So it's flat Earth, right?
No, that doesn't follow.
Oh, it isn't. Okay, right. So if it doesn't rise up, there's no curve. What's going on, dude, in your mind?
What do you mean rise? What do you mean with rise up?
What do you mean? What do I mean with rise up? In your model, you have a arc, which means from the observer standing on it, the ground appears to rise up to the ground appears to arc up into the horizon in your model.
What? Arc up?
No. The
you
horizon
have a
appears to
curve.
rise because of perspective. All right.
Yeah. What causes perspective? Earth curvature or your eyesight?
What? That doesn't make any sense.
So when you look at objects in the distance, are they actually squishing and changing size?
No.
So it's not Earth causing it then. Earth
No
isn't
one's
doing
ever-
it, is it?
How are
Earth
you
isn't
equating-
changing.
when is
Earth
Earth
isn't
current into
changing and
this?
morphing size, is it? Earth isn't changing and morphing size now. Come on, right?
Does no one see
Arma,
this?
keep in mind that he thinks that there's only one possible variable. That if there is something, then
here's
it can't
the
be
main
something
variable.
else.
Here's the main variable. How do I get a horizontal surface if it's not horizontal?
A horizontal is perpendicular to your local vertical.
Right on, which is 90 degree, right?
Yeah, your local plumb where you are.
So
And then
two observers looking at each other 3 miles apart
excuse
have
me,
290
flat
degrees.
Earth?
Their
Flat
units
Earth?
don't diverge, right?
Flat Earth. Excuse me. Please don't interrupt me while I'm trying to
data. Just say data, buddy.
data. Please
That's
don't
pretty rich.
interrupt.
You're the number one interrupter, bro.
No, I'm asking him not to interrupt me in mid-sentence when I'm trying to answer his questions. He's asking me questions. I get halfway through the sentence, and he's
Brenda,
already
how are
asking
you?
me.
How are you doing, Brenda?
Just excuse
Change the
me.
subject. How are you doing, Brenda? How are you
Stop
doing?
it. Stop it.
How are you
Stop
doing, Brenda?
interrupting.
How are you doing?
Data.
Stop it.
Instead of whining.
Data, please, I do not want to give you a warning, Data.
Right. Okay. So a perpendicular is a local, right? You construct a vertical where you are using a plumb bob. That would be one way, and then from that you take 90 degrees. That's your local horizontal, and from that horizontal, the Earth drops away at 9.8. I can't remember the number. At what is it, 8 inches per mile? 8 inches per mile or something like that.
A horizontal surface from a curved surface.
Somewhat close to that.
Yeah,
Brenda, can
it's
I get a horizontal
perpendicular.
surface from a curved surface? Can I do that?
You get a horizontal from the vertical, not from the curvature.
Oh, so I get the vertical is 90 degree to the
No, the
horizontal,
vertical.
and that's just a local 1-point position that you want to reference, right? So if I'm trying to triangulate or find an intersection point, do I apply that method at 3 different locations?
Right. So a vertical is where
Brenda, you localized it to 1-point position. If I did it if I wanted to find an intersect point of where I was located, would I do that exactly the same process at 2 other locations? And if I did do that, I'd have 3 locations using 90-degree angles, zeniths, claiming to your vertical getting horizontal. That means that all my radiuses would be equal in altitude, and all my circles would be equal in altitude, correct? Because that's what the math would show, right, Brenda?
I deafened myself because you interrupted me.
Oh, don't answer. That's fine. Everybody else heard it.
What do you think that a circle of equal altitude is?
Brenda.
So you're going to ignore what I just stated too and ask a question? Noted.
You just leave?
You have 3 points.
Anyway, piece of advice, Brenda. Like, if you don't want people to interrupt you, try not to interrupt other people.
I didn't interrupt him.
I'm just giving you some advice. I'm not trying to argue with you.
Yeah, I didn't interrupt him. He interrupted me.
Okay, then don't take the advice and just keep doing it.
I didn't interrupt him.
Okay.
And you should say what which it says, not what
Mo Man, I can't hear you. I don't know if other people can, but I can't.
No, you're really
Yeah,
low now.
yeah, a little low. Yeah. Okay. I guess we're waiting on Moment right now, or
You guys ever just gonna let the globe lie go, man?
Well, what part of the model don't you understand, Witsit?
I certainly understand it's typically better than their proponents.
Do you think there's a hump?
Yeah, in layman terms, sure, why not?
Yeah, there's no hump. So you don't understand it. You don't understand it. No, there's no hump.
Would the hump be the sagitta, Brenda?
No, the hump would
be... Could we just change adjectives here instead of hump? We'll just say sagitta. Would that be a good word to correlate the you know, or describe or communicate, you know, what we mean? Hump and sagitta being the same thing.
I would agree with that.
Yeah, so all the globers agree it's just
as,
semantical nonsense.
The only time you should use hump is in the colloquial way of saying sagitta. That is my opinion.
Well, I like saying hump.
Layman. I said layman. I said yes in layman.
Yeah.
A hump
I like to
implies
say the word hump because you guys actually think of 2 observers 3 miles apart looking at each other. There's actually a hump between them. It's priceless.
There's no hump. There's no hump between them. Because when you say hump, what that implies is a change in elevation. There is no change in elevation between the 2 observers. They're at the same elevation.
So they wouldn't be, Brenda, if we applied your first principle, which is to have a vertical to the horizontal. It would show that there is indeed a hump. That's how you would get a drop. Do you understand that?
That didn't make any sense at all. You have no understanding
Your
of
argument was to get your horizontal, you only need a vertical, right? You know, perpendicular, and therefore you get your horizontal. You don't need a horizontal to get a horizontal as long as you have the vertical. That's what you said. Well, if that's the case, then using your own analyze, method of reality here, that there would indeed be a sagitta 3 miles away between 2 observers. You just said there isn't. Could you explain?
Let me ask you a question. I'm going to explain by means of a question. So if I'm standing right, let's see, on the shore in England, in London, England, and another person is standing on the shore on New York, right? They are at both the same elevation, which is sea level, which is 0. Nevertheless, there is a sagitta between them because the Earth curves, but they're at the same elevation.
So it's a hump. It's a hump. Got it.
No, there's a sagitta is straight line through the
Every
Earth.
time you say Sagittari, I hear hump because it's the same word. We already agree upon
No,
it,
it's not
right?
the
So I'm
same
just
It's
word.
colloquial. It's
That's
colloquial.
not
It's
the
just
same word.
semantics. Brenda,
A
you looked into it.
sagitta,
We've already agreed upon that it's described and translated and can be communicated
they're
as
not
hump.
the same. They're not the same. A sagitta, right, is a line connecting the midpoint of a line with an
Sagitta
arc.
is a word to explain a calculation for the rise along the chord. So it's just an adjective. Again, the hump clearly describes that there is a bulge due to Earth curve between two observers. That is what's causing the obstruction in your model. To continuously deny this or sort of beat around this bush, Brenda, just sort of asinine. Would you like to explain what I said earlier, Brenda?
The problem is we say you are allowed to use the word hump as long as you're referring to the sagitta, and then you agree, and then you use the word hump to mean not the sagitta. That is the problem we're having right now.
So here's the thing: the sagitta is the word that understands the calculation of the chord, which is essentially the hidden or the drop. Which is what causes the hidden or the drop is the hump, because that's what's obscuring the object. So, this is basically a bullshit conversation at this point. Let's go back to actually, Brendan. Would you want to answer the question?
No, hold on. You said that what causes the drop is the sagitta.
Give me a break,
That
guys.
is
You
incorrect.
guys already agreed that the hump is the sagitta, right? So it's all
Are
good.
you gonna let me finish?
No, it's a waste of time. Move on.
No, you're gonna let him finish.
Exactly, you are. Go,
I was gonna
Gummy.
say what causes quote unquote drop isn't the sagitta, it is the angle of the tangent compared to the angle of the ground curving away. That is all it does. That is the reason for drop. The sagitta is merely a result of drawing a chord line between two positions on a sphere.
So if I
You
look
can't
horizontal, there's
conflate
going to be a physical hump blocking me.
No, that if you look horizontal, there is no such thing as a hump. There is only such a thing as drop.
Yeah, if you look
the way we
horizontal,
use that.
you'd be looking eventually out into space.
No,
Exactly.
you get blocked by the air.
The only time you get this so-called hump or the sagitta would be if you manage to point your eyes through Earth to the exact position of them, which normally we don't. We look along the horizon, which is why there usually isn't a hump for your personal perspective.
Clarify this. You just said that a line to the tangent is what causes the hump, right?
No,
you're drawing mathematics with a presupposition.
He didn't say that. He didn't say that.
Yeah, he just said that. Go back and
No,
listen.
he just said he didn't say that.
He just said that. He actually just said
No,
that like 2 minutes ago.
But Data, he just said he did not say that. And then you continued to talk instead of listening.
Oh, this is so. You
try to
guys
listen.
just like to argue. It's so lame.
Yeah, dude. Here's the thing. You're going to deduce a hump or a sagitta from a tangent. That's what the claim is. That's how you get a measurement.
No.
Oh, that's how you get a measurement. So how do you get a measurement?
Correct.
You don't get a tangent?
No. So what I'm saying is, whenever we talk about the tangent, we literally never talk about a hump, because the hump is never relative to a tangent. It is only relative to a chord. That's why when you use the word tangent, you already are not allowed to use the word sagitta or hump.
No, that's not true. So a tangent line is just your begging the question of a horizon line due to the physical boundaries of a sphere. That's your adjacent or your linear calculation that you use to show that there is drop, right? But again, it's a trigonometric function over a presupposition that the hidden is caused by Earth curvature. We know that trigonometry is wrong because the supposition in this calculation is that it's due to physical Earth curve, hence why you're drawing a circle. But that's not the reality now, is it?
Data, let's try what we do agree on. Okay? How about that?
That's a short list.
Well, what we do agree on is that there is a chord, right? And the sagitta is the midpoint of that chord, correct?
Okay, so the supposition you're going to have, or presupposition, is going to be the radius of that circle to get a chord length, so you can calculate the sagitta.
Small steps. Small steps.
Can I ask Gummy Bear a question?
Well, I was trying to work with Data. We agree on there's a chord between these two different observers on the Earth, correct, Data?
It's irrelevant at this point because you're still begging the question that you're dealing with a physical boundaries. You just overlooked what I said to you. First, prove that it's a physical nature due to Earth curve, and you don't do that. What you do is you show mathematics based on a model of a ball rather than an optical effect. So your premise is incorrect. It doesn't account for reality because there's nothing squishing or changing, or there's not actually any physical horizon line. Due to Earth ball, it's just the optical limitation of our eyesight.
No, I'm just trying to work with him on what we know to calm things down. And
we know that there is no radius of
Okay.
3,959 miles. I can do a test myself, even using the calculation for the ball model in adding in refraction. So let's say I have 1 foot observer height, and I use the 1.32, not the 1.22, but the 1.32 as added refraction, like I've seen in many papers. So when you use that calculation, you still have an apparent position for a ball radius, claiming that if you're going to look at this calculation, you have to understand it is to do with Earth curvature, nothing to do with optics. That's the mistranslation and the misconception here when you're reading the formulation, is understanding the implication of why it's calculated the way it's calculated and how it represents itself in discussion. When we're talking like this, you're claiming that this demonstration is showing physicality due to a shape. And we're saying, no, this mathematics will show that this is an angular limitation and you have refraction of light, which has the apparent effect, and then added in exponential calculation due to perspective, right? Which is not discussed, not analyzed in the mathematics or formulations. It's ignored and rebuked with strawmans, red herrings, and sophistry.
Yeah, let's let Crypto go.
Yeah, can I just I just want to ask Gummy Bear a question if he's still there.
Yeah, sure.
Because I feel like we can come to a point of understanding, but obviously you don't like the word hump, so let's go in a different direction. If I'm standing at a river and I'm looking at a building, and the half of the building, according to you guys, this isn't my idea, this is your idea. If half of the building is obscured by water, how do you describe what that water is doing?
Well, what the water is doing is just remaining at its level. The water isn't doing anything.
Okay, but how do you describe that water?
I'd say that it's level, but then I'd have to describe what level is, and level is a curved surface. It's equidistant from the center of a sphere.
Okay, so can you describe that in a single word? Is it like a hill of water?
Level. One word, level.
It's level water. That's what I'm saying.
Level.
Oh, so that's the level that's blocking the buildings. That's how we should say it.
Okay.
If you wanna talk about what's blocking the building, it would be the obstruction due to the curvature of Earth. If you want to do so in words.
So a hump.
Yeah, there's no hump. And
Like,
level is the adjective, not the noun.
Humpty Hump.
So it would only.
Okay. Anyway, about 15 minutes saying that hump wasn't the right word, and now we don't have a word to replace it with. That's what I'm getting frustrated by. Give us a
we
word.
did. We had sagitta.
Why do you need just one word? Why do you insist on just using one word?
Because we like
so you can just say, here's
I
the
always
one
think
word.
of SD Montreal when I hear the word hump, and it brings me back to how stupid it is.
Crypto was
is it a hump or is it a drop?
Please, Crypto was trying to have a conversation.
The one word is Earth.
Sorry, go on.
The one word is Earth. It's obstructed by Earth. You don't have to say hump. You don't have to say sagitta. It's obstructed by Earth. That's all you need to say.
Wow.
So the bottom of that building is obstructed by an earth of water. Okay, cool.
Do you guys see the image that Moon Gazing posted in text?
I don't see how it's hard. I mean, I think I could explain it to a 6-year-old, the hump and drop difference, and they would understand it. I don't see how it's so hard.
I don't think it's hard. I think it's that you guys are rejecting words on a very arbitrary, asinine basis.
How? Which words do we reject?
Hump.
Hump, obviously.
Hump. Okay, what
Well,
do you mean with the hump?
No, hold on, because you say that we do it on an arbitrary basis, but we give you exactly why hump is the wrong word to you. and then you say it's arbitrary.
You say it's curving water. Whether it's, I mean, it doesn't matter really what you call it, but you've told me that I can use an earth of water. I think that sounds ridiculous, but we can call it an earth of water.
Crypto, do you see the image that Moon Gazing posted?
No, I'm driving.
Do you see that image? I couldn't hear you.
No, because I'm driving. I'm not going to look at the chat.
Oh, okay. Well, that is
if there's a hill, if there's a mountain on the globe, would that be a hump?
Wow, you guys look ridiculous, man. That picture right there. That's what you are.
No, but
dude,
if there's a mountain on a globe,
what
is
you
that a
are
hump?
arguing. That's what you are arguing with it. You are arguing that nipple on the sphere is what you are talking about. We are not.
You feel smart right now.
So would a mountain be a hump on a globe, according to the flat earthers here?
It would be a mountain, wouldn't it? Hence the why you have an adjective or a noun to describe it.
Okay, then there's curvature, so no hump.
So would there be a difference? The question you should be asking, is there a difference between hump and a mountain?
Sure,
what is the inference of a mountain versus a hump in the context of what our discussion is? Or is it a blatant obfuscation and a non sequitur, your argument?
Time waster?
Mountain is a hump on a sphere.
Big hump. Any time wasting?
It's a hump on a sphere, isn't it? It's a mountain on a sphere, right?
Yeah, you guys.
It's a hump. Would it be described as a hump? Would it be described as a mountain?
But okay,
sure.
so what we're
Just like curvature would be described as curvature, not a hump.
Okay, whatever. This is
the point we're making.
Bad
is
your argument is.
Yeah,
a mountain is a hump. Therefore, if we say hump, is it a mountain or earth curve? Is that what you mean, guys? Like, come on, man.
I'm showing you how fucking stupid this argument is.
You will never see.
You're the one. This is your argument, buddy.
I could explain this. I could explain this. I could explain this to a 3-year-old and they would get it.
You don't need to be talking.
Can a mountain block the bottom of a boat, or does the mountain already block a boat?
It's pointless to talk about this.
Man.
I told you to change this hump conversation 5 minutes ago.
You know, it's almost like they're deliberately avoiding it because they know that what they're saying is bullshit.
Time wasting.
Stop self-projecting, buddy.
Yeah, it's just
that's all it is.
Time waste.
They're just wasting time. Look at the smile. Look at the smile in their speech. They have a smile in their speech when they do it.
Whatever.
Well, that's what I'm saying. They come in here. They come in here because this gives them some like. This is a guess, okay, but it's like this. It's like this meaning. It's like this. It's like this purpose they think they get out of it. So it's just purely contrarian
because we're the ones who make YouTube videos and go around the USA preaching about this. Yeah, that's us.
Why are you so triggered about what I do, though? That's my point. You literally just made my point. You made my point.
How about we all move on from this talk?
You just made my point. So anyway.
Yeah, I'll gladly take a win in your loss. Yep, no problem.
Well, sure, if you think you can change anything in reality, then sure.
Hey, call it whatever you want to. There has to be a physical obstruction, and in layman terms, you could call it a hump.
Like just what I'm saying. Yeah. So what I'm saying is the only time we will accept you saying that there's a hump is if you're talking about the chord. We don't see using chords, therefore you should never be seeing a hump. That is what we're saying.
If I walk up to a hill of dirt, can I see through it to the other side?
Is that hard to understand with it? Is that difficult to understand?
Why do you always ask me about my comprehension when you're clearly the one that lacked in that field?
Because I summarized it very simply for you, and then you asked a question that was already answered through my summarization.
Oh my God, I just made a point that colloquially using the word hump is perfectly acceptable. You guys are contrarian psychopaths. Therefore, you've gone into 10 minutes of semantical bullshit.
You're a mod, and you're calling them...
You're allowed to use the word hump to refer to a hump of dirt, for example. But if you want to refer the surface of Earth as being a hump, the only time I personally will allow that or agree with you is if you're talking about in relation to the chord and therefore talking about the sagitta. That is the only time I will agree with you that calling the curvature of Earth a hump. Any other time, only use it for a hump of dirt or so on.
No flat earthers saying that there's a hump in addition to the convexity of the presupposed sphere. And everyone knows that, so this has been semantical bullshit for 10 minutes. Now we're going to move on because it's very, very dumb.
Okay, thank you.
You're welcome.
Just to show how dumb it is, I just had to do a quick lexico search from the Oxford Lexicon Dictionary, and it says that the hump definition, first one, is a rounded raised mass of earth or land. So in the classification of hump in the context of our conversation, it's regarding the obstruction of objects in the distance, and the cause in your model is a hump.
Well, no, because you just said that the definition was great. Because he just said the definition. Let me answer. Your definition was
rounded raised mass of earth or land, right? There you go.
Hold on, Gummy Bear.
You're gonna let me finish. So
I'm not
you said
Gummy Bear
a
data.
rounded raised mass of Earth. Yeah, as in it has an elevation change, which is what we were pointing back to. Earth's surface does not. Therefore, it is not a hump by your own current definition that you just used.
As objects reach a point of the horizon, they're in your own model, it shows that there is an arc. And that arc from the observer shows that there is a hidden surface that is blocking the bottoms in your drawing. If you want to use the chord to calculate that hump, you can call it a sagitta. And in this case, you are claiming that it's earth curvature, which is a hump of water or a hump of land in between the two observers blocking the or obstructing the observation.
So,
this is what's classified. This is what's classified. This is what's classified in your earth curvature calculators, and apparently you can calculate this hidden drop based solely on a parameter of a ball and nothing to do with optics.
Okay, so you just used the word the hump of water, and you previously used your definition of a rounded raised of mass of Earth.
Correct.
How
So
does
if
that?
you're-
How
if
does
you're-
a hump of water?
Okay, so in your mind, just in curiosity, in your mind, when you look at when you're looking at an object between two observers, the ground doesn't rise as you agreed upon, correct? The ground doesn't rise.
Sorry. I asked a question, and you're talking about something different now. All of a sudden.
No, we're talking exactly about this hump. Okay, we're talking about the sagitta, the calculation using the chord. We're talking exactly that.
Okay.
I asked you again what causes the ground to rise. You agreed that the ground doesn't really rise, or that might have been Brenda that said that, right? Which means it's flat. There's no.
So my question.
Hold on, let me finish. So there's no apparent effect of the ground. It's only optical. In other words, the horizon is not an effect of rising. And according to your model, you're looking down at the horizon, right? So if you're looking down at the horizon, that means the ground isn't parallel to the 90-degree line of sight, right? It means there's some type of arcing or drop away from it, right? Correct?
Yes, and for a 6-foot observer, it drops 0.04 degrees from perfect eye level.
Take 0.04, divide it by 60, divide it by 57.3, and you end up with the radian value, and then times it by the distance, and you get the apparent maybe 5.5 feet or something. Very similar effect. If you just conflate the idea that one is for refraction and one is for earth curve, it's very similar. But again, a linear function for an exponential function due to the optical effect of light. It seems to be that the 1 over distance squared, the intensity of light, plays in a factor here, because everything we see comes from light. So if we're going to have an effect of light, you can't conflate trigonometry effect for an actual physical boundary when it's an optical effect. Stop doing it, guys.
And can you stop using the wrong words like hump?
Can I ask we're gonna move on from
you
the
already-
hump, man. Oh
You
my
you
God.
agreed that the ground doesn't rise, right? So it's either parallel to the 90 degree or it's looking down. So if it's looking down, that means the ground is either arcing away from you or doing something. This is your own model.
So if
Right.
I can clarify this time before you keep talking, I would say that the ground doesn't rise in relation to level. The Earth does rise in relation to the chord, which is why I allow you to use the word hump for the sagitta. It does not rise in relation. Let me finish. There's one last sentence.
The rising of the ground is due to the chord? I don't understand the
No,
logic.
this was my turn to finish. Okay. The last statement was it does not rise in respect to your vision, which usually is along the horizon or along a tangent. So it only rises when you in respect to the chord. That's why I allow you to use the word there, nowhere else.
It's very nice that Gummy Bear is allowing use words. I want to ask Karma a
First of all,
question.
I'm going to say hump all day long because that's what you claim Earth curvature is doing. It's causing a hump, obstructing the bottom, and then I'm gonna for sure always reiterate the fact that your trigonometric functions of Earth curvature are done on the supposition that it's physical boundaries and not optical, and also conflating a linear function for an exponential function and arguing the two. What are you gonna say when your 1.22 for your 1 foot observer height doesn't match observable reality? What are you going to conflate your model as next? A radius of 5,000 or 500,000 miles?
So when you say that we conflate a linear function for an exponential function, what exactly are you referring to?
So it appears that when I look at all of the calculations, like for instance, if I take a demonstration of a camera on a flat surface, like a hardwood floor, massive hardwood gymnasium floor, let's say Olympic-sized gymnasium floor, if I lay objects along that floor, there'll be these optic effects where you'll have objects appear to converge on top of one of each other due to foreshortening effects, which is just an optical due to the nature of the lens and telephoto lens and refraction of light, right? You'll have this squishing effect happen. There's no other word to describe it. It essentially compresses a linear function, and the way it does it isn't linear. It looks like it does it in an exponential. In other words, the distance between these two objects as they move away, the farther away they are, the more they compress faster together. In other words, in other words, you have this effect with light that seems to increase exponentially over the distance. So, which is 1 over the distance squared is the intensity of light, which ironically is the same as the 8 inches. If you use the 8 inch per mile squared or the 666 feet, and use that as an exponential function, you can get, but it only works on an apparent position of the eye. It doesn't work. That's why you can use other optic lenses, long telephoto lenses, to show that the mathematics don't work compared to the human eyes, because the human eye has a 28 millimeter to 50 millimeter focal view, and when you use a camera, you end up using 2,000 millimeters, let's say, or whatever, like high optical zoom, which you reduce your angle, but you open that diffraction point. You open all those angular limitations due to the focal length of the human eye versus the telephoto lens, right? So you have an amazing tool to show you that diffraction points, refraction limitations are optical effects, and apparent positions change if you change these focal lengths, and that's what's evident in reality, and that's not calculated for in any of your curvature models. None of it.
Okay.
I would
now,
like to see that.
When it comes to this effect that you're talking about, that is not linear, it's more like exponential, but not really. The answer is it's neither. It's trigonometric. That's how vision works.
Well, you can use
quite
calculus,
simple.
yeah. So calculus, apparently, for the infinitesimal, right? Calculus is one tool used with trigonometry to help find curve functions in smaller spaces, right? So yeah, they come up with other, like the Bessel equation, which derived the 1.22, 2.56, 3.56 from visible light, right? I think it was going through a tube, and you would have a first minimum and a maximum where that light would reach down the length of the tube, and through this functionality you could devise this, because it's based on the size of an aperture too, right? So a certain aperture size, you have a certain linear function of light, but you add in refraction, now you have an exponential function of light. That's why, for instance, if you just use linear functions in calculating drop, you can do so by assuming that light is going to, let's say over 10 miles, you have 5 arc minutes of refraction. If you break that down, times that over the distance using feet, let's say, whatever meters you want, you'll find that there's a similarity to the assumption of refraction and this exponential function of x squared, which is whatever, 8 inches miles squared, right? There's a very good similarity there. And if you understand one is based on refraction and one is a linear function, then you're like, oh, I understand. This is an optical effect with refraction, and we're going to use an exponential function that works at a certain rate, but at a certain height it doesn't work. And this is proven using other optics.
I mean, dude, we have to really be realistic here. You're talking to people that like believed every story they told them for the last 2 years. You know what I'm saying? Like, you have to kind of have a bigger scope of it. Like, dude,
Excuse me, is a mod ad homing right now?
no. So you can stop with your virtue signaling here. I'm not ad homing anyone. I'm saying that people that, and there's no particular person named here, but people that just believe what they're told, man, they're not gonna ever like try to step outside of it to re-examine. They're gonna have to make the
Not
personal.
believing what you're told. It's
You have
understanding.
dude. I think my voice just really triggers you, dude. I guess
No, it's just what you say.
you just always interrupt so much, man.
Well, keep in mind, if we're talking about reinvestigating things that we've learned, for instance, I've independently verified that whenever I induce a density gradient such that the highest density is below, light always bends downward and distant objects always appear higher. That's not believing what story I'm told. That's believing something that I've personally tested.
The reality
and
is
then you have to
light bends towards the denser medium. That's
and then you
what
have to
happens.
believe someone that.
Okay, so my bigger point was
you have to believe someone that. Oh my god.
Sorry, go ahead. You went out.
Bad. My mic's fucked up. Go ahead.
No, you go. You got it.
Yeah, and then you have to believe someone when they tell you that something's appearing higher than an actual position when they don't have an actual position. That's just dumb if you believe that shit. We can do this shit all day, doofus, if you want.
Right, but what you're saying is that gradient index optics is not something we know about.
That's not what I'm saying at all.
What I'm saying is I'm not going to believe someone that tells me something's higher or lower than an actual position when they don't know the fucking actual position. That's just stupid. Let's do that again.
Yes, we can continue to do we can continue to do this dance where you reject gradient index optics. Yes, you can keep doing that.
What I'm doing is I'm rejecting somebody telling me something's higher or lower than an actual position when they don't know the actual fucking position. That would be stupid and dumb, and anyone that falls for that shit is a straight sucker.
Nice opinion. However, when we do have light bending downward and distant objects appearing higher, I know that when light bends downward, distant objects will appear higher. That's a fact.
In the meantime, in the atmosphere over long. In the meantime, in the atmosphere over long distance, when somebody tries to tell me that something's higher or lower than an actual position, they don't know the actual position. That's just dumb. I don't know who's falling for that goofy shit.
So everybody who knows optics is falling for it, according to you.
No, they just have another conflation for the concept of optics and what it does. The reality is it's all happening behind the human eye, and none of it is taking place on the physical nature of the Earth. The only thing that is evidently true is the horizontal surface of which palm we live, and all the angles of elevations that are deduced from that position. That's reality.
It's not horizontal. All right, so if I induce a density gradient such that the highest density is below, and light goes through that and curves in a downward path, and distant objects appear higher through it, what am I conflating?
So again, you're looking at optical effects, nothing to do with the shape of the Earth.
Oh, so optics, right? The way that we see light?
Optical effects.
So basic optics principles. Basic optics principles. Yeah.
Illusions, bud. Illusions.
It's an illusion. The light is definitely taking a different path.
They're all illusions. There's really actually nothing going on. It's all happening inside the human eye, brah. Your bullshit isn't secret.
When I induce a gradient in front of my vision, that's not happening inside my human eye.
So when you observe a medium change and you observe light transversing through this medium change, you'll see an optical effect, right? Now, it is physically interacting with the environment because it is a density difference between where it's at and where it's going. It has nothing to do with the shape of the Earth. It is an optical effect.
Cool. So optics is now a useful tool. We can use that to determine.
Cool. Tell me how it has to do with the shape of the Earth, doofus.
This is not a useful thing, and now
Tell
we can
me
use it
how
to
it has to
determine
do with the shape of the
optics
Earth,
is
Please
doofus.
stop
a
interrupting.
useful
Yo,
optics
why are
is
we
now
talking
a
all
useful
over each
thing.
other, guys? Relax.
Right. If he could stop talking over me while I'm talking, that would be great. So optics is now a useful thing. We can use it to determine how it is that we see things in the distance. We can verify using the measurements of the atmosphere what light is going to do through that, right?
You can approximate. Yes. But there are, of course, errors, my friend. Now, are you talking about a general application of understanding this? Are we using modern technology? What are you going to apply in your thought process? Because at the end of the day, explain to me how light passing through a medium has to do with the shape of the Earth.
How we see things in the distance is very applicable to the shape of the Earth. For instance,
It is
you
now,
mentioned
especially if
a
you
moment
ignore
ago.
optics, right?
For instance,
He
a
wasn't
moment
done.
ago. For instance, a moment ago, you mentioned that there are errors. Can you give me what those errors are?
Yeah, not knowing the actual density gradient over 50 miles, not knowing exactly the actual location of that position of the star. You have to estimate those positions. And then you have all kinds of error calculation corrections that you can do to help pinpoint your position. But again, are we looking old school? Are we using modern technology? Because a lot of the techniques are lost on most individuals because they rely on GPS and other signals, right? Again, what methodology we're going to use here? Because in the practicality of any of these measurements, you need straight lines and angles, which require all points of position to be horizontal between each other to get the first measurements of the first order. Without the first order measurements, you can't calculate the third.
Cool. All that other stuff that you said. Let me
Again, you
address
need
the
first
first.
order
Let me address
measurements.
let me
Without the
address
first order
let me
measurements, you
address
cannot get the third.
Hey,
You listen.
I'm in the middle of talking.
Go ahead, doofus.
All right. The first thing.
Nah, fuck that. Don't yell. Somebody's talking over you. Doesn't mean yell louder. Not what we're doing. I told him that twice today already earlier.
That's fair.
Jeremy, that's what you do all the time.
That
You
is
guys
a
are
good
on one
point.
today.
That is a good point, actually. Jeremy, you do that.
Yeah.
Hey, you guys,
All right.
just calm down.
All right. So now, if we want to talk about measurements of the atmosphere real quick, we can easily do that. Because if you say over 50 miles, we don't know what's going on. Well, it's cool. Actually, 20 feet above ground level or higher, we got a pretty good idea of what's going on up there via measurements of temperature and pressure.
I'm not saying you don't have those calculations now in modern times. Sure, you can quantify them more because of all the data that's in. But at the end of the day, you need first order measurements to calculate them. And that's only possible if you're dealing with a plane surface. Thank you.
No, measuring temperature and pressure doesn't require a plane surface.
You need a first order measurement. Go ahead, tell me how it's done.
Right. We'll get to that part when we finish the actual optics
We'll
topic.
get to
And I
that
know
part. No,
you
no, no.
want to
You're
change. And I know you want.
invoking
You
were doing so good for like 1 minute.
You want.
You're invoking measurements. You're invoking measurements, but yet you can't.
Okay.
I'm still talking
measurements.
here. I'm still in the middle of talking.
I think you both need to take a minute, maybe.
Right.
Please don't
would it be
scream. I
possible?
don't care what I do when I conversation. I need to be modded if I'm arguing with these guys. However, while I'm modding, can't be yelling just louder if somebody overtalks us. We can't do that.
All right.
Well, then maybe he can be muted when he starts over talking me.
Yeah, he's muted right now.
Yeah, just take a deep
All
breath,
right.
man.
Yeah.
All right, let's try this one more time. We can go to the first order measurements of the surface of the Earth topic if we close out the optics topic. That's very cool sounding. Now, when we have the measurements of temperature and pressure of our atmosphere, and we determine what kind of density gradient is present from that data, I can conclusively tell you which direction light's going to bend and which direction things will appear in relative to their positions in the distance. Correct?
Again, another fallacy, and I'll explain how, is because in your own model, the sunset is quantified as an optical illusion. In fact, when you look at the sun, it's not actually at its apparent position. So, which means there is a constant refraction effect that's making the sun happen. That's not quantified mathematically. Is it in your example? What you want to do is use terrestrial refraction over a plane surface, because to do all your calculations, you need a normal. If you don't have a normal between positions, let's say 2 and 3, that are parallel zenith positions, then how do you get a barometric or a proper pressure reading mathematically? Because all first order calculations are all linear measurements. Would you like to show me when or how you calculate curve first order?
Great dodge. That was excellent. Let's try this one more time. Pressure and temperature measurements taken about.
How do you order? How do you measure these? How do you measure this? How do you measure this shit, dude?
Why does it every single time I start talking, you've got to start talking at 2?
I feel your pain. I feel your pain. I'm not just sitting there waiting to mute someone. So give us a chance. We will hear that it's happening, and we'll take care of it, please.
Jeremy, control yourself, please. Can I make a point quickly? I had this conversation with Flat Daddy yesterday. I don't know if you guys were there, but literally the very first thing he said whenever he started talking was a jab at me, and then wanted to continue talking. I would suggest that to both Doofus and to Flat Earth Data, if your first comment is a jab, you're going to be overtalked by the other person. So don't open with a jab. Just make your point.
If you don't if you open with the jab, you sorry, fuck that.
You won't get jab back. That's
I was gonna say if you open with a jab, you're gonna get knocked out. But yeah.
Fuck me.
That was terrible.
Instead of being like, "Oh, you're a dickhead." Anyway, as I was saying, like this isn't work.
Yeah,
Right,
you're
so
like asking them to interrupt you.
Yeah.
So if we're calling into question whether or not the barometric pressure readings can be taken over a plane, whatever, I don't care. If I have a barometer and I have a certain altitude and I take a reading, that doesn't require me to first establish the shape of the Earth. I'm just taking a pressure reading.
All papers that I've ever read, all papers I've ever read, over 10 miles, they assume 5 minutes of arc refraction along the terrestrial plane. If you're viewing a star, you're not going to want to do anything 15 degrees below that apparent position. Although you can, there is some calculations in the nautical almanacs that you can look at, but at the end of the day, you're accounting for bending of light. So if you can tell me the association of this bending of light to do with Earth curvature, when all positions and all measurements are at normals, which are 90-degree perpendiculars to the horizontal at all positions, that would be technically first order measurements. So if you're going to be honest and genuine and you're going to measure over 50 miles, you're not measuring at one location, you're measuring at several locations over those 50 miles. And all of those points of positions are normals. So please show me where it's curvature in your first order when you're doing these measurements.
Right. I get that you still want to drone on about that topic. We can get to that topic when we close out the optics topic. When I go ahead and measure the atmosphere at altitudes above the surface to have a density gradient such that the highest density is below, from that I can make conclusions about what I'm seeing in the distance. If I can see in the distance that objects are dropping away from horizontal that are at my same altitude, then I must conclude that since they should appear higher than their actual position, that there is curvature present.
Yeah, so in your ideologies here, as objects are above a neutral point position, they'll appear to converge down, and objects below that neutral point position will appear to converge up, and that's due to Earth curvature?
Yeah, they won't cross your eye line. Yeah.
I'm not asking you left lane, I'm asking the other guy. That's due to curvature, right? So this apparent effect, it's not actually happening, you're claiming is actually happening then.
If there was no curvature, if everything at your eye level was at your eye level, the same altitude all the way across that surface, the problem we have is that the measurable gradient in our atmosphere would cause distant objects to appear higher, and we observe them lower than horizontal.
Yeah, so that's your begging the question. So I understand light will change its direction based on the medium change. Whether that's high or low, that's irrelevant. It just changes the density. So is it not possible there's an inversion of this due to temperature differential, whether this a hot surface or a cold surface versus a hot air versus a cold air? The inversion would be possible, correct?
I'm specifically in my example that I gave, 20 feet above ground level or higher is what I mentioned specifically.
Sure. So these anomalies change sporadically based on season and time of day, correct?
Not up there. Not when you get away from the surface.
Okay, so they don't change magically. The atmosphere doesn't change conditions. There's no weather changes. There's nothing then. Just all I have to do is go up 20 feet and there's no changes, right?
So
You go up 20 feet, you would have a gradient such that the highest density is below. Whether that gradient changes in strength over time
in your
is irrelevant to the fact that the orientation of that gradient is still the same.
In your mathematics, are you drawing a plane surface or are you drawing an arced surface? In your mathematics.
I'm not using mathematics in this instance.
Oh, so how do you calculate the angle change if you don't have your math? You need a point of pressure, and like you said, pressure and moisture, if you will have an influence on light. That's what you're saying, right? That's why you have to take these measurements.
What I'm doing at this point is entirely qualitative, where if I have a density gradient such that the highest density is below, light will bend downward from its path. It will take a deviation toward the more dense medium.
It will also
that's
just
all
changes
entirely
medium.
qualitative, and that doesn't change based on your opinion.
Again, it just changes on medium change. That's it. So it moves into the denser medium. It pivots position when it enters it encroaches on a denser medium. It will pivot the point of entry. That's how it's described, right? So it's irrelevant of up or down. It's the fundamental is the density difference. So if you have, like I said, an inversion or hot surface and cold air or a cold surface and hot air, you still have the effect because it's not dependent on one direction all the time. It's dependent on the medium change. That's it.
Okay, cool. As I mentioned already, I'm at 20 feet AGL or higher. That's where I'm taking these observations from.
It doesn't matter. What you're doing now is you're changing the optical effect, which is done for whatever reason. If you're looking at internal reflection or refraction, because water itself is reflective properties. So you have this called a critical angle of incidence, which is I think 46.2 degrees or 48.8 degrees. I can't remember which is the critical. Which means, here's an example. So internal reflection, which is an aquarium, if you will. If you look at the edges of an aquarium, you'll see this internal reflection effect. Or if you look below, you'll see this internal reflection effect. So this happens due to the angle position of light passing through at a right angle for the eye to see it. So if you change the position of the angle of the eye, you change the optical effect. So can you already move on to a better argument? You trying to use optical effects as your argument. Again, the apparent position or junction, it's not happening. The only way to get any kind of convergence is you need parallel lines, which means the Earth is flat, parallel. That's how you get convergence.
All right. I have only one question. Why did you add liquid water to an observation in air? That's my question.
Okay, so water and air are associated with each other. They have the same effects when it comes to, or they have relatable effects when it comes to light. In other words, they bend light. So moisture in the air will bend light. Water will bend light. That's a common property derived from water. So I don't understand your position of contention.
All right. What's the refractive index of water vapor? Not liquid water, but water vapor.
They claim that the Earth air is 1.01, basically, which is close to a vacuum. And then they have 1.33, I think, is water, perhaps, or maybe
not liquid water.
So anyway, the point is that you have these quantified effects that require normals. And if you're going to make these measurements, laterally along a plane horizontal surface, they're all going to be parallel zeniths. That's how the math is. That's the first order calculation. So again, spare me your bullshit. Where's the curve?
All right, let me try that one more time. What is the refractive index of water vapor, not liquid water?
Water vapor, I don't know, depending on the volume of it, I'd imagine.
No, it's water vapor. If you have 100% water vapor, right, what is the refractive index of that?
Well, if you have a small amount of it, I'm not certain, but water is 1.33, so water, it'd have to be less than 1.33, but it'd have to be more than 1.01.
It would have to be? Are you sure about that?
Well, air is 1.01. Vapor itself, I know that there's this really cool effect with actually water vapor and light. There's when the process of entropy takes over, you have a upward force and a downward force in effective entropy. So you have this energy exchange causing an effect to light. So the higher energy exchange or the higher exchange of entropy produces this, if you will, heat wave that affects the way light travels through it, right? So if you're asking me for that vapor effect, that density effect, I actually don't. I have to go look at the refractive index to see what vapor would be. But water is 1.33 and air is 1.01, I think.
Would it surprise you to know that the density of water vapor is very slightly less than the general composition of air?
Yeah, so this is the argument when it talks about the cold air versus hot air and the refraction of light. I understand the position, but again, like I said, there's an energy exchange as well. There's a heat wave, if you will. If you look at, for instance, the black swan, you see a heat wave. There's an energy exchange there affecting the wave of light, which means it's all squiggly. So obviously, in that indication, there is a hot and cold factor in between it. That's why you have the waves. Because it's changing from the observer to location, it's changing its path several times, right? And that's why you have the wavy pattern. So you do have these effects even through, like say, a vapor gas, like you say, because theoretically they claim that it's less dense. I understand that argument. I've heard that before. But nonetheless, the effects are visible. It does affect light. So it affects it based on density difference, right? That's evident of that.
I don't know why you answered a yes or no question with 300 words, but I'll go with that you're slightly surprised that water vapor is slightly less dense than air.
I'm not surprised
however,
at all. I've already heard this argument, and I explained to you the black swan is an example of that vapor that you describe, but the effects are still the same. That's why you have the wave, because you can see that as the vapor is exchanging, which is due to energy exchange, entropy. You can see that it's wavy. That's because it's going between hot and cold, which in this particular case, the vapor and the cold air between it is causing the wavy pattern, right? But
that's a nice positive claim you have, that water vapor is the cause of what we see in the black swan, by the way.
That's entropy, dude. That's energy exchange. It's a heat wave. That's all that's what I've said it was from the day one over the surface of the Earth. We've seen them many times. It will change. Just give it like an hour and maybe the heat wave will disappear. It's just a stronger change of entropy, right? Which causes the air to have more turbulence.
There's no energy change there.
Yeah,
of course there is. It's evaporation, right? It's solid gas. It's a solid to a gas, right? That's what's happening before our eyes, and we're seeing that energy exchange.
No, but you don't look through the solid. You look through the gas.
You look through the entropy exchange. Yeah, absolutely. Yeah.
No, but there's no energy change.
Right, you're looking
at
entropy.
It's going from cold to hot, right? So
not.
if you have this. Yes, the hot air is evaporating and going cold. Yeah.
No, there is no updraft there. I didn't know that there is.
When you see that hot air, it's because it's surrounded by cold air, right?
What? How do you see hot air or cold air?
You've never seen a heat wave?
If we're talking about energy exchange, right? If we're talking about energy exchange, with a water vapor is carrying heat away from the body of water.
Yeah, from cold. Well, it's warming up. Then in this case, right? It's having another energy enter it. Rather than energy being released, it's having energy enter it. That's why it turns into a gas, right?
It's taking some of the energy with it, is what it's really doing.
Well, exactly. It's exchanging. right? It has to go from hot to cold. So that hot means there's cold all around it. And then the turbulence that you see is the patchways between hot and cold between the observer, right?
Except it doesn't work out like that. When on an average day, we also have the water evaporating from the surface of a body of water. Like we have that evaporation on days where it doesn't look like the black swan any normal day.
Yeah. Like I said, and you only have these effects on a horizontal surface. No ball Earth will give you these effects. You need normal positions to have any refractive, because you use straight lines and angles in all of the calculations, and all points of position, they're all linear functions. There's no, the first order functions are all linear. If I do 50 miles, I'm not using any spherical first order functions. I'm using first order linear functions.
Let's say you take 50
First
miles.
order linear functions, buddy. Linear functions, first order. Euclidean, whatever you want.
No, what functions are you doing?
So if you have a refraction, you need a normal, which means you have a horizontal and a perpendicular to that horizontal, right? That's what you have. So you need that. And if you have 5 positions over 50 miles, then you have all of those normals over 50 miles, which are first order, which means none of those zeniths are diverging. They're all on mathematically. All mathematically together. It's over a plane surface. It's in the math, you dumb shit. It's in the math, the first order maths. Just stop. It's in the first order math. Stop.
Give me the math then.
Well, you don't know about it. Why don't you go learn it? Why don't you go learn it? Why don't you go learn how they use the normal for refraction index, and then go use that and go take that over a surface of area and show me where there aren't first orders. Show me where you're doing second or third order calculations. You're doing first order, buddy.
Say that geodesy, the first order measurements are happening on a curved surface. Just go and see it. Just check it out. Go and if you don't know it, go and
first order. The first order is straight lines and angles. That's what you use.
In what?
Okay.
In what?
Okay, so listen, in modern times, can we fly a straight path and a curved path with our flying instruments?
What? What does that have to do with anything?
Well, because there is a way to calculate a straight path and a curved path. Do you follow?
I mean, maybe. I don't know what you're meaning.
Maybe. Okay.
What does this have to do with first order measurements that you claimed earlier?
Okay, so you want to go to geodesics, which is an assumption of straight lines being curved because it's basically a mathematical model. But that isn't applied in first order calculations. And yes, it is. How to distinguish first order calculations is understanding that your model and bending lines, you must be able to distinguish between straight and curved. How do you know either? Well, in modern reality, we can distinguish between straight lines and curves. Do you know how we do that?
Well, give me the first order measurements then.
Well, the first order measurements would be using a normal at all of the positions if we're talking of any kind of refraction measurements, right? If we're talking about any refraction measurements, we need a normal. So if you have a whole bunch of positions over the Earth, you're going to have this one normal. And if you want to have it mathematically accurate and consistent, you have to use the same normal at all positions.
Data.
Or else
you're assuming they do. You started this with saying that there's a normal and first order measurements. Then I asked, what are those? You went into flight paths being short or curved.
No, you brought up geodesics.
Hold on.
You brought up geodesics. Listen, you brought up geodesics. And then I asked you if you can determine between a straight line and a curved path. And you were confused by that question.
I have to mute you, Data.
He interrupts me and then it doesn't understand my question properly, so I have to correct him.
Can you correct him after you finish?
No, because
I asked you about the first order measurements. Yeah, I asked you about the first order measurements. Just one measurement. You said we can know straight path or curved path. And then you went back to first order measurements talking about refraction. So give me a single first order measurement that shows that the Earth is a flat plane. Just one.
So if we're going to calculate a refraction of index, we're going to use a normal. That normal will be used at all various positions across the plane. Why is it a plane? It's because mathematically there is no diverging zeniths between each normal. There's nothing. They're all parallel to one another because that's what the math says. Why does the math say that? It's because you're deducing the refraction effects over a distance and you need a plane surface to calculate these linear functions from. If you don't, then you're begging the question in your mathematics and you're subjected to a lot of presuppositions as what rate things are doing the things they're supposed to be doing at. Instead of having a horizontal, neutral default, unbiased position, and then deducing angle profiles from that default unbiased position. And then that's what's done at several positions. There's no implication or function in the first order other than the actual measurements.
Okay,
Your
so
your
the last
first, your
word you
your
said.
position is that all normals are parallel with one another, which
In
is
the
your
mass, yeah.
default, and that's your default biased position because you're
No,
assuming that all the
that's the
normals
mass.
because
The
you're
mass, the first
assuming
order
that
mass.
because you're assuming that all of the
You know
normals
how
are
you have to have
because you're
convergence.
assuming that all of the normals are parallel with one another.
That's what the math says. If you can show me
No, it
where you
doesn't.
do the math, if you can show me where you do the math, so for instance, doofus, if you're real legit, go over 5 miles in your real life and do these barometric pressions or whatever refraction measurements over 5 miles and use your normal. That's what you're going to record first, not because you're being biased. It's an actual first order function. And then when you sit down, you have your actual measurements. Then you go to the second order, which is how far is the distance between them? What's the rate of drop? And then then the third order would be calculating taking that linear function, transposing it into a spherical coordinate or it would be a spherical coordinate in this case. And then you would have a function in 3D space that would match that apparent angle, because what you would do is you would basically say that two parallel lines creating 180 will converge, and therefore they'll converge at this point, which you're still using parallel lines in reality, which is the first order. It's just your third order saying they're converging in 3D space. And then you have a quantification mathematical to give you that point in 3D space, which is almost equal to the 3D space in flat space, right? I believe there is a spherical excess error due to the nature of spherical triangles being inaccurate, not because you're getting Earth curvature. It's a byproduct of using that assumption. That's why they use linear calculations, because it's easier and more accurate. Except for they need calculus now, right?
Okay, all of that was bullshit because altitude, pressure, temperature, distances, all of those things. Oh, and
Again,
angles.
so this
All
not
of
just
those
ad
are
homs again. None of it. What I said is not bullshit at all.
All of those
Again,
are
you just ad bomb. You're just a fucktard that.
Just hold on a minute, because I'm already talking. Altitude, temperature, pressure, distance, angles. Those are all first order measurements.
And none of them require a ball surface at all.
And none of them require a planar surface.
None of them require it. The only time
They
that you
do.
talk about
I'll tell you why they do. I'll tell you why they do. Because mathematically, you have to have an adjacent horizontal to deduce any deviation. So you have to mathematically have a linear surface. This is just fundamental to get any calculation to begin with. So the first order at all points of position is horizontal. No curvature between them. They're all equal altitude circles, radiuses. That's what the math shows. How is this demonstrated? And how can I demonstrate my claim and prove it? I can grab any map and use 2D circles because the Earth is distance and elevation information. That's why I can use 2D circles, bottom line.
Right, I can use any map myself. So if I use Google Earth, for instance, and get distances between major cities, and find out that those distances match.
You use a 3D program that isn't reality, right?
Those distances. I understand that you're
3D
triggered.
program.
So let me just go ahead and finish. Let me go ahead and finish what I was saying. If I use Google Earth, which is a map by the definition of the word map, if I go look it up, it's a map. Now, if I use those distances between major cities and I find those distances as I drive them to be accurate, and those distances don't match up with what a flat surface would do, then I can only conclude that the Earth is not flat.
Yeah. Okay. So you're using a 3D model.
Data.
You're using a 3D model.
Man, I can't
That's. Yeah, I heard you, bro. You're using a 3D model. It's a cartoon.
Yeah, you got to let people finish because I can't sit here and mute and unmute you all day. So please, man, just let these guys finish and then you go.
The Google Earth has no Earth curvature. Google Earth has no Earth curvature in it whatsoever, 0. And the red herring
Oh my God.
is using a cartoon image. The surface data that Google Earth does have, on the other hand, matches the map data, which maps observable reality. If you hop into a plane, you fly 2,500 feet, grab any map in your local area and look at Google Earth and look at the elevation data, you will fly over that terrain just as it sees and is observed in reality, which is instant elevation profile information. Zoom out of that data, and then you get a cartoon ball, which is prescribed mathematically. Now, he wants to use an argument over the flat surface Earth, like the Earth is a perfect pancake and there's no undulations, is just bullshittery, and a weak argument at best, for the simple reason that you know that you have them cornered when they go to something extremely unfalsifiable, which is getting into an airplane, flying the distances, and then driving a car, flying the distances. The Earth presents itself as stationary. That's observable, objective reality. We do not see any spinning, rotating. We see the heavenly bodies move. That is our first-order senses. Without those first-order senses, we wouldn't be able to calculate the ball model. That is a simple fact.
Google Earth has no curvature in it. Flat Earth Data 2022. Oh my God.
That's
The
correct.
problem
What
is every time you...
what rate of curvature does Google Earth have? Can you go to Google Earth and go, hey Google, what is the rate of Earth curvature, or how much Earth curvature is there between Los Angeles and New York? Could you do that for me, boys?
Yeah, you can actually do that. Blue did a demonstration of this not too long ago.
Can you do it for me right now? Can you record your voice?
Blue actually did a demonstration of this not too long ago when Bev had the same problem, where he keeps saying the word unclamp when nobody actually says that. The lines that you draw in Google Earth have parameters on them. You can set them to conform to the surface of the spherical Earth or not. If you choose to not have them conform to the surface of the spherical Earth, then the deviation from that line that you drew will show curvature.
So here's something as well. Do you think that Google Earth is a correct map?
Yeah.
You do. Well, there's your first error. Google is not correct. It has the wrong circumference, wrong diameter. It doesn't match in meters and kilometers. There's an error there. You look at the distance from the North Pole to the equator, it also doesn't match up. There's an error there as well. Land masses aren't consistent in size. They change size. And here's another thing too. If Google Earth map is correct, why are we still using the Mercator map from 1500 when all of the map sizes are incorrect? The surface of the Russia and so forth, Greenland are all wrong sizes, right? The Google Earth itself doesn't have proper sizes of the continents either. So to use this argument, because you're looking at a 3D screen, is not only an appeal to authority, the only argument that you have is appealing to the stone. When I'm going to say this to you, is that you have no way to verify the map is authentic. All you can verify is that it has many errors in it, that they're inconsistent, and no map actually tells the true reality of where we live. Because depending on the first order of measurements they use, whether it's a smaller measurement or a larger measurement, you have different topography shapes. This is a known fact in map making and an error. So you want to appeal to Google, you can. And I can appeal to Google in the same sense that all the elevation data information that they offer me is exactly in the maps, which show a 2D surface with horizontal and distance information. Of course, we live in 3D environment. That's why we've got depth, and we can travel these linear surfaces. Now, to claim that the Earth is perfectly flat for your argument is also weak and coming to an end.
Almost is that. All right.
The
so
same way
Google
that
Earth,
every time you talk about
the Google Earth distances, the distances that are on it, the ones that I can confirm for myself, those do match reality. When we say things like, this map is a very good depiction of reality, it's because we can confirm the stuff that's on it.
Doofus, good luck with your argument appealing to a 3D screen. The reality is there is no curvature. I can hop in a plane, Doofus, and fly 200 miles easily over a stationary extended plane surface. Why do you deny that observable reality and claim that because if I fly a certain distance, the Earth is a ball, when there is no map to compare to? You have to appeal to one source of authority, which is Google, right? There's no other way to check it. We're not rich. We're not billionaires. We can't go verify this stuff. But what we can verify personally, Doofus, is I can hop into a plane for $150. I can fly a 150-mile triangle, not account for curvature, not account for rotation, and land perfectly fine with my instructor over a horizontal plane Earth.
Doesn't mean anything.
The USGS publications
It
are
means
actually
everything.
public. Right. The
Yeah, so I
USGS
reached out to you.
publications
I
are
reached out to
actually
USGS.
the
Yeah, I reached
USGS
out to them.
publications are actually the
Check it out.
USGS publications
Doofus, I reached out to him.
the USGS publications are
Yeah, I
actually
reached out to him,
public,
buddy.
and you could
Yeah,
actually
I reached out to them.
Jesus fucking Christ, dude.
I reached out to them, Doofus. I sent him an
for the
email.
fuck's
And
sake.
you know
It
what I
doesn't
said
matter
to him? I
what
said,
you want to say.
you know what I said?
It doesn't matter
I said,
because clearly nobody else can speak.
He's on a mountain, right, taking a photograph.
Let's just have
Right.
flat Earth data just take control of the room whenever he wants to
Right.
speak and not let
I
anybody
reached out
else
to the
say
head.
anything. We'll just continue that charade as though that's fucking discussions, as though we can actually have a conversation.
Dude, you always sound angry. You might need to take a break.
It was
Well,
one of those
maybe
people-
we could actually have a discussion instead of flat Earth data just blasting over people, and then I get muted for it.
Well, maybe put yourself
muted.
on. Go take
He's
it back
muted,
to
and
that.
he's muted, and you didn't get muted for it. So you go ahead.
All right. USGS publications are public knowledge, those things that you can go out there and get. You can even validate them if you really wanted to with the same kind of tools that they use. The distances that are on those publications between major cities do not fit a flat surface.
That was the last time I'm muting and unmuting you, by the way. So
Yeah,
I was trying to overtalk people, please.
The surface isn't flat.
That's what I mean. It's a weak argument. It's not a pancake Earth, dude. There's undulations, there's mountains, there's valleys. That's why I can fly a plane over them and independently rise and lower my plane independently of the shape of the Earth, right? Because the aircraft works off of air. It doesn't work off the shape of the Earth and the center of gravity bullshit, or the Earth being a ball and needing that center of gravity. All things have a center position due to their own classification, nothing to do with the shape of the Earth. That's why you can have rigidity in 3D space and orientate and do what you want in 3D space. It's because that's the liberty of being independent of any kind of fucking philosophy. And your philosophy says that the USGS, I'm going to go up to the surface of Mount St. Helena. I'm going to take a photograph. Now, if you go to USGS website, you can go look this up right now for yourself. I reached out to the guy who took the photograph. He's on Mount St. Helens. Go look at that photograph, buddy. And I want you to be honest with me right now, doofus. Go to USGS website, type in Mount St. Helens, USGS, I can't even say the word now. Go look it up and tell me if that's a real image, buddy. Tell me if he's really looking at Mount St. Helens and he's noticing that much curvature. I want you to tell me, once you see that photograph, you just use them as a reference, as somebody to go to. And then at the same breath, I want you to look at that photograph and you tell me if that's a true photograph or that's a lie. Because I reached out to him and I said, hey, man, that's an amazing photograph of the curvature of the Earth. Blew my mind, I said to him. With exclamation. I was like, what camera did you use? How did you do that? Right? Do you think I got an email back? I pretended as a boy fan, or what do you call it? A fanboy. Right? USGS shows a picture of Mount St. Helens with massive curvature on it, and you want to use them as a source of reference. Good job, bud.
What I referred to when I speak about USGS is the measurements they make with the tools specifically tasked for the job. If you want to go about, if you want to go on about a photograph and how it appears and what your opinions are of that, if you want to go on about a photograph, if you want to go on about a photograph and how it appears and your opinion of that appearance, that's fine. You can have that. I don't care. However, the actual measurements that they make with tools that are purpose-built for the task show that you're full of shit.
Yeah, again, the USGS is full of shit. They show you a fake image of curvature. Not only that, if you read their information and their claims of all their funding, it wasn't until like late 70s they actually started measuring the Earth again. It required like $300-400 million to start up. So they didn't actually really start measuring the Earth until, like, this is on USGS website, bro. And then I think National Geographic did a little stint with it, and then they did something with the great trigonometric measurement in is it Africa? Or India. And so listen, all these first order measurements are over a plane surface Earth. Without those first order measurements, you can't create a model. Is because when you use coordinate systems, you have a first order in the measurements of these coordinates to transpose them. And you can't escape that, no matter how hard you want to escape it. The Earth is observably a horizontal plane. It operates as so. We build as such. We fly over it as such. Can you take those mathematical measurements and transpose them into other coordinates? You can. And that's what you're using as your argument, is transpose coordinate systems. Mathematics.
No, what I'm actually using is the direct measurements. So for instance, when they do a triangulation across a line of latitude, then like here in the US, they did it across Utah. Here, okay, you mentioned one across Africa. When they do those triangles, they come up with more than 180 degrees, not because they presupposed a sphere, but because the measurements actually added up to more than 180 degrees.
So they didn't, and that's a lie. If you go look at the great trigonometric thing, there's no extra spherical triangles. They're all triangles from points of position. They're all measured as such. That's a lie. So again,
well, let me post it then.
Well, just go look at the math. There's the first order math is they're all straight lines and angles. There's no supposition of a. There's no measure of a curve. There's zero. Locally, you're a small individual locally on a plane. There's no curvature between point A and point B. And if you look at theodolites, I think the maximum is 1.5 kilometers. In distance, they can measure up to at a time accurately to like 0.1 minute of an arc, apparently. But this is, again, an optical effect. And they have, if you look at the errors, culmination errors, you look at refraction effects, there's all these added in, like I said, pressure change and so forth. So there's lots of added effects over larger distances, which means create more errors. So what they do is they have to do it in smaller distances for better accuracy. And in the smaller distances, there's no curves, dude, zero.
Right, which you would expect on a spherical surface. The smaller the triangle, the more like a planar triangle it is, because there's less curvature. If you do a larger triangle, if you do a larger triangle, then you do end up with these angles that add up to more than 180 degrees.
Getting louder really don't help, because then it's you and another person just talking over each other, and nobody can still hear what's going on.
Right? If he understands that I'm talking and that he's talking over me, the third, the fourth, and the fifth time.
Cry a little bit more. I suggest a bubble bath. Actually, a hot bath just isn't going to do it for you. Try some bubbles.
Thanks for talking over, Rakia. Thank you for cutting in to talk over me. That was fantastic.
It's very unintellectual of you,
the
Rakia.
third, the fourth, and the fifth time.
Man.
Does that not? Thank you yet again for doing it. That was wonderful. Why don't you do it again? Why don't you just keep doing it until I can not get my point out? Try to silence me. Now, let me try this one more time. If he cuts in for the third, oh my God, Rakia. Let's do this again, because Rakia is a little bitch. He can't let me finish what I'm saying. Let's try this again.
Wow, that's going a little too far.
If he cuts in for the third, the fourth, and the fifth time, does that not demonstrate that he's... Oh my God, Rakia! Rakia, shut it! Now, if data comes in for the third, the fourth, and the fifth time, does that not demonstrate that he's doing it just to piss me off, right?
I don't know why he's doing it. However, Mod will deal with it, right? We got him every time since I've been on. I've been able to mute him. I can't do it instantly, which means if you start, just come on, man, work with us.
But maybe if he keeps doing it, he's blatantly disobeying mods, which means maybe he shouldn't be talking right now if he can't follow the rules.
Oh, that's a great idea. Who was that? That's unbelievable that you come up with that all by yourself.
So much to the conversation, okay? You add so much. Very intellectual.
Right, hey, just like you're doing now. Right?
Data, do you have the
data? Yeah, just mute him. That would be good.
Yes.
I agree.
You talked about the first order measurements. Do you have any? I asked you earlier and you went to refraction. and calculations.
So the
Do you
only
have
first
any?
order measurements that I've seen are written in papers. That's it. And like I said, one of the commonalities I've found in calculating atmospheric effects over 10 miles, they claim to be 5 minutes of arc refraction up to 8 minutes of arc refraction. I've noticed 5. Go look at the papers they use. It's all Euclidean linear functions. And then with an understanding of why, or a claim to understand why effects are happening. Most claims the effects are due to physicality of the Earth curve and not optical effects. Although they are measured through optics, it's not quantified as solely due to optics. That's what the papers express. And then there's also the functionality of the 3,959 miles, which is in every function, which can be deduced from the apparent path of the sun, which is 60 by 60 by 24, which if you look at 60 arc minutes, which is 1 degree, which is 1 arc minute is 1 nautical mile. Arc minute is an angular measurement. You can deduce that angular measurement from the movement of the sun, and therefore deduce a apparent pathway or a circumference. So if you look at it all comes down to angular measurement, optics of the human eye, and then what we deduce philosophically from that. The inference is you guys claim these apparent effects are due to physical Earth curve, and we're claiming that the Earth is a plane horizontal surface with refraction effects due to light and perspective.
But you still didn't give me a
Refraction in the
single.
vertical component does not make a spherical. It does not make spherical excess suddenly materialize. Refraction in the vertical component will not.
Spherical triangle.
Refraction in the vertical component will not. Refraction in the vertical component will not. Jesus Christ, dude!
You're lying, dude.
Refraction in the vertical component will. What the fuck, dude? Refraction in the vertical component will not cause an object to move left or right such that the azimuth would be different, and the azimuths between these 3 distant locations, the internal angles of those, add up to more than 180 degrees.
Okay, you realize Data overtalks you every single time you address him? You know, and it's a huge headache for you and you're getting angry. I would stop addressing him. That's what I would do.
I would go take a bubble bath myself.
Right. If he's okay, if it's on me to not respond to him being an asshole, and you guys are okay with him being an asshole, I can just go ahead and leave. Sure, I'm allowed that freedom to just not be here while you guys play this bullshit game that you're playing.
Yeah. See you later.
It's not a bullshit game, and he's not free to do that. We've clearly muted him. I've muted him about 10 times since I woke up about not even 30 minutes ago. Okay.
But if all the punishment one gets is a temporary mute, then
I don't know.
You can just keep doing it. That's the problem. He'll just
Stop
keep
taking
doing
Data off mute. Stop taking Data off mute, guys. Not the one who keeps taking him off mute. Leave him on mute for a few minutes. I've asked him time and time again to stop over talking to people, please.
Yeah, because it's not going to change if it's just temporary.
Yeah. But one problem is, sure, if you locally do first order measurements towards a normal, of course, all the measurements are just going to be lines and angles. The problem is that if you want to compare the different normals, you have to make, for example, the assumption Data makes is that they're perpendicular or that they're parallel, which is an assumption. When we make the measurements, we don't make what are they? I forgot the acronym just now, but the ones that you guys are talking about, they don't make such assumptions during their measurements. They do the measurements. There's a difference between assuming all normals are equal and just measuring the angles that are made at each location and comparing them up, seeing the spherical axis.
Yeah, I think it's weird that he said that there's the first order measurements, but then he said that because those show something that it might be curving, it's not due to curvature, it's due to something else. So it's like the first order measurements would be on a curved surface, but there's an explanation for those on a flat
He's
surface.
saying they call them first order measurements. He didn't say they were first order measurements. When you add in calculations for refraction and tool error and human error, it takes away from how accurate the measurement is. I think that's what he was saying. You might be getting the excess because your measurement is wrong in the first place.
So then the first order measurements would be off.
Yeah, I agree. I would agree. Any measurement done with an optical tool over 10 miles would definitely be off. Yeah.
I would say that if it's done over 10 miles, if you can show that it deviates like horizontally, then I would say yeah. If it's shown that it can deviate a lot like horizontally, then sure.
Deviates from what? Its actual position?
Sure. Let's say its
How'd you
actual
get it?
position
Yeah, how'd you get its actual position?
by measuring it like 10 times in a row, different days, different weather.
No, that doesn't give you an actual position. That gives you the average of taking measurements 10 times of
You
a
get an
reflection
average. Yeah,
10
when you do
miles
that,
away.
when you do that, you get an average of the apparent position, not the actual
Right,
position.
exactly.
That's dumb.
Okay.
Yeah,
So you can
you
never
know
know
that, right?
anything's actual position. That's your claim.
No, we're saying that that is a possibility of it not being accurate, especially when they got to do all these special calculations for refraction. So they absolutely know it's happening. To what
You don't need
degree
to do
they're
that.
assuming and calculating for that and calling the rest risk curve.
But you don't do any calculations for refraction in left to right.
They don't do any calculations when they're getting the spherical access. Is that what you're saying?
So what do they measure?
They're taking an angle measurement to a reflector, right?
What angle?
Well, you tell me, bud.
Yeah, I don't know. I mean, if you're measuring
So
the
why are
angle,
you
internal
talking?
angle of a triangle, then I don't know what refraction would do. How
If you
much
don't
would it
know
be
what an
off?
angle is in a triangle or spherical excess, then I don't know why you're a part of this combo. But
Yeah,
you realize
I
doing
don't know.
atmosphere at low level, long distance, right? And they're getting pretty high order magnitudes of refraction and some other errors that they're computing and calling the rest spherical excess, which y'all say is a triangle on a sphere.
Yeah, but what do you mean error? Like what error are you talking about when they measure the triangle?
Well, you have tool error and human error for one, but then when you're
Multiple. Oh, my bad. Go ahead, Rakia. Multiple errors. Go ahead, Rakia.
and when you do it over long distance, they're also calculating in the error of that distance, which they're calling refraction.
What do you mean with that? Like if I'm looking at an object, and then I look at another object and I measure the angle between those two, what should I take into account? How much would refraction change the heading that I'm looking to an object?
I would
say there was no error. If there was no error,
no, I'm asking how much would there be error?
No, but if there was no error, you wouldn't have to do it, I don't know, multiple times and then take an average. If there was no error, you could just do it once and be like, boom, there it is.
Well, I don't see like what, like if I like how they do the triangulation, they're not measuring any vertical angles.
Do you guys have any actual measurements of spherical excess? Because I've been asking for this for a long time, and all I've gotten was the averages of spherical excess measurements. I don't even know if you guys even have the actual measurements.
Where did the averages come from? Yeah, where did the averages come from?
Maybe they made them up. Maybe they made a math calculation. Maybe they fucking lied about them. I don't know. But where's the actual measurements? Who knows where the averages came from? I could care less.
Maybe it's Maybelline. Who knows?
Maybe you can go to if you accept Google Earth, can you use that? You can't. You don't accept it.
No, don't try to put this off on me. You guys said you got spherical excess measurements, right? Post one.
Sure, Duke has posted them. Duke has already
The
posted
actual
them.
measurement?
Yeah.
Average of measurements. Is it that one from the 1900s where they just have averages posted?
No, observed angles, then correction, spherical angles, and spherical excess. So there's observed angles.
What's the timestamp where he posted it?
50 to
50?
10 to. Yeah, 10 to the hour.
Okay, these are averages. That's clearly not a measurement. You think they can measure 3 digits past the arc second?
Well, it says observed angles.
Not an observed angle because we know they can't measure that. We can't measure that now. You wouldn't be able to make that measurement now with the tools we have now. No, that's not a measurement just because they went 3 digits past the arc second. I'm talking actual measurements. That's an average, homie.
That's an average?
Do you think we can measure 3 digits past the arc second, Mo man?
What angle are you talking about?
Observed angle. Is that the measurement?
To a triangle. So vertical, not vertical angles, horizontal angles.
Observed angle. You think they measured 3 digits past the arc second? That's what you think?
It shows that. I'm not sure. I mean, that's
It shows that,
numbers
yes.
there.
But now I'm asking you: do you think we can measure 3 digits past the arc second?
That's a good question. I don't know.
Well, I do know, and I know that you can't.
Okay, how do you know that?
We don't have tools that can do that now. They definitely didn't have it back then, and this is already an admitted average.
So how accurate can we be now with the tools that we have now?
Well, it depends. I mean, maybe a tenth of an arc second, maybe 100. Definitely not 1,000th of an arc second.
Maybe.
Definitely not 1,000. Well, definitely not 1,000th of an arc second.
Okay. Do you know that?
That's not an actual measurement. So do you have any actual measurements like I asked from the beginning of this?
I mean, this is one, but I mean, I guess I can give you some more if you want.
It's not one. That's not one. It's not an actual measurement. We can't measure 3 digits past the arc second.
That's a claim that you believe in.
That's a fact of measuring.
Well, I'm gonna get you the measurements.
Yeah, we went over this for 3 days in GEMS one time, and I found out that it was an average. They were posing these as actual measurements. I found out what was an average, and their next argument was an average is a measurement. That's from the best of the best of your guys.
The only way to get an average is through many measurements.
Or you could just I could make one up and not do a single measurement, and then I could have an average and give you an average.
And then you need that to be consistent with other people's measurements as well. So you can't just make it up.
Who else did that measurement?
That exact measurement?
That it needs to be consistent with? The other people that it needs to be consistent with. Who are the other people that made that same measurement?
Anyone who measures the curvature of Earth.
Yeah. Was there anyone that made that measurement that
Me.
they made so we can know it's consistent?
I measured it. 3-degree drop, 30,000 feet. There's your
You know
measurement.
what we're talking about. You don't even know what we're talking about.
Doesn't matter. It's always wrong. You're wrong. I should just come in here every time and just say, "You're wrong. You're all wrong." What was the measurement you were talking about?
Spherical axis.
Oh, yeah.
Geodis.
I'm unmuting Flat Earth Data since Zanuck is here. I feel like it's only fair.
That's an interesting topic, actually. A little bit mind bending if you think about it, because you start thinking about straight lines to certain points, and yet we're measuring curvature via the straight lines. And how do you get a triangle with curved lines?
It's almost like the normal vectors of Earth aren't parallel.
I know, right?
Isn't that interesting, Flat Earth Data? That the normal lines of Earth are not parallel.
He's got to Google it real quick.
But no, he's been making that claim all through today. The normal lines of Earth. Yeah, he's been making the claim that
one of these measurements using a plumb bob or a zenith position in a lot of these older calculations, did they count for deflection? Apparently, if you're near certain material,
that's a good point.
The plumb bob will deflect. Now, when I've looked at these measurements, I don't see any of that.
That's a good point. Tell me, what do you think about that question? Could probably be a huge piece of granite in Yosemite or something, and then maybe the plumb bob would be off slightly.
Yeah, or like a mountain.
Mm-hmm.
It would be interesting too. Like if we would found like a mountain or something, and then we could name this experiment the Schihalian experiment.
Right. Wow, they've actually done that for some reason. Why would they do that? Oh, because they do know that plumb bobs do deviate due to gravitational inconsistencies. Most geodetic surveyors know this, but you haven't looked into it, I guess, yet.
And these plumb bobs deviate. And these plumb bobs deviate for some reason at mountains, right?
Near
mountains?
strong near gravitational inconsistencies. Mountains for
which would be near mountains, right?
Yeah,
could be. Yeah.
Yeah, and when they did this spherical excess measurement, horizontal near a mountain. Were they near a mountain when they did the spherical excess measurement? This is rhetorical.
Let's say they are. Even then, they're still proving gravity. Then, so I'd accept that.
No, they're proving plumb lines deviate sometimes for some reason, an anomaly that we're not sure about. Yeah, so they did.
Gravity, yeah.
I mean, let's say they are. Did they do the spherical excess measurements near a mountain?
What I'm saying is, I don't know, but whether they did or not, they'd either be proving spherical excess, which it's a globe, or they'd be proving gravity, which it's a globe. So I'm fine with both.
If you don't know, you shouldn't be answering, and they wouldn't be proving gravity. They would be proving. Sometimes we have an anomaly where plumb bobs deviate. I wouldn't know if they did these spherical. I can't with you fucking guys. I don't know why I bother. It's like you're playing games. I can hear you laughing in the background.
Because it's funny. You're funny. You're like entertainment for us, Jeremy.
Funny that you needed to have a horizontal to keep your azimuth.
No, you don't.
Have plumb bobs deviating near mountains.
Jeremy, I posted the measurements for you.
Angles, 3 digits past the arc second. Observed angles or measurements?
What? What's the question?
My bad, I was looking at the wrong thing.
Yeah, it's the ResearchGate thing. It's for the Struve arc that they did from northern Finland to the Black Sea.
I'm not seeing it.
What? It's a link.
Measured triangles?
Yeah, measurements of segments of the Struve geodetic arc.
So at Carl 10, are they measured 125 triangles?
Yeah.
Arc segments measured. Yeah, what we're going to need is a triangle where the measurements add up to more than 180 degrees. I don't know what that is. I don't see that on that page anywhere.
Did you download the PDF?
No, I'm on a cell phone.
Sure, you can do that on your cell phone.
Well, if somebody else wants to do it, I'm not downloading that shit. If you want, you can download it. If you want, you can download it and then post the image of it.
Good.
Well, if you want, you can download the PDF and then post an image of it. I'm not jumping through hoops trying to search for your shit. Show me a measurement where a triangle has more than 180 degrees.
Jeremy, just sorry to interject, bro. Just look, man, they don't have fucking. I looked at all their shit. They don't have it. Nothing. Question for you guys: did you guys hear about the Congress meeting on UFOs? Apparently, they're meeting now. Congress is coming together to talk about fucking UFOs.
I heard about that. Yeah, yesterday.
What the fuck is going on? We literally listen, man. I don't. What do you think of that shit?
I think
UFOs doesn't mean that it's from outside.
Case of mistaken identity. People.
Yeah, UFOs does not equal aliens.
No, I understand. I agree. But the thing is that because they operate on a frequency of fear mostly, right? Political leaders to some degree, it's always kind of that, approach. What do you think they're going to be using it for? This unidentified potential here.
I'll tell you what, if the UFOs are real, they're going to have a big problem because some of them appear to be breaking laws of physics that these guys don't think can be broke.
Well, it's also when you see things from, remember, it's motion. Motion is reference, right? It's based on reference points. So when you see things, it may look like something's going supersonic, but if you're passing like a balloon at a certain altitude above the surface with clouds as a marker, it may look like it's going supersonic in the other direction, but it might just be you going at a certain velocity. So it's all relative. I mean, these mistaken identities, mistaken velocity estimations are based on not having the reference points in order to make those measurements. Even the ones that were taken by the Navy officers or off the coast of San Diego.
Well, anybody grabbing After Effects, watching a couple of Andrew Kramer tutorials could make the same UFO footage in a day and pass it off as real. That's what I know. I don't know you guys know who Andrew Kramer is, but he's a After Effects tutorial guy who gives you all his free tutorials on how to use After Effects.
Oh yeah, I know him.
Yeah, he'll teach you how to make these UFO videos. It's so stupid and so in your face because they. Well, I'm just saying that these videos can be duplicated through After Effects in a day. Not even half. They can probably do it in an hour easily. And Andrew Kramer shows you, and then you look at the same footage that Andrew Kramer shows you how to make on television, and everybody's believing that shit. I just don't get it.
I don't believe it either. I don't believe it either. I think all this UFO shit that they're putting out, I think it's all bullshit. I'm being very serious about that.
But do you think, Pladatera, do you think that they manufacture these videos in order for people to believe in a globe, because then there would be space?
Well, here's what I do know. I do know that for controlling a population, wonderment and amazement and unfalsifiable things are what we call imagination, and there's no harm in imagination, right? So if you look at it as if you look at it as imagination, that's one thing. But if you're claiming that we need to be taxed for this imagination, then I would say that's an ethical, immoral thing to do, right?
You don't control people by pretending there are things in the sky. You control people by controlling them.
Yeah, but by fear, right? It's fear, essentially,
no,
right?
Not by fear, by controlling them. Look at every totalitarian regime in history. They didn't control people by putting things in the sky, okay, or pretending to go places, right? No one controlled anyone in history by pretending that something is something else. What they did is control them directly.
You're on levels of control. We're talking about mental, physical, difference there. You don't generalize it because there are prisons that the governments put people in psychologically. They're called psyops. They're called psyops, right? So
psyops are an invented term. I don't believe that there are any psyops.
Well, whether you believe them or not, that's not my problem. The problem is they exist, and there's documentations in their operations based on psychological influencing population. There's been experiments done on population. Anything of this denial is just utter stupidity at this point to deny that these aren't things that they've done.
Well,
Social media came out. Social media came out and admitted that Facebook is bad, Instagram's bad. They all, motivate the user for monetary purposes, even if it's detrimental to the user. So don't tell me that they're not going to use the same strategy on all. They're not going to use the same strategy in all. Hold on, they're not going to use the same strategy in all facets. Of course they are. It's a working strategy where you make money.
That's not.
What's not correct?
How any of that works.
Yeah, they're getting eyeballs. They're getting eyeballs and they're making money on advertisement as a product. Hold on, can I finish? As a product of that, they do have psychological influences on these kids. Not their directive. It's not their goal, but it is an effect on these kids that could be negative. But they don't really care. All they care about is making money through advertisement. The more eyeballs they have, the more money they make.
It's
not a
the
control.
it's the vague idea that they will put lights in the sky to create wonderment that then they use to control. That's just all fanciful, and it's so vague. It's something you can't even disprove. You know, it's unfalsifiable. So what totalitarian regimes actually do in actual reality is actually control people. And if you look at the Chinese regime or the USSR or any of the the tin pot dictators in Africa or wherever they are, they do it by genocide, and they do it by mass imprisonment, and they do it by taking control or controlling free speech. They don't do it by putting lights in the sky to create wonderment. I'm sorry, that's.
So again, it's not you that's putting lights in the sky or the government per se, but I can tell you that if you go look at the stock exchange and you go look at these satellite companies that exist, right? They, for instance, there's one called GILT, G-I-L-T. It's a satellite company. I think it's $5 a share right now. So it's through this Kathy Woods ARK investment. So if you look at these companies, they exist. What do they produce? They produce satellites, right? They produce things in the sky. What do they produce it for? Well, they produce it for. They produce it for. Let me finish. They produce it for. They produce it for. So, for instance, the idea behind some of the technology is simple. It's just spying on your land or keeping track of your land. So, for instance, one company you can go invest in, they promote their satellite technology as stationary, geostationary satellites over your land. Or so if you were a farmer, you owned hundreds of thousands of acres, and you wanted to keep an eye on it, you could do so through this company that you pay a service, and they put their geostationary satellites above your land and they watch. Now, these aren't low over Earth, are they? I don't know. I know that you can look at these images as they pitch the product to you. You can see that they're high altitude images. So there is a service out there putting lights in the sky. Now, when I know why they put lights in the sky, it's to spy and espionage. So to control a movement, unless they're all families or all the ingredients, which I don't agree they all are, which are all the rulers' families. I don't think they're all ingredients with lands, mineral, and resources. I don't think they agree. I don't think the Chinese emperors agree with the Indian emperors and so forth. I think there's some hands in the pots there that they'll worth fight over, right? So control your population. You do it through all facets.
All over the place, man. Can you be more concise?
Facets of espionage and spying aren't limited to lights in the sky. They're designed to control and to spy and to do everything. So no, you're wrong. It's all facets that are used. That's not paranoia at all. It's a fact.
That's not a reasonable argument.
Okay. So listen, buddy. If they have a service already for farmers to buy for geostationary satellites to watch their land, not only that, why don't you go look at this? So they're doing it in Brazil. So what they want to do is they want to have a grid system. Let me finish. They want to have a grid system in Brazil. So all of Brazil's rainforest is under satellite surveillance, right? They want to have a grid. Here's an example. So go look at Amazon in your household. You have the Amazon devices. They signed. Let me finish. I'm going to give you a final. No, dude, we're talking about the government using lights in the sky to control people. And you're like, no, they won't. I'm saying they're building a grid system with lights in the sky. They're building a grid system. Well, Elon Musk, Starlink is a form of it, let's say.
Okay. So they want to spy on you.
So if you want to look at Amazon, of course, they have to ask your permission, and you just agree because it's a free service, right? Well, it's not really free. If you read the fine print, they can use the data, and then what they do in the fine print, if you read it, they'll tell you that that your information is private, but any other company that comes in and acquisitions it or takes it over, they now have access to your data. Well, what do you think Discord did? Discord started up, one owner, one data, private. And then Google took them over, took all the data. That's what happened. So that's what happens at every institution. Everything that starts from the ground up, it builds a base, gets bigger, gets bought out, and then the information is taken over by the entity that buys it out, which is usually the entity that is monopolizing on everything. So don't tell me it's paranoia. Don't tell me it's spying and espionage is paranoia. You're full of shit, dude. You're not being authentic or genuine at all.
All you've done is just spout utter nonsense. Okay, we started.
Okay, so utter nonsense is that satellite companies exist. Satellite companies exist.
We started with the idea that they put lights in the sky, unidentified flying objects to create wonderment, and now you're on Brazil, you're on SpaceX.
No, they have lights in the sky. It is a wonderment to look at something that's a light in the sky and not know what it is, numbnuts. It's a byproduct of the lights in the sky, whether it's intentional, it's just a byproduct we experience. So when we look at a light in the sky and we don't know what it is, we call it a UFO. Well, the connotation with the UFO means what? all means different things to you, to me, and everybody else.
Listen to me. I don't know how often I tell you guys don't call names. Please, man. I'm going to have to start issuing warnings or something for people that call names consistently.
Yeah, I got you want him off. There you go.
Anybody who's not paying attention and just saying, "Oh, it's just paranoia that that these institutions don't exist, that this technology doesn't exist," and anybody who is unaware of this technology will, if and at any moment, see it. For an example, when I saw a military drone for the first time where I'm living, randomly flying at night, I thought that was highly unusual. You know, what was it doing out doing its thing? It was doing its thing. But why? What's the reason? That caused me to wonder, right?
How did
So
you know?
all these,
Could it be that it was just a training?
because I saw it, I saw it move really fast, and I had an Inspire 1, right? So I was very familiar with operating drones and using the light, just using it long range, right? Using the UAVs long range, 3 to 7 miles kind of thing. So it's not like crazy distances that they can do in reality. This is just, you know, for prosumer, I suppose, application. What's that?
Someone learning how to fly. Could it just be like someone
So
is?
So an Inspire drone goes about 60. Inspire drone goes about 60 miles an hour, right? And that's you know, at that prosumer. Now I don't know if you've seen a 60 mile an hour drone get into a wind. You know, it goes much faster than 60 miles an hour. So if you see one of those things zipping by, and the way that mine was built, it can stop on a dime pretty much and change orientation pretty much. I'd imagine that the Pro style is you know, carbon graphite through and through, or whatever upgraded Teflon carbon graphite they have. So this device that they fly in the air is easily 100 miles an hour, easily changing velocity on a dime. Right? I've seen this stuff.
But
so when I seen it.
You a question. Like, what if it's just a military drone that is just doing its thing? Someone is flying it just for educational purposes.
Well, sure. Because at the end of the day, you don't know the implication. Just know that they're already there. They've been doing it for a while already. And where I'm at, I use a low pass filter on my camera, and I've yet to post the footage actually, but I've got lots of activity, man. Lots of these objects moving back and forth in the sky, and sometimes there's nothing, and sometimes like a week straight, I've got, like, I don't know, dude. On the every 10 minute, you can see something moving. So. Lots of activity up there now.
Yeah, you can get consumer grade drones that do like 200 miles an hour. That's what consumer grade drones are pushing right now.
Well, yeah, I was meaning my Inspire, man. I mean, it's 60 miles an hour, this big beast. I mean, I've seen the little ones that you're talking about. Yeah, those are pretty fast, man. And they switch on a dime. I mean, if you throw some lights on that fucker, you synchronize them, put them up in the sky, people would think that's UFO, no problem.
Perhaps. They're pretty noisy, though. I guess if it's far enough, if the distance is great enough, then it might not be that loud. But
well, I know at 500 meters thereabouts, you can still hear it. Sounds like a bee's nest, like the Inspire anyway. But if you had a group of them, they would be pretty loud. But I'm sure there would be a way to cancel that out. Right, because after all, if you can cancel out, you can cancel sound with sound, right? So there might be a dampener effect or something.
Damper, not dampener.
What did I say? Dampener. I always say dampener for some reason. Damper effect. Damper. Is that right?
Yeah. It was interesting. We had dampers, and a lot of people were talking dampeners. And I always had, it was my sport of always correcting people. It was funny. They always laughed. Oh yeah, that's right. Damper. Shit.
How does the drone account for the ones that have gone into the water and came back out?
You've got prosumer drones or consumer drones, pardon me, that you can throw in the water and they'll fly out of it. So I don't see how they can't
underwater.
upgrade. The same
They go
thing.
underwater.
You can throw it in the water and it will all of a sudden. Sure, why not? If it can fly out of the water, why wouldn't it be able to sink and then turn on and fly out?
I was thinking it's on the water. If you throw it in the water, it's on the surface, and then it can develop lift to fly out. You're saying they can actually.
I suppose you could have some ballast. I suppose you could have some ballast in there to functioning tube ballast, so that you could suck in water right away to make yourself slightly less buoyant and therefore sink, and then calibrate that and then fly out. I mean, there's come on, man.
I don't know. I've never seen a drone underwater rise itself to the surface and then fly out of the water.
Are they going to show you that stuff if they can? If they can show you consumer stuff that does it, well, then why wouldn't they do it on a larger scale? I mean, I've seen a consumer product do it. I've literally seen advertisements.
In the first place is the military, and then they give a little piece of it to the consumer. But why wouldn't we assume already that they have drones that can, are different power, like, you know what I'm saying, under a different realm that the consumer products are under? Of course the military would have an advanced product, right?
Well, it has to have work on propulsion, right? Because of the medium that we're in. So what other, propulsion mechanism that you've seen that we can have? I mean, I know that magnet.
They're working on the anti-levitation type stuff, that the motors with no moving parts, using the energy of the earth, to generate power. Maybe
you're talking about the hoverboard, bro. That hasn't existed. The hoverboard doesn't exist. You're literally talking about hoverboard technology. We've already had that, man. You're talking Back to the Future stuff. So if that would already exist, the hoverboard, the hoverboard would be a byproduct of it, right? You'd have to have this you'd have to have this opposing frequency, a resonating frequency that would, use the field that you claim that Earth has. But, again, that
or
resonance,
something that's rotating so fast it's generating its own lift, like through energy, through the electrical energy.
You need a propulsion, you need a fluid, you need a transfer of energy, right? You can't escape the first law of thermodynamics. You need an energy transfer.
I'm saying it is increasing the positive and negative charge. Maybe they
energy transfer is the second law.
No, entropy.
Maybe they figured out the
first law is energy. No, first law is energy
cannot
be transferred.
About thermodynamics. You're going to educate me on thermodynamics.
The first law is energy cannot be transferred or destroyed, or it cannot be created or destroyed.
Come on, stop trying to educate me on things that I know about and you don't know about.
That's the first law, Zanuck. That's the first
law. Is yes, is created nor destroyed. The second law is energy transfer. No, the second. You said. Energy transfer.
Is the second law.
Energy transfer. The direction of energy transfers. Energy goes from high to low. That's what second law says.
So pressure goes high to low. You can have no energy exchange but entropy, right? So that is the second law.
You're throwing words out again. You don't understand. No. Entropy is only a measure of what happens through the process.
Entropy is not an exchange of energy. It's just an exchange of pressure.
No, it's not. That's right.
It's equalization. It's equalization, right? It's not an exchange of energy.
You like to be right, right? Don't repeat that because it doesn't serve you any purpose. It just makes your Hopisana even worse. So stop doing that.
So in the case of high pressure to low pressure, when it equalizes,
no, that's not entropy. Entropy is the measurement of this lack of the energy available to do work.
Entropy is a description.
If you don't listen, you'll never learn.
Entropy is a description, Zanuck.
Entropy has nothing to do with high pressure moving to low pressure at all. Doesn't do anything with that. It has to do with the measurement of a system's energy potential to do work. Now, the lack of energy the amount of energy that can't do work. The amount of energy that can't do work is
an energy exchange.
It's amount of energy that cannot do work is its amount of energy that cannot do work is its entropy. Do you understand that? The amount of energy in a system that can't do work is its entropy.
Which means it's just a pressure change.
That's not a pressure change. That's what I'm trying to get you. Stop. Get off the QE bandwagon. It's stupid.
It's an equalization.
Really dumb. It's not equalizing. No, that's not what entropy is. That's not what entropy is.
Yes,
that's not what it is.
It's all about equalization. Yeah.
It's not about equalization. Forces are about equalization. Newtonian mechanics are about equalization. Entropy is not about equalization.
Equalization. Would you like me to read it?
It's not about equalization.
Dirty Data, what's wrong with you?
Hey,
Are you not
Data.
listening to me? Now you can challenge me saying I think it is and here's
Data,
why,
be careful.
but no,
You're
you
gonna
keep on
get muted
disagreeing
if
with me.
Frank talks over you one more time. Be careful, Data.
Well, no, I'm just trying to have him stop in his tracks that he's wrong. It's not about equalization.
We're
It's
allowed
about
to be wrong here, Zanuck.
I'll tell you why.
Nice if you didn't holler over the top of him while he's doing it.
Well, if I have the floor, I'll tell him why. I'll tell you why too. Entropy is a measure of the system's energy level. That's unavailable. Okay, so you're going to do it too, Jeremy, huh?
Guys, let's.
Yeah.
I could be roboting, but let's let everyone finish.
Yeah, let me fit. I'll handle it. I'll give him space. Give me space, Jeremy. For a second. Just stop. You're roboting anyway. Just go away for a second. Thank you. Okay. Data. Entropy is the measure of the energy unavailable to do work in a system. It's not about equalization. People say that they're wrong. High pressure, low pressure. No, that's a Newtonian mechanic aspect of energy.
It's thermodynamic equilibrium, Zanuck. That's the second law of
That's not
thermodynamics.
entropy. No. Thermodynamic equilibrium does mean a balance, but that's not entropy. Entropy is a system.
Entropy is just a description, dude. It's just a word to describe an event. That's it.
That's a law.
Entropy is not a law. Entropy is a measurement. It's an
a
aspect.
description.
It's not even well, yeah, of course it can be a description, but what it is, it's a property of the second law. It's a property. It's a thermodynamic property of the second law of thermodynamics. What it means is, and you can measure this by a simple, if it's Gaussian or Boltzmann, it could be as simple as the heat divided by the temperature. The change of heat divided by temperature is, I think my namesake even says that on there. But that's what you got to think about. Stop using entropy like QE uses it, because it's wrong. Absolutely, positively wrong. I mean, not even close
You
to
didn't
being
understand. Right. You were wrong with the first law of thermodynamics, and then you corrected yourself.
No, I said it was
energy.
No, I didn't. I said you were wrong about the second law because you said it's about energy transfer. Energy transfer is a
get out of here, man.
Energy.
Zanuck, you're on too many drugs. Gotta
energy transfer is the second law.
You're not helping, bro.
Energy transfer is the second law. You said it was the first law. I said it was not. It was the second law.
Zanuck and
you are
Data,
so
please stop talking over each other, please.
I know, right? Let's give each other space. I'll say something, you can say something.
Some percent. Take care of this percent. I'm in a very bad area. I'm roboting. I can't even hear what's happening, but
I'm busy
I hear
doing
that it's
something.
utter chaos.
I'll try to mute when necessary. Carry on.
Okay, flat earth data, real quick. You said energy transfer was the first law. I said no. Energy transfer is the second law. Energy being created or destroyed is the first law. You correctly stated that too. Then you start talking about equilibrium. And no, it's not about equilibrium.
That's
Entropy
the second law,
about,
not the first law. The second law is about thermodynamic equilibrium. That's why you have any high pressure system into a low pressure system, because it's
not.
It's in a sense about ordering the structure, right? And then the entropy is the entropy is the word to describe the measurement. Entropy is the word to describe the measurement, right? It's the description. Entropy is the description.
Entropy is the measurement.
Well, that's what it is, right? And you're looking at this process automatically as a natural law. It's an automatic natural law that's irrelevant.
Hold up, Zanuck, stop interjecting, please. And when you get a chance, describe how entropy is a measurement.
It's not a law.
How are you measuring energy that's not available?
That's a great question. That's the fundamental foundation of what entropy is. It's like enthalpy. You measure it in a system. To measure in a system.
There's no working.
Oh my God! Can you let me finish?
Hold up. Let
I'm
me
going to talk to percentage.
How are you measuring something energy that doesn't exist?
If you have a system and if you measure a change of heat with respect to its temperature, that'll give you a value of the ability of its system's ability to do work with that energy level. That energy level's ability to do work is enthalpy. Its inability to do work would be entropy.
Okay, so you're not actually measuring the entropy. You're measuring a change in temperature, and you're inferring
that is entropy, though. That's how it's defined.
By definition.
That's how it's defined. Change of heat over temperature.
The amount of energy.
The equation is S equals delta Q over T. That's the equation for entropy. That's what it is. Enthalpy is not that equation. It's something else.
I know, but when you say equation, that's a calculation, not a measurement. So you're measuring change in temperature, and you're
No,
calculating
you measure
entropy
to get
from
to
it.
plug it into the equation. You measure those. It is a measurement, and a measurement
Exactly.
of
You're
those
measuring
two
the
factors.
change of temperature, and you're
Oh my
calculating
God.
the entropy from it. You plug it into the equation, just like you said. Correct?
You're measuring two quantities.
Right. You're
Okay,
gonna
so
argue with what entropy is in the equation, and what is, and you're gonna get
no,
semantic
you're
on.
saying
Oh,
two
it's not a measurement.
contradictory
It's
things,
it's an equation. Is that what you're really gonna do right here? Percentage?
No, I'm saying you're saying two contradictory things. You're saying
If
on
no,
one
I'm not
hand,
saying anything
energy
contradictory.
is.
Nothing
Hold
is said. I
up.
said is contradictory.
I'll point it out again if it wasn't made clear. You're saying that entropy is the quantification of energy not available to do work. I asked you, how do you measure that? Because you claimed you could measure it. You said you measure a change in temperature. You measure the temperature, and then you plug it into the equation. So you calculate. You don't actually measure entropy. You're measuring the temperature, and you're calculating the entropy because you plugged it into the equation. Agreed?
No, I don't agree.
Well,
Then
that's
how
what
are you
entropy
directly
is. It's
measuring
measure of that temperature.
energy that's not available to do work?
That will be a way to measure the change of entropy, not entropy itself.
Okay, so you can't measure.
So the word entropy is confusing for you. I know it. So we have the change of entropy.
One second.
So really,
we can't directly measure. Zanuck,
what?
please let me respond to what you just said. You said we're measuring the change of entropy, not entropy itself. How are you measuring a change of something that you can't directly measure?
You can. Why do you think we know what the entropy is of a gram of water?
Because we calculate.
We know this, right? How do we calculate it?
We calculate the change in temperature, if any.
No, that's not how you do it. So you don't know. So just why don't you ask me
how
you do it, then I'll
how are
tell
you directly measuring energy that's
well,
not even
I'm
there?
going to ask you. How do you think? Does a gram of water have entropy?
It depends on the temperature.
It doesn't depend on anything.
Happens.
It does.
If it's
you just don't know what entropy is. See, I'm asking these questions.
Hold up.
I can't have an
if it's not doing
conversation.
anything,
You're going to talk over me because you have the mute button.
No, you ask me a question. I'm going to respond. You
Okay.
ask me, can you measure a gram of water? And my answer is, if it's not doing anything, if there's no change to the system of this water, then no.
Yeah.
It's losing
then you're
heat.
incorrect.
How's it losing heat if there's no change to the system?
It's not changing entropy. We're measuring the entropy of a gram of water.
You're not making sense, bro.
I know, because you don't understand what entropy is. If you understood what it meant,
you're
this
saying
would make
on one
sense to
hand
you.
that you can calculate it, and on the other hand, you're saying you can measure it.
Yeah, you can have change of entropy and you can have entropy.
Yes,
What is the entropy of air? Hold on. What is the entropy of a gram of air and a gram of water? What's the entropy difference? And how would you calculate?
Tell me how you can directly measure entropy.
I'm not going to talk to you about it because these are concepts that you're not familiar with, and so it's almost futile to be discussing with
All
you.
right. Well, for the benefit of the audience, I think I've shown how you're basically speaking out both sides of your mouth.
No, I'm not.
Can I ask him a question real quick? So do you think speed is a measurement?
Asking me?
Percentage, yeah. Is
No,
speed
it's not
a measurement?
It's a calculation.
It's not a measurement. Okay, so
it's a calculation. Yes.
That's really odd. So if you take two measurements and you combine them, it's not a measurement.
It depends on how you combine them. If they're two things, like let's say I took a foot, like I was measuring, like a meter stick for a stick, all right. And at first I measured a foot, and then I realized that it wasn't long enough to measure the full thing. So then I added in this little mini ruler and measured 12 centimeters on top of that. Then I'll know that it's this plus this. They're both lengths, both the same unit, so it's not a calculation, as it were. You're not changing any units of measurement.
Okay, is speed real?
Is speed real?
Yeah.
Things move.
Okay, so would that be yes?
Things move at varying velocities.
Okay, so in the same way that speed exists, entropy exists, right? You have two measured quantities, you combine them, it exists. And they take the same form factor, one over the other. Q over T.
There's a problem here, because when
V
we're
over
talking
T.
about speed, when we're talking about that, we're talking about something moving, something of matter moving, changing position, right? So in reality, you don't have like you only have these concepts that you independently measure. You have units of measurement for each specific like thing that you're talking about. Time, which is actually just movement, and then the length.
Time isn't movement.
Time is movement.
Time is not movement.
You're basically measuring the movement of whatever is moving
It's
versus the movement of the
delta
sun.
position, delta distance over delta time.
Yes, and time doesn't actually exist. You're just measuring the movement of the thing relative to the movement of the sun. That's how we got our system of measurement called time.
You can use any unit of measure you want to measure speed. You could see, I could have a leaking plastic bag of water, and I could count the drops and say my speed is relative to that.
You absolutely could. Then you're going to be carrying the movement. You're going to be comparing the movement of whatever's moving, like whether it's a car or whatever, relative to the movement of the drops of water. In the end, time is movement. It's motion.
Time is not motion, but okay. Let's go back to entropy real quick. Back to the question real quick. So we have entropy. Is entropy higher of gas or liquid? Which is higher, gas entropy of gas or liquid?
That's irrelevant because you still haven't.
No, it's not irrelevant. I want to help you real quick. I promise will be fast. I'm not doing this to like embarrass you or to be a jerk. I'm just saying, just real quick. What do you think the entropy is higher for a glass of water, or water itself, a mole of water, or a mole of H2O, in gas form or liquid form?
I think you would depend on other factors.
Say that one more time. Say that one more time. That's like asking That's like asking what's heavier, a feather.
No. We have the same amount, a mole of H2O. If it's in gas form or in liquid form, which has higher entropy? And I know you know the percentage.
I would say because it's like it's
same
easier
temperature
for the temperature to move, basically, for you to have changed temperature,
same temperature
in gas form. It would be but there's still going to be a change in temperature.
No change. I have a mole of gas water, and I have a mole pure gas, and I have a mole of water, liquid water. Same temperature. Which has higher entropy? Doesn't depend on anything.
So you have this in like a frozen state?
No. Gaseous water.
No. So if you heat up, so one of them is heated up to exactly 100 degrees and stopped at 100 degrees before becoming gaseous. The other one is heated to 100 degrees and added just enough energy to become gaseous. So they're both at exactly 100 degrees. However, one is gaseous, the other is liquid.
Before they change states.
Yeah.
Come on, you know the answer because you've heard this a million times about the relationship between gas, things that are spread out. I'll give you the hint. Things that are spread out versus more condensed. There's an entropy value that these both would be relative to.
This isn't relevant at all.
It will be when you give me the answer.
So say
you don't know the
entropy of the gases is more. What's the point?
Okay.
How does that let us measure it?
So why is it more?
How is it letting us measure it, Zanuck?
Well, we can easily take the joules, the energy, divided by the temperature.
Vibration. There's a higher vibration, Zanuck, with the gases than there is with the water.
Why is there a higher contact? I mean, more frequent contact? That I would go along with.
Higher vibration. Yeah.
What does that mean? Higher vibration.
What do you mean by higher vibration?
If there's a higher vibration, what does it mean?
They're both at the same temperature.
How do you cause a higher vibration? You mean more interaction, right?
No, what does higher vibration mean? They're both 100 degrees exactly. However, one is gaseous, the other is liquid.
Are you claiming that the both can have the same frequency at two different states? One has to have a different state of frequency to maintain its properties. That is just the rule. So if they have different frequencies based on their properties, one has to increase based on the properties of entropy, or the mathematical description of it, gives you the effect that this particular gas would move at a higher rate to fill the available space, because it's activated in an expansion or expanding at a faster rate than the solid liquid is.
So Gummy, he gave you your answer. So his definition is the frequency, the collisions of these molecules, the frequency of those collisions.
Yeah.
and that's not too far from being right. And that's why we have a liquid at the same temperature as a gas, and the frequencies are going to be greater with the liquid because they're closer together, but they're vibrating at the same rate, the same velocity. Right? Data? Their velocities are the same, right?
Not the state of the water and the state of the gases. They have to be at different. The natural states are vibrating differently.
Yeah, I think we're agreeing with you. You're very awkward in your wording, but we understand what you're saying. So yes, you're right. The frequency would be higher for the liquid, but the speed would be the same.
Well, if the speed would be the same, then there would be an inverse equation to that you could use.
Why would there be an inverse equation to be used?
Because how would a solid gas, how do a gas turn into a solid? Would it require the same inversion of minus 100? Would it operate the same?
No, we had both these substances, this with one substance in two different states at the same temperature. We can even do it at room temperature. They can be at liquid and a gas.
Yeah, but they're at different frequencies at all, even just at their state.
We all agree. We all agreed that there are different frequencies.
So the thing is, so here's the thing. So temperature is measured as the average kinetic velocity of these. And if they have the same temperature, that means they're moving at the same speeds. But the difference between the liquid and the gas is that for the gas, it has gotten that additional amount of energy to make it go from the phase of liquid to gas by breaking the bonds. The energy went into breaking the bonds.
Right, but we're keeping it the same temperature, and then we have two different states. So we have
but that's what I'm saying. The only difference between the two is that the liquid still has some weak hydrogen bonds, while the gas does not. That is the only difference. The temperature is the same, which means the movement's the same.
Yes.
It is merely the structure, and by structure I mean the bonds, the hydrogen bonds within that liquid.
So I'll give you the value. So the entropy of water in liquid form or in gas form is about 3 to 1. It's three times more entropy in the gas. You would all agree with that, right?
How is that quantified? They have to have a subset of volume and then something to like what? How do you get that calculation?
That statement you just made is why
So you say they can't figure out how much energy is in the substance?
Well, you'd have to have a preset volume, right? You'd have to have some sort of capitulated.
They know how much energy. They know how much energy is in water.
Did you say it the wrong way around? Where liquid water has more?
No, I said gas.
Right.
Gas has more entropy.
Okay,
3 times the entropy of.
Has about
3 times the entropy of liquid water.
Yeah, but what volume is that?
I don't know when he learned that, but he
volume. It's not a volume.
Well, you have to have some sort of test for that.
It's not a volume. It's not a volume because obviously the liquid will have a less volume than the gas. It's a molar value.
Yeah.
It's a mass volume.
All it's related to is per mole.
Mass,
so we have
mass in relation to, because they don't operate the same physically. So if they're mass and they have properties, the inherent properties aren't equal. They have different properties to begin with.
No, it's the same mass because it's the same mole or amount. It's the exact same amount.
Gas and a solid gas, a solid and a gas, whether they're moles or not.
Not a solid. It's a liquid and gas.
Well, the matter is in liquid, which would be a solid, and a gas would be a gas.
Gases are not solids.
They're fluids. They're both fluids.
They're fluids, yeah, but one's in a bonded state, one's in an unbonded state, right?
Yes.
So that situation in itself.
We'll change the mass a little bit.
Well, the point is that
no, it doesn't.
You would think it would change the weight a little bit because of the vertical air
column,
the weight of the air above.
Same mole, same amount, same mass of gas.
I know, it could be the same amount, but
H2O.
Because of the surface tension of the liquid, it's going to be catching more weight from the weight above, basically.
It can't be the same mole. You can't quantify. You can't quantify the same mole. You can't quantify it as the same mole. You can't quantify it as the same mole.
Okay.
One is bonded. One is bonded. One is bonded, and one is unbonded. One is bonded. Let me finish. finish. Then let me finish.
Oh
let me
my
finish.
God!
So one property in one state is bonded. One property is unbonded. Therefore, the properties of states are different. What you're doing is you're quantifying them as equal states, but they're not.
I'm not calling from equal states.
I'll give you one example. We'll give one example. You have two equal vials. One, and in each vial, you put 1 mole of H2O in it. And then, like I said before, you heat both of them up to 100 degrees, but one of them, you add that little bit of extra energy for it to go through the phase transition and become gas. You now have 2 vials with the exact same amount of H2O, the same amount of water. However, they're both at 100 degrees Celsius. However, one is gaseous, the other is liquid.
Yeah, but here's the thing: the properties of the mole, a gas state, don't have the same properties as the liquid state. They don't operate the same.
Well, it's one of the reasons why the entropy. It's actually one of the reasons.
Hold on. That's why you have the. I'm almost done, dude.
You're missing the point.
That's why you have the gaseous state, just because the vibration of those molecules are interacting to compensate for the energy transfer. So when you have that energy transfer, you have that friction creating that gas state that you claim, right? But they're independent from each other, wanting to go in opposite directions. So they have no mass. They have no mass to it. Where there's a vector direction. Let me finish, dude.
Oh God!
Let me finish.
Go ahead.
So this mass that you quantify doesn't apply to an unbonded matter because there's no vector associated with liquid or solid.
You're throwing words out. I can't help myself. I'm sorry, but you're just throwing words out there that may have no meaning.
I'd like to address what Gummy said.
Mole isn't a mass. Yeah.
So you said 2 vials, right? And one of them, you heat the water up to, let's say, 99.9 degrees.
No, you heat it to 100.
100.
No, you heat it to exactly
but the boiling
100.
point's
Both 100.
No, how that works is once it's at 100, the next bits of energy is going to go into the phase transition.
Sure. Okay. Let's say the boiling point is now 100.1. Okay.
No, it's still 100.
That's not how that works. The temperature of both of them will be 100. However, in one of them, the hydrogen bonds have been I forgot the word you use. They've been undone.
Coulombic?
Sure.
So the hydrogen bonds, that's where the extra energy went.
How'd you dissolve them if they're the same temperature applied?
That's how it works. That once the substance reaches boiling point, which is 100 degrees, the next bit of energy will go into breaking the bonds.
And not change the temperature at all.
It doesn't change the temperature. It only breaks the bonds.
And
so
it's one of the reasons.
It's just
and Gummy, can I add real quick? It's one of the reasons why. It's one of the reasons why the entropy has gone up.
Yeah,
you can't have 100 degrees Celsius in both vials
for a little bit longer.
Yes,
and then have one slightly increase the temperature.
Yes,
they're not equal now. They're not equal now at 100 degrees Celsius.
I listened to both you guys. I have not got a word in since you guys.
No, but this scenario is broken, Zanuck, because if
can I
hold up.
I might help you understand. Zanuck, let me talk.
Let me just say this. Get this up real quick.
Wait, let me. Why is it about you?
Zanuck,
why can't I talk for a second?
Because
just let me talk. I heard both you guys, and I have a lot to say. I mean,
I'm saying it's broken.
I have a lot to say in a few words. I have a lot to say in a few words.
All right, go.
Let me talk. All right. What Gummy's trying to say, and he said it very clearly, is that when we have two same temperature substances like H2O, and you have it at 100 degrees, the next bit of energy, heat you apply to it, doesn't go into raising the temperature of the actual substance.
We understand this. Why are you repeating the same thing he said, and then that wasn't even a few words?
Can I finish? You said I could, and then you just talk over me.
You said a few words.
You're repeating what he said. We understood what he said.
What am I going to say? What am I going to say?
Leaving at the same temperature, it denatures the
What happens next?
Lord, are you like dead?
Go ahead. Tell me what happens next. What am I going to say?
Okay, so he's saying you don't increase the temperature. You leave it on the same temperature for a little bit longer, and it denatures the bonds so that it becomes a gas.
No, not a little bit longer. No, not a little bit longer. So
it doesn't matter how much.
You didn't know what I was going to say.
The point is,
so if you don't know what I'm going to say, why you think you can finish my sentence?
What new information are you going to add? Go ahead.
The part that you're missing. You're adding the energy. It's not a little longer. You're adding more energy. And that energy goes into breaking the bonds that cause it to be a liquid. That now allows it to spread out.
Then.
You added heat, yes, but it didn't go. The temperature didn't go up.
So now you see how these are two different things. You're treating them differently.
No, it's the same substance.
The
One's
same
a liquid,
substance. One,
and
you
the other
added
one's a,
less heat.
the other one was
you
a
added
liquid
more
too.
heat.
Well, that's why.
And
All
you're
we're
asking
controlling is
why?
the temperature and the pressure. All we're controlling is the temperature and the pressure. The same
Except
substance.
for one of them, you're
exactly.
adding more temperature. You're adding
We're
more.
adding, no, we're not.
Heat.
Temperature is not heat.
We're adding more
Common
heat,
mistake
which
of a lot of
increases temperature.
We're not increasing temperature. We're increasing heat.
Okay, so if you're adding less heat to the other one, don't you think the temperature would drop a little bit?
We're not adding less heat. We're adding more heat to one.
Yes, which means
not
less
changing
heat for the other.
See, listen how silly this sounds.
No,
we're
listen
not
how silly
adding
you
heat.
sound. You're
We're
saying
not,
relatively,
we're not
you're not
adding
adding less heat to one
You
of them.
can't add less heat. Listen,
There's
you're
less
listening to
heat
yourself.
being added to the vial, to one of the vials.
We're not
in the totality
adding
of
less
heat being added, there is less. The quantum is less for one of them.
No, we have. Okay, look, we're
No,
both
hold
at 99 degrees.
Wow.
We're
We need
both
to
at
make
99
sure-
degrees. Okay.
we
Hold
need
on,
to make sure we
let me finish real quick. Let me try.
differentiate
Gummy, let me just finish real quick. We have both are 99 degrees. We add heat to both. They both go to 100 degrees. Both still liquid. But one vial we add a little more heat to. The temperature doesn't change, but it changes state. That's where the energy went into. Didn't change temperature. They're both still at 100 degrees. We did add more heat to one, but the temperature did not change at all.
Obviously, because you added heat to one of them, obviously it's going to have more entropy or more energy. You
No,
added more
entropy is not
energy into the
energy.
system.
Yeah,
That's not energy. No,
Yeah,
you're
but
wrong.
after entropy is
That's
entropy
incorrect
is the
statement.
energy that's not available.
I'm
The
only
point
going to
is you
interrupt when
added
you're
more
wrong.
energy to it.
But that's not why it has more entropy.
Of course it is.
No,
You can't have
because
entropy
I
without
was
energy.
getting more entropy adding energy. I was getting more entropy when it changed states.
Yes, because you added more energy to
No,
it.
hold on. Adding energy doesn't mean you increase entropy. It often means the opposite of that.
Right.
If you have a transition wherein that energy is changing, like, it's going towards changing the state, for instance, it's being used, work is being done, then yes, it means more entropy.
No. For example, if you have a battery and you're recharging it, you're adding energy to it, but the entropy is decreasing of that battery. So you're adding energy, but the entropy is decreasing. For this water vial,
Good example,
the entropy is increasing, but it's not because energy has been adding to it. It's because the energy was specifically used to break bonds, which makes it more unordered. That is literally why in one scenario, the battery it decreases.
I don't like unordered. You spread
when
out.
you have a battery
right.
and you're recharging it, you're allowing there to be like more energy to be available to use whatever the batteries are being used for, right?
Why does the entropy go down then?
What do you mean? Why does it go down? Because the entropy is the energy that's not available to do work. You're increasing the energy
Yes,
available to do work.
Good. Yes.
So the vial,
add energy,
you're decreasing the energy available to do work because it's a closed system. That's the energy is going towards denaturing these bonds or what have you, and turning the liquid into gas. So entropy is increasing.
But hold on. You know that the same way that you can use a battery to fuel something, you can use very hot air to fuel something. That's
correct.
That's turbines. So saying that we can use the energy isn't the same. Like you're conflating some of the parts of this.
Being used to. Yeah, well, the energy is being used towards a system where you can't use it any longer. In charging a battery or anything else like that, if you can use it towards something else, then obviously there's energy available to do work. There's work.
Okay.
I
got Gummy. I got something. So with that theme, you just made me think of something with the steam to be able to do work. So we got the energy and we put that into the vial that had liquid water, and it expanded. Let's say when it expanded, actually did some work. It actually moved a piston or something. But after it's done, and we added that energy, temperature didn't change, and it's a little bit of a loose example. Energy didn't change, but it already did work. That work's already been done, so it can't be done again. So you can say that system now is losing its ability to do work. That's why the entropy, because now the gas is all spread out, it can't be recondensed again unless you have another process. So it's now expanded. It's already done its work. So that system's ability to do work has gone down. Even though the temperature is the same, it's now spread out. And we did the work by adding the extra energy to it to break those bonds, to make it push out the piston, did the work. Now what's left over is a spread out gas. Spread out is a better way of looking at entropy rather than disordered. And now that it's spread out, it can't do that work anymore. It's never going to be able to do it. It's always going to stay in the gas until something else changes on it. Does that make sense?
So, has this actually been done?
Yes or no? Does that make sense? Does that make sense or not?
Yes. So, if you increase the heat, has this actually been done in the lab where they increase the heat just a little bit, just to like, you know, boil it off, and then they decrease it again, and it doesn't condense?
Well, wait. He's not saying you decrease the heat. Or what do you mean when you say decrease it again?
So you have the heat, and it's at 100. It's at 100 degrees Celsius, right? It hasn't boiled yet. You increase the heat just a little bit to get it to boil. And then,
so it goes through a phase transition.
Yeah, and then you decrease it again, so to back to like the other one that's, you know, just maintaining 100 degrees. Has it been shown that it doesn't condense at that point after you decrease the heat?
As in you're taking heat back away from it?
Do you have to keep the heat in its increased form to constantly, you know, perpetually be boiling it off?
You're using this keep it at its point as if it's like how do I even... I'm having a hard time explaining in words. Like when you say keep it at its heat or take away heat, like if you leave something, it will give away heat if the surrounding is cooler.
Let me describe it again. So you have these two vials at 100 degrees Celsius, right? Let's say the heat is on 7 for the one on the left, and the heat for both of them. Okay, you increase the heat to 8 units of heat. All right, and now it's at enough energy to boil. Does the heat have to remain on 8 after it's boiled, or can we turn it down to 7 again, just like the one on the left, and maintain the temperature, or will it condense at that point?
Well, percentage, the first law, the thermodynamics states that you'd have to keep applying energy to have that as a constant.
Yeah, I mean, the process of boiling removes energy and heat from the
Gummy bears, Anik?
And heat.
What was the question?
The question is, do you have to keep it in increased amount of heat that was necessary to cause the phase change after its phase changed, or can you decrease it to the, you know, the heat that was necessary to keep it?
No, the heat's already. You've already applied the heat. The heat's already in the substance.
So you could turn down the heat after that.
It's contained in the mass.
So you could
mass already contains that. You added the heat to the system. You added the heat to the system, and if you have an isolated system, it will not change.
Starting again.
It will not. Hold on. If you added heat to the system and it's isolated, you will not lose heat. Kind of think of a thermos with coffee in it.
So can I say my headset was
if you're losing
headset was Sorry, I can respond now because my headset was messing up. So essentially, if it's 100 degrees and it's gaseous and it starts losing heat, it won't actually decrease in temperature. Only it would start. I always forget the words, but condensate, I think it is, where it's going from gas to it would start condensing. So the heat that's coming off it now it's usually called latent heat, where it's not actually decreasing the temperature. However, it is changing phase again. So that energy, it's not like it's disappeared. It's more like in the phase of the matter is inherent.
One of the reasons these liquids will change temperature when they change states, called latent heat energy. And
it's
one of the reasons why air conditionings and things work.
Let's just say that it needed 1 joule to go from liquid to gaseous, and it's of course at 100 degrees already. Well, then when you take 1 joule away from it, it's still gonna stay at 100 Celsius. However, it's not going back to liquid.
Yeah, so it happens in perpetuity. You have to keep on applying the increased heat to get it to maintain the state change.
Well, yeah. So if the water in there, or the H2O, is losing energy or heat in some manner, then in order for you to keep it at that at whatever way it is right now, you would have to keep adding it at the same rate. Yes, correct.
But he said specifically to keep it at that level, you have to keep on adding heat. But then you assume that he was thinking about losing energy through like the thermos or the container. If you're not losing any energy out of the container, you don't need to keep adding heat to keep it at that state. It'll stay there
If it
indefinitely.
was an isolated system, you wouldn't have to keep on adding heat to either one. You
Correct.
Just heat them up,
good.
and that's
Yes.
it.
Yes.
Correct.
Percentage. There's 2 people in VC check-in. It looks like if we can handle that.
I don't see anyone.
They were there a second ago. Nope, they're gone. Yeah, they were there just a second ago.
Do you remember their names?
No, I didn't. I didn't recognize them though. I did look, but yeah, they're gone.
But yeah, but so percentage. I mean, I feel like that's a given. If it's losing heat, then in order for it to stay the same way, it needs to also gain the same amount of heat. I feel like that's a given. I'm not sure what that is supposed to address. That question.
I'm not sure what this whole scenario was supposed to address. Obviously, the one that has larger amount of heat going into it is going to have more. You're putting more energy into the system. It's going to cause this phase change, and it's going to have more entropy.
Yeah, but you're acting as if
something you said, Gummy Bear. I disagree.
Yeah, but hold on. You're acting as if the adding of energy made the entropy go up, which isn't necessarily true. It's not the fact that it's just got more energy that makes the entropy go up.
No, yeah,
it's the fact that the energy went towards breaking the bonds. That's what made the entropy increase.
It didn't just went. It continuously is doing that. If you stop, applying the heat, then it's going to stop doing that. But yeah, I disagree with
only if it's losing. Only if it's losing heat.
It's always losing heat.
No,
but then the entropy is decreasing.
Unless you're imagining it, it's always losing heat.
No, but as Gummy said,
well, we usually talk about an isolated system, which of course is usually idealized, but that doesn't stop us from talking about it.
If it's an isolated system, how are you adding energy to begin with, or adding heat to begin with?
What's the external system? So if you have a closed system, what's the external environment look like?
Oh, hold up.
Let's say the external environment was 100 degrees C.
Can you add heat? Can you add energy to an isolated system?
Well, it can be isolated after we've added energy to it.
Exactly. So it's broken either way.
No, it's not.
We can have, let's say that we develop this extremely, there's this big vacuum chamber. In the very center of it, we have this really isolated little chamber. And so we pump this fully into a full-on vacuum so we don't get any convection, loss of heat. And then we add a laser to the inside of the vacuum wall. The only way we're getting more energy into that system is if we turn on the laser to add energy. There you go. It's conceivable, but we are talking about an idealized one.
I agree.
A closed system.
It's only conceivable.
How about this? No, just think of that container. Think of that container all in 100-degree. So it's a closed system, but it's in a room that's always going to be kept at 100 degrees C, always.
Yeah, that too. Yeah, that's fine as well.
That way the system will never change temperature, and adding the energy to one, because they're both closed, will change the state of one and not the other, and nothing will ever change.
Sure, it wouldn't be an isolated system. I don't
think about it. The temperature is the same. Everything's the same. The outside of these two, you have two chambers, two containers, call them chambers, two closed systems, and then inside a big room. The room is kept at 100 degrees C. Obviously, naturally, these two liquids all become 100 degrees C, and they will not change state. But we use a laser and fire into one. That one. All right? The one changes states into a gas. Still kept at 100 degrees, not losing energy outside the container because the outside environment of these closed systems is still 100 degrees. But yet one now is a gas and one is a liquid, and it'll stay that way forever.
Yeah, because there would be no reason for them not to.
That's probably the best way I can explain it.
Sure, that's probably the closest you could get to a closed system.
That is a closed system.
Well, no, it's the closest you can get.
Well, all it means is, technically, any closed system that we know and that we can construct will always have some leakage.
Anyways, Gummy Bear, you said something earlier. You said it's only the difference in bonds that's affecting it, right?
What do you mean? It's affecting what? The entropy?
The entropy of the gas versus the liquid.
But by virtue of breaking the bonds, you spread out that,
so
that
it's
mass.
So if I said it's only the bond, then I misspoke. It is, of course, both. It is temperature and the bond. But I'm saying that the reason why it went from a certain amount of entropy per Kelvin to 3 times that is because of the bonds.
I'm with you.
Yeah.
So yeah, the temperature allowed for the bonds to be undone, causing the phase change. Blah blah. My thing is, okay, so let's say we have these vials, right? And let's say one of them is, in liquid form. Let's say it's, 1/3 liquid, right? And the other one is in gas form because we've applied the extra heat. Wouldn't you expect that the weight of the air above the liquid, the pool of liquid, has weight?
Well, we have them both in sealed vials, so they're going to expand to fill the available volume, and there won't be any difference in the external pressure. So no.
Only the gas one will expand to fill the available thing. The liquid one is still like 1/3.
But let's say that it already does fill the entire thing. We made a vial that's perfectly fit for that amount of liquid.
Oh, so they're different volumes?
No, they're the exact same volume.
So how are you, if it only has enough room for a liquid form, how are you turning the other one into a gas without...
By giving it more energy.
So it's in a gas... So you have... I don't understand how you can do that.
Because we gave it enough energy to break the bonds? What do you mean? I don't quite get what do you mean.
Well, because liquid is more dense.
He's saying that
more
the vial of liquid is only the size
the vials are
no,
full.
So neither... No, they would be the same density. You can have the same density of a gas and a liquid as long as you pressurize the gas enough.
So basically, the gas one, it's the molecules are as close, as packed as the liquid one, but the only difference is the bonds?
In that sense, yeah. I mean, the gas one would have a higher pressure, pretty sure, internally. If I'm thinking correctly right now.
I think it would look like it's
why
still
wouldn't
liquid.
it be possible?
Because if the molecules are so close together, just like the liquid one, I think you wouldn't be able to tell that it was actually a gas.
Well, no, because the thing is, the difference between the gas and the liquid is that within the liquids, the individual molecules are bonded to each other, so they can only slip by each other slowly by interchanging bonds, while the gas will be able to rush all over the place, bump into each other, and move freely in respect to each other.
Okay,
so
sure,
the
maybe
behavior of
molecularly-
them, the behavior of the molecules will be different.
I'm with you. Maybe molecularly or microscopically, you might be able to tell the difference. But in terms of looking at the vials, if you have a vial of gas that's packed as much as water is, as liquid is, then I don't know how you'd be able to tell.
Because the optical properties of a liquid and a gas are different. The fact that there are these bonds will make the light that gets to travel through the water be different than the light that gets to travel through the gaseous form of it.
Has this ever been done, or are we just speaking like...
Yeah, you can do this. If you ever work with nitrous oxide or any kind of containers that are pressurized, you can have liquid nitrogen, you can have liquid oxygen, you can have in the same container, same density.
Yeah, things have been
We're not talking about liquid.
compared.
We're talking about having the same volume
have been
of water.
Yeah, you'd have to have tremendous pressure to make...
Yeah,
I don't know.
Has it ever been done?
I don't know if anyone's ever done this scenario where they have the identical volume, because I feel like that would be useless. It would go a lot of effort for very little.
I feel like it would be impossible.
I get why you say that, but I don't see why it wouldn't be.
You have to have 1,000. You have to have 1,000 times the pressure to do that. Like the density between the density differential between.
But that's the Sorry.
Density difference between the gas and a liquid for water is about 1,000 times. So if you could have 1,000 times the pressure, you could have this. You can have a gas and a liquid in the same container.
Well,
okay. So just to be clear, you guys are speculating that it's possible. This would happen.
I never looked at this before like this, but
No, so at the pressure required, I'm not sure if we could keep, if it would stay gaseous. I feel like it might be like supercritical at that point. I actually don't know, to be honest, at that point. Because how many atmospheres is beyond the critical point for water? I'll have to look this up.
Yeah, I could put the chart up real quick. I think you're definitely in that range.
So it's about 217 atmospheres. Is beyond that is the critical point. Yeah. So yeah, that it wouldn't quite be possible.
And that's what percentage was toying with, and he's rightfully intuitively correct in that. But the point was, you're trying to go to a point, and then we use an extreme, and then he got
It's the fact that we're using extremes that fuck it up. But I get what you're getting at, percent.
Yeah, my other point was just that, like, obviously, for it to be, possible, you'd have to have the less water in the vial. Like if it's in liquid form, that's why I said like 1/3.
Yeah, that's why he got derailed when you said same volume. So we have a big volume, a big container where there's a little bit of water in there and there's a little bit of gas, but the amount of both is the same. So there's room for this expansion or this condensation to happen without any kind of challenges to the supercritical states.
Exactly. And my point was it's not just the denaturing of the bonds that's a factor. I would think that the surface tension of this pool of water would enable it to basically carry more of the weight to register a higher force from the the air that's in that vial relative to the gas.
You weigh things on containers and through containers on a scale or even hanging the same exact way you weigh things with gas. This is the collisions that are disproportionate to the bottom versus the rest of the containers walls. So since most of them, the velocities are greater downward for both liquid and the gas, that's why there's weight being weighed.
No, but how did we weigh it in the vial? Because I feel like after it makes its phase transition, its phase change, that then the air will be pushing, since it's buoyant, it's going to be pushing above, and because it's not catching all of the the air, like that pool at the bottom of the vial in the other vial it's going to be less heavy. It's going to be lighter.
No, that's like, let's weigh an ice cube, same mass. Let's weigh the liquid, same mass. Let's weigh the gas, same mass. You're missing the mechanics of how force is applied to the scale.
I think you're missing the mechanics. If we have two
I understand it very well. So
if we have two water balloons, one is in liquid form, and the other one we've somehow made it.
So how does the liquid different than how does liquid different from the salt percentage? How does liquid different from the?
Anyways, go ahead.
Every time I talk, you're going to talk over me. I mean, what do you mean? I waited. I start talking, then you start talking again. How is it different? Fuck, you're a jerk. How is it different? Again,
I apologize. That's unintentional. Go ahead, please, Annie.
God damn, just say it.
Man, I can't, because every time I start talking, he starts talking over me. You have a liquid, and I don't mind being gently interrupted, but this is kind of interesting. Okay, so you got liquid and you got the ice, both the same molar mass of water. Explain to me the mechanics of how the scale registers weight for those two items.
Why are you going to ice?
Because it's a solid block. I want you to understand that a solid block applies a force on the surface, similarly how a liquid does.
Yeah, but ice expands.
No, ice is it's already ice.
Like water expands when it turns into ice.
Doesn't matter. We have a container that can accommodate expansion. Remember, because we have gas in there too. We have this big block, biggest containers you want, and it's filled with air and water. All of it filled with air and water, and one is filled is ice, one is water, liquid, and one is water, gas. What are the mechanics for how the scale registers weight? This is what I'm trying to explain this, because you sound, the way you objected to it and your logic was an error, and that's why I wanted to go over this.
Okay, first off, because of water's unique way of expanding as it freezes, I don't think it's proper to use ice as an example, because you have
ice, you got a liquid, you have a glass of water, an ice cube, and you got a balloon of gas in a vacuum. How are they weighed? what are the mechanics of those?
Let's just talk about going one phase.
Forget about the
to
entropy
the
thing.
next.
Forget about
There's
this.
no
Just get
point
a
in jumping
random block of ice. I don't care what. They don't even weigh the same. They're different masses. How do you weigh the ice cube? How do you weigh the glass of water? And how do you weigh a balloon of air?
Listen, man. It's like you're not listening to what I'm saying. If you want to compare ice with water, that's fine. Even though ice still messes it up because normally things get more dense as they get.
It's not a matter of dense. I'm just wondering how they're. I'm trying to go over with you the mechanism of how they're weighed. You're not responding to how they're weighed. How do you weigh an ice cube? How do you weigh a glass of water? And how do you weigh a balloon full of either water gas or even just air in a vacuum? All this is in a vacuum, by the way.
You're not listening to me, man. But fine, let's address your red herring. Go ahead.
It's not a red herring. Well, let's just go back to, I guess where I'm getting at, I'll cut to the chase. You measure the gas, and the weight of that gas is registered because the velocity of these molecules are greater going down than they go in any other direction. And that force imparted on the bottom of the container will be a result of a change in momentum. And we all know that these collisions are elastic collisions with no energies lost, and there is a force because they change direction. And by definition, any change of direction is a change of momentum. Any change of dimension results in a force. So this force is acting on the bottom of the container more than any other side, and that's why the gas registers its weight. Now, if you freeze that gas, or if you change its pressure so that it condenses into a liquid, the weight will be weighed similarly, but it's not about these velocity of the collisions. It's just about the direct force acting on the bottom. Because it's not going in all directions. It's sitting at the bottom. An ice cube, same thing. It's a very fixed mass that doesn't have any movement at all, but it's still weighed exactly the same. So there's two ways of near the same type of measurement, mechanics, and then the gas, completely different, but the net result is all of them will register the same exact force on the scale.
I disagree with you.
Well, you can disagree with all you want, but that's how it is.
In terms of the ice and the liquid, I wouldn't disagree. I would say the only thing you have to be mindful of in that regard is that ice doesn't require a container, whereas liquids and gases do. All right. So let's say the ice, and then
they're both in glasses. They're both in glasses of water.
Yeah. Let's say the ice is in a glass and the liquid is in a glass. I have no issue because they're both at the bottom. They both have the weight of the air above, and there might be a small difference in terms of the difference of density. But aside from that, that's it.
Now I have the balloon of air sitting on top of the glass.
See, yeah, that's the issue. Now let's say
it's not an issue for you. It's an issue. The same cup. You disagree, but you can't explain why. I'm listening.
Let's go back to the vials. Let's go back to the vials since they're all the same container, right?
Okay.
Let's say
before you go, just to set the stage, we don't go any derailed. I'm going to let you talk. I'm going to listen to everything you say. I'm very interested in your logic here. We have the glass of water. No, you have no problem. We have a glass of ice, and ice is in there as well. No problem. You have the same glass with a air balloon, water gas balloon, helium balloon, doesn't matter, a balloon sitting on top of the glass. Now we know this is all in a vacuum, by the way. So there's no other buoyancy factors involved. We just have this balloon sitting on the glass, water in the glass, ice cube in the glass. Go ahead.
All right. So instead of glasses, we have vials first off. And I think the key point here is to talk about it before the phase change. Okay, so
just do those three as I set them up.
Let me
three scales, three items.
Zanuck, you said you'd stop and let me talk.
I know, but you're changing things again.
If you'd
No, but I set the stage and you said no, we're not going to use glasses. We're using vials. You're getting some gotcha. I don't know where you're going. Just use what I gave you. Why can't you use my example?
Zanuck,
why can't you use my example?
I'm giving you my explanation, so I'm going to use my.
Okay, go ahead.
Then
go ahead.
So you have 3 vials, and each one you have water, the same volume of water. Okay, for one of them, you freeze it. For the next one, you leave it, and for the third one, you boil it and you turn it into gas. Okay? When you